Welcome to Simplilearn's YouTube channel. Programming languages are the foundation of modern technology. From websites and mobile applications to artificial intelligence, cloud computing, and software systems, programming languages enable developers to build the digital solution we use every day. Each programming language is designed for a specific purpose. Some are ideal for web development, others are used for data science, automation, enterprise application, mobile app development, or system programming. Understanding programming languages help developers choose the right tools to solve real-world problems efficiently. As technology continues to evolve, programming skills have become one of the most valuable and in-demand skills across the industry. In this complete programming language course, you will learn the fundamentals of programming and explore some of the most widely used languages in technology industry. We will start with the basic programming concepts and gradually move into practical applications of different languages. Throughout our courses, you will explore languages such as Python, Java, JavaScript, C++, SQL, and more, along with their use cases in software development, web development, AI, data science, and backend systems. You will also learn important concepts such as variables, data types, loops, functions, object-oriented programming, and problem-solving techniques that are common across programming languages. By the end of this course, you'll have a strong understanding of the programming fundamentals and how different languages are used in real-world technology environments. Having said that, let's take a look at the agenda for this course. We will start off with Module 1, which is the Introduction to Programming and Logic Building. Module 2 is Variables, Data Types, and Operators. Module 3 is Conditional Statements and Loops. Module 4 is Functions and Modular Programming. Module 5 is Object-Oriented Programming Concepts. Module 6 is Python Programming Fundamentals. Module 7 is Java Programming Basics. Module 8 is JavaScript for web development. Module 9 is C and C++ Programming Fundamentals. Module 10 is SQL and Database Programming. Module 11 is Data Structures and Algorithms Basics. Module 12 is APIs and Backend Programming Concepts. Module 13 is Version Control with Git and GitHub. Module 14 is Real-World Programming Projects. Module 15 is Interview Question and Answers. That's it. If these are the type of videos you'd like to watch, then hit that subscribe button and the bell icon to get notified whenever we host. Also, just so that you know, if you want to upskill yourself, master software development skills, and land your dream job or even grow in your career, then you must explore Simplilearn's cohort of various software development programs. Simplilearn offers a variety of master's, certification, and postgraduate programs in collaboration with some of the world's leading universities. Through our courses, you will gain knowledge and work-ready expertise in skills like core and advanced Java, mean and MERN stack development, software testing, and a lot more. And that's not all. You'll also get the opportunity to work on multiple projects led by industry experts working in top-tier service and product companies. After completing these courses, thousands of learners have transitioned into software developer or a software tester role as a fresher or moved on to a higher-paying job and profile. If you're passionate about making your career in this field, then make sure to check out the link in the pinned comments and in the description box to find the software development program that fits your experience and areas of interest. So let's get started with our programming language full course with a small quiz. What does OOP stand for? Is it Object-Oriented Programming, Online Operating Platform, Organized Output Processing, Open Object Platform? Please let us know your answers in the comment section below. Now over to our training experts.
For every software developer, data structures are essential to their daily lives, helping them organize, store, and access information more efficiently. While data structures are primarily used in computer science and engineering, they can also be applied to many aspects of your daily routines. For example, shopping, personal organization, finance management, social networking, and many other areas of everyday life can be managed effectively using data structures. Data representation and manipulation can be done in a way that makes it simple for algorithms to operate with. The performance of your program can be enhanced, for instance, by selecting a data structure to store large amounts of data that needs to be frequently accessed or modified. Arrays, linked list, stacks, queues, trees, and graphs are some common data structures used. Each of these data structures has advantages and disadvantages, and selecting the appropriate one for your problem can significantly improve the efficiency and maintainability of your code. In fact, data structures are crucial tools for programmers and computer scientists since they aid in optimizing data storage and processing in various applications. On that note, hey everyone, welcome to Data Structure Full Course Part 1 video by Simplilearn. In this video, we'll begin with an introduction to data structures, followed by an explanation of an algorithm, and then we'll learn about data structures, pointers, and structures. Next, we'll move on to topics like arrays, linked list, types of linked list, and finally the fundamental distinctions between arrays and linked list. Then we'll dive into little advanced topics like stacks, queues, trees, and graphs, covering their various types of it in the next part. So without any further delay, let's get started. Over to our training experts.
Data is an information that has been translated into a form that is efficient to movement or processing in computing. As it relates to today's computers and transmission media, data is an information that has been converted into binary digital form. The term raw data refers to the data in its most basic digital format. After defining data, let's look at what data structure entails. A data structure is a data organization, management, and storage format in computer science that allows for efficient access and modification. Or, a data structure is an algebraic structure about data that contains a collection of data values, their relationships, and their functions or operations that can be applied to the data. We will now understand why exactly we need data structures now that we have already defined what is a data structure. So, let us have a look at some of the data structure characteristics. The first one is, each data structure allows data to be stored differently. Following that, the data structure allows for more efficient data search and retrieval. Then, specific data structures are chosen to solve specific problems. Last but not the least, it enables the management of large amounts of data such as large databases and indexing services such as hash tables. Let us now look at some real-world examples of data structures. First and the foremost, we have the dictionary. Assume that we are looking for the word Simplilearn in the dictionary. And we know it begins with the letter S. So we can search for this word beginning with the letter S, and then this is an example of array data structure. As a result, this dictionary can also function like an array data structure. Following by that, we have a music player example. If you have a playlist with 3 songs, the second song will play after the first and the third will play after the second. So these will be played without any interruption because all these 3 songs are linked with each other using linked list type of data structure. So followed by linked list, the next example we have is the data structures. The stack of books analogy is a perfect example of the real-time working of the stack data structure. Subsequent to that, assume there is a line of people at a ticket window and the person who comes first gets the ticket. This particular movie window queue is an example for the real-time implementation of queue data structure. Last but not the least, Google Maps. Google Map is the graph data structure in which all the cities and states are connected. If we want to go from one place to another, there may be many ways to do so. So we can use some algorithms to find the shortest path. As a result, the Google Map is a perfect example for the graph data structure working analogy. Following that, we will look at some different types of data structures in this tutorial. So the first type is the linear data structure. The elements in the linear data structure are arranged subsequently one after the other. They are simple to implement because the elements are arranged in specific order. Followed by the first type, the second type is the non-linear data structure, which we will be discussing a bit later. So in linear data structures, we have 4 different types. The first one is the array data structure. Memory elements are arranged in a continuous order in arrays. And arrays elements are of same type. The software program also determines the type of elements that can be stored in arrays. So followed by arrays, we have linked list. Linked lists are completely similar to data structures. Data elements in linked list data structure are linked together by a series of nodes. Furthermore, each node contains the data items as well as the address to the next node. The third data structure is the stack data structure. Elements in a stack data structure are stored using LIFO principle. In other words, the last element stored in the stack is removed first. In stack, operations can only be performed in one end, namely the top. And the last data structure is the queue data structure. Unlike stack, queue data structure operates in the FIFO principle, which states that the first element stored in the queue is removed first. In a queue, insertion and deletion are carried out from opposite ends. Now we will discuss the second type of data structures, which are the non-linear data structures. The non-linear data structure is the second type of data structure. Non-linear data structures do not have elements in any order as opposite to the linear data structures. Instead, they are arranged in hierarchical order. with one element connected to one or more others. So the first one in the nonlinear data structures is the tree data structure. A tree data structure is built using nodes and edges. Each element in the tree data structure is called as node or vertex. Each vertex or node is connected to the other nodes or other vertices using edges. And the second one in the list is the graph data structure. A graph data structure is completely like a tree data structure. It also has the vertices and edges. Each vertex in a graph data structure is connected using edges. The only difference between a tree and a graph is that in tree you can have n number of vertices, but in graph you will have only 2 vertices. After discussing the graph data structure, we will move ahead into the last segment of this tutorial, that is importance of data structures. So the first one, data structures are widely used in almost every aspect of computer science, both for simple and complex computations. Next, data structures are used in all areas of computer science, including artificial intelligence, graphics, big data, operating systems, and much more. After that, the data structures are an essential component of many computer algorithms because they allow programmers to manage data efficiently. So how does algorithm work in real life? So we'll have a use case here. On my screen, we have a lady and she is Shreya. Shreya wants to make some tea, and for that she is following some steps. So the first step is, she'll take a pan and fill it with water and place it on a gas stove. Followed by that, the second step is, she'll make sure that the water comes to a nice boil, and then she adds some tea leaves and sugar. Followed by step 2, we have step 3, where she'll allow the leaf to be fully expanded and she'll add some milk after that. Next we have the step 4, where she will wait for the tea to come for a good decent boil. Next we have step 5, where she'll turn off the gas and she'll take the pan off from the stove and the tea is ready to get filtered. And lastly we have the step 6, where she is all set with the tea. So in computer science, an algorithm is a method or set of rules that we must be following to perform some specific calculations or other problem-solving operations. As a result, an algorithm is a collection of rules or instructions that govern how a work needs to be conducted step by step to achieve the desired results. To accomplish a task, we first provide some input and then follow a sequence of steps to acquire the required outcome of the input. So that is the fundamental definition of an algorithm, and we also had a use case. And now we will move ahead and understand the characteristics of algorithms. So basically we have 6 characteristics of algorithm. So the first one is, it should be clear and unambiguous. The second one is that it has to be well-defined inputs. And the third one is that it has to be having well-defined outputs as well. The fourth property of an algorithm is its feasibility. Followed by that, finiteness, and finally we have language independence. Now we will look into each one of the characteristics in detail. So first we have clear and unambiguous. So this statement is the one which states that the algorithm should be straightforward, simple and easily readable. Each one of its steps should be distinct in every way and lead it to a single conclusion. So the next one is, it should be having well-defined inputs. So this means that an algorithm should indicate what output can be expected, as well as the input should be properly well-defined. Now we have the third one. Similarly, we should also have well-defined outputs. So the well-defined output characteristics of an algorithm means that the algorithm must clearly indicate what output can be expected, as well as the output should also be well-defined. Followed by the third characteristic, we have the fourth characteristic, that is the finiteness of algorithm. So the finiteness of algorithm says that the algorithm must be finite and it must not result in infinite loops or similar situations. So followed by the fourth one, we have the fifth characteristic that defines about the feasibility of an algorithm. So feasibility of an algorithm states that the algorithm must be really simple, generic and practical. It must be able to be executed with resources available. Now the last characteristic of the algorithm is being independent of the language. So it means that the algorithm should be defined in such a way that it is completely independent of the language. It must be simple instructions that can be implemented using any programming language. So these were the 6 major characteristics of algorithm. Now let's move ahead and understand how to write an algorithm. Writing an algorithm does not have any hard and fast rules. Next, algorithms are never created to support a specific programming language. As we all know, algorithms should be capable enough to support the conditional statements such as if else, switch, etc. An algorithm should be capable enough to execute some of the conditional statements such as if else, switch, etc. And also it must be capable to execute the iterative statements such as for loop, while loop, do while loop, etc. We usually create algorithms in a step-by-step manner. However, this isn't always the case. After the problem domain has been well defined, algorithm writing is a procedure that is carried out. We build an algorithm to find a solution to a problem. A problem can be resolved in a variety of ways. Let's look at an example of how to write an algorithm. Consider the following scenario. We need to create an algorithm to determine the largest number among the 3 given numbers x, y, and z. As a result, the initial solution to the problem can be written in this manner. So we begin with reading all the 3 numbers, and in the second step we will have a condition that says if x is greater than y, we will proceed to step 4, else we will proceed to step 5. Next, in step 4, we establish a condition that if x is greater than z, then x is the largest of the 3 numbers. Otherwise, z is the largest. If y is greater than z, z will be the greatest number. Otherwise, y will be the largest number amongst all the 3 in step 5. And the procedure will be terminated. Let's have a look at what the next solution has to offer. In this algorithm, we begin by reading all the 3 variables, then compare all the 3 numbers in the third step to determine the largest number, which is if x is greater than y, then there is another if else statement that states that if x is greater than y, then x is largest, otherwise z is the largest. Then there's if else statement which says that if y is greater than z, then y is greater, otherwise z is the greatest of the 3 numbers. So this is how we have multiple solutions to the same problem. So after discussing these solutions, we will move ahead and understand algorithm analysis. The algorithm may be studied in 2 levels. First, before it is made, and then after it is created. The 2 analyses of an algorithm are as follows. The first one is priori analysis and the second one is the post analysis. So first we will talk about the priori analysis. Priori analysis refers to the theoretical analysis of an algorithm performed before its implementation. Before implementing the algorithm, other parameters such as processor speed might be considered, which does not affect the implementation component. Next, we will talk about post-analysis. A practical analysis of an algorithm is called as posterior analysis, and it utilizes any computer language to build the algorithm. The purpose of this analysis is to determine how much time and space the algorithm takes to operate. Now, after being understood the algorithm analysis, we will be able to comprehend the algorithm complexity. 2 methods can be used to assess the algorithm complexity. The first one is time complexity, which states that the amount of time required to finish an algorithm's execution is known as its time complexity. Followed by time complexity, the other one is the space complexity, which is calculated by the quantity of space required to solve a problem and produce an output of space complexity of an algorithm. Let's take a closer look at these complexities. Now we will begin with time complexity of an algorithm. The big O notation is used to express an algorithm's time complexity. The asymptomatic notation is used to depict temporal complexity of big O notation. The time complexity is mainly determined by counting the number of steps required to complete the task. Let's take a look at an example to understand this time complexity in a much better way. If we want to find out a multiplication of n numbers, we can do it by executing a loop from 1 to n, then calculating multiplication when the loop ends. Then multiplication holds the n numbers multiplication, and last we return the calculated multiplication. The loop statement's time complexity will be at least n, and when the number of n increases, the time complexity will also increase. While the code's complexity, that is, returns multiplication, will remain constant because its value is unaffected by the value of n, and it will obtain the result in every single step. Next, we will discuss about space complexity, which is expressed with big O notation, just as time complexity. These four items are stored in space complexity. It initially saves program instructions, then stores constant values, then stores variable values, and finally it keeps track of function cells, jumping statements, and so on. The sum of auxiliary space and input size is used to calculate space complexity. The extra space or temporary space used by an algorithm is referred to an auxiliary space. After learning about algorithm complexity, we will look at some of the algorithm's pros and cons. So let's start with the advantages of algorithms. Firstly, algorithms are easy to understand. Next, algorithms are step-by-step representation of a solution. And lastly, the problem is broken down into smaller bits or steps in an algorithm, making it easier for the programmer. Now, an algorithm also have various drawbacks, one of which being it takes long time to write, hence it is time consuming. Second con of the algorithm is algorithms make it harder to demonstrate branching and looping statements. So followed by the advantages and disadvantages of algorithms, we now enter into the final segment where we discuss the differences between algorithms and programming. So the first difference is that an algorithm is a type of programming. On the other hand, a program is more directly associated with the computer performing one or more tasks, but an algorithm is more of a notation, a technique for solving a problem. Now, let us discuss the second difference. An algorithm can be decoded or run by a human, whereas the program is only run or decoded by a set of compilers of the computer. Now, the third difference. Basically, an algorithm is a design of the solution to the problem. Here, we can only analyze the solution, but we can never run it. But whereas on the other hand, programming is completely a different ball game. Here, you can directly implement a certain phase or an entire program and test the programs and get an output. So the fourth and the last difference between an algorithm and programming is an algorithm is written using natural human vocabulary, whereas programs are written using any programming language such as C, C++, Java, Python, etc.
A pointer is a variable that points to an address of another variable. It is declared using a star symbol, also called asterisk. And then we allocate a memory of a variable to it. We can access a variable's address using the ampersand symbol in the same manner as the pointer declaration. Let's write a code. We will declare a variable a is equals to 5 and a pointer ptr. Then we will assign this variable a's value to pointer ptr. Now let's write a print statement to directly access the variable's value using variable name. Let's write another print statement to print the value of a using pointer. Let's try and execute this program. As you can see, we have successfully accessed variables value using both variable name and pointers. Let's get back to our slides. Now, let's discuss different types of pointers. First up, null pointer, void pointer, while pointer, and dangling pointer. Let's discuss these in details. First up, null pointer. It is a kind of pointer that points to a null memory. As you can see in the figure, here is a pointer which is pointing to a null memory. To get a better understanding, let's try a simple program in the code editor. Let's write a code. First we will declare a pointer var. Then we will assign its value to null. Now let's try to print this statement. Let's execute this. As you can see, since this pointer points to a null or nothing, that's why it doesn't print anything. Let's get back to our slides. Next, void pointer. When a pointer is created with data type void, then this pointer is called void pointer. If we want to print the variable's value, then we have to typecast this pointer to avoid any error. For better understanding, let's get back to the code editor and try it with a simple code. First, we will declare an integer variable a is equals to 5 and a void pointer ptr. Now we will assign address of a to pointer ptr. Let's write a print statement to print this pointer. Let's run this program. As you can see, we are getting an error. That's because we can't print a void variable. To print this, we have to typecast this variable to integer. Let's do this. We can typecast a variable like this. Now let's print this. As you can see, we can print it now. Let's get back to our slides. Next, while pointer. When we create a pointer but don't initialize it by assigning any memory to it, then this kind of pointer is called while pointer. These pointers can be very tricky. They can even cause a program failure or a segmentation fault. Let's get back to the code editor and try it with a simple code. First, let's declare a pointer ptr. But we will not assign it with any address. Let's write a print statement to print it. This time we will directly print it. Let's execute this. As you can see, we are not getting any results because there is no value assigned to it. Sometimes it may even show segmentation error. Let's get back to our slides. Next, dangling pointer. Let's suppose there is a pointer p which is pointing at a variable. Now, if we deallocate this memory using a free function, then this pointer will point at a free space or a non-existing memory. Then this pointer will become a dangling pointer. To get a better understanding of this pointer, let's try it with a simple code. Let's declare a pointer ptr. Here we will dynamically allocate memory using a malloc function. To do this, we will put int star in a bracket, then malloc function, then in another bracket we will put memory size to be allocated. Now let's declare a variable a and assign its address to the pointer. Now to make it a dangling pointer, we have to deallocate the memory of this pointer. We will use free function for that. Now let's write a print statement to print this pointer. Let's execute it. As you can see, since we have deallocated its memory, that's why it is pointing to nothing. Hence, it doesn't print anything.
Now let's begin by understanding what a structure is in C. As we all know, array is a collection of elements of the same data type. Similarly, a structure is a collection of elements with the same or different data types. For example, unlike an array, a structure can have members of different data types like int, float, char, etc. Now let's have a look at structure declaration in C. We use the struct keyword before the tag name to define a structure. Tag name is nothing but a structure name. Whatever is declared inside the struct curly brackets are members of the structure. Once the members are declared, the variable has to be created to access the members of the structure. Now let's see the example. We have struct keyword followed by student as a tag name, then a list of structure members. And they are name of type char, roll number and age of type int, and s1 as a structure variable. We can have a list of structure variables. Another way of structure declaration is we can declare structure variable outside the curly brackets by using struct keyword followed by a tag name and then declare variable list. For example, struct keyword, then student tag name and s1 as a variable name. In structures in C programming, we cannot assign values during the definition of a structure. It indicates the wrong way to the declaration. So now, let us try to understand the right way of assigning values to the structure members in C. To assign values to all the members of a structure and access, we use dot operator, also known as a period operator. Look at the syntax below to clearly understand how we access and assign the structure members. First, the structure variables followed by the dot operator and structure members. For example, s1 dot roll number is equal to 34, s1 dot age is equal to 18, and we make use of the string function strcpy to copy the name. Next, we have structure initialization in C. We can also initialize the structure variable. And to initialize, we can directly assign values of all the structure members inside the curly brackets with an assignment operator. For example, struct student s1 is equal to inside the curly brackets enter the values separated by comma operator. In this particular example, name is John, the roll number is 22 and the age is 18. Now that we know how to declare and initialize structure variables in C, let's see how the structure elements are stored in the memory. As we know, char takes 1 byte of memory space. So, according to the size of the string, the characters will occupy in the memory. In structures, the memory is created once the structure variable is declared. As per this example, s1.name is a string, so that memory will be allocated and its base address will be obtained. For the s1 variable, the total memory allocated is 8 bytes, that is 5 bytes for s1.name, 2 bytes for s1.roll number and 2 bytes for s1.age.
So I think you got a good understanding of how memory is allocated for the structure elements. Okay, so let us move on to the structure within structure in C. When a structure contains another structure as a member, it is known as a nested structure or structure within a structure. For example, let's consider a structure named student and another structure name as a date. In this example, a structure date acts as a member. So, a structure date has its own members and they are date, month and year of type int. And structure variable for date is DOJ. And the structure variable is initialized for both the members of the structure, that is name, admission number, age, date, month and year. Now let's execute a simple structure program.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
As you can see, in this particular program using the structure, we have initialized the variables and trying to print the values. And by using the dot operator, we are accessing the members of a structure. So now let's run it. And here we got an output, name, roll number and age of a student structure. In our next program using structure, we are using another way to declare variable and initialize the structure members. As you can see, we have declared variable outside the structure curly bracket. And inside the main function, we have initialized the structure members. So now let's run the program. So here we got the same output.
So to understand this, let's go through a simple concept. Let us imagine that we have some data and the data is related to students, right? So if we wanted to store the marks of individual students, then we had to declare a variable for each of the student. So you can see we have student 1, student 2, student 3, 4 and 5 and their individual scores. So the score 1 is assigned to student 1 and so on, with student 5 being assigned to score 5. So in the real time, this might be a little clumsy. We have here just 5 students, so that is okay. But what if we had 500 students or 5,000 students, right? That might be an issue. There we have to create some 500 or 5,000 variables and it would be a little tough to handle that, right? Even if we wanted to apply some operations collectively on all the variables, that might be a little tedious. So what if we had one variable which could store all the 5 students or 500 students or 5,000 students all together and make it really easy for us to apply some operations collectively on all the students, right? This sounds a little bit logical. So similarly, we do have a data structure which can do that, which can collectively store all the data elements in it as a single variable. And it will also help us to apply the operations which are logical or mathematical on all the variables and their values together as a whole. So that is the purpose why we had created arrays. That is the purpose why we needed arrays. So far we have understood what was the necessity for arrays. Now we will understand what exactly are arrays. So basically an array is a linear data structure that stores the elements in a sequential manner, one after the other. And when you declare an array, the variables will be stored one besides the other, that is adjacent to each other in a sequential order. Now let us understand how the array is represented by the compiler. Now the next part, that is the memory representation of arrays. Now let us imagine that we have declared an array which stores character type data. And another important point to remember about arrays, when you declare an array, it stores only a single data typed elements only. For example, here we have declared a character type array, right? So we cannot store integer type data or float type data in it. We only have to save character type array or character type elements in this particular array. So now let us imagine that we have created an array which is of character data type, and these are the elements, which are A, R, R, A, Y. Now, how does the compiler represent it in the form of memory? So when you create an array, these are found, that is the index values and the address. So basically, compiler will select a block of memory and it has addresses to that block, and it can be anything. Right here we have 11, 12, 13, 14 and 15, and in real time it might be 1001, 1002, 1003, 1004, 1005. The main motto is assign a sequential block of memory, and this is the array, and the elements are A, R, R, A, Y, and this particular one, which is the last one, is the index of the array. That is the position of the array for user. So using this index, you can access the elements in the array. More on that in the accessing part. So let us imagine that we wanted to access the element R. So how to access it? We might not know the address, right? In that instance, we will use the index. This is for R reference. So we will tell, I want the element from array index number 2. And then we'll have the ARR, R element. So in the practical form, this is how we use the index. Now let's continue with the lower bound and the upper bound. So the first initial location is called as the lower bound, and at the last or the max value of the array is called as the upper bound. Now let us jump into the next topic, where we will understand the different types of arrays. So these are the different types of arrays: one-dimensional arrays and multi-dimensional arrays. In multi-dimensional arrays, we have two more types, that is two-dimensional arrays and three-dimensional arrays. So how are arrays different from each other, right? So the first one, we'll deal with the first one, that is the one-dimensional array. Now, how is an array declared as one-dimensional? For that, we need subscript. So one-dimensional array requires only one subscript to specify the number of elements in an array. So how is it actually represented? So here you can see an example right on my screen. So here is how a one-dimensional array looks like. So here we have the data type, that is integer data type, and marks is the name of the array, and this is the size of the array. And here the elements will be stored, and here it is the index value of the array. And remember, the index value of array always starts from 0. In the previous example, that was only for basic understanding, so I just started that with 1. In the practical way, the array index always starts from 0. So followed by the one-dimensional array, we will deal with the multi-dimensional arrays. In that, we have the following. The first one is the two-dimensional array, and the second one is the three-dimensional array. In the multi-dimensional arrays, we require more than one subscript. In the previous example, we had one-dimensional array, so the subscript is just 1, that is 10 columns, right? So we just had one single row and 10 different columns. But in the multi-dimensional arrays, we need multiple rows and multiple columns, right? So we need 2 subscripts for two-dimensional array and more than 2 subscripts for three-dimensional arrays. So first we have the two-dimensional arrays. The 2D array is organized in the form of a matrix, which can be represented as a collection of rows and columns. So here is the example. As you can see on my screen, we have 3 columns and 3 rows. And we have 2 subscripts that define the number of rows and the number of columns and the elements in each and every row. So the 1, 2, 3 confines the first row, 4, 5, 6 confines the second row, and 7, 8, 9 will be the third row. Now similarly, we have three-dimensional arrays. A 3D array is a collection of 2D arrays which consists of 3 subscripts: block size, row size, and column size. So here we have an example for that. So we have 3 subscripts. That is, the first one is block size, the second one is the row number, and the third one is column number. So this happens to be the first block, this happens to be the second block. And this is how a 3-dimensional array can be represented. Now we have the next stage where we will understand how to declare the arrays. And the syntax is right on my screen. You need to specify the data type of the array, which is integer, float, or character, any selection which you make. Followed by that, you need to select an array name for your array, and inside that you need to declare the array size. And sometimes you can also eliminate the array size if you wanted to, have a dynamic array. And here is an example for that. You have integer data type, name of the array is example, and the array size is 6. So the compiler will allocate continuous memory block of 6 integer type blocks. So these are the few more methods to initialize the array. So here you can see integer data type, array name is A, element size is 5, and we have 5 elements. The method 2 is, remember I've said you can eliminate the size of the array, right? So here you can use this way as well, integer data type, array name A, and no size here, and you can directly declare the elements. And the method 3rd. So here you have the name of the array, size of the array, and you are allocating the elements to the individual memory locations. This is also another method to initialize array. And method 4 is using a for loop. You can just initialize a for loop and the I value will be stored in the array locations starting from 0. Now let us understand how to access the elements in an array. So to access the elements in an array, you need to specify the name of the array and memory block where you have that element that you want to access. So here we have an example, which is integer data type. Name of the array is XYZ, and the element we wanted to access is 5. So here we have an example that is integer type array. Array name is XYZ, and it has the size 5. And now we wanted to access the first element in an array. That can be done using the first index, that is XYZ of 0 index, that is the first element, and accessing the second element, and so on. XYZ of 1 will be the second element, XYZ of 2, 3, 4 will be the third, and fourth and fifth elements. Now let us understand some basic operations that can be performed on the array elements. So the following are the operations that can be performed on the array elements, that is the traversal, insertion, deletion, searching, and sorting. Now let us get into practical mode and try to execute some examples based on traversal of the array, insertion of an element into the array, deletion of an element from an array, searching for an element in an array, and sorting the complete array. So at first we'll carry out the traversal operation. So here we have an array that is A of 5 and the elements are 1, 2, 3, 4 and 5. Now we're going to use a for loop to traverse through this array and print all the elements sequentially. Now let us execute this code and see the output. So as you can see, the code got successfully executed and the elements, that is 1, 2, 3, 4 and 5 from the array A are printed sequentially. Now moving ahead, we'll try to execute some examples based on insertion of element into the array. So on my screen you can see an example for inserting an element into the array at the starting position of the array. Now let us try to execute this code and see the output. Don't worry about the codes. These code documents will be attached in the description box below and you will be able to have an access to it and run these codes in your personal laptop and get a better learning experience. Now you can see the code got successfully executed and now it is asking for the size of the array. Let's declare it as 5 and now let's enter the elements into the array. Now it is asking for the element to be added at the beginning of the array. Now we have 2, 3, 4, 5 and 6 existing in the array. Let's add the first element, 1, and there you go. The resultant array is 1, 2, 3, 4, 5 and 6. The element which we added at the ending, which is 1, is supposed to be in the first or the beginning part of the array, which is here at the first index location as planned. Now let's get started with another example on the insertion. Now let's try to insert an element at any given location as per the user's choice. So as you can see, we have a program on my screen and running this program must help us to insert an element into any given location of the array. Now let's try to quickly run this program and see the output. So there you go. Enter the elements into the array. Let's enter 1, 3. Let's try to run this program and see the output. So there you go. The program got successfully executed, and now the output is asking for us to tell it the number of elements in an array. Now let's say 4 elements. So now let's enter the 4 elements. 1, 3, 4, 5, and 6. Okay. So the 4 elements, which is 1, 3, 4, 5, are been inserted. Now it is asking for the location where you want to insert the element. Now let us insert it in the second location. Now let us set the value as 2, and there you go. The resultant array is 1, 2, 3, 4, and 5, and the element, which is 2, was supposed to be added in the second location, and it has been successfully added. Now let's try to execute another example based on insertion, where you will try to insert the element in the last position. Now this program on my screen will help us to add an element at the end of the array. Let's quickly run this program. Now it is asking for us to enter the 5 elements of the array. Let's enter that. Now it is asking to enter the element to be inserted. Now let us enter the element, and this element should be added at the end location as discussed. The resultant array is 1, 3, 5, 7, 9, and 11. Now let's continue with the deletion operation. Now the program on my screen is an example for deleting an element from the beginning position of an array. Now the program got successfully executed, and it's asking for us to enter the size of the array. Let's enter the size as 5. And now let's enter the elements of the array, that is 1, 2, 3, 4, and 5. Now the element from the first location, that is 1, has been deleted, and the resultant array is 2, 3, 4, and 5. Now the code on my screen will help you to eliminate the element from the ending location of an array. Now let's try to quickly run this program and see the output. So you can see that the program is successfully run, and it is asking for us to enter the size of the array. Let's enter 4. Now let's enter the elements of the array, that is 1, 2, 3, and 4. Now after eliminating the last element from the array, that is 4, we have the resultant array, that is 1, 2, and 3. Now a little homework for you guys. Let's try to execute an example for deleting an element from any location of an array. This will be a homework. Now don't worry, try on your own, and if you don't get that, you can refer to the comment sections below, where you have the code document attached in the description box, and you can refer to it. Now let's continue with the next operation, where we will search for a given element in the array. So you can see that on my screen we have an example which will help us to sort the elements in an array. Let's quickly run this. So there you go, the program got successfully executed, and now it's asking for the array size. Let's enter 5, and now let's enter the elements in a random order. Now the resultant array should be sorted. So there you go. The array after being sort is 2, 3, 5, 14, and 21. So there you go, the array got sorted. So now we have finished our practical session. Let's have a quick overview again. So traversal in an array is a process of visiting each element once. Traversal can be done by various means, that is by counting the array elements, printing the values sorted in the arrays, and sum of all elements present in the array, and many more. So this is how we traverse our array from the first location to the last location. Again, the insertion operation. Insertion in an array is the process of including one or more elements in an array, and it can be done at the beginning, at the end, and at any given index of an array, which we executed for all the 3 types of examples. Now next we have the deletion operation. So deletion operation, or deletion of an element, is a process of removing a desired element and reorganizing the array, and it can be done at the beginning, at the end, and at any given index. So we have executed the example for at the beginning and at the end, and the homework was at the given index. Don't worry if you don't figure it out, you can always refer to the example document which is mentioned in the description box below. Now the search operation. Searching is a process of finding a given value in the list of values, and it decides whether the search key is present in the array or not, and we have executed an example on that. And again, the sort operation, where we will sort the given array. If the given array is not in the default order or in a given order, that is ascending or descending, then we can sort the order of the array by the user's choice, given it is ascending order or descending order. Now in the next section of the tutorial, we will discuss the advantages of using arrays. So the first one is array stores multiple elements of same data type with same name. Next one, elements in an array can be accessed randomly using just the index number. Array memory is predefined, so there is no extra memory loss. Array avoids memory overflow. And finally, 2D arrays can represent the tabular form of data in a very efficient way. Now let us also have a look on some of the disadvantages of using arrays. The first one, the number of elements in an array should be always predefined. So there is no chance that you can add some extra element in the last moment. Array is static in nature, so its size cannot be varied after declaration. What if, consider that you wanted to store 10 student data in one array and you end up having just 7 students. So the remaining 3 is a waste, right? So you are wasting memory there. That's the problem. And insertion and deletion operations in an array is quite difficult as the array stores elements in a continuous form. And finally, allocating excess memory than required may lead to memory wastage. So we will see a brief definition of arrays. The array is a data structure that stores elements of the same data type in a sequential order. Two-dimensional arrays are considered as an array of arrays. Two-dimensional arrays represent the information in the form of rows and columns, which is completely similar to a tabular form of data. Following by the definition and briefing of the two-dimensional arrays, we will understand the need for two-dimensional arrays. So the main advantage of using a two-dimensional array is the elements can be represented in the form of a matrix, that is rows and columns. Using two-dimensional arrays, we can initialize, access and print multiple elements in the matrix form by just running one single code segment. You can see an example right on my screen here. This is an example of marks list. Suppose a class has 3 subjects, namely English, Science and Maths. We have 4 students and we wanted to represent the data in the form of a database. So here, the marks of the 4 students can be represented using two-dimensional arrays. Now, we will see the syntax of a two-dimensional array. So here, the syntax. At first, we need the data type. The data type can be integer, character, float, string, etc. Then we have the name for the two-dimensional array. And later, we can have 2 subscripts which represent 2 dimensions, that is the rows and columns. The first subscript defines the number of rows and the second subscript defines the number of columns. And note that the column number can never be null. At the end, we have a semicolon to terminate the syntax. And here we have some examples of two-dimensional arrays. So in the first example, we have the name of the two-dimensional array and we have 3 rows and 4 columns. And followed by that, we have another example which is of character data type and the name of the array is names and we have 7 rows and 15 columns. Next, we will see how to visualize two-dimensional arrays. We read earlier that two-dimensional arrays are a collection of rows and columns. Let's see an example of two-dimensional array. We will consider an array with 6 rows and 4 columns. As you can see on my screen, we have integer type array and the name of the array is array and we have 6 rows and 4 columns. The product of rows and columns will give us the total number of elements present in a two-dimensional array. In the current example, we have 6 rows and 4 columns and the product is 24. So we must have 24 elements in this array. Next, we will see how to initialize two-dimensional arrays. So there are two ways to initialize a two-dimensional array. So in the first method, we declare the elements in the set of curly brackets. This array consists of 3 rows and 3 columns. Note that the index always starts from 0. Here we have 3 rows. It means the row starts with 0 and ends with 2. The same goes for the column. But sometimes this method might be a little confusing. So we have a better method. The advantage of this method is clarity. We can visualize all the elements with better clarity compared to the previous method. So the first 3 elements are 9, 6 and 1. They are present in the first row. And in the second row, we have 144, 70 and 50. They comprise the second row. And finally, the third row in which the elements are 10, 12 and 78. So far, we have learned how to visualize and initialize a two-dimensional array. So we have done it by using the index values, that is the row index and the column index. So the row index value was 3 and the column index value was 3. For accessing an element in the two-dimensional array, we need to pass the name of the two-dimensional array followed by the row index value and the column index value. For example, let us assume that we wanted to access the element 9. For doing so, we will pass the name of the array followed by the row index value and the column index value as shown below. That is int first 0, 0. And an important point here is indexing always starts with 0. We will now start printing the two-dimensional arrays. So to print a two-dimensional array, we will be using 2 nested for loops. So to understand the process of printing the two-dimensional array, let's get back to the practical mode and we will work on a code. So on my screen you can see an example for two-dimensional array. So here we have declared an array with the name first and we have 3 rows and 3 columns. And inside that, the first row of elements is 9, 6, 1 and the second row of elements is 144, 70 and 50 and the third row of elements is 10, 12 and 78. Followed by that we have 2 counter variables which are I and j. So we are using the first counter variable I in the outer for loop and the second counter variable j in the second inner for loop. And inside the inner for loop we have a print statement which is used to print the elements in the array. Now let us try to execute this code and see the output. So you can see the code got successfully compiled and we have our elements here, which is 961, 144, 70, 50, 10, 12 and 78. Now let us understand the logic. So here we have declared the counter variable as 0 and the condition is I should be less than 3, which is true. So the control will enter into the second inner for loop. Here we have j is equals to 0 and j should be less than 3, which is true. So here the condition or the statement is valid and it will print the first element 9. Followed by that j will be incremented again. J is now equals to 1 and j is less than 3. So again we'll print the second element 6. Again j value will be incremented to 2, so 2 is less than 3. Then we will print the third element, that is 1. Now when you increment the value of j from 2 to 3, the condition will fail because 3 cannot be less than 3. So the control will enter into the outer for loop. Here we have I value is equals to 0, which will be incremented to 1. So 1 is less than 3. Again, the control will enter the inner for loop. Here again, we will check for j is equals to 0, which is true. So we will print the second row of elements, that is 144, 70, 50, in the same way how we printed the first row, right? So j will be equals to 0. So then we'll print the first element. So j will be incremented to 1 and 1 is less than 3. Then we will print the second element, that is 70. And again, j will be incremented to 2 and 2 is less than 3. So we will print the third element, that is 50 in the second row. And again, j will be incremented to 3 now. The compilation of the condition will result in false. So it will exit the second for loop and it will come back to the first outer for loop. Now the value of I will be incremented to 2. So 2 is less than 3. The control will enter into the inner for loop again. Then we will print the third row of elements. That is 10, 12 and 78 in the same way how we printed the first row and the second row. After printing the third row, the condition will fail when j value is incremented to 3 and it will enter the outer for loop. Here the I value will be incremented again from 2 to 3 and the condition fails. Now the overall control will come out of both the for loops and it will terminate here. So that's how we got 9, 6, 144, 70, 50, 10, 12 and 78.
A linked list is a linear data structure made up of nodes. These nodes consist of two parts, data and reference to another pointer. Typically, a linked list starts with a head node, which goes all the way up to the last node, which is called tail. Next, let's discuss why do we need linked list. A linked list is a linear data structure like arrays, but an array can only offer a fixed size, whereas a linked list can dynamically increase its size. Also, operations like insertion and deletion are much easier in a linked list than in an array. Now, let's try to implement the linked list in the code editor. Let's start by creating a node. To create a node, we need a class. Let's declare a class node. We will declare its member as public. The first member is int data and the second member is node pointer next. Now we will go into the main block and initialize our first node. To initialize a node, we need to use node star. The node name head equals to null. Similarly, we will create more nodes. And our last node tail. Now we will allocate these four nodes in the heap. To do that, we will use a node name equals to new node star, new node braces. Now we will allocate all the nodes in the same manner. Now we will assign data to our first node. To access the member of the node class, we will use arrow formation. Then we will use data equals to, let's give it a value as 2. Now we will link this first node with our second node. To do that, we will use head, same arrow formation and next, which will be equals to our n1 node. And now we have created our first complete node. Now let's create other nodes as well. n1 arrow data is equals to Let's give it 3 and one arrow next is equals to n2. N2 arrow data is equals to 5. N2 arrow next, 2 arrow next is equals to tail. Now tail is equals tail arrow data equals to 7 and tail arrow next is given null. Now let's call up function to print this list. We will give head as the argument, as we can only traverse a linked list from its head. Let's write a definition for this print list function. This function will be a void function. Argument is node star a. We will use while loop to traverse this linked list. We will give it condition if a is not equals to null, then cout is a data and L. Now we will change our cursor from the current node to the next node. To do that, we will use a is equals to a arrow next. Now let's try to execute this code. As you can see, we have traversed our complete linked list. Now let's get back to our slides. Now let's discuss different types of linked list. The first are singly linked list. Next is the doubly linked list, the circular linked list, and finally we have the circular doubly linked list. Let's discuss each one of these in details. First up, singly linked list. It is a unidirectional linked list. While using the singly linked list, we can only traverse it in one direction, that is from head node to the tail node. Next up, doubly linked list. It is a bidirectional linked list. We can traverse it in both the directions. In this linked list, the node has an additional pointer that points to the previous node. Next up, circular linked list. It is a regular linked list except for its last node points to the head node. Programmer needs to be careful while traversing it, or they might get stuck in an infinite loop. Next up, the circular doubly linked list. It is a combination of doubly linked list and a circular linked list. Its last node points at the head node and the previous pointer of the head node points to the last node. It is also bidirectional linked list so that we can traverse it in both directions. We have now discussed the linked list, why do we need linked lists, and types of linked list. Now let's learn about some operations we can apply on linked list. We can use majorly two operations on linked list. First up, insertion and deletion. We can perform these operations in three different situations. First, at the beginning, at the last, or at a specific position after a node. Next, we will discuss these operations in detail. First up, insertion. We will discuss first insertion at the beginning. We have to give the first node's address to the new node's next pointer to execute this. Next up, insertion at the end. We have to give the new node's address to the last node's reference pointer. Next up, insertion at a specific position. To do this, we will have to change the reference address of the previous node to the new node's address and the new node's reference pointer to the next node's address. Now, let's discuss deletion. First up, deletion at the beginning. We have to change the first node's address to the null to execute this. Next up, deletion at the end. We have to change the second last node's address to the null. Next up, deletion at a specific position. We will change the reference address of the previous node to the next node's address. We have learned a lot about linked list during this session. Now let's discuss some benefits of linked list. First up, a linked list is a dynamic data structure. That is, we can dynamically increase its size. Next, it offers easy insertion and deletion than other linear data structures like arrays and string. Since it can dynamically increase its size, resulting in no memory wastage. Next, it is pretty handy in implementing complex data structures like stacks and queues, etc. Now, let's talk about some disadvantages as well. First up, since the linked list is made up of nodes, it takes extra storage for storing data and reference pointer. Next, the traversal in the linked list is a bit harder than other data structure. Reverse traversing is easy in doubly and circular doubly linked list, but since it uses one extra pointer, it takes extra storage, making it another limitation. So without any further ado, let's get started with introduction to singular linked list. A single linked list is a linear data structure made up of nodes. These nodes consist of two parts, data and reference to another pointer. These nodes can be traversed using pointers. It starts from the head node all the way up to tail node. Now let's try to implement the single linked list in the code editor. Start by creating a node. To create a node, we need a class. Let's declare a class node. We will declare its member as public. The first member is int data and the second member is node pointer next. Now we will go into the main block and initialize our first node. To initialize a node, we need to use node star. The node name head equals to null. Similarly, we will create more nodes. And our last repeat, and our last node tail. Now we will allocate these 4 nodes in the heap. To do that, we will use a node name equals to new node star, new node braces. Now we will allocate all the nodes in the same manner. Now we will assign data to our first node. To access the member of the node class, we will use arrow formation. Then we will use data equals to, let's give it a value as 2. Now we will link this first node with our second node. To do that, we will use add same arrow formation and next, which will be equals to our n1 node. And now we have created our first complete node. Now let's create other nodes as well. N1 arrow data is equals to, let's give it 3. N1 arrow next is equals to N2. N2 arrow data is equals to 5. N2 arrow next, 2 arrow next is equals to tail. Now tail is equals, tail arrow data equals to 7, and tail arrow next is given null. Now let's call up function to print this list. We will give head as the argument, as we can only traverse a linked list from its head. Let's write a definition for this print list function. This function will be a void function. Argument is node star a. We will use while loop to traverse this linked list. We will give it condition if a is not equals to null, then cout is a data and L. Now we will change our cursor from the current node to the next node. To do that, we will use a is equals to a arrow next. Now let's try to execute this code. As you can see, we have traversed our complete linked list. Now let's get back to our slides. We have now introduced the single linked list. Now let's discuss some of the operations we can apply on a linked list. First up, insertion. We can perform insertion at three different situations, like at the beginning, at the last, or at a specific position after a node. Next up, deletion. Similar to the insertion, we can perform it in three different situations as well. At the beginning, at the last, or at a specific position after a node. Let's talk about them in detail. First up, insertion at the beginning. To execute this, we have to give first node's address to the new node's next pointer. Next up, insertion at the end. To execute this, we have to give new node's address to the last node's next address. Next up, insertion at a specific position. To execute this, we will change the previous node's reference address to the new node's address and the new node's reference pointer to the next node's address. Now, let's try these operations in a code editor. As you know, a linked list is made up of nodes, so we should start by creating a node. To create a node, we need a class node and we will define its members as public int data and node pointer next. Now we will create a function to insert a new node in front of the list. For this function, as an argument, we will give the reference to the head of the list and integer new data. Now in the definition, we will allocate a node new node equals to now we will put in the data in the new node. We will use arrows to access the data equals to new. Now we will make the next of this new node as head. Now we will move the head to point to the new node. Now we will create another function to insert a node after a specific position. As arguments, we will give it the address to the previous node and the integer new data. We will first check if the given previous node is null, if it is, we will print given node cannot and then we will return the function. Otherwise, we will allocate a new node and then we will enter the new data in that. Now we will make the next of the new node as a next of the previous node. And then we will move the next of the previous nodes as new node. Now we will write a function to insert a node at the end of the list. As an argument, we will give it a node pointer to pointer head and integer new data. We will first allocate a new node we will also create a last node and give it head. Now we will put in the data in the new node since this new node is going to be the last node, so we will make its next as null. Now, if the linked list is empty, then we'll make the new node as head. To check that, we will use if star head is equals to null. If it is, then we will do star head equals to new node. Else, we will traverse it to the last node. While last, next, not null, last is equals to last, next. Now we will change the next of the last node as new node. Return. Now we will write a function to print this list. While node is not null, cout node arrow data handle and node equals to node. Now we will write the code for the main block. First, we will define a head node. And mark it as null. Now we will start using those functions to make a linked list. First, we will use append function to add 6 in it. Next, let's use another function push and add 7 in it. Now we will try to insert 1 at the beginning. So we will use push again. Comma 1. Now let's try to insert 4 at the end. So far the list looks like 1, 7, 6, 4, null. Now let's try to insert 8 after 7. To do that, we will use insert after. As argument, we will use head next as 7 is present next to the head, comma 8. Now let's try to print this linked list. Cout created linked list print list head. Return 0. Let's execute this. As you can see, we have created the linked list in the correct order. Let's get back to our slides. Now let's talk about deletion. First up, deletion at the beginning. To execute this, we have to change first node's next address to null. Next up, deletion at the end. To execute this, we have to change the second last node's address to the null. Next up, deletion at the specific position. We will change the previous node's reference address to the next node's address. Now, let's try these operations in a code editor. We will start by creating a class node. In this class, we will declare the members as public int data and the node pointer next. Now to insert the data in the node, we will use a function push as argument. We will give pointer to pointer node head and integer new data. We will allocate a new node we will give this new node the data as new data and new nodes next as head. Now we will write a function to delete the node. As argument, we will give a node pointer to pointer, head, and int key. Now we will store head in a temp node. And we will create a node prev as null. If head node itself holds the key to be deleted, we will use if temp is not equals to null and temp data is equals to key. Then head equals to temp next. Now we will free the old node. Else we will search for the key to be deleted. Else while temp is not equals to null and temp data is not key, so prev equals to temp and temp will be iterated to its next. If the key is not present in the linked list, then we will just return the function else we will unlink the node from the linked list. And delete. Now we will write a print list function to print the list. Its argument will be a node pointer node while a node is not null. Cout less than node data we will iterate this node using node equals to node next. Now we will move on to the main block. We will start with the empty list node star head equals to null. Now we will add the element to this list. So push ampersand head comma 7. Next push percent head comma 2 push ampersand head comma 5. Next push ampersand head comma 9. Now see out created list print list head Now we will use delete node function. Delete two. We will use argument as ampersand head comma 2. Now we will check the linked list. Of 2. Print list Let's try and execute this. As we can see, we have deleted the 2 from the linked list.
A doubly linked list is complex as compared to a singly linked list. In the doubly linked list, the traversal happens in two ways, forward and backward direction, and each node consists of data and address of the previous and next node. As it is clear from the above diagram that the first node's previous is pointing to null, which means no more nodes before it, and its next part is holding the address of its next node, that is the address of second node. Similarly, second node previous is holding the address of the first node and next is holding the address of the third node. Followed by that, the third node's next is pointing to the null because no other node after it, and its previous is holding the address of the second node. This will continue as many nodes are in the doubly linked list. And the elements are located at some random location in the memory. For example, as you can see, if the first element is inserted at the location 2000, then the next element would be located at 2016 and then at the next free location, and so on. Moving ahead, let's have a look at the doubly linked list memory representation. Let's consider one example and understand the representation of a doubly linked list. So, consider three elements to be inserted into the list, where each node consists of data part and address part of previous and next node, and it is stored at some address 2000, 2016, and 2022. The address of the first node is stored in the special node called head node. As I discussed before, the first node's previous is pointing to null because there are no nodes before it, and the last node next is pointing to the null because there are no nodes after it. Every node in a linked list is connected in two ways from forward and backward direction with the other through the pointers called previous and next that points to the address of its previous and next node. It is represented by the arrows in this diagram. For example, so let our elements to be inserted be 10, 20, and 30. And the address of the first node is stored in the head node. And the next part of the first node, that is this, is holding the address of the next node, that is 2016. And its previous is pointing to the null. Similarly, the second node is holding the address of the third node, that is 2022. And its previous is holding the address of its first node, that is 2000. Whereas the third node, the previous is holding the address of its previous node, that is 2016, and its next is pointing to the null. And in this way, they are linked together. Up next, we have the syntax of a doubly linked list. A doubly linked list consists of an extra pointer compared to a singly linked list. So, the syntax starts with a struct keyword followed by structure name called node. Then we have the variables declared, that is data, and struct node asterisk next and previous, a pointer variables pointing to an element of a structure node. So with this, let's try to execute a simple doubly linked list program to understand in a better way. So from this program, we are going to create 4 nodes and insert the elements into it. So we have previously discussed this syntax of a doubly linked list. So here we have a previous and next pointer variable. So moving ahead, we'll see that we have a head node and we are creating first, second, and third and fourth node. So initially those are null. So they are initialized to null, and for creating we need to allocate the memory for it, right? To create a node, we need to create memory for it. For that we are using malloc function to allocate memory for the node first, second, third, and fourth. And once we create memory, we are going to assign the values to it. So here the values are 10, 20, 30, and 40. So these values are assigned in the first data part, in the second data part, third data part, and the fourth data part of every node. And once after assigning, we need to link these nodes together. So for that, we have the first next part is assigned to the second. That means it holds of the second element. And its previous is assigned to null because there are no node before it. And the second node's next part is assigned to third, and its previous is assigned to first. Similarly, the third next is assigned to fourth, and its previous is assigned to the second node. And the last node, that is fourth node's next, is null because there are no node after it, and its previous is assigned to third. That means it holds the address of a third element. And now the first is assigned to head. That means the address of first node is holding in the head node. And finally, displays the first. So this display function we have to display all the element in a doubly linked list. So this will So as you can see, here we got the output. The doubly linked list elements are 10, 20, 30 and 40. Okay, so now let us move on to the operations on a doubly linked list. First, we have insertion operation, next deletion operation, and finally traversal operation. So let's understand them in detail. Under insertion operation, we have insertion at beginning. So basically, we insert the element at the beginning of the element list. Next, insertion at end. That means it inserts the element at the end of the element list. And lastly, insertion after specified node. That means it inserts the element after some specified node. So now, let's run the program and understand these operations practically. So using insertion operation, we are going to execute a simple program. So we have previously discussed that we have two pointer variables, that is previous and next, that is pointing to its previous and the next node. And first let's discuss the insertion at beginning operation. So basically we are going to insert a node at the beginning of a linked list. So for that we are creating a new node and allocating memory for it using malloc function. Once creating the memory, the new data part, the new node's data part is holding the new data. And the next is pointing to the head. And its previous is pointing to the null because there are no nodes after it. So if head is not equal to null, that means head's previous is equal to new. And now new is assigned to the head. So it's simple. Now the head is holding the address of a new node. Next, coming to the insertion at end. So here again, we are creating a new node, allocating memory for it, and that new data is holding the new data, and its next is pointing to null because there are no more nodes after it. And we are creating a temporary variable where true hold the address of a head. So now if the head is equal to null, that means new previous is pointing to the null and new is assigned to the head and return. While the temp next, if it is not equal to null, then the temp next is assigned to the temp variable, and now the new is assigned to the temp next, and temp is assigned to the new previous. So now the last node is inserted. Now coming to the insertion after node, that means inserting in between of two nodes. So if previous node is equal to null, that means the given previous node cannot be null. For that, we are creating again a new node and allocating memory for it using malloc function, and its new data is holding a new node's data part is holding the new data, and the new node next part is assigned to the previous node's next, and we are just changing the addresses. So now here previous node next is pointing to the new, and the previous node is now assigned to the new previous. So if new next is not equal to null, that means new next previous is equal to new. So coming to the display here, while node is not equal to null, it will print all the node data till it finds the null. And here in the main function, we are creating a head which is initialized to null initially, and when the control comes to the insertion at end, it will print a value 4. And next, when it encounters the insertion at beginning function, that means it will insert 2 in front of the element 4. And again, insertion at beginning. So it insert the element 1 in front of element 2. And similarly, insertion at end. That means it will print element 5 after the element 4. And insertion after node head next. That means it will insert the element after the element 2. So now let's try to execute and run the program. So as you can see, the elements are listed in a proper way. That means we have the elements 1, 2, 3, 4 and 5. Followed by that, we have deletion operation to delete from the beginning, delete from the end, and delete after a specific node. So now let's run a program. So now we are going to perform the deletion operation. So for that, we have a function called deletion node. So basically we are going to delete a node from a list. So first, it checks the condition if head is equal to null or node delete is equal to null. That means a node to be deleted is also equal to null, then it will return. That means the deletion is not possible. Next, it checks the next condition if head is equal to node delete. That means if a node to be deleted is our first node, then head is equal to head nodes next. That means the head node next is assigned to the head. Next condition, if node delete next is not equal to null, that means if it is not the last node, that means point the previous next node to the node delete previous. And finally, if node delete previous is not equal to null, that means if the node to be deleted is not the first node, then point the next previous to the delete node delete next. And finally, we are going to free up the memory space for that node. And coming to the main function, where we have print function, after deleting an element, it's gonna delete the node. So here after the head, next 1 2 3 4th. So after the fourth node, it's gonna delete the fifth element. That is, it will delete the last element 5. So let's check the output. So as you can see, after deleting an element, so our previously inserted elements were 1, 2, 3, 4 and 5, and after deleting, now the element 5th is deleted. Finally, we have traversal operation. In this operation, we visit each and every node at least once, maybe to display all the data elements or to perform operations on it. So let's understand it practically. So here we are going to perform a traversal operation. That means it actually visits each and every node at least once and display them. So here, using a display function, we are going to display all the elements that are present in a linked list. So now let's try to execute and run it. So as you can see, first the inserted elements were 1, 2, 3, 4 and 5, and after deleting an element, now the elements are 1, 2, 3 and 4. That means the fifth element got deleted, and now the final list of elements are 1, 2, 3 and 4. I hope you got a clear understanding of how to perform insertion, deletion and traversal operations in Doubly linked list. Now let's begin by understanding what a circular singly linked list is in C. In a circular linked list, we can perform a circular singly linked list and circular doubly linked list. So this session is on a circular singly linked list. In the circular singly linked list, there is no null in any of the nodes. Instead, the last node's next pointer holds the address of the first node. So basically, there is only one pointer variable in the circular linked list. And the traversal of a circular linked list is until we reach the same node we started in a list. Moving ahead, let's have a look at the circular singly linked list memory representation. So first, let's consider 4 elements to be inserted into the list. And for that, we have 4 nodes, where each node consists of data part and address part stored at some address 2000, 2016, 2022 and 3000. In the singly linked list, the last node points to null. But when we compare a circular linked list with singly linked list, we don't find a null. Which means, in a circular linked list, the last node's next pointer holds the address of the first node. In other words, we can say that the tail node's address is pointing towards the head node of the linked list. And as I discussed before, every node in a linked list is connected with the other through a pointer that points to the address of the next node. And that is represented by the arrows in this diagram. For example, So let our elements to be inserted be 10, 20, 30 and 40. As you all can see, the last node next is holding the address of the first node, that is 2000. And the next part of the first node is holding the address of its next node, that is 2016. Similarly, the second node is holding the address of its third node, that is 2022. And the third node is holding the address of its next node, that is 3000. And the last node is holding the address of the first node. And in this way, they are linked together. Up next, we have a syntax of a circular singly linked list. The syntax of a circular singly linked list is similar to that of a singly linked list. So, we have a struct keyword followed by a structure name called node. Then, we have a variables declaration, that is data and struct node asterisk next, a pointer variable pointing to an element of a structure node. So with this, let's try to execute a simple circular singly linked list program to understand in a better way. So in this program, we have a pointer variable called next, and inside the main function, we are creating nodes, and they are first, second, third and fourth. So for every node, we need to allocate memory for it. So using malloc function, we are creating memory, or we are allocating memory for it. And once allocating memory, we are inserting values into it, and the elements are 10, 20, 30 and 40. And once inserting value, we need to link each and every node. So for that, first next is holding the address of second node, second next is holding the address of third node, and third next is holding the address of fourth node, and the last node, that is fourth node next, is holding the address of its first node, and last is equal to fourth. And display function will display all the elements in a circular singly linked list. So it first checks the condition. If the last node is equal to null, then the list is empty. Pointer is equal to last node's next, do. So it checks the condition. It prints the values, that is pointer's data. It prints the data of every node and then checks the condition while pointer not equal to last node's next. So now let's try to execute. And here we got the output. The elements are 10, 20, 30, 40 inserted into a circular singly linked list. Okay, so now let us move on to the operations on a circular singly linked list. First, we have the insertion operation. Next, the deletion operation. And finally, the traversal operation. Let's understand them in detail. Under insertion operation, we have insertion at beginning. So basically, we insert the elements at the beginning of the element list. Next, insertion at the end. That means it inserts the element at the end of the element list. And lastly, insertion after a specified node. That means it inserts the element after some specified node. Now let's run the program and understand these insertion operations practically. So in this program, we are going to perform insertion operation. So first let's start with insert to empty list. So we are going to insert a new node into an empty list. So if head is not equal to null, then return head. Create a new node and allocate memory for it. And once creating memory, assign a data. And now the new node is equal to head. And head next, that means creating a link to itself. Head next is equal to head and return head. And next we are going to perform insertion at beginning. So insert a new node at the beginning of a linked list. So if head is equal to null, then return to insert to empty list function. Create a new node and allocate memory for it. And then assign a value for a new node. So new data is equal to data. Now new next is equal to head next. So the new is the head node, return head. Let next, we are inserting an element at the end of a linked list. So for that, it checks the condition. If last is equal to null, return to insert to empty list function. And create a new node, allocate memory and assign a data. And now link the address. So new next is equal to last next. Now the new node is the last next and written last. Next we have insertion after node. So it checks the condition last is equal to null, then return null. Else we are creating here the new and a pointer variable. Pointer is equal to last next. So do if pointer data is equal to element, that means if we find the element, then allocate memory for the new node and assign a data. And now new next is assigned to pointer next. And now the pointer is assigned to the pointers next. And if pointer is equal to last, then assign new to last and return last. Next, pointer is equal to pointers next. So while pointer not equal to last next, the given node is not present in the list and return last. Next we have display function where it displays all the linked list elements. So for that it checks the condition if head is equal to null, then the list is empty. Else it will print all the elements of a node. So now coming to the main function, here we have inserting values. There are 20, 25, 10, 15. So first insert to empty list. So we are inserting the 20 to the empty list, that is the first element is 20, and then coming to insert at end, after 20 it will print 25, and insert at beginning. So before 20 and 25 it will insert element 10, and insert after node, that means after 10 it will print 15. So now let's execute and see the output. As you all can see, it is printed in a order 10, 15, 20 and 25. Followed by that, we have a deletion operation to delete from the beginning, delete from the end and delete after a specific node. So now let's run a program. So in this program, we are going to perform a deletion operation. So we are basically deleting a node. So for that we have a delete node function. It first checks the condition if last is equal to null. That means if the linked list contain no elements, then it return. Else it will check whether the list contain a single element. So if last data is equal to key node and last next is equal to last, then free the last and assign last is equal to null and return. Next, creating a temp variable is equal to last and delete node. So here it will delete a last node. So for that, if last data is equal to key node and while temp next is not equal to last, and assign temp next to temp. So here the last next is assigned to temp next and free the last, and temp next is assigned to last. Then we are traversing to the node, or we are finding the node to be deleted. So for that we have while temp next is not equal to last and temp next data is not equal to key node, then assign temp next to temp, and if the temp next data is equal to key node, that means if you find the node to be deleted, then assign the temp next to delete node and delete node next to temp next and free up the delete node space. And then coming to the main function, it prints after deletion the linked list elements. So we are going to delete the element 15 from the list and it displays the element. So now let's execute it. So as you can see here, the linked list elements were 10, 15, 20 and 25. So after deletion, that means we deleted the element 15. So after deletion, the linked list elements are 10, 20 and 25. And finally, we have traversal operation. In this operation, we visit each and every node at least once, maybe to display all the data elements or to perform operations on it. So let's understand it practically. So in this program, the display function works as a traversal. So it traverses the every node in a linked list. So basically, it first checks the condition. If head is equal to none, then the list is empty. It prints the list is empty if it does not find any node in a linked list. Then it returns. Now assign the head next to pointer so that it prints the data of every node and checks the condition while pointer not equal to head next. Coming to the main function, here we have it prints the elements of a linked list. That means after the insertion and deletion operations, it will print all the elements present in a linked list. So now let's try to execute it. So here linked list elements are 10, 15, 20 and 25. So after deletion, the linked list elements were 10, 20 and 25. Then it displayed the elements after deletion and insertion. The elements are 10, 20 and 25. So the final linked list elements are 10, 20 and 25.
So at first, what exactly is an array? So an array is a linear data structure that stores homogeneous data elements in a continuous form. So homogeneous in the sense, you will be able to store only one single data type of elements in an array. For example, consider that you have declared an array and you wanted to store some elements in the array. So you can declare a data type first, after that the name of the array, and if you declared that the array should store integer data type, then you can only store integer elements in that particular data type. You cannot store any other data type like float or character. That is the meaning of this particular definition. And it stores the elements in a continuous order, that is in the adjacent format, as you can see in the example here, 10, 20, 30, 40, and which are located in the adjacent locations, that is 0, 1, 2 and 3. Now let us understand what exactly is a linked list. So similar to array, even a linked list is a linear data structure, but the only difference is it is a dynamic data structure. Here you can increase or decrease the size of the linked list in runtime. The only difference is here the memory locations are not adjacent to each other, but they are taken from the memory heap. So there is a huge memory chunk. Out of that, the linked list will borrow some of the memory locations, and one after the other, the memory nodes will be interconnected using pointers. So that was the difference between array and linked list. And similar to arrays, even the linked list store homogeneous type of elements. That is, if you declare a linked list of float data type, then you can only store float data type in it. You cannot store any other different data type like character or string. Now followed by that, let us understand the types of arrays. So basically we have three different types of arrays. Those are the one-dimensional arrays, and inside multi-dimensional arrays we find two more types. Those are the two-dimensional arrays and three-dimensional arrays. Now one-dimensional arrays will be having only one subscript, that is, they'll be having only one single row. Whereas in the two-dimensional arrays we will be having two subscripts, that is, it will be having rows and columns. And in the three-dimensional arrays it will be having three subscripts, that is, the row, column and the block address. Now followed by the types of arrays, we will understand the types of linked lists. So similar to arrays, even linked lists are divided into three types. They are singly linked list, doubly linked list and circular linked list. The difference between them is a singly linked list will have two parts, that is the node address and node element. In this particular segment, the element will be stored, and in this particular second segment, the address that points to the next node will be saved. And similarly in the circular linked list, the only difference between the singly linked list and the circular linked list is at the end of the singly linked list you can see a null pointer which indicates the end of the linked list. But in circular linked list, the address will not be null. Instead, it will point back to the head node. That is what which makes it as a circular typed singly linked list or a circular linked list. When it comes to the third type, that is the doubly linked list, we can see there are two address locations. The first starting node will have null as its first address location, then we'll store the element, and the second address location will point to the next node. And you can see in the second node will have element, and the first address location will point to the previous node, and the second address location will point to the next node. And at the end, the second address location will be pointed as null, which indicates as the end of the linked list. Now that we know the types of linked list and arrays, we will look into the fundamental differences between arrays and linked lists. So the first fundamental differences between the arrays and linked list is the array element can be accessed randomly using just the index values. But whereas random access is not possible in linked list. If you want to access any element in linked list, you need to perform the traverse operation sequentially. The second difference between the both is array is static, which means memory size is fixed, which cannot be changed in runtime. But whereas in the linked list, the memory is dynamic, which means you can either shrink or expand the memory in runtime according to your requirements. Followed by that, the next difference is each element in array is independent in nature. That is, you can access any element just by giving the index location. Whereas in linked list, the elements are interdependent on each other. Whenever you want to access a specific element, you need to go through the other elements or traverse through the other elements. Next one is the array takes more time in operations like insertion and deletion, whereas linked list takes less time to perform the operations of insertion and deletion. Followed by that, the next difference is accessing any element is faster in array as random access is possible, and the array data structure just by using its index values. But whereas accessing an element in linked list is slow, because we know that we need to traverse through all the node elements to access a particular element. Now the next difference is, in case of an array, memory allocation is done in compile time. Whereas in linked list, the memory allocation is done during the runtime. Memory utilization is inefficient in an array as it is allocated as in static and it is allocated during the compile time. In case of linked list, the memory utilization is very efficient as the memory is allocated during the run.
What is a stack? So basically, stack is a linear data structure just like arrays and linked lists. The only difference is that it follows a specific order when an operation is implemented on it. So what is the specific order that it follows? That is LIFO, last in first out, or FILO, first in last out. In the next parts, we will understand this order in a much better way. All operations can be done only at the one end of the stack, that is on the top. Now we will discuss much about that in the operations part of the stack. Now let us understand the first fundamental, that is the representation of stack. That is, how do you represent a stack normally? So a stack can be represented using two different methods, that is using an array or using a linked list. So in an array we will be using the continuous memory. And in stack, we will be using a non-continuous memory, and the stack will behave like a dynamic stack or a dynamic data structure. Now the first method, that is the array method. So in this method, an array is used to represent the stack. As you can see in the image below, we have a stack. So the name of the stack is stack itself, and you can see two more things here, that is top is equals to 2 and max is 4. So the max is the value of the array or the length of the array, the maximum length of the array, and top is the position where the last element of the stack is present. Here in this case, 56 is the last element in the stack, and top is inclined, or it is addressing to that particular address, that is 2. And now let us discuss about the linked list representation of stack. So in this method, a dynamic data structure, that is a linked list, is used to represent the stack. This representation leads to a dynamic stack. It does not need to define the maximum number of elements present in the stack. Remember, in arrays, we had to define the max value. In the previous example, we had the max value as 5, but in here, you need not to assign the max value as the stack itself is dynamic. The pointers links are used to store the address of the upcoming nodes, and the variable used in this method is top. So the top is holding the address of the topmost element in the linked list representing the stack. Now moving ahead, we shall understand the basic operations on stack. Now here we will understand the previously discussed definition, that is push, pull, etc. in a much better way. So the basic operations on a stack are push, pop or pull, and peek. Now let us discuss each one of them in a detailed way. The first one is push operation. So the push operation is the mechanism of inserting a new element into the stack. As you can see, we are trying to insert the elements from the top. So the push operation basically involves the following steps. Check if the stack is either full or not. So basically, whenever you're trying to insert an element into the stack, you need to make sure that the stack is empty or it has some space. If it is full, you cannot insert an element into the stack. Step 2. If the stack is full, produce an error and exit. That's what I was talking about. Now the step 3. If the stack is not full, increment the top by 1. That is, when you're inserting an element, then you need to update the top value. For example, in the previous slide, when we had the array representation of a stack, we had the top value as 2. So if you try to include an element into the stack, then you need to update the top value from 2 to 3. That is incremented by 1. Now the fourth step, add data elements to the stack where the top is pointing. And finally, success. The push operation has been successful. So this is how you insert or push an element into the stack. Now followed by push operation, we have pop or pull. So the pop operation is a mechanism of eliminating or deleting or removing one data element from the existing stack. So we shall understand the pop operation in a much more detailed way. The operation involves checking the stack is empty or not. If in case the stack is not empty, then you can carry forward the pop operation. But in case if the stack is empty, then you have to provide an exit status and exit the control and leave the stack. So if the stack is not empty, approach the data element at the top, that is at the top position. For example, in the previous array example, remember, right, we had the top position pointing towards 2. So you need to take the control to the top position and pick out the element and pop it. And finally, decrease the top by 1. So when you eliminate the top element, then the top value from 2 will be decremented to 1. So this is how the pop operation is carried over on a stack. Next one is the peek operation. The peek operation involves returning the topmost data element from the stack without moving it. So here you can see the top is pointing to the element number 4. And you're picking the element number 4 and you're not removing it from the stack. You're just returning the topmost data element. You're passing the value of the top element. So to understand the push, pop and peek operations on stack in a much more better way, let's carry out a practical example. Now we are on the practical mode, and here you can see on my screen we have the code example for the stack. Now first we'll be checking if the stack is empty. As per the steps mentioned in the previous discussion, we will check if the stack is empty or not. If it is empty, then we will return, else we will continue. And again, another step, we also check if the stack is full. If the stack is full, we will exit, else we will continue with the operation, whatever it is, peek, pop or push. And here we have an example for the peek operation that we discussed previously, and followed by that we have a pop operation. We are trying to exclude an element from the stack, and another one we have the push operation where we'll be trying to push the elements into the stack. So these are the three functions for push, pop and peek. Now we'll try to push in the elements and also pop and try to involve some functions on it or run some operations on the stack. Now let's run this code and see the output. So you can see that the code has successfully executed and we have the statements here. The first one says the stack is not full, that is false, and stack is empty, that is true, right? And after that you can see that the elements which we tried to push into the stack, that is 11, 76, 71, 15 and 66 are been pushed into the stack. And if you clearly observe it, we have the element 11 in the bottom, 76 upon that, 71 upon that, and 15, and last 66. So the order is first in, last out. That is, the first element was pushed first, and when you are trying to eliminate the elements from the stack, then you will first pick out 66, followed by that you will pick out 15, followed by that you will pick out 71, and so on. So this is the rule what stack follows. Now I hope I made myself clear with the example. Now we shall continue with the applications of stack. So these are the few applications of stack. The first one is expression conversion. So you can see we have the infix notation, prefix notation, and postfix notation. So the infix notation is no rocket science. There is only one thing here to learn, that is we have two operands A and B, and we have one operator, that is the addition operator, in between those two operands. And when you use the prefix notation, you will have the operator located at the first place, then you will have the operands followed by it. And in the postfix one, you will have the operands first, and followed by the operands you will have the operator. So basically all the infix, prefix, and postfix notations give out the same results, but the only difference is the representation of those operands and operators. Now let us understand this in a much more detailed way. So conversion of expression from one form to another form is the main application of stack. So we have the first one, that is infix to prefix and infix to postfix. Now let us see an example. Here you have 1 plus 2 star 3 plus 4. So this is the normal infix notation. And when you try to present the same expression in the form of prefix notation, so this will be the result, and this is the result for postfix. The next one, prefix to postfix and prefix to infix. And this is the way you write the prefix notation, and if you want to convert that to infix, this is how you can write it. And this happens to be the result of postfix notation. And finally, postfix to prefix, postfix to infix, and these are the results. Now followed by expression evaluation, the next important application of stack is checking parentheses. And you can see if the parenthesis is set properly, the expression gets evaluated. If not, it will not be evaluated. Now the last one, memory management and function call. The very useful thing of using a stack is the memory will not be allocated to your stack elements unless the function is called. Here you can see it is the main function, and these are the elements that you wanted to declare into your stack. And unless you make a function call, the elements will not be declared their memory, or the elements will not get the memory allocated for them. Now another good application of stack is the backtracking problem, or the n-queen problem. The n-queen problem is an example of backtracking problem. The n-queen solution to this problem is to position the queen in such a way that the opponent queen cannot attack your queen. Now another example is string reversal. You can see on my screen we have a string that is A, B, C, D, and E. Now using stacks you can reverse this. Right? So you're basically eliminating an element and relocating it to the first place. And finally, after reversing your string, this will be your result, A, B, C, D, and E. Followed by that we have conversion evaluation. So stack is used to evaluating the expression as shown in the example. Since parenthesis has the highest precedence, 5 plus 4 gets evaluated first, and it will result in 9. Then multiplication and division have the same precedence. Now the associativity comes into picture. So the associativity is always from left to right. So first 4 into 9 will be executed, which will result in 36, and then 32 divided by 4, which will give us 8. Now we have 36 minus 8, which will give us an answer that is 26. Now the last application is the Tower of Hanoi. So the Tower of Hanoi is a mathematical puzzle consisting of 3 rods and n discs. This puzzle consists of some rules. The first rule states that one disc can move only at a time.
The second rule is that the disk can only be moved when it is at the uppermost position on the stack. The third one, no disk is allowed to place on the top of the smaller disk. So this is how the Tower of Hanoi works. So a stack is a linear data structure that follows FIFO or first in, first out principle. All the operations on the stack are done only from one end, that is the top. So you can see this image here, and this particular image of books can be considered as stack. And you can see that the addition or elimination of elements, that is books in this particular case, is happening only through the top section. Now we will understand what are the basic operations that can be performed on a stack. So the basic operations that can be performed on a stack are push, pop, and peek. So this particular image on the right side will help you understand what exactly is push, pop, and peek. As we discussed, the elements will be added into the stack from the top. So when you add an element from the outside into the stack, it will be pushed from the top. That is the push operation. And if you want to eliminate an element from the stack, it will be eliminated from the top. That is the pop operation. Apart from these two, that is push and pop, we have another operation that is called as peek. The main intention of peek is just to see the element which is on the topmost part of the stack. It will just retrieve the element from the top. It will not pop it, or it will not push any other element onto the top. It will just copy and it will just print what is present on the top. So these are the main operations, that is push, pop, and peek. Now let us see how to implement this stack using array. So implementation of stack data structure can be done in two ways, that is array and linked list. Now in this particular session, we will learn how to implement stack using array data structure. Now without further ado, let's get started with the implementation of stack. So we will be performing push operation, that is inserting a new element into the stack. Now followed by that, we will be performing the pop operation onto the stack, that is eliminating or deleting an element from the top position of the stack. And followed by that, the last operation, that is the peek operation, where we will be just retrieving the topmost element from the stack without removing that element from the stack or without adding any new element to the stack. Now that we have a detailed understanding of what are the basic operations that can be applied onto the stack, let's get started with the practical implementation. Now you can see that on my screen we have the basic fundamental operations onto stack, that is the push and pop. Now without further ado, let's get started with running this code. Don't worry about the code. This particular code will be present in the description box below, or if you need it, you can always write down to us in the comment section below and we will have it sent to your mail ID so that you can have a better understanding of the code and try to execute the code in your local system. Now let's run the code and see the output. As you can see, the code got successfully executed and the topmost element is A and the topmost element is B after the element is being popped away, and it says that the element B was popped out, and after that the topmost element was A, and after that the element A was also popped out, and now the top is pointing to -1, which means to say that the stack is empty. So with that, we have come to an end of this tutorial on stack implementation using array data structure. So first up, what exactly is a linked list? So linked list is a dynamic data structure. It allocates memory dynamically. The nodes are maintained in a non-continuous memory. That is, in linked list, we have nodes. So each and every node is connected via a pointer, which points to the address of the next node. Each node contains next pointer, that is the next pointer's address, which keeps the reference to the next node. And it also has another section which stores the data. The topmost node always contains null in its address. And this is how a linked list looks like. So this is the top, which is the beginning position of the linked list, and this is the address of the first location, and this is the next node, this is the following node, then this is the last node, and this points back to the head node. So this is how you can implement a stack like data structure using linked list. You can see that we can perform stack like operation, that is the elements are located one above the other and the top is pointing to the head node. Now let us go through the implementation of stack using linked list. First, we will go through traversing of stack using linked list. So displaying each node of the linked list representing stack is termed as traversing. Copy the head pointer to the temporary pointer and then move temporary node through all the nodes and display values of each node. So you can see the animation here will explain you how the traversal goes through the linked list in real time. Now another linked list implementation of stack is the push operation. So adding a new node to the top of the stack is termed as push operation. Generally in stack we have three operations, that is push, pop and peek. So one of the operation is push, where you add an element into the stack. In the same way, using linked list you can add a new node to the stack and point it as the top of the stack or the first element which represents the top in terms of stack. Now create a node first and allocate a new memory to it. If the list is empty and node consists of data and null is the address, it will be inserted as the first node. If there is some node already existing, then add a new node at the beginning to avoid violations. So the following animation will help you understand how we add a new element or the top element to the stack using linked lists. Now followed by the push operation, we have the pop operation. So now let us go through the pop operation. Removing a node from the top of the stack is termed as pop operation. In the same way, we will be eliminating the first node from the linked list, which is termed as top. Underflow condition may occur when you try to remove the node if the stack is already empty. In stack, node can be removed from one end only. Therefore, the value stored in the head pointer must be deleted and the node must be freed. Followed by the pop operation, we have the peek operation. Retrieving the topmost node of the linked list representing stack without removing the linked list node from the top of the stack is termed as peek operation. Generally, when you're using a stack data structure, just retrieving the value of the top node is called as peek operation. You're not going to eliminate or you're not going to add a new element to the top. You're just going to copy the element or you're just going to retrieve the element which is pointed as top. This operation is called as peek. Now, in the linked list, you can also perform this operation of peek. Now, with the theory discussed, let us execute a practical program based on stack implementation using linked list. Now, on my screen, you can see a code example using which we will implement stack using a linked list. Now, here we have the pop operation, push operation, and top, and then the main function. Don't worry about the code. This particular code snippet will be attached in the description box below, or you can also request us and we will have it sent to your mail ID and you can understand the code and try executing in your local system. Now without further ado, let's directly run the code. So there you go. The code got successfully compiled and we have tried to add some elements into the stack, that is A, B, C. And C is being the topmost element of the stack, and that element has got popped, and followed by that the element on the top currently after C being popped out is B, and the node element B got popped again, and the only element which was present in the stack is A, and that element is also popped out after performing the pop operation, and now currently the stack is empty. You can see that we have tried to push the elements A, B, C, and also we tried to pop the elements A, B, C.
You know that all of us depend on messaging applications like WhatsApp, Facebook Messenger, Instagram chats to communicate with our friends and family members. And while using them, you must have observed that the person you are trying to communicate with receives messages in the same order as you have sent them. Now the question that arises here is, how is this happening? How are these applications maintaining the order of these text messages? And the solution to these questions bring us to queue. Basically, in these applications, a queue is maintained for each user, containing the messages to be delivered to the user. When the user connects to the network, all the text messages in the queue gets delivered, and once the messages are delivered, empty queues get deleted. This example clearly illustrates the importance of data structures. So let's dive further and understand the structure of the queue in depth. But before doing that, let's look at a real-life example of queues to understand it more clearly. The most common and relevant example of a queue is a movie ticket counter. In the movie ticket counter, you must have observed that both of its ends remain open. Also, these ends are fixed with the help of barricades, and that is why no one can enter in between these ticket lines. Additionally, the person who enters first receives a ticket first, and the person who enters last will obviously get served at last. Queues in data structure resembles all these properties of a movie ticket counter, which makes them better at creating virtual first-come, first-served systems. Basically, they are defined as a linear collection of different data types that allow insertion at one end and deletion at another. Unlike any other data structure, the queue ends remain open, allowing it to have different functionalities at both ends. The end at which insertion takes place is called rear, and the end at which deletion takes place is known as front. Furthermore, there are two approaches to consider the structure of the queue, and both of them depend on the approach of the programmer. That means, being a programmer, if you consider the left end as front, then your rear node will be at right end. Otherwise, if you consider the left end as rear, then the right end will be your queue's front node. Unlike arrays and linked lists, elements in the queue cannot be operated from their respective locations. Here, they can only be operated from the front or rear position. Moving on, let's discuss the operations in queue data structures one by one. The first operation is enqueue. It is used to store the elements in the queue. Next up is dequeue. This operation is used for removing them. Further, we have isFull and isNull operations. IsFull function scrutinizes if the queue is full or not, and the isNull operation evaluates if the queue is empty. We also have a peek operation that helps you get the element from the front of the queue without removing it. Let's now understand how these operations work with the help of the following examples. Here we will look at enqueue5, enqueue1, enqueue-2, then isFull, then dequeue, peek, and isNull. But before explaining these operations, it's essential that we initialize the queue data structure by assigning some random size to it. For example, int queue of 3. By this declaration, we are assigning only 3 spaces for insertion in queue. Also, at this phase, there is no element in the queue as it's empty. So both the front node and rear node will point to the same location with null memory space in the storage system. Let's consider that null index to be -1 for ease of our convention. Now the first operation on our list is enqueue of 5. As we discussed previously, enqueue operation is nothing but the insertion of data into a queue data structure. It begins with checking if the queue is full or not. If the queue is full, then the previously assigned memory is completely filled with data elements. So insertion would not be possible. This is also known as overflow error in terms of programming. But as our queue is empty, so the insertion can be performed here. For that, we have to increment the rear pointer to index 0 from index -1. And once we do that, the data element 5 will be added to the queue. Also for front insertion, both front and rear will point to the same location as there is only one element present in this queue. Let's insert 2 more elements into this queue with the operations enqueue1 and enqueue-2. For that, we have to increment the rear pointer to the next index, which will be 1. Now, as the pointer is incremented, so the data will be entered into this position. Next up is enqueue-2. Again, we have to follow the same process of incrementing the rear pointer. We will increment the rear pointer to point towards the next index, that is index 2, and hence the data element with value -2 will be entered here. The next operation on our list is isFull. In this operation, if the rear pointer points to the max size, then the queue is considered to be full as there is no space left for insertion. In our case, the max size of our queue is 12 bytes. Additionally, we are considering to enter only 3 integer elements. And one integer data element takes 4 bytes of the memory space. That means 3 integer elements will take 12 bytes. Hence, this function will prompt queue is full on the screen. Now we will discuss the dequeue operation. If we want to access data from a queue, we have to perform 2 subtasks. The first one is access the data where the front is pointing, and another is to remove the data after access. And this complete process is called as dequeue operation. The first step of this operation is to check if the queue is empty. If the queue is empty, then there is no element available for deletion. This is a case of underflow error. But as our queue is not empty, we can proceed with the next steps. We will be accessing data from the front node, and later we will be incrementing the front pointer in order to remove the link to the previous node so that the data gets removed. Now, front will point to the index 1. Thus, the data value 5 will be removed from the queue and will also be prompted on the screen. Therefore, this function comes with an integer return type. Next up is peek operation. In this operation, element at the front node will be accessed without deleting it. The algorithm for this operation begins with checking if the queue is empty or not. If the queue is not empty, then data at the front node will be accessed with temporary variable and printed on the screen. Advancing further, let's perform 2 more dequeue operations here. First is dequeue of 1 and another one is dequeue of -2. The data at a front node will be accessed primarily, and the front pointer will be incremented to point to the next data element. When we do the pointer incrementation, the link to the previous node gets removed, which results in data deletion. Similarly, we will perform a dequeue of -2 operation here. Now, the front will be pointed to null memory space as there is no element left in our queue, and the data -2 will be removed. The last operation on our list is empty. This function checks if the queue is empty or not. In the previous procedure, we mentioned that if the front points to the null memory space, then the queue is empty. And in our case, the front is already pointing to -1. So the output of this function will be queue is empty. This is all about operations in the queue. I hope that you all are clear with these operations. Next, we will discuss different types of queues and their structures at a glance. Basically, there are 4 types of queues: linear queue, circular queue, priority queue, and double-ended queue. The structure which we have discussed till this time is that of a linear queue, so now we will move on to circular queue. The circular queue is almost similar to the linear queue, except that the last node of this queue is connected to the first. It is also known as ring buffer as all the ends are connected to another end. Additionally, this circular queue is a better version of the linear queue as it removes the drawback of insertion in the linear queue. The empty space available in a circular queue can be filled with the new element by simply incrementing the value of the rare position. We will learn about this in detail in our further sessions. A priority queue is another special type of queue data structure in which each element has some priority assigned with it. Based on the priority of each element, the elements are arranged in a priority queue. If the elements occur with the same priority, then they are served according to the first in, first out principle. In the priority queue, the insertion occurs based on the arrival, while the deletion occurs based on the priority. The above figure shows that the highest priority element comes first, and the elements of the same priority are arranged based on the first in, first out structure. The last type of queue is dequeue. Dequeue is a linear data structure in which the insertion and deletion operations are performed from both the ends. We can say that dequeue is a generalized version of the queue. Dequeue can be used as stack as well as queue as it allows the insertion and deletion operations on both the ends. If the insertion takes place at one end and deletion at another, then that dequeue is known as a linear queue. And if both addition and deletion are performed at a single end, then that dequeue is called stack. Advancing further, let's discuss some applications of queues to gauge an insight into the importance of queues. The queue data structure is used in computers, printers, and applications to utilize the benefits of the first come, first served technique. In computers, whenever you work on documents or PPTs, you must have observed that whichever key you press on the keyboard appears in the exact same order on the screen. But when your processor is too busy with other tasks, you might notice that the keys you press appear on the screen with some delay after you press them. Basically, those keys are stored in queue, and when the processor becomes free, it processes in the order the keys are pressed. That means the key pressed first will be written in a Word document first. So this is how computers use a queue to eliminate deadlocks when multiple processes are in a ready state. Next up is printers. A queue data structure is used in printers to maintain the order of pages while printing. That means the pages are stored in a queue in the order that you want to print them, and once the page is removed from an ordered queue, it gets printed. Another most common application of queue data structure is their usage in web or mobile apps. Applications like Domino's, Swiggy uses a queue for maintaining food order status. If you place an order from an online portal, your order ID enters the queue, and once the previous orders before your order ID gets catered, then your order will be catered as well. From these examples, we can clearly say that queues are used whenever there is a need for an FCFS strategy in software development. So whenever you work on projects that need a first-come, first-serve approach, then remember that you have to implement a queue data structure to complete it successfully. Finally, let's have a look at some key takeaways that we discussed in this session. We started this session by examining the structure of the queue. We learned that the queue is a linear data structure. After that, we talked about different operations of queues in which we learned enqueue and dequeue are responsible for data manipulation in a queue. Later, we discussed different types of queues as well. Finally, we discovered some applications of queues and how they fulfill the need of FCFS systems. We have also made it clear that queues can handle multiple data types as well. We will be discussing about stack versus queue. Primarily, we will discuss the definitions of both these data structures first. The stack is a linear data structure similar to arrays and linked lists, restricting the random access of elements. In the case of arrays or linked lists, you can access elements by either traversal or random indexing, which is reframed in stack data structure. You can understand a stack by visualizing it as a container of elements in which elements can only be placed on top of each other and removed from that same direction only. Stack as a data structure in computer science is not very different from stack as a way of organizing objects in the real world. So stack can be thought as the way you arrange books stacked on top of each other. These books can only be placed upon each other from the top end. Furthermore, to remove any particular book, you will first have to remove books stacked over it. This scenario accurately depicts sequential book access, equivalent to the stack data structure in computer science. The queue in data structure is also a linear data structure like a stack, having some restrictions on insertion and deletion. In the case of queue, insertion is performed from one end and the removal is performed from another or opposite end. The queue in data structure can be understood using the real-life example of a food court line. In any food court line or a movie ticket counter line, the customer who enters first always gets served at first, and the customer who enters last will absolutely get served at last. Furthermore, both the ends of these queues remain open, performing different operations. The rear end of the food court queue performs the insertion of a customer, whereas the front end performs the removal of the customer after providing him with the service that he desires. Both the stack and queue data structures follow the different operational principles to execute data manipulation operations. The stack data structure follows last in, first out, or first in, last out principles to execute its operations. In simpler words, the stack data structure removes the last inserted element at first and the first inserted element at last. Let's understand the principles mentioned above with the help of an example. As you can see in this example, 3 is the last inserted element, and if we start removing elements from this stack, 3 should get removed at first, and 7 should get removed at last. Unlike stack, the queue data structure follows FIFO, which is the first in, first out principle, to execute its operations. According to this principle, the element which gets inserted in a list at first gets removed at first as well. For example, in this queue, 6 is the element which is inserted first. So, while performing the deletion, it should also get removed before all the other elements inside the queue. Moving forward, let's discuss different data manipulation operations for both of these data structures. The first parameter that we will talk about is the insertion operation. The process of inserting data entities in the stack is called a push operation. This operation can only be performed at the top end of a stack. For instance, consider the simulation of stack inserting few data elements. The elements that are getting inserted inside the stack are of homogeneous data type. Thus, we can say that stack can only store one type of data element. The insertion of elements in a queue data structure is referred to as an enqueue operation. It gets executed at the rear end of a queue. The simulation given in this section represents the execution of our enqueue operation. The next data manipulation operation we have on our list is deletion. The deletion of data entities from stack data structure is achieved using pop operation. The deletion of data entities from stack data structures is achieved using pop operation. This operation removes the elements where a top pointer is pointing. Thus, we can say that the stack performs the removal of data entities from its top end. This simulation shows how the removal of elements happens in the case of a stack data structure. Now, let's move to the deletion in queue data structure. The process of deleting data elements from the queue data structure is called dequeue. This operation is usually performed at the front end of a queue. The simulation given below represents how deletion happens from the front end of a queue, abiding with the first in, first out principle. Both of the data manipulation methods we reviewed earlier can be matched with previous real-life examples. What I mean by that is, the book stacking system can only place books at the top end as well as it can remove them from the top end only. Furthermore, the waiting queue analogy is deemed to be consistent with queue data structure because it adds people from the back end and removes them from the front end. Now here's the interesting question that we want y'all to answer. So, until now we have understood the structural differences between stack and queue data structures, and both of these data structures can be implemented using static or dynamic data structures. So based on your comprehension of these data structures, which implementation strategy for constraint memory management is the best choice? The first option is array implementation static, and your second option is linked list implementation dynamic. Do think and answer. It will be interesting to see how many of y'all will get this right. So guys, leave your answers to this question in the comment section below. In a week's time, we will be announcing the right answer and y'all can check it out. So moving ahead, we will discuss about the pointers maintained in the case of both these data structures. For stack data structure, our ADI only remembers one location, that is the address of the topmost element. This tracking of a topmost element is achieved using one pointer, which we name as a top for our convenience. Whereas in the case of queue, we maintain two pointers named front and rear. The rear pointer points to the last inserted element in the queue, and the front pointer points to the first inserted element in the queue. We use and maintain these two pointers to execute different operations at both the front and rear ends. The last parameter that we have for differentiating stack and queues is when to use which data structure. The stack data structure is mainly used to solve problems that are recursive in nature. For example, memory management in programming environments. The resource allocation and execution of the programs is a repetitive process based on the invocation of different function calls. And stack is the basic memory management architecture for any modern computing environment. A stack is at the heart of the runtime environment for Java, C, C++, Ada, Fortran, and other languages which is independent of their native codes like x86, Sun, or VAX. The Stack Memory Management Unit is compatible with old and new operating systems, including Windows NT 10, Solaris, and Linux runtime environments. The next applications of the stack on our list are expression handling and backtracking algorithms. The expression handling algorithms evaluates the output for arithmetic operation closed inside the parenthesis. The stack data structure is also used to perform expression conversions as infix to postfix, infix to prefix, postfix to infix, or prefix to infix. Furthermore, the backtracking algorithm is also implemented using a stack. This algorithm moves backwards and performs steps to evaluate a more adept solution. Now let's discuss about when to use queue data structure. The queue data structures work on sequential processing of data. Hence, whenever your application needs a sequential processing, a queue data structure can be implemented. For example, queue is used in messaging applications. You are probably aware that we all rely on messaging apps like WhatsApp, Facebook Messenger, and Instagram Chat to interact with our friends and family. And you must have noticed that the person you are attempting to communicate receives messages in the same sequence as you have sent them, irrespective of whether he's online or offline. Actually, the queue is implemented in messaging applications at the user's end, containing the messages to be delivered to the user. So when the user connects to the network, all the text messages in the queue gets delivered, and once the messages are delivered, empty queues get deleted. The next application of queue is its use in operating systems. Multi-user, multi-programming, and time-sharing environments are common in today's computers. In this OS setting, a system handles multiple jobs at once, and the concept of a queue is employed to manage these activities. So, remember guys, you can implement stack data structure to solve recursive problems and queue data structure to solve problems that need sequential data processing. Queue implementation using array. First, we are going to take a small recap on queue in data structure. We then dive into the declaration of a one-dimensional array and pointers for queue implementation. Finally, we will formulate code for queue data structure using the C++ coding language. On that note, without any further ado, let's get started with a recap on queue in data structure. In the last session, we introduced you to queue data structure as an abstract data type. As we know, when we talk about data structure as ADT, we define it as a mathematical or logical model. We specify all the features or operations available with the data structure. So considering that we learnt a few basic features of a queue in the last session, let's go ahead and learn more. A queue is a linear collection of different data types that allow insertion at one end and deletion at another. Unlike any other data structure, the queue ends remain open, allowing it to have different functionalities at both ends. Additionally, the queue works with the restriction that insertion should be performed at the rear node and deletion at a front node. Those processes of insertion and deletion are called enqueue and dequeue respectively. We discovered both of these operations along with three more supportive procedures named as peek, isFull, and isNull. Now that we are considering to implement a queue data structure, so all these operations will become different functional blocks. Additionally, all these operations must take constant time, and it must not depend upon a variable like the number of elements in queue or the size of the queue. By that, what I mean is the complexity of all these operations must be O of 1. Having said that, let's dive deep into the strategy to implement queue data structure. Until now, we have understood that queue is a special kind of list with some restrictions on insertion and deletion. And there are two approaches to deal with queue implementation. The first one is array-based and another one is linked list-based. In this session, we are going to focus on array-based implementation. Initially, let's say we want to create a queue of integer elements. For that purpose, firstly, it is essential to declare an array of random spaces. Let's take 100 as the size of our array. That means our array can have a maximum of 100 integer elements. The declaration of an array is made with this line of code, int q100, where int represents integer data type and q is the name of our array, and 100 is its size. The array that we just initialized is going to store our queue. By that, what I mean is at any random index of an array queue is going to start with two marked-ends, front and rear. In this array, I'm showing front of the queue towards the left and rear towards the right. For making those end nodes, we need to initialize two pointers, front and rear. At this moment, as our queue is empty, so both of those pointers should point towards -1. So initialization of these pointers should be done as int front is equal to -1 and int rear is equal to -1. When the insertion or deletion happens in queues, these pointers will be either incremented or decremented, so they are an essential part of this queue implementation process. Now you must be clear with the array and pointers declaration part. So let's dive further and formulate code for queue implementation using a one-dimensional array in C++. It is essential to include header files into our source file as we cannot access standard C++ functionalities without them. That is why here we are going to load IOStream and standard input-output files along with using namespace std. Once this is done, we will initialize our array along with front and rear pointers. Remember, we always have to declare the size of an array before compilation. That means we cannot update the size of an array at runtime. This scenario is the biggest limitation of queue implementation using arrays. Having said that, let's proceed with pointers declaration. Now we are done with the initialization process. We will now work on implementation of queue functionalities. Let's first work out supportive queue functions like isNull, isFull, and peek. IsNull function validates if the queue is empty. And as per our previous discussion, when both front and rear points to -1, then the queue is considered to be empty. So the condition to determine if queue is empty will be if rear is equal to -1 and front is equal to -1, it will return queue is empty. If the queue does not satisfy the previous condition, then it is not empty. So by using the else condition, we can display the queue is not empty. Next up is isFull function. This function validates if the queue is full, and we can clearly say that if the rear pointer is equal to the max size of the queue, then our queue is going to be completely full. Next is peek. The peek function extracts the element where the front pointer is pointing without removing it from the queue. For this functionality to work, our queue must contain data elements in it. What I mean is our queue should not be empty. If our queue is not empty, then data at the front node can be accessed. This is how we implement supportive queue functions. Let's immediately dive into the development of main queue operations, enqueue and dequeue. For enqueue operation, if the queue is full, then our function should prompt an overflow error. For that to happen, we have to put this condition. If the front pointer is pointing to -1, then we have to increment the front pointer to 0 manually. Otherwise, it can be incremented by rar ++. After pointer incrementation, we have to ask for a data element to enter into the queue. Once the data is given, it should be inserted at the position where the rar is pointing now. Finally, let's code the final main queue operation called as dequeue. If the queue is empty, then there is no element for deletion, so it should prompt an underflow error on screen. Also, if there is only one element left inside queue, then both pointers should again be pointed towards -1. For that, let's write another condition here. If both the previously mentioned conditions are false, then deletion of an element can be achieved by just pointer incrementation. We have implemented all the queue functionalities here, but we haven't implemented a function that can show us how our queue looks. So for that, let's implement one more function with the name display. This function should prompt the elements of the queue on the screen. Elements will only be printed if the queue is not empty. Hence, we have to check for the emptiness of the queue first. Finally, we are done with the hard part. So let's arrive at the main function to contemplate these operations in order to visualize outputs. We are going to use a switch case to take a user command. Thus, not to waste your time on this, let me just get done with this block ASAP. That's all, we are done with the queue implementation using arrays. Let's just examine if our code works fine or not by compiling it. This program should return a console that asks the user to give commands for performing different operations. So as you can see on your screens, if I input 1, I can perform insertion in a queue. Let's perform some insertions now. We will insert 4 elements, first 3, then 21, next 78, and finally 12. After inserting these elements, we will print the state of the queue using case 3. Now let's also check the dequeue function. If we perform a dequeue operation, then 3 should be removed from the queue. Let's check if it is removed using the display function. And yes, our code works just fine. Now if you're concerned about this code, then don't be, as we can send it over to you if you drop your email IDs in the comment section below. Additionally, you can also try to run it on your local system to have a better understanding of the concept.
We will be discussing about queue implementation using linked list. At first, we will quickly revisit the queue functionalities that we have covered in previous sessions. Followed by that, we will understand the need for linked list implementation of queue. Advancing ahead, we will deal with representation of queue using linked list and the challenges that occurs while implementing queue using linked list. Finally, we will cover the coding implementation of queue data structure. I hope I made myself clear with the agenda. Now let's get started with our first topic, which is quick recap on queue functionalities. Queue, as we know from our previous discussions, is a structure in which whatever goes in first comes out first. For example, customer service queue. In a customer service queue, the customer who enters first will leave the billing line first, and the customer who enters last will definitely get served at last. This scenario for insertion and deletion is also known as first in first out principle. Moving ahead, let's discuss some features of this queue data structure. Basically, queue is a linear data structure that follows certain restrictions on insertion and deletion. The insertion can only be made from one end and deletion can only be performed from another end. Further, deletion is called as dequeue and insertion is called as enqueue. Along with these two primary queue operations, there exist 3 more supportive queue operations named as peek, isFull, and isEmpty. Peek operation should simply return the element at the front without removing it from list, and isFull and isEmpty operation should return the state of queue that is empty or full. All these discussed operations must take a constant execution time. By that, what I mean is the time complexity for all these operations should be big O of 1. Now moving ahead, we shall understand the need for linked list implementation of queue. When we discuss the implementation of queue using arrays, we discuss the limitation of fixed size. According to that limitation, an array will always have a fixed size and it should be declared before the compilation of program. Furthermore, once all the positions in an array are taken or it is exhausted, then we only have 2 options. We can either deny insertion by saying that the queue is full and we cannot insert anything now. Or what we can do is we can create a new larger array and copy elements from the previous array to the new larger array. The time complexity for this copy operation will be proportional to the number of elements inside filled array. In other words, we can say that the time complexity of this copy operation will be big O of n. But again, as we are giving random larger size to the array, there is a possibility of massive memory loss. Like right now in this array, 70% of the memory is unused, and the memory is a crucial resource that we should always be protecting. It's not that some amount of unused memory will be a real problem in today's modern day computer, but it's just that while designing solutions and algorithms, we should always analyze and understand these implications regarding memory. Along with this memory wastage, there exists another sort of memory management issue that occurs while utilizing an array to implement a queue data structure. The space of an array which is used to store elements can never be reused to store the queue elements, because items can only be inserted from the front end, and the front end's value may be so high at that time the space before the pointer will be lost for eternity. Let's have a look at an example to understand this drawback more clearly. In this example of array representation of queue, a queue of size 10 having 5 elements is shown. The value of the front pointer is 5. Therefore, we cannot reinsert values in the place of already deleted elements before the position of front. That means the space of the array before front pointer can never be reused for storage purpose. These drawbacks represent the need for a more appropriate method to implement queues, and by using a proper dynamic data structure like linked list, these drawbacks can be easily removed. On that note, let's discuss about the representation of queue using a linked list. A linked list, as we know, is a collection of data elements that we call nodes. These nodes are stored at non-contiguous locations in memory. Further, each node contains two fields, one to store data and another to store the address of next field or the reference to the next node. Let's assume that the node in this figure are at addresses 200, 400 and 500 respectively. I have filled these addresses in the address field as well. The identity of the linked list that we always keep with us is address of the head node. We often name a pointer or reference variable at which we store the address as head. So now we are saying that we want to use a linked list to implement queue data structure. And the basic definition of queue conveys that a queue is a linear data structure in which insertion is performed at the rear node and deletion at the front node. It's really effortless to enforce this property of a queue in linked list. We can simply pick one side of a linked list for insertion and another side for deletion. If the head node is considered to be front, then the tail node will be the rear. Otherwise, if the head node is deemed to be the rear, then the tail node will be the front end. Whatever side we are picking for whatever operation, we just need to make sure one thing, and that thing is the operations that we are carrying out must take a constant time, or in other words, their time complexity should be big of 1. I hope that you guys are clear with the representation of a linked list as a queue data structure. Now moving forward, we will discuss about its implementation. But before that, let's have a look at the time complexity management challenge which occurs in queue implementation of a linked list. In the case of linked list, the cost for insertion or removal from the head side is big of 1, but the cost for insertion or removal from the tail side is big of n. So here is the deal. In a standard implementation of queue using linked list, if we insert element at one side and remove them from other side, then one of these operation nq or dq, depending on how we are picking this side, will cost us big of n. But the requirement that we have specified before for queue implementation suggests that both these operations must take a constant time. So we'll definitely need to do something to ensure that both nq and dq operations take constant time. Let's call this side front and this side rear. So I want to enqueue a node from the tail side and I want to perform a dequeue at the head side. We are good for dequeue operation because removal from the front will take a constant time, but insertion or enqueue operation will be costing us big of n. Let's first see why insertion at the tail will be costlier, and then maybe we can try to do something. To insert an element at the rear end, what we will have to do is, first we'll have to create a node. Let's say I got this node at address 350 and the integer that I want to enqueue is 7. The address part of this node can be set as null. Now we have to build a link with this created new node, and to do that, first we'll set the address part of the last node as the address part of this newly created node. But the only identity that we always keep with us in case of linked list is address part of head node. So to get appointed to any other node, we need to start at head. That is why first we'll create a pointer variable temp and we'll initially set it to head node. And now using this temp pointer, we'll traverse to the end of our linked list, that is the tail node. And here using this pointer temp, we can write the address part of the newly created node at the previous tail node to build this new link. This traversal of pointer from head to tail is taking all the time for insertion. We use a statement like temp is equal to temp.next to move the next node. What we can do is we can avoid this whole traversal with the help of pointer variable just like head node. We can call this variable tail or even rear. Let's call this variable rear for now, and also the variable which storing an address of head as front. In any insertion or removal, we'll have to update both front and rear now. But from now on, whenever we will perform enqueue operation, we can directly check where a rear node is and update its address to formulate a new insertion link. This simple addition of one pointer resolves our problem with the cost of insertion. Let's understand this scenario with the help of an example. Previously, we were traversing from head node to the tail node, but now, as we know the location of tail node, there is no need for any traversal. We can directly update the address part of rear node to make a link for new node. Here, the new node with data element 7 will be linked to the previous node, and the rear pointer will also be updated to point towards the newly inserted node. Now, the complexity for both the operation will be big of 1, which means we can now begin with the coding implementation of queue using a linked list. So, let's dive directly into that. In order to get started with our coding implementation, we'll need to load some dependencies that are called as header files. I have already included those header files here. So, first of all, we'll declare a structure to create nodes for our linked list. And inside this structure, we'll initialize data and address part. So, let's get started with creation of this structure. Struct node. Now, the initialization of data and address part. Int data struct node star next. Now using this created structure, we will initialize front and rear pointers. So let's create this front and rear pointer. Struct node star front is equal to null. Similarly, struct node star rear is equal to null. The declaration of variables that we have done here is in global scope. The reason behind that is to make sure that these variables will be accessible to all the functions. So moving forward, let's work out the primary queue operation. We'll start with enqueue operation. So let's create a function for that. Void enqueue, and inside this function we'll pass an argument int x to insert an element. Now inside the enqueue function, we'll take an integer as an argument. In this function, we'll create a new node for purpose of insertion. So let's create that new node. Struct node star temp is equal to struct node star malloc size of struct node. So with this size of function, we have allotted the size of address part as well as the data part. One more thing I want to tell you guys is I am using malloc in C here for dynamic memory allocation. If you want to implement this code using C++, then you can use new operator instead of malloc. The purpose of using malloc here is to create a node in dynamic memory. Now, moving ahead, we can start working on two cases of enqueue operation. Primarily, there won't be any element inside the queue. So for the first insertion, we'll manually set both front and rear to the address of this newly created node. So to do that, first we'll have to create a if condition. If front is equal to null and rear is equal to null, front
is equal to rear is equal to temp, which is nothing but the new created pointer variable, and will return the control. If this condition fails, that means there are already some elements present inside our queue. So using else condition, we can write another statements rear dot next is equal to temp, and rear is equal to temp. Basically, these two lines of code are just updating the address part of the next node along with setting the temporary data into rear node's data field. This code will be further clear if I'll show things moving in simulation. So let's revisit PowerPoint for that purpose. Let's say initially we have an empty queue, so both front and rear will be null. Null is only a macro for address 0. At this stage, let's say we are making a call to enqueue function passing number 2 as an argument. Now let's go through the enqueue function and see what will happen. First, we'll create a node. The data part of this node will be set as 2 and the address part will initially set as null. Let's say we got this node at address 100. So a variable named temp will store this address. Right now, the front and rear both are null. So we'll go inside this if condition and simply set both front and rear as 100. After the first enqueue operation, our queue will look like this. Let's say we are making another call to enqueue function at this stage, passing number 4 as an argument. Once again, a new node will be created. Let's say I got this new node at address 200. This time the queue is not empty. So in this function, we'll first go to the statement rear.next is equal to temp. So we'll set the next part of this node at address 100 as the address of a newly created node, which is 200. So we'll build this link now. And now we'll store the address of this new rear node in this variable named rear. So this is how my queue will look like after the second enqueue operation. I hope that you guys are clear with the implementation of enqueue operation and the working of its code. Let's deal with the next queue operation named as dequeue in our code editor. Now inside this dequeue function, I'll create a temporary pointer to the node in which I'll store the address of the current front or head node so that we can directly delete it. So the statement I'll write for that is struct node star temp is equal to front. Now the first condition that we'll write in this dequeue function is underflow error. So let's begin with if block. If front is equal to null, printf queue is in empty state /n and return the control to the next function. Otherwise, in next case, when both front and rear will be equal, we'll set both these pointers to the null manually. So to do that, we'll insert another if block. If front is equal to rear, front is equal to rear is equal to null. This if block will get activated when there is only one element inside the queue. In all other cases, we can simply make a front point to the next node. So we'll simply do a front is equal to front.next. So for that, we'll write else block, else front is equal to front dot next. In all three previous mentioned cases, we are trying to remove elements and that can only be done by implicit call of function free. So let's call function free to delete the front node from our queue. So the statement that we'll write is front free the temporary variable which is actually storing the head node address. Next, we'll work on peek operation, and for that we'll create a new function int peek. Basically, the peek function is used to extract a value of print pointer. For print pointer, we will simply check if the queue is empty. If it is empty, then obviously there is no element at front node to extract. But if it is not empty, then we can extract a value from print pointer. So for that, we'll create a if block if front is equal to null, which also means the queue is empty. Then we'll return printf queue is empty /n. Otherwise, we will return the data present at front node. Now we have implemented all important queue functionalities, but we won't be able to check the state of queue with the help of these functions. So let's formulate one more function called as print to visualize our queue. So let's define this function void print Inside this function, we'll create a temporary pointer struct node star temp is equal to front. We are initializing this temporary pointer to the front so that we can traverse the whole queue elements using iterator element. So moving forward, let's create this iterator element using a while block. So the statement that we'll write for that is while temp is not equal to null, printf modulus d comma temp dot data. And we will set temp is equal to temp dot next. This is nothing but the traversal of linked list. Now we'll also printf /n so that all elements will be printed in order. With this, we have completed the implementation of print function as well. Now let's work on our driver method called as main function to contemplate the output of our program. Inside this, we'll make call to the enqueue function enqueue to, and we will print the state of our queue using print function. Next, we'll make call enqueue for, and we will also print the state using print function. Next, we'll make call to enqueue 6, and we'll also print the state of our queue at this instance. Now, after this, we'll dequeue few elements, dequeue, and we'll print the state. Next, we'll enqueue one more element, enqueue 8. Now that we are done with the coding implementation of queue using linked list, let's execute the program and visualize the output. This is the output that we have received. Let's compare it with the calls that we have made in order to judge its correctness. The first call that we made was enq2. So the print function has printed 2 over here. After that, we inserted element 4 and 6, and our print function has printed the state after these operations as well. Next, we deleted the element present at front pointer, which is 2. So after deleting 2, the output that we got is 4 and 6. Finally, we inserted one more element to check if it is getting inserted at the rear end, and that element was 8, which is exactly inserted at the rear end of queue. We will be discussing about circular queue in data structure. So at first, we'll discuss why the concept of circular queue was introduced. Followed by that, we will understand how we can represent a circular queue using an array and linked list. Advancing ahead, we'll deal with the implementation of a circular queue using array and linked list. And finally, we will cover the applications of a circular queue to understand its importance. I hope I made myself clear with the agenda. Now let's get started with our first topic, which is why the concept of circular queue was introduced. In our previous sessions of queue implementation, we discussed the challenge of memory wastage while operating on linear queue. And as per our previous discussions, we know that memory is a crucial resource that we should always be protecting. It's not that some amount of unused memory will be a real problem in today's modern day computers. It's just that while designing solutions and algorithms, we should always analyze and understand implication like memory usage as well as the time taken for execution. In the case of linear queue, we have already learned that insertion is done at the rear end and deletion is done at the front end. Initially, when the queue is empty, both of these pointers point to null memory space, that is -1 according to our convention. But as we keep adding elements into the queue, the rear pointer keeps incrementing until it reaches the max size of the queue. In this particular example of the queue, the new data element will be inserted after each incrementation of a rear pointer until the pointer reaches the end of a queue. When the front pointer remains pointing at the exact same location until we perform dequeue operation. But here comes the challenge. When we perform those dequeue operations, the empty space gets created at the starting part of the queue. And there is no way we can reutilize this blank space as the rear pointer has already reached the end of queue. So to overcome this limitation, the concept of a circular queue was introduced. A circular queue is nothing but the extended notion of a linear queue, as it also follows the principle of first in first out, with the exception that the last position of this particular queue is connected to its first position, making a circular link. This circular link is responsible for naming of this queue as a circular queue or a ring buffer. Additionally, this new circular link feature resolves the problem of memory wastage in a linear queue. Let's understand how this problem is actually getting resolved with the help of an example. This figure is an illustration of a circular queue having size 5. The element at the front node is 7 and the element at the rear node is 9. As we can clearly see, this queue is completely filled, and if we try to perform enqueue operation, it will definitely return an overflow error. We can only perform a dequeue operation on this queue. But if we perform dequeue operation, the front pointer will be updated to point to the next available data element. Further, due to this dequeue operation, the empty space will get created in the beginning part of a queue. But because of the circular link, rear pointer can arrive back at the empty space for making insertion of a new data element. Hence, the circular queue concept is better version of a queue data structure considering its benefits over a circular queue. Moving ahead, we'll discuss how we can represent a circular queue using an array and linked list. However, initially we should also look into the principle of circular incrementation, which drives the insertion in a circular queue. The circular queue incrementation is a process of pointer incrementation that allows rear pointer to arrive back at the beginning part of a queue once it reaches the max size of queue. Let's understand how circular incrementation works with the help of an example. The simulation of a circular queue shown here has max size 6, which means it can store 6 data elements. In the first scenario, when queue is empty, It can store elements by simply incrementing the rear pointer as shown in the animation. The other scenario for insertion in queue is when the rear pointer is at the end of queue and there is an empty space at the beginning portion of a queue due to dequeue operations. In this case, the rear pointer can arrive back at the beginning of queue to insert a new element at any empty space. But the biggest question that arises here is how the circular incrementation is happening logically or arithmetically. Let's contemplate the logic for this process of circular incrementation with the help of previous example. In the last example of a circular queue, the max size of a queue was 6 and rear pointer was pointing to the index 5 where front pointer was pointing to index 2. Now for the new incrementation to happen, we have to bring rear pointer to the index 0. Let's analyze how we can do that. If we simply add 1 to the rear pointer, then we will get 6 as a result, which is also the max size of our queue. Now, if you guys remember the modulus operator in programming, you can clearly achieve the circular incrementation. For example, in this case, rear plus 1 modulus max size will output 0, the result which we want. So, with the help of modulus operator, we can perform the circular incrementation to formulate a circular link using arrays. Now that you have understood how circular link is implemented in case of array implementation of circular queue, we will now look into representation of a circular queue. In the array representation of circular queue, you can clearly see that the last index of the array is connected to the first index by circular incrementation process. Moving forward, we'll look into the different cases of inserting an element into the queue. The first case that we are going to discuss is to determine if the queue is full, as we cannot insert a new element into the queue when it is full. But how can we judge if the queue is full? Well, that's quite easy. If the result of circular incrementation matches to the index value of front pointer, then there is no space for insertion of a new data element. That means if rear plus 1 modulus max size is equal to front, then the queue is full and insertion cannot be achieved. The next case for inserting an element into a circular queue is when there is space at the beginning of a queue. Let's say the size of an array is 5, in which the rear pointer is pointing to the index 4 and the front pointer is pointing to index 2. By making circular incrementation, we can insert element at the empty space. By using rear is equal to rear plus 1 modulus max size statement, we can bring our rear pointer to the beginning part of our queue to make a new insertion. That's all about array representation of a circular queue. Now moving ahead, we will discuss the representation of circular queue using a linked list. The linked list representation of a circular queue can be achieved by changing the reference field of the tail node. For that, we can just add the address of head node in the reference field of the tail node. The implementation of a circular queue using linked list is more efficient than array implementation as it manages memory more effectively. Further, it is a dynamic structure that can be allocated with more memory space if required at the runtime. On that note, we have covered the representation of circular queue using both arrays and linked lists. Now, we will implement a circular queue using both of these data structure with the help of C programming language. First, let's dive into the array implementation of a circular queue using the C programming language. For that, let's visit our code editor and get started. The program for array implementation will begin with the declaration of array and pointer variables. So let's create an array first, int a, close braces and semicolon. Now the size that we want to allot to this array is 5. So let's define our max size value as 5 first. Hash define max underscore size as 5. Now let's pass this as an argument to this array. Now we will define the pointer variables as well. So int front is equal to -1. And also the rear pointer Okay, now we have successfully created our array and pointer variables. So after this, we'll begin with the implementation of circular queue operations. The first primary queue operation that allows us to manage data flow in a queue is enqueue. So we will create this function first. Void enqueue, and we'll pass an argument variable x to insert an element. For implementing this operation, we have to check if the queue is empty. If a circular queue is empty, then we'll set both the front and rear pointer to 0 manually. For that, we'll write a statement if front is equal to -1 and rear is equal to -1, then set front equal to rear equal to 0. We have just written the condition for instance when the queue is empty. Next, we'll write the condition to check if the queue is full. So for that, we'll create else if condition, else if rear plus 1 modulus max underscore size is equal to front then printf queue is full /n and return the control to the next function. If both these above mentioned conditions fail, then we'll have to increment the rear pointer using the technique of circular incrementation. So for that, we'll create another else loop. Else rear is equal to rear plus 1 modulus max underscore size, and outside this we'll make an insertion into our array. With this, we have successfully created our enqueue operation. Now we'll move towards the dequeue operation. For that, we'll create another function, void dequeue. The dequeue operation is responsible for removing the element from the front node of a queue. Further, an element can only be deleted when there is at least an element to delete. So, first we'll have to check if our queue is empty or not. For that, we'll write a statement if front is equal to -1 and rear is equal to -1. Now inside this block, we'll printf queue is empty and we cannot delete any element. We will return the control to the next function. In addition to that, if there is only one element inside the queue, we'll have to set both front and rear pointer to the null manually. So for that, we'll write another condition, else if front is equal to rear, which must be the 0th index or the last element inside queue. And inside this function, we'll write front
is equal to rear is equal to -1, which means we'll set it back to the null state. If both these conditions fail, then we'll simply have to increment the front pointer using technique of circular incrementation. For that, we'll write another condition, else front is equal to front plus 1 under braces modulus max underscore size. With the help of these three conditions, we'll be able to delete element from our queue. Now, moving forward, we'll look into another operation, that is print function. So let's create a new function for that, void print We will understand this function with the help of PowerPoint, cause it will be more understandable to all of you if I show things in moving simulation. So let's visit PowerPoint for that purpose. The count variable used in this print function is supposed to count the number of elements inside the queue. We'll understand how it is operating arithmetically with the help of an example. Let's say the max size of our array is 5, where front pointer is pointing to index 1 and rear pointer is pointing to index 4. To work out the value of count variable, we'll need to perform following operation. Rear plus max size minus front modulus max size plus 1 is equal to count. By filling the values in this operation, we'll get 4 as a result, which is the exact number of elements inside the queue. Now we will iterate through the queue using for loop and will also print the elements. I hope you are clear with the implementation of this print function now. Moving forward, we'll revisit the code editor to write main function and to check the result of our program in C. Inside this main function, we'll call enqueue function to insert some elements into the queue. And after few insertion operations, we'll call print function to represent the state of our queue. So let's insert few elements at first. Enqueue 5, enqueue 7. Next element that we will insert is enqueue -3. Next enqueue 0. Now let's write one printf statement. The element inside the queue are and in next line we'll return the state of queue using print function. Well, there is single mistake in this code here. We have written printf statement in uppercase, which is a case error in C programming. So we'll change it to the small p. Now we'll dequeue few elements to understand the operation of dequeue as well. So let's dequeue 2 elements. One more time. And after these two operations, we'll also print the state of queue once again using the print function. Well, we'll write one more statement. Printf the state of queue after 2 deletions. And also we want this statement to come in next line, so let's write /n. Okay, So with this, we have successfully completed a coding implementation of circular queue using arrays. So let's compile this code and check if it is working fine or not. Well, here is the output that we have got. The elements inside the queue are 5, 7, minus 3, 0. So let's check our order of insertion. So we include 5, 7, minus 3 and 0. And in similar order, the elements are inserted in our queue. Also, we deleted two elements from the front node, that is 5 and 7, which are also deleted here. With this, we can say that our code works fine. So let's move towards linked list implementation of circular queue. For linked list implementation of queue, first we'll need to create structure of a linked list and pointer variables. So first we'll create a structure for node, struct node int data part and the address part. Semicolon. Now we'll create pointer variables. So for that, we'll write statement struct node star front is equal to -1. Similarly, struct node star rear is equal to -1. After done with this pointer declaration, we'll begin with the implementation of queue operations. The first operation that we'll work on is enqueue operation. For that, let's create a new function, void enqueue int x. And inside this function, we'll create a temporary node using the previous structure of node. So for that, we'll write statement struct node star new node is equal to struct node star malloc size of struct node. After creating a new node, now we will also insert values into both data and reference fields. Data will be the argument provided by the user and the reference field will be set to null initially. So let's do that here. New node, arrow operator, data is equal to x. And similarly, new node, arrow operator, next is equal to 0. Now, there are two conditions for inserting a new node into the linked circular queue. In the first condition, we'll insert a new node into an empty queue. In this case, both the front and rear pointer must be null. So let's write a condition for that. If rear is equal to -1, then front is equal to rear is equal to new node, and rear dot next is equal to front. Now, in the second case, the queue already contains more than one data element. The condition rear is equal to -1 becomes false. In this scenario, we'll just update the rear pointer to point to the new node. For that, we'll create a else block, else rear dot next is equal to new node and rear is equal to new node, where rear dot next is equal to front. With this, we have successfully implemented our enqueue function. So now let's move towards dequeue function. For that, we'll create a new function, void dequeue, and inside this function body, we'll also create new temporary pointer. So let's create that struct node star temp, and we'll set this temp is equal to front so that we can delete it from our queue. Next, we'll build a condition for deletion. The first condition that we'll check is if our queue is empty or not. For that, we'll write statement if front is equal to -1 and rear is equal to -1. If this condition becomes true, then we will printf queue is empty. Let's add slash in here so that it gets printed in next line and semicolon. Okay. Further, if there is only one element in the queue, then we'll set both front and rear pointer to the null manually. So for that purpose, we'll create another block, else if front is equal to rear, which will happen when there is only one element in our queue. And inside this condition, we'll put front is equal to rear is equal to -1, and we will free the temporary variable, which is also storing the front pointer. Okay, now if both these above mentioned conditions fail, then we will update the value of front pointer to point to next node, and we'll also deallocate the memory of deleted node using free function. For that, we'll write another else condition, else front is equal to front arrow operator next and rear arrow operator next is equal to front, and we will free the pointer present at front node, which we have previously stored in this temporary structure. With this, we have successfully implemented the dequeue operation. Now we'll work on the display function, which will represent the state of our queue. For that, let's create new function, void display, and inside this function we'll also create the temporary node struct node star temp is equal to front. And now let's write one printf statement to display the elements in a queue. The elements inside the queue are semicolon. Now the first condition that we are supposed to check inside this function is if a queue is full or not. For that we'll write if statement if front is equal to -1 and rear is equal to -1, then printf queue is empty. Let's add /n. Otherwise we will print the elements inside the queue using while block. Temp arrow operator next is not equal to front, then printf modulus d, which is nothing but the data part of our temporary pointer, and again printf modulus d comma temp data. With this we have successfully completed the implementation of our display function. Now next we'll look into our driver method, that is main function. Inside this driver method we'll call enqueue function to insert few elements. First we'll pass 5, then we'll insert -32, then 6, and we will enqueue 3 finally. Now let's print the state of queue using display function. Now after this we will dequeue few elements, and we will display the state of queue once again. But before this we'll write one more statement, printf the state of queue after deleting 2 elements. And let's add /n so that this statement gets added to the next line. With this we have successfully implemented our linked list implementation code for circular queue. So let's compile it and check if it is working fine or not. Okay, there are few. We have successfully implemented our code now, but the only problem we are facing here is all the elements are getting placed close to each other. To remove this close proximity, we'll have to make changes in our display function. So let's do that. We'll add space before modulus d in both the cases and again compile it. So let's run it again. Okay, so now our output looks fine, right? The elements inside the queue are 5, -32, 6 and 3, and after deleting first two elements that are front elements, we will remain with 6 and 3. That means the first two front elements 5 and -32 will get removed out of our circular queue. Okay, so we have finished the circular queue implementation using linked list as well. So let's move back to our PowerPoint presentation. The last topic that we have on our agenda is applications of a circular queue. So let's deal with this topic to understand the importance of circular queue. The first application of a circular queue that we are going to discuss about is data buffer. After that, we'll discover CPU scheduling algorithms and computer controlled traffic light systems. Data buffer is a region of a physical memory which is used to temporarily store data while it is being moved from one place to another. Typically, the data is stored in a buffer as it is retrieved from an input device such as a microphone or just before it is sent to an output device such as speakers. Basically, when the input is provided to the microphone while using applications such as Google Meet, WhatsApp, Zoom meeting, etc., then the input does not get stored in the physical memory of the device. Instead, it gets stored in data buffer implemented in this application. The data buffer will store the input signal in order and similarly it will dequeue it in exact same order, just like first in, first out circular queue. Furthermore, this data buffer is also used in internet streaming applications. Let's understand how it is used in case of one of the most famous streaming platform, Netflix. Netflix uses Amazon Cloud Services to cater for their computing as well as storage needs. The servers of Netflix are deployed over AWS Cloud, which are further connected to the content delivery network servers that are spread across the globe. These servers work together to provide fast delivery of internet content in the form of audio and video chunks or packets. These packets will be received in a virtual data buffer implemented inside MS Silverside, which is an application used by Netflix to stream content on remote devices. This buffer acts like an accordion in this streaming application. It gets filled when packets are being delivered at a rate that exceeds the video stream data rate and empties when the packets are not being delivered fast enough. The next application of a circular queue is a ready queue in CPU scheduling algorithms. CPU scheduling determines which process will own CPU for execution, while other processes are on hold. The main task of CPU scheduling is to ensure that whenever the CPU remains idle, the OS at least selects one of the processes available in ready queue for execution. The algorithm named round robin uses a circular queue to implement the ready queue state. The ready queue stores all the processes that are available for resource allocation having their own burst time. The burst time is the time that processes need to hold the CPU for their execution. But in this algorithm, the CPU has assigned with timestamp of 2 microseconds. This timestamp is the actual period for which the processes can hold the CPU for execution. So for example, the first process P1 had a burst time of 4 microseconds, but it can only access the CPU for 2 microseconds due to its timestamp. So this process will again re-enter the queue at the rear end. Further, the empty space created at the beginning of ready queue will be managed by the process of circular incrementation. This is the advantage of implementing ready queue using a circular queue. The next application is computer controlled traffic system. The circular queues are used in these systems to activate the signal lights for constant intervals of time. The computer system used for traffic light control stores a circular queue containing the commands to lit the traffic lights. These commands will be activated for a certain amount of time and will be reinserted at the rear end of a queue. This process is an example of circular FIFO principle, which is followed in insertion and deletion for circular queue.
We will be discussing about priority queue in data structure. We'll start this discussion with introduction to the priority queue. Followed by that, we will understand how we can represent a priority queue. Advancing ahead, we'll deal with different implementation strategies for priority queue. After that, we'll understand what is a heap data structure and what different types of priority queue are available. Followed by that, we'll contemplate different operations in priority queue. Once finished with that, we will implement a priority queue using heap data structure. And finally, we will cover applications of priority queue to understand its importance. I hope I made myself clear with the agenda. Now let's get started with our first topic, Introduction to Priority Queue. Primarily, we will have a look at the real-life example of priority queue to understand it better. A hospital emergency queue is almost an ideal example of priority queue. When you go to the hospital, you must have observed that the person who needs immediate medical attention will be treated first, irrespective of his arrival at the reception. That means treating a person who is in agonizing pain or in emergency medical condition is the priority of the queue of patients. Priority queue in computer science also works with same approach. So what exactly is this priority queue? Well, a priority queue is an abstract data type that operates similar to the normal queue except for the fact every element has certain priority assigned to it. This definition of priority queue suggests that this particular type of queue also follows the same restrictions for insertion and deletion of data elements. The insertion in the priority queue will only be achieved at one end and deletion at another or opposite end. Additionally, the priority of data elements will determine the order of removal. The elements which has higher priority will leave the queue at first, and the elements which has lower priority will definitely leave the queue at last. As a side note, I would like to tell you guys that the priority queue only supports the elements that are comparable, meaning the data that we are going to insert into priority queue must be orderable. The compiler should not be facing any difficulty while comparing these data elements. Otherwise, the execution of a priority queue will definitely fail. Moving ahead, let's have a look at an example of priority queue. In this priority queue, we will insert 7, 2, 45, 23 and 12 respectively. These elements are not ordered. So how the priority queue is going to store them in order? Well, at the time of insertion, the priority queue conducts a comparison of each element with every other element present inside a queue to store them in order. But as there is no element inside a queue, so the first insertion, that is an element with value 7, will be attained. Followed by that, the next element will be inserted in a queue. Since the newly inserted element is smaller than that of previously inserted element, we'll swap their positions in order to maintain order. Remember, the element with least value will have a higher order and the element with greatest value will have a least priority or order. Now we will insert the next element in a queue, that is 45. As 45 is a larger element than the elements inside the queue, there is no need to shuffle elements. When we make the next insertion, the element 32 will get inserted at index 3. Now this element is smaller than that of 45. So the algorithm will have to swap the locations of these elements. Now we will perform the final insertion into our queue. We will insert 12 at index 4 now. But as you can see, this element is smaller than both the previous elements. Thus the algorithm will have to swap their positions. Now 45 will reach the end of queue as it is the element with highest value, and 2 will remain at the front of queue as it is the least valued element. As a humans, we could see the numbers visually inside the priority queue, and further we can easily arrange them. But how does the machine know this? Does it restore all the elements inside the priority queue before each insertion? No, obviously that would be highly ineffective as there will be n comparisons for insertion of n elements leading to time complexity big O of n square. This is an enormous time complexity which we cannot allow in any software application. We will understand how the priority queue manages to reduce this time complexity in upcoming topics. But right now we will contemplate different properties of a priority queue that we have learned from previous example. The first property of priority queue suggests that each element has a certain priority assigned to it. That priority might depend on value of data element. It can be either larger or smaller. The next property states that element with higher priority will leave the queue at first, where the element with least priority will leave the priority queue at last. Further, if two elements have the same priority, then the element will be removed from the priority queue based on their arrival. That means the element which arrived at first out of the elements having same priority will be removed first. Now, moving ahead, we'll deal with the representation of priority queue using a linked list, as usage of arrays is not an ideal way to implement priority queue. If we consider array implementation of priority queue, then inserting items into the sorted array will cost us big O of n, and in general, processing each element will further cost us big O of n square as discussed previously. So in this tutorial, we'll just look into the linked list representation of priority queue. We will understand the representation of priority queue with the help of an example. Initially, let's say there are 3 elements inside a linked priority queue and all of them are in order. 3 being the least element has highest priority, where 43 has the least priority. The purpose of keeping 3 at the head node is that we want our priority queue to delete elements according to their priority. Now, we want to insert a new node consisting of data element 2. And as the data element is smaller than the element at head node, that is 3, so this new node should be inserted prior to it. This particular scenario of insertion seems pretty perfect as it does not cost us more time. But what if the element is significantly larger than all the nodes in queue? For instance, let's say we want to insert 45 as a new element. In that case, primarily it will be compared with element 2, and as 45 is larger than 2, our temporary pointer will move to the next node for comparison. Now, 45 will be compared with element 3, and again the temporary pointer will be moved to the next node for comparison. After 2 comparisons, the temporary pointer has reached element 17 for performing the next comparison. And here also 45 is larger than 17, so the temporary pointer will again move towards the next node. Now finally, our temporary pointer has arrived at the tail node consisting of element 43. Again, in this case, the element 45 is larger than 43, thus the new node will be inserted after node containing data element 43. From this specific example of insertion into a priority queue, we can clearly see that there are n comparisons leading to the time complexity big O of n, where the complexity of deletion remains constant, that is big O of 1. While understanding the representation of priority queue, we came across some facts that make priority queue implementation using linked list quite vulnerable. So here we will again try to recall them. The first drawback of priority queue implementation using linked list is that it costs us big O of n for inserting a new element. Further, it also costs us big O of n for peak operation. And as memory and time management is the purpose of data structure, hence we must try to analyze other implementation strategies. That is why in upcoming slides we'll look into different approaches to implement a priority queue. There are 3 approaches that implement a priority queue with complexity less than big O of n square. We have already discussed the linked list, so let's also look into other 2 approaches. Binary heap and binary tree provides almost similar complexity. These approaches cost us big O of log n for insertion and deletion, and big O of 1 for peak operation. But which one of these operations is most optimal approach to implement priority queue? Well, to answer this question, we again need to discuss about memory management in the case of both these data structure. You guys know that binary heap data structure is implemented using arrays, and since it utilizes arrays, there is always a better locality of reference as well as operations become more cache friendly. The binary search tree uses pointer to implement front and rear node, which definitely takes up more space in memory. Due to that, building a self-balancing BST cost us big O of n log n, where binary heap just cost us big O of n. These facts clarify that the binary heap is the base data structure to implement a priority queue. Now you must be thinking about what exactly the heap is and how does it work. So moving forward, we'll look into the definition of heap and its properties. Basically, a heap is a tree-based data structure that satisfies the heap invariant, or in simpler words, heap property. The heap invariant states that if A is a parent node of B, then A is ordered with respect to B for all nodes A and B in heap. What that means is the value of parent node is always greater than or equal to the value of child node in the heap, or other way around, the value of parent node is less than or equal to the value of child node for all nodes in a heap. Further, there are two types of heap named as max heap and minimum heap. First, we will look into max heap. The max heap is heap in which value of parent node is greater than the value of child node. For this particular example of max heap, you can see that the root node is the biggest element in tree and each child node is smaller than its parent node. The next type of heap is minimum heap. The min heap is heap in which the value of parent node is less than the value of child node. In this specific example, you can observe that each child node is larger than its parent node and the element at the root node is smallest element of the heap. Both the structures that we have discussed are binary heaps as every node has only two children. In upcoming slides, we will discuss some complex structures of heap data structure to better understand how we can judge if a tree-like structure is heap or not.
Okay, so you can see a tree-like structure on your screen, and we are supposed to check whether if it is a valid heap data structure or not. But actually, here I would like you all to give it a try by yourselves. You can also pause this video if you want, but here I will provide you with a short moment to inspect this structure. Alright, I can clearly say that this is not a valid heap data structure. As you can observe, the highlighted part is violating the heap invariant. Moving forward, let's analyze another tree-like data structure to consider if it is a valid heap or not. Well, yes, this is a valid heap because even though this one is strangely structured, we are free to move around the visual representation of nodes to make it organized. Now you all must be thinking how we can do that. Well, we'll understand that scenario in upcoming slides. Now, how about this one? Is this a valid heap? No, right? This is not a valid heap. This structure is not even a tree as it forms a closed cycle and every heap must be a tree. So it's pretty clear that this is not a valid heap. Now, what about this one? Is this a valid heap? Yes, this is a valid heap as it satisfies the heap invariant that all the child nodes must be greater than or equal to or smaller than or equal to its parent node. Now, this is the last structure that we are going to check if it is a valid heap or not. What you guys think? Is this a valid heap? Well, I think it's pretty clear that this is not a valid heap, but it can be converted into a heap by making a one small change. Now, if we make 6 as our root node, then this structure will get converted into a max heap, which is absolutely a valid heap. I hope you all are clear with the heap invariant and how to judge if a given tree is a valid heap or not. Now moving ahead, we'll discuss the different types of priority queue. Basically, there are two types of priority queue based on the priority of elements. If the element with smallest value has highest priority, then that priority queue is called as min priority queue. And if element with higher value has the highest priority, then that priority queue is known as max priority queue. Furthermore, it's vividly clear that the min priority queue can be implemented with a minimum heap, where the max priority queue can be implemented using maximum heap. Moving ahead, we'll deal with the operations in priority queue considering the heap as implementation strategy. The common operations that we can perform on priority queue are insertion, deletion, and peek. But there is one more hidden additional operation that gets performed during these operations. That operation is called as heapify. Heapify manages the priority of data elements in a heap by shuffling the data elements after new insertion or deletion. First of all, we will understand how insertion in priority queue happens with the help of an example. In this example, we are inserting a new data element that is 43. But due to this insertion, the structure disobeys the priority queue invariant that the parent node of the max priority queue must be greater than its child node. Now, the heapify operation solves this problem by rearranging data elements by carrying out the comparison. In this particular case, 43 becomes the parent node where 40 becomes the child node. The next up is deletion. As we know, the highest priority element will be the first to leave the priority queue, and further, it is stored at the root node of a max heap. So definitely, the element present at the root node will get removed. But due to this operation, the order of priority queue gets affected. However, the heapify operation comes to the rescue. It reshuffles the elements of the priority queue to rearrange them in order. The next operation that we are going to discover is peek. The peek operation simply returns the element present at root node without removing it, and it is easily accessible. Thus, the time complexity of this operation is big of 1. I hope you all are clear with the operations that can be performed on priority queue. Moving forward, we'll try to implement them with the help of minimum heap. As discussed earlier, while implementing a heap data structure, we know that all the elements will get stored in an array, and we don't have any pointers pointing to either child or parent nodes. So how exactly does the heap data structure remember nodes like parent nodes and its left or right nodes? Well, if you have learned binary trees, then you must know the formulas present on your screen. These formulas determines the left child, right child, or even the parent node of any binary tree. Let's understand how this phenomenon works with the help of an example. We'll begin with index 0. If we enter 0 in this arithmetic expression, then we will get 1 and 2 as output. That means the element at index 1 will be the left child and element at index 2 will be the right child, and tree structure will look like this. Now, moving ahead, let's take an example of index 1. For index 1, the left child will be at index 3 and the right child will be at index 4. Similarly, for index 2, the left child will be at index 5, where the right child will be at index 6. Using these formulas, we'll be implementing heapify and primary queue operations. So note them down for further reference. Now moving further, we will visit code editor to implement priority queue data structure using C programming language. Previously, I mentioned that heap is implemented using arrays. So to begin with heap implementation, primarily we will create a structure consisting of different variables or objects needed to implement heap data structure. So let's create a structure, struct heap consist int size, int count variable, and int star heap array, which is a dynamic array that we are creating here. And next, we'll also declare a pointer to heap structure along with size and count variable in a global scope. So let's do that. Int star heap comma size comma count. We'll create one more variable int initial underscore size to represent the initial size of our priority queue, and let's assign it value 4 for now. Okay. Now it's time to allocate memory to our heap array. For this purpose, we'll create a new function called heap underscore init. So let's create this function void heap underscore init, and inside it we'll pass an argument struct heap star h, which is a reference of this structure that we created previously. Okay. In this function, let's initialize the variables that we have created inside this heap structure. So for that, we'll initialize h arrow operator count is equal to 0. Similarly, h arrow operator size is equal to initial underscore size, and h array is equal to int star malloc size of int star 4. This statement is just allocating 4 integer variables to our heap array. Basically, our heap array is dynamic data structure. That's why we have to provide it with dynamic memory using malloc. If you are using C++ programming language to implement this data structure, then you can use new instead of malloc. Moving forward, now we'll work on our condition if not h arrow operator allocates memory to heap array, then printf error while allocating the memory, and that /n. Next, we will write exit command. Okay. With this, we have successfully implemented our heap init function. Now moving ahead, let's implement heapify function to move the nodes. For that, we'll create a heapify function void max underscore heapify int star data int log int count. So all these are required variables to implement this heapify function that we have passed in argument for this max heapify function. Now let's create few more variables that we need. Int left comma right comma largest comma temp. Now, as discussed earlier, left will be equal to 2 star location in array plus 1. and right will be equal to left plus 1. Now let's say largest is equal to LOC, and we'll work on conditions now. If left is greater than or equal to count, and data left is greater than data largest, that is the location we have stored in largest variable, then largest is equal to left. With this block, what we are doing is we are checking if the element at location left is greater than the element at recent position, and the value at left is also greater than the value of recent location. If these conditions are true, then we will set the recent location as left. And here we are getting signal that there is semicolon missing over here, so we'll add it. Okay, now let's work on next condition. Now we will check the value at right position. If the recent location is greater than the right and the value at right is greater than the largest value, then element at largest will be set to right. So for that, we'll write condition if right is greater count and data right is greater than data largest, then largest is equal to right. Otherwise, if largest is not equal to location, then we will store the data present at location in temporary variable, and data LOC is equal to data largest. This is a swapping operation that we are carrying out here. And next, data largest is equal to 10. And now we'll make recursive call to our heapify function max underscore heapify data comma largest comma count. Okay. With this, we have successfully completed our heapify function. Now we will work on insertion operation on priority queue. Let's call this function heap underscore push, because we are treating this structure as heap, right? So in heap, insertion is called as push operation. So we'll call it void heap underscore push, and we'll pass arguments struct heap star h int value. And inside this function, we'll create few more variables int index and parent. If you guys remember, the initial size that we have allocated to our array is 16 bytes. You can verify with this statement here that we are providing 16 byte size to our heap array. But what if you want to insert elements more than 4? Then what we'll do? Well, for that, we'll need to increase the size of our heap array. So we'll do that here. For this resize, we'll create if condition if h dot count is equal to h dot size, then h dot size plus equal to 1 and h dot heap array is equal to realloc h dot heap array size of int star h dot size. Basically, we are using realloc function in C to extend the dynamic memory space for our heap array. And in order to increase the size, we have to increment the size variable first. So that's what we have done in this statement here. And now, once done with this, we'll check if our dynamic memory is getting allocated or not. So for that, we'll add one more if condition inside this if block. So it can be called as nested if you guys want. Dot heap array, then exit -1. Now we'll move out of this if block and we will set index variable to h dot count plus plus. Basically, we are iterating with help of index variable here. So next we'll add for condition for loop index to index is equal to parent. And inside this condition, we'll make parent node is equal to index -1 by 2. This is nothing but the formula that we have discussed in previous part. Now we'll add one more condition inside this for loop if h dot heap array parent is greater than or equal to value, then we will break this for loop. Otherwise, h dot heap array index will be equal to h dot heap array parent. Now we'll move outside this for loop and we'll add one more condition of insertion, that is h dot heap array, and at position index we will add the value provided by user using argument to heap push function. Okay, with this we have successfully created our heap push function. Now we'll move towards the next function, that is heap underscore delete. For that we'll create new function heap underscore delete, and let's make this function integer, and we'll pass struct heap star h as an argument. We will create one more variable temp is equal to h arrow operator heap array, and inside this we'll pass a negating index. That means we are using this temporary variable to traverse through all list of elements. So for that we'll write dot minus minus h arrow operator count, which will decrease count one by one. Now next we'll add condition if h arrow operator count is greater than or equal to h arrow operator size plus 2 and h arrow operator size is also greater than the initial underscore size. Okay. Then what we will do is we will set size to negate itself by 1 for each iteration, and then we will add h arrow operator heap array is equal to realloc h dot heap array comma size of int star h arrow operator and size and semicolon. So basically what we are doing here is we are checking if count is smaller than the size of heap plus 2 and the dynamic size of queue is also larger than initialized size, that is 4, then what we are doing is we are reducing the size for deleting an element using this statement, and in next statement we are reallocating that deleted space. So this is how this if block works. Now moving forward, we'll add condition to check if memory is getting reallocated or not. For that we'll write condition if not h arrow operator heap array. Then what we'll do is exit with -1. Okay, now let's move out of this if block, and now we will set this removed variable to h arrow operator heap array and index 0. So if you guys remember, 0 is the index of the highest element in our maximum heap. What I mean here is the element with highest value is stored at index 0 for max heap. Now moving forward, to delete this element, what we'll do is we will set h dot heap array and index 0 is equal to temporary variable or pointer that we have created previously. And next what we'll do is we'll call max underscore hippify function to rearrange the structure of our priority queue, which has been shuffled due to this delete operation. Now for that we'll pass arguments our heap structure, that is heap array, and next the index which was removed and the count variable. And we'll return the removed element. Okay, with this we have successfully implemented our delete function. Now to understand the order of deletion in priority queue, we will implement one more function called as mtpq. So let's create this function. And in this function we'll pass the reference of heap structure in order to operate on it. So let's pass the structure heap star h, and inside this function we will create a while loop h dot count is not equal to 0, then printf modulus d and recursive call to heap delete function, in which we'll pass h. Now we are done with this mtpq function. Further, we'll create one more function to visualize our priority queue. Let's call this function void heap underscore display, and inside this we'll pass structure heap star h. And now we will create one iterator element, and using that iterator element we'll create for loop I is equal to 0 to I is greater than arrow operator count plus plus I. And inside this for loop we will print the elements present in our queue using this format, modulus d, and we'll call heap array. But for that, we'll need to call structure as well. Heap array, and we'll pass this iterator variable into it. Okay, and then next we'll get outside this for loop and we'll printf this to the next line using /n. Okay, now we have implemented all the required function for our priority queue. Moving forward, we'll work on our driver function, that is main method, to contemplate the result of our program. So for that, we'll first call struct heap h, then we'll call init function to create heap structure. So heap init, and we'll pass the address of h. Next, we will call heap underscore push function to insert element, and h comma 1. Next, I'll copy this part, we'll paste it to insert another element. Now we'll insert 5 here. Next, paste, and we'll pass 3. Next, we'll insert element 7. Next, we'll insert element 9. And after this, we'll insert element 8. Okay, so now let's display the elements inside our heap using heap underscore display function. And let's pass an h object to print it. And again, we'll call empty pq function, empty pq, pass h, and after deleting all elements, it will return the state of our heap array again, or our priority queue. So finally we'll add return 0 statement, and now our code is ready. So let's compile it and check it if it works fine or not. So we are getting 4 errors here, guys, so we'll need to resolve them. First, we'll need to check line number 82. So for 82, okay, here we haven't added semicolon, so I think this should be fine now. Still we have 2 errors. Before I is there, so let's recompile it and check it if it is working fine now. So we have received our output now. Now if you look at our output is printing elements 9, 7, 8, 1, 5 and 3, and deletion of elements is also happening according to their order. So 9 is getting deleted first, after 8, 7, 5, 3 and 1. So that means our elements are getting removed in proper order. Further, we can say that our program for priority queue implementation works fine. Now, if you guys are worried about this program, then not to worry. We have you covered. You can mention your email IDs in comment box below and we will send it over to you. Remember guys, we can make comments private to protect all your data. So you can fearlessly put all your email IDs in comment box below. Now we will discuss applications of priority queue to understand its importance. The first application that we are going to discuss is use of priority queue in Google Maps. You must have used Google Maps several times to navigate from one city to another or from your location to nearest desired location. Have you ever wondered how Google Maps managed to do that? How does it provide an optimal path to reach your location? Well, Dijkstra's shortest path algorithm implemented in Google Maps actually manages to do that by gaining access to all possible paths. This algorithm uses the priority queue to maintain all the paths in order. Let's understand how it works in detail. Now, when you provide the location of place you want to reach via your mobile device, Google Maps feeds the data of all possible paths to Dijkstra's algorithm. Those paths or road are stored in minimum priority queue considering the distance as parameter for priority assignment. And we have learned that the minimum priority queue maintains the lowest value at the front or root node. This is how the priority queue helps Google Map to search for an ideal path for reaching destination location. The next application that we are going to discuss is data compression in WinZip or gzip. These applications use Huffman encoding algorithm to reduce the size of files. Huffman coding is a lossless data compression algorithm, and in this algorithm, a variable length code is assigned to input different characters. The code length is related to how frequent characters are used. Most recurring characters have the smallest codes, and longer codes are for the least frequent characters. This is how the generated codes will maintain the complete data while utilizing less memory space. Let's understand how this process works with the help of an example. Let's say our text file contains these random characters. The Huffman encoding algorithm creates codes for each character based on its number of occurrences. For instance, the frequency of character A is more prominent than B, and character C has less frequency. So the length of code A is smaller than B, and length of code B will be smaller than C. Now, according to the amount of generated code, the priority queue will determine the priority of characters and will store them. These codes takes less size than the actual characters in memory space, and due to the mapping of occurrences, data does not get lost. I hope now you guys understand why the priority queue is treated as an abstract data structure itself and why it is the better version of queue data structure.
The stack is a linear data structure similar to arrays and linked lists, restricting the random access of elements. In the case of arrays or linked lists, you can access elements by either traversal or random indexing, which is reframed in stack data structure. You can understand a stack by visualizing it as a container of elements in which elements can only be placed on top of each other and removed from that same direction only. Stack as a data structure in computer science is not very different from stack as a way of organizing objects in the real world. So stack can be thought as the way you arrange books stacked on top of each other. These books can only be placed upon each other from the top end. Furthermore, to remove any particular book, you will first have to remove books stacked over it. This scenario accurately depicts sequential book access, equivalent to the stack data structure in computer science. The queue in data structure is also a linear data structure like a stack, having some restrictions on insertion and deletion. In the case of queue, insertion is performed from one end and the removal is performed from another or opposite end. The queue in data structure can be understood using the real-life example of a food court line. In any food court line or a movie ticket counter line, the customer who enters first always gets served at first, and the customer who enters last will absolutely get served at last. Furthermore, both the ends of these queues remain open, performing different operations. The rear end of the food court queue performs the insertion of a customer, whereas the front end performs the removal of the customer after providing him with the service that he desires. Both the stack and queue data structures follow the different operational principles to execute data manipulation operations. The stack data structure follows last in, first out, or first in, last out principles to execute its operations. In simpler words, the stack data structure removes the last inserted element at first and the first inserted element at last. Let's understand the principles mentioned above with the help of an example. As you can see in this example, 3 is the last inserted element, and if we start removing elements from this stack, 3 should get removed at first, and 7 should get removed at last. Unlike stack, the queue data structure follows FIFO, which is the first in, first out principle, to execute its operations. According to this principle, the element which gets inserted in a list at first gets removed at first as well. For example, in this queue, 6 is the element which is inserted first. So, while performing the deletion, it should also get removed before all the other elements inside the queue. Moving forward, let's discuss different data manipulation operations for both of these data structures. The first parameter that we will talk about is the insertion operation. The process of inserting data entities in the stack is called a push operation. This operation can only be performed at the top end of a stack. For instance, consider the simulation of stack inserting few data elements. The elements that are getting inserted inside the stack are of homogeneous data type. Thus, we can say that stack can only store one type of data element. The insertion of elements in a queue data structure is referred to as an enqueue operation. It gets executed at the rear end of a queue. The simulation given in this section represents the execution of our enqueue operation. The next data manipulation operation we have on our list is deletion. The deletion of data entities from stack data structure is achieved using pop operation. The deletion of data entities from stack data structures is achieved using pop operation. This operation removes the elements where a top pointer is pointing. Thus, we can say that the stack performs the removal of data entities from its top end. This simulation shows how the removal of elements happens in the case of a stack data structure. Now, let's move to the deletion in queue data structure. The process of deleting data elements from the queue data structure is called dequeue. This operation is usually performed at the front end of a queue. The simulation given below represents how deletion happens from the front end of a queue, abiding with the first in, first out principle. Both of the data manipulation methods we reviewed earlier can be matched with previous real-life examples. What I mean by that is, the book stacking system can only place books at the top end as well as it can remove them from the top end only. Furthermore, the waiting queue analogy is deemed to be consistent with queue data structure because it adds people from the back end and removes them from the front end. Now here's the interesting question that we want y'all to answer. So, until now we have understood the structural differences between stack and queue data structures, and both of these data structures can be implemented using static or dynamic data structures. So based on your comprehension of these data structures, which implementation strategy for constraint memory management is the best choice? The first option is array implementation static, and your second option is linked list implementation dynamic. Do think and answer. It will be interesting to see how many of y'all will get this right. So guys, leave your answers to this question in the comment section below. In a week's time, we will be announcing the right answer and y'all can check it out. So moving ahead, we will discuss about the pointers maintained in the case of both these data structures. For stack data structure, our ADI only remembers one location, that is the address of the topmost element. This tracking of a topmost element is achieved using one pointer, which we name as a top for our convenience. Whereas in the case of queue, we maintain two pointers named front and rear. The rear pointer points to the last inserted element in the queue, and the front pointer points to the first inserted element in the queue. We use and maintain these two pointers to execute different operations at both the front and rear ends. The last parameter that we have for differentiating stack and queues is when to use which data structure. The stack data structure is mainly used to solve problems that are recursive in nature. For example, memory management in programming environments. The resource allocation and execution of the programs is a repetitive process based on the invocation of different function calls. And stack is the basic memory management architecture for any modern computing environment. A stack is at the heart of the runtime environment for Java, C, C++, Ada, Fortran, and other languages, which is independent of their native codes like x86, Sun, or VAX. The Stack Memory Management Unit is compatible with old and new operating systems, including Windows NT 10, Solaris, and Linux runtime environments. The next applications of the stack on our list are expression handling and backtracking algorithms. The expression handling algorithms evaluates the output for arithmetic operation closed inside the parenthesis. The stack data structure is also used to perform expression conversions as infix to postfix, infix to prefix, postfix to infix, or prefix to infix. Furthermore, the backtracking algorithm is also implemented using a stack. This algorithm moves backwards and performs steps to evaluate a more adept solution. Now let's discuss about when to use queue data structure. The queue data structures work on sequential processing of data. Hence, whenever your application needs a sequential processing, a queue data structure can be implemented. For example, queue is used in messaging applications. You are probably aware that we all rely on messaging apps like WhatsApp, Facebook Messenger, and Instagram Chat to interact with our friends and family. And you must have noticed that the person you are attempting to communicate receives the messages in the same sequence as you have sent them, irrespective of whether he's online or offline. Actually, the queue is implemented in messaging applications at the user's end, containing the messages to be delivered to the user. So when the user connects to the network, all the text messages in the queue gets delivered, and once the messages are delivered, empty queues get deleted. The next application of queue is its use in operating systems. Multi-user, multi-programming, and time-sharing environments are common in today's computers. In this OS setting, a system handles multiple jobs at once, and the concept of a queue is employed to manage these activities. So, remember guys, you can implement stack data structure to solve recursive problems and queue data structure to solve problems that need sequential data processing.
So what exactly is a tree data structure? The tree is a non-linear data structure that consists of nodes and is connected by edges. I know it's a little difficult to understand just by the definition, so let me show you the pictorial representation. As you can see, we have the elements, that is 10, 20, 30, 40, 50, 60, and 70, and all these are stored in the tree data structure. They are stored in a non-linear structure. If we had used arrays, it would have been in a linear consecutive way where 10 starts first and 70 ends at the last position. Now, in the next section, we will discuss why we had made to a switch to the tree data structure when we already had a linear data structure, that is array. Now the next topic, that is why we need tree data structure. So there are many reasons why we had switched into tree data structure, and one of the reasons is a linear data structure always stores the elements in a sequential form, that is, one after the other. And in operations to be performed in linear data structure, the time complexity increases as the data size increases. You can see here that, as discussed before, the elements are stored in a linear form, that is 10 at the first place and 70 at the last place. Imagine you wanted to access the element 70. Then using the traversal, you had to start from the first position, that is 10, 20, 30, 40, and slowly at the end is 70. So accessing that particular element is really time consuming. We are facing this just for 70 elements. Imagine if we had 700 elements, right? So that is exactly why we had made a switch to tree data structure. And using tree data structure, we have many advantages, as the tree data structure is completely non-linear and it allows easier access and quicker access of the data elements. How is that possible? We will look into it into the next segment, where we will discuss about the traversal of trees. Now, before we understand the traversal of trees, we should understand another important topic, that is the terminologies of tree. So, the first one is the node. Node is the entity that contains the keys and pointer to its child nodes. So here, you can see that the elements A, B, C, D, E, F and G are the elements. So each and every element, or the blue dot, is called as a node. And the blue dots here are 1, 2, 3, 4, 5, 6 and 7. So we have 7 blue dots. So we have 7 elements here. So you can see the line between each elements, right? So this particular line is called edge. Now we'll discuss about the edge in the next part. So the connecting links between any two nodes are called as edges. So we discussed about the nodes, right, where the element is stored. The blue dots are the nodes, and the lines connecting between the elements or nodes is called as the edge. So out of all the nodes, this first node, that is the element A, is called as the root node in a tree data structure. So indirectly, root node is also called as the parent node of all the nodes. Now we will understand what are parent nodes and children nodes. So in a tree data structure, the node, that is the node's predecessor, is called as parent node. So here we have discussed that A, or the root node, is the parent of all nodes. So for A, B and C nodes are children nodes. And for B and C nodes, A happens to be the parent node. Similarly, D and E are the children nodes of B, and F and G are children nodes of C. And the nodes D and E have B as the parent node, and the nodes F and G have C as the parent node. Now followed by that, we will understand the descendant node. So as discussed before, the descendant node is the node that comes after the parent node. Here, the B and C are the descendants of A, and D and E are descendants of B, and similarly F and G are the descendants or children of the node C. So in a tree data structure, the node which does not have any child is called as the leaf node. Now at the end we have D, E, F and G. So these particular nodes do not have any children nodes like B and C. So these particular 4 nodes which do not have any children are called as the leaf nodes. In a tree data structure, the node with at least one child node is called as the internal node. So here the internal nodes are B and C, which have at least one child. In a tree, the total number of children of a node are called as the degree of that node. So in this particular diagram, the degree of a root node is 2 because it has 2 child nodes, and the degree of B is 2 as it has 2 child nodes. Similarly, the degree of C is 2 because it has 2 child nodes. But when it comes to D, E, F and G, the degree is 0 because they do not have any child nodes. In a tree data structure, the root node is said to be at level 0, and the children of the root node are said to be at level 1, and the children nodes of the level 1 are at level 2. So to understand this, let's go through the diagram. As you can see, this particular root node is called as level 0. And followed by that, we have the children nodes of A, that is B and C, and that level is called as level 1. And followed by that, we have level 2. And if this tree goes forward, the levels also increase accordingly. Now, in a tree data structure, the total number of edges from a leaf node to the particular node is the longest path, and this particular path is called as the height of that node. Now here we have our general tree data structure, and here you can see the height of node A is 2. And the height of node B and C together is at 1. And the height of the last leaf nodes happens to be 0. Next, in the tree data structure, the total number of edges from the root node to a particular node is called as the depth of that node. Now in this particular tree data structure, the depth of the root node is 0. And the depth of B and C together is 1 because the number of edges connecting to the node A from B is just 1, and similarly the number of edges connecting the node C from A is just 1. So the depth of both B and C is 1. Now if we consider the last leaf nodes, then the depth is 2 because if you see, G is connected to A using 2 different edges. Similarly, F is connected to A using 2 different edges, and E and D also have 2 nodes to connect to A. So the depth is 2. Now in the next segment, we will understand the tree node. So the tree data structure has data part and references towards left and right child node in the tree data structure. So here you can see this is the node, and the node has 3 segments, that is data element and the references towards left child and the references towards right child. Now there are 4 different types of trees. The first one is the binary tree, followed by that we have the binary search tree, then we have AVL tree, and finally we have the B tree. Let us discuss each one of them. The first one is the binary tree. A binary tree is a tree data structure in which each parent node at most has 2 children. So in this particular tree, we'll have at most 2 children. That means it might have 1 or more than 1, but not more than 2 children per node. Moving ahead, we have the binary search tree. So a binary search tree or a BST is a tree data structure in which each node has a maximum of 2 children. All nodes of the left subtree are less than the right node. All nodes on the right subtree are more than the root node. So here you can see the image or the GIF which represents the image of a binary search tree. So here, all the nodes of the left subtree are less than the root node and all the nodes of the right subtree are more than the root node. The next type of the tree is the AVL tree. The AVL tree got its name after inventory Georgi, Adelson, Welsky and Landis. AVL tree is the self-balancing tree in which each node maintains a balance factor whose value is either 1, 0 or -1. Balance factor is equals to height of the left subtree minus height of the right subtree, or height of the right subtree minus height of the left subtree. So in this particular image, you can identify it is an AVL tree. And now the last type of tree, that is the B tree. B tree is a special kind of self-balancing search tree in which each node can contain more than 1 key and can have more than 2 children. B tree is also known as the height-balanced M-way tree. Now in this particular GIF, we can see how a B tree looks like. Now followed by this, we will discuss the tree traversal. So traversing a tree helps to visit required node in the tree to perform specific operations. Tree traversal can be performed in 3 different ways. The first one is the pre-order traversal, where we visit the node and visit all the nodes from the left side, then visit all the nodes from the right side. So this particular GIF is an example for pre-order traversal, where we visit all the left side nodes first, then we visit the right side nodes. Now we will move ahead into the next type of traversal. That is the in-order traversal. First, we visit all the nodes from the left side, then we visit the root node, and then we visit all the nodes from the right side. So this particular GIF will be an example for the in-order traversal, where we visit all the left side nodes, then we visit the root node, and followed by that we will visit the right side nodes. And the last type of traversal is the post-order traversal, where we visit all the nodes from the left side first, then we visit all the nodes from the right side, and finally visit the root node. So this particular image on the right side is an example for post-order traversal. Now before we get into learning the applications of trees, we will try to execute one example based on the post-order, pre-order and in-order traversals in tree data structure. So you can see that we have an example on my screen right now. So here we have the node structure, then we have the in-order traversal function, followed by that we have the pre-order traversal function, and finally we have the post-order traversal function. Now let's quickly run this program and see the output, and don't worry about the code. This particular code document will be attached in the description box below and you can have access to it. Now we have the run option over here and the program got successfully executed. You can ignore this warning, and here we have the in-order traversal of the tree and the first output. Then we have the pre-order traversal of the tree, and finally we have the post-order traversal of the tree. Now let's discuss the last part, where we will learn the application of trees. So the application of trees are as follows. Binary search trees are used to quickly check whether an element is present in the set or not. Then we have the most popular database usage of B-tree, which is a variant of tree data structure. Then we have the modified version of trees called as Tress, which is used in the router to store routing information. And finally, the compiler uses a syntax tree to validate the syntax of every program you write. So it is a tree data structure in which each node can have at most 2 child nodes. These nodes are referred to as left child node and right child node. Next, let's discuss about some terms related to binary tree. First up, a node. A node consists of data and a link to its both child nodes. Next, the root node. Root node is the first node of the tree. Next, leaf nodes. These are the nodes which has no child. Next, parent node. Apart from the root node, any node which has at least one child is called as parent to that child node. Next up, a child node. Any node with a parent is called as a child node. Next up is the internal node. Any node with a child and a parent is called as an internal node. Next up is the height of the binary tree. The longest path from the root to any leaf node is called as the height of the binary tree. Next up is the depth of the binary tree. The depth of the node is the total number of edges from the root node to the target node or the last child node. Now let's try to implement the binary tree in the code editor. As you can see, now we are on the code editor, and the code on my screen is an example for binary tree. Now here you can see that we have created a structure for node, followed by that we have a function where we will print the tree, and this is our main function. Now don't worry about the code, this particular code segment will be available in our description box below, and you can always have access to it and try to edit and run this code on your own local system to have a better learning experience. Now without further ado, let's try to run this program quickly and see the output. So there you go, the code got successfully executed, and here you can see the output of this particular binary tree. Now let's get back to the theory part. So as discussed before, followed by the implementation part, we will learn about the properties of a binary tree. Now let's discuss the properties of the binary trees. First up, maximum number of nodes at a level L is 2 to the power L. Next up, maximum number of nodes in a binary tree of height h is equals to 2 to the power of h minus 1. Next up, minimum possible height in a binary tree with 2 nodes is equals to log of L plus 1 base 2. Next up, the minimum possible level in a binary tree with n nodes is equals to log of L plus 1 base 2. Finally, a binary tree with L leaves has at least log L base 2 plus 1 levels. Now, let's discuss about the different types of binary trees. First up, we have the full binary tree. Followed by that, we have the complete binary tree. Then we have the perfect binary tree. Followed by that, we have the balanced binary tree. And lastly, the degenerate binary tree. Let's discuss about these in detail. First up, full binary tree. A full binary tree is a unique tree data structure in which a node can have either 2 children or no child. Next, a complete binary tree. So a complete binary tree is another specific binary tree where each node on all levels except the last level must have 2 children, and at the lowest level, all leaves should reside possibly on the left side. The next one is the perfect binary tree. A binary tree is perfect if every node must have 2 children and every leaf is on the same level. The next one is called as the balanced binary tree. A binary tree is balanced if, for each node, the height of the left subtree and the height of the right subtree varies at most by just 1. At last, we have the degenerate binary tree. A binary tree is said to be degenerate if every internal node has only one child. We have now discussed the binary tree, some terms and properties related to binary trees, and types of binary trees. Now we will look into the operations that needs to be performed on the binary tree. So there are basically 3 types of operations that can be performed on binary tree, which are traversal, insertion, and deletion. So first we'll look into the traversal operations. There are 3 different types of traversal operations possible on binary tree, which are pre-order traversal, in-order traversal, and finally the post-order traversal. Now let's get back into the text editor mode and try to execute our example. So right now we are on the text editor, and this particular code is for the traversal operations on our binary tree. And here you can see we have the structure for node, and we have also the in-order function, pre-order function, and post-order function. And don't worry about the code. This particular code will be available in the description box below. And after you have written the code, we have some standard input over here. You can see that we are giving the number of edges as 4, and the left subtree elements are 2 and 1, and the right subtree elements are 2 and 3, and another left subtree elements are 3 and 5, and lastly we have 5 and 6 for another left subtree. Now let's try to execute this code. Now we have already executed the code, and we also have the output over here, and here you can see we have entered the number of edges as 4, and the traversal is in-order traversal, which is 1, 2, 6, 5 and 3, and the pre-order traversal output is 2, 1, 3, 5, 6, and the post-order traversal is 1, 6, 5, 3 and 2. Now let's get back to the PPT. Now we have the insertion operation. And now let's get back to our text editor and try to see an example for insertion operation as well. So on my screen you can see an example for insertion operation. So here we have the insert function. As I said, this particular code will be available in the description box below. Now let's provide the standard input. So the standard input will be 4 edges, and we have 2 and 1 as the left subtree, and 2 and 3 as right subtree, 3 and 5 as left subtree again, and 5 and 6 as the left subtree. Now let's quickly run this code, and there you go, the program got successfully executed, and here we have the output. The nodes got inserted, and it has provided an in-order traversal, that is 1, 2, 6, 5 and 3. Now let's get back to the presentation, and the last type of operation is the deletion operation. Let's quickly execute an example based on deletion operation as well. Now as you can see, we are on the text editor again. Now here the example is for deletion operation. We have the delete function over here. Now for this particular program we don't need any standard inputs, so just let's run the program. So there you go, the program got successfully executed, and we have the output over here. And in order traversal before deletion, and in order traversal after the deletion of an element. So the deleted element is element 11. Now with that, let's get back to the presentation mode again. So that's how the element got deleted. Now we have reached to the last part of this session, that happens to be the final key takeaways. So what are the final takeaways? So binary tree is faster at search operations than other type of tree, and it is easier to find maximum and minimum elements in the binary tree. Binary tree does not allow duplicate values, and graph traversal is done using binary tree. It is used to convert the postfix expressions into the prefix expressions. So these were the final takeaways. Tree traversal is a process of visiting each and every node in a tree data structure. So right here on my screen, we have a tree with different nodes, that is A, B, C, D and E. So here we will be visiting all the nodes one after the other using the tree traversal methods. Now that we have a brief understanding of what exactly is a tree traversal process, let's get into the next topic of our discussion for today, that is the data structure used for tree traversal. In a tree data structure, there are primarily two data structures utilized for tree traversal. The first one is the stack data structure and the second one is the queue data structure. A stack is a linear data structure that operates on the last in, first out, LIFO principle. There is only one pointer in the stack, that is the top pointer, which points to the stack's topmost element. Only the top of the stack is used for insertion and deletion. Now the next one is the queue. A queue, unlike stacks, is open on both the ends. The one end is always open and used only for input and the other is only used for deletion or elimination. The principle followed in queue is first in, first out or FIFO approach. Followed by that, we will look into the different types of tree traversals in data structure. Tree traversal can be done in the following ways. The first one is breadth first search and the second one is the depth first search. First, let us have a look at the breadth first search algorithm or breadth first search traversal. We follow level order traversal in breadth first search. Breadth first search traverses nodes by level instead of subtrees. First, we visit the root node. Followed by the root node, we visit the left subtree of the tree. Then, followed by the left subtree, we finish the right subtree of the entire tree. After that, we go until the leaf nodes of the entire tree is found. The second one is the depth first search. In depth first search, we traverse tree data structure in three ways, that is pre-order traversal, in-order traversal and post-order traversal. Let us take a look at how these traversals are carried out. First, let us discuss the pre-order traversal. We traverse the root node first in the pre-order traversal. Then we traverse through the left subtree and finally we traverse through the right subtree. Then there is in-order traversal. In-order traversal involves traversing of the left subtree first, followed by that we enter the root node, then we visit the right subtree. Lastly, we have the post-order traversal. So post-order traversal involves traversing of left subtree first, then the right subtree, and finally we visit the root node. Now next, we will have a look at some of the important applications of tree traversal in data structure. So we use tree traversal in data structures to build a prefix expression or Polish notation from expression trees. Then utilize the pre-order traversal and then traverse the expression tree in a pre-orderly manner. A binary tree's postfix representation or reverse Polish notation can be generated using post-order traversal. Because it returns values from the underlying set in order, according to the comparator setting up the binary search tree, in order traversal is often employed on binary search trees. A complete binary tree can be deleted or released when deleting or freezing nodes and values in the post-order traversal. Now, next we will see an example based on tree traversal in data structures. So on my screen we have an example for tree traversal in data structure. To begin, we have included the enum or user specified data type traversal. It mostly used to give integral constant names which make a programmer easier to comprehend and maintain. We defined three variables in the enum data type, that is pre-order, in-order and post-order traversal. We can define the type that can take one of the two values by using the typedef and enum keywords. We have a traversal data type with trav variable and a node data type with node variable. Then we define the node using the data structure type as struct node. We declare one variable x and two nodes as a left and a right nodes respectively in this node section. We then attempted to create a node using the create node function, passing the root node as an argument. In this code, we use a malloc function to create a node, assign data to x and null to both the right and left nodes before returning to the root node. If node t is not equal to null, we simply return it. Otherwise, we will use the released tree function to release the left and right nodes, and if neither is a root node, then we will use the free function to release the node t, which will behave as the root node. Then we define the display tree function, which takes the trap variable and the root node as parameters. There is a condition in this function, that is, if the root node is not null, we will return the root node. Then, using the switch case scenario, we attempted to traverse the tree using all three types of traversals. We utilize a trav variable in the switch function, so if any of the in-order, pre-order or post-order variables match the trav variable, the traversal will be executed. Then, we created a tree using the createTree function, which takes a data variable as input. In the createTree function, we used a malloc function to create the root node, and we first assigned null to the left and right nodes, as well as the data to the variable x before returning to the root node. We first traversed the root node, then the left subtree, and finally the right subtree in the pre-order traversal case. In order traversal case, we first traverse the left subtree, then the root node, and finally the right subtree. And in the post-order traversal case, we traverse the left subtree, then the right subtree, and finally traverse through the root node. And finally, we exit the display tree function and moved on to the main function. We assign the values 5 as the root node, then 10, 20, and 30 as the left nodes, and similarly 15, 25, and 35 as the right nodes, and then we call the three tree traversals, that is pre-order, in-order, and post-order, to traverse the tree. And finally, we release the root node. Now, let us try to execute this program and see the output. So there you go. The program got successfully executed, and you can see that the output has been displayed on my screen. So the pre-order traversal is 5, 10, 20, 25, 15, 30, and 35. Followed by the pre-order traversal, we have the in-order traversal, that is 20, 10, 25, 5, 30, 15, and 35. And finally, we have the post-order traversal, that is 20, 25, 10, 30, 35, 15, and 5.
So without any further ado, let's get started with introduction to binary search tree. Binary search tree is a set of nodes organized in such a manner that they all have the same binary search tree characteristics. A key and a value is assigned to each node. The requested key is compared to the keys in binary search tree. So during search, if the key is found, then the corresponding value will be retrieved. Next up, properties of binary search tree. First up, the left subtree of a node contains only nodes with keys lesser than the parent node. Next up, the right subtree of a node contains only nodes that are greater than the parent node. The left and the right subtree each must also be a binary search tree. Next, let's discuss what are the operations we can perform on a binary search tree. First up, insertion. Last, deletion. Let's discuss them in detail. First up, insertion. We can insert a node in such a way so that we obey binary search tree rules. That is, the new node should be either less than the parent node if it's on the left subtree, or if it's on the right subtree, it should be greater than the parent node. Let's execute this in the code editor. We will start by creating a class for the binary search tree. So class bst int data and bst pointers left, right. Next, we will define some functions publicly. Public First, default constructor. And a parameterized constructor. A function to insert the value. And a function to traverse the node. Now let's write default constructor's definition. So bst Now let's write the parameterized constructor's definition. Bst int value data is equals to value and left is equals to null and right equals to null. Now let's write the definition for the insert function. So bst bst star root comma int value. Now we will check if the tree is empty or not. So if root, then we will insert the first node. So we will return new bst value. Otherwise we will insert the data. So if the value is greater than root data, then we have to insert it in the right subtree. So root right is equals to insert root right comma value. Else else the value should be inserted in the left side. So root left is equals to insert root left comma value. And then we will return root. Now let's write the traverse function. So void tst traverse tst star root. If root then we will return otherwise we will first traverse left side then we will print the root data. And then we will traverse the right side root right. Now let's write the main block. So we will start with an empty tree. So bst b comma star root is equals to null. The root is equals to b dot insert root comma 50. B dot insert equals to root comma 10. B dot insert gonna be root comma 30. B dot insert gonna be root comma 50. Sorry, we already used 50, so we will use 60. B dot insert root comma let's use 20. Let's try to traverse this. So b dot traverse root. Let's execute this. As you can see, we have successfully created and traversed our first binary search tree. Let's get back to slides. At last, deletion. We will delete a node following the binary search tree rules. That is, the value of the left subtree should be less than the parent node, and the value of the right subtree should be greater than the parent node. Let's try these in the code editor. Let's start by creating a node. This time we will use structure. So struct node int key struct node star left comma star right. Now we will create a utility function to create a new binary search tree node. So struct node star new node int item. Struct node star temp equals to struct node star malloc size of struct node next temp will be assigned the key is equals to item temp left equals to null and temp right is equals to null. Now let's write a function to traverse the tree. Traverse struct node star root. So if root is equals to null, so traverse root left cout root e traverse root right. Now let's write a utility function to insert the new node with the given key in the binary search tree. So struct node star insert struct node star node comma int key. So if node is equals to null, then we will return new node key. Otherwise, we will recur down the tree. So if key is less than the node key, then we will insert in the left subtree. So node left is equals to insert node left comma key. Else node right should be inserting key. Now let's return the node. Now we have given a non-empty binary search tree, so we have to return the node with the minimum key value found in that tree. So we will start struct node star min value node struct node star node struct node star current is equals to node. So we will loop down to find the leftmost leaf. So while current and parents left is not equals to null, so current should be equals to current to return current. Struct node star delete node struct node star root comma int key. If root equals to null, return root. Now, if the key to be deleted is smaller than the root's key, then it lies in the left subtree. So we will check if key less than root key, then root left, it will be equals to delete node root left key. Comma key. Now if the key is deleted is greater than the root key, then it lies in the right subtree. So else if key is greater than root, root right is equals to delete node root right comma key. Else if roots dot left equals to null and root dot right is equals to null, then return null. Else if root left equals to null, then struct node star temp is equals to root right and free root. Return temp. Else if roots right is equals to null, then struct node star temp is equals to root free root. Return temp. Now node with the two children get the in-order successor smallest in the right subtree. So struct node star temp is equals to min value node root right. Now we will copy the in-order successor's content to this node. So root is equals to temp. Now we will delete the in-order successor. So root right equals to delete node root right comma temp p. Now we will return root. Now let's write the main block. We will start with an empty tree struct node star root is equals to null. Now root is equals to insert root comma 2 root is equals to insert root comma 5 root is equals to insert root comma 3 root is equals to insert root comma 4 root is equals to insert root comma 7 and root equals to insert root comma 6. Let's try to traverse this. So cout traversal of the given tree traverse root. Now first we will delete a value. So cout delete 2 now root is equals to delete node root comma 2 or cout traversal after deleting the traverse route. Let's execute this. As you can see, we have successfully deleted 2 and traversed the tree again. Let's get back to our slides. At last, let's sum up what we have learned from this session. First up, left side nodes are always lesser than the parent's node, and the right side node are always more than the parent node. Next, it is easier to search and sort elements in a binary search tree. Finally, a binary search tree offers faster insertion and deletion operations. So let's get started with introduction to AVL trees. An AVL tree is a height balanced binary search tree. For each node, we have to make sure that the height of the left subtree and the right subtree can differ by at most 1. We can calculate this balance factor by subtracting the height of the left subtree from the height of the right subtree. Now let's discuss various rotations we can perform on AVL trees. First up, LL rotation. Next, RR rotations. Next, LR rotation. At last, RL rotation. Let's discuss them in detail. First up, LL rotation. It is a clockwise rotation when a node is inserted on the left subtree of the left subtree of a node. Then we apply this rotation to balance the tree. It is applied on the node below the balance factor 2 node. That is, we will apply right rotation on the green node. Next, RR rotation. When a node is inserted into a right subtree of the right subtree of a node, then we perform RR rotation. It is an anti-clockwise rotation which is applied on the node below a node having balance factor -2. That is, we will apply it on the green node. Next up, LR rotation. When a node is inserted into right subtree of the left subtree of a node, then we perform LR rotation. It is a combination of RR and LL rotation. First, we will apply RR rotation on green and yellow node. After this, red node is still unbalanced, so we will perform LL rotation on the yellow node. Finally, RL rotation. When a node is inserted into the left subtree of a right subtree of a node, then we perform RL rotation. It is a combination of LL and RR rotation. First, we will apply LL rotation on green and yellow nodes. After this, the red node is still unbalanced, so we will perform RR rotation on the yellow node. Now, let's discuss complexity of AVL trees. First up, space complexity is a big O of n. Next up, AVL tree offers a complexity of big O of log n for searching. Next up, AVL trees offer a complexity of big O of log n for insertion. Finally, AVL tree offers a complexity of big O of log n for deletion. We have now introduced an AVL tree and rotations on it. Now, let's discuss some of the operations we can perform on AVL trees. First up, insertion and deletion. Let's discuss them in detail. First up, insertion. We will insert a node following binary search tree rules. Then we will check if the nodes are balanced or not. If they are not, then we will balance it by using suitable rotations. Now let's try these operations in a code editor. Let's start by creating a node. To create a node, we need a class node. We will create its member as public int key node star left node star right
int height. Now let's write a function to get maximum of two integers. So int max int a comma int b. Now let's declare a utility function to get maximum of two integers. So int max a comma int b. Now let's write a function to get the height of the tree. Int height node star n. Now if n is null, then we will return 0. Else we will return n calls height. Now let's write that function to get maximum of two integers. Int max int a comma int b. We will return if a is greater than b, then we will return a, else we will return b. Now let's write a helper function that allocates a new node with a given key and null left and right pointers. So node star new node int key. Node star node equals to new node. So node key will be equals to key node left will be equals to left. Node left will be equals to null, and node right will be equals to null, and node height will be equals to 1. And return node. Here we have kept height as 1 because at the new node is initially added at leaf. So by default it will always be at 1. Now let's write a utility function to right rotate subtree rooted with y. Node star right node star y. Now node star x is equals to y's left and node star t2 is equals to x right. Now we will perform rotation. So x right will become y and y's left will become t2. Now we will update the heights. So y height is equals to max of height of y left comma height of y right. Plus 1. Now x height equals to maximum of height x left comma height of x right. Plus 1. Now return x Now let's write a utility function to left rotate subtree rooted with x. So node star left rotate node star x node star y will be equals to axis right and node star t2 will be equals to y's. Now we will perform rotation. So y left will be equals to x and x right will be equals to t2. Now let's update height. So x height is equals to maximum of height of axis left comma height of axis right and y's height is equals to maximum of height of y's left comma height of y's right. return y. Now let's write a function to get balance factor of node n. So int get balance, argument as node pointer n. If n is equals to null, then we will return 0. Otherwise, we will return height of n's left minus height of n's right. Now let's write a recursive function to insert a key in the subtree rooted with node and returns the new root of the subtree. So node star insert node star node comma int key. Now we will perform the normal BST insertion. So if node is equals to null, then we will return new node key. Now if this key is less than node's key, then node left will equals to insert node left comma key. Or else we will insert that in the right. Node right is equals to insert node right comma key. Now we will return node. This if else will make sure that we will reach to the leaf node and then we will insert the key. Now we will update the height of this ancestor node. So node height is equals to 1 plus max height of node left comma height of node right. Now we will get the balance factor for this ancestor node to check whether this node became unbalanced. So int balance is equals to get balance. Now if this node becomes unbalanced, then there are 4 cases. So if balance is greater than 1 and key is less than node left key, then we will return right rotate node. This if statement for the left case, so or LL case. Now let's write it for the right case or RR case. So if balance is less than -1 and E is greater than node right key, then we will return left rotate node. Now write for the left right case or LR case. So if balance is greater than 1 and key is greater than node left key, then node left is equals to left rotate node left. Now return right rotate. Now let's write the right left case or RL case. So if balance is less than -1 and key is less than node to the right key, then node right will be equals to right rotate node to the right, and we will return left rotate. Now we will return this node. Now let's write a function to print pre-order traversal of this tree. So void pre-order node star root. So now if root is not null, then cout root key and now pre-order root. And pre-order Now let's write the code for the main block. We will start with an empty tree. Node star root is equals to null. Now we will try to construct tree. So root is equals to insert root comma 10. Now root is equals to insert root comma 5. Root is equals to insert root comma 2. Root is equals to insert root comma 3. Root is equals to insert root comma 7 and root is equals to insert comma 9. Now let's try to print this tree. So cout avial tree is equals to tree in pre-order pre-order root. Let's execute this. As you can see, we have successfully created our first avial tree. Let's get back to slides. At last, deletion. We will delete a node following a binary search tree rules. Then we will check if all the nodes are balanced or not. If they are not, then we will balance it by using suitable rotations. Now let's try these operations in a code editor. Let's start by creating a node. To create a node, we need a class node. We will define its members as public int key node star left node star right int height Now let's write a utility function to get height of the tree. So int height node star n. If n is equals to null, then in that case we will return 0. Otherwise we will return n's height. Now let's write a utility function to get maximum of two integers. Int max int a comma int b. So we will return if a is greater than b, then a, else b. Now let's write a helper function that allocates a new node with a given key and null left and right pointers. So node star new node int key. So node star new node is equals to new node parenthesis. Now new node will get key as key. New node left is equals to null, and new node right is equals to null, and new node's height is equals to 1, because new node is initially added as leaf. That's why it is always be given as 1. Now we will return this node. Return node. Now let's write a utility function to right rotate a subtree rooted with y. So node star right rotate node star y. Node star x is equals to y left node star t2 is equals to x right. Now we will perform rotation. So x right is equals to y left is equals to t2. Now we will update heights. So y height equals to maximum of height of y's left comma height of y's right plus 1, and x height is equals to maximum of height of x's left comma access right plus 1. Now we will return this new root. So return x. Now we will write node star left rotate node star x node star y will be equals to axis right and node star t2 will be equals to y's left. Now we will perform rotation. So y left equals to x and x right is equals to t2. Now we will update these heights. So x height is equals to maximum of height of x left comma height of x right plus 1 and y's height is equals to max of height of y's left comma height of y's right plus 1. Now we will return this y. Now we will write a function to get balance factor of node n. So int get balance node star n. So if n is equals to null, then we will return 0. Otherwise we will return height of n's left minus height of n's right. Now let's write a function to insert a node. So node star insert node star node comma int key. Now we will perform normal BST rotation. So if node is equals to null, then we will return new node key. So now if key is less than node key, then node left will be equals to insert node left comma key. Now if key is greater than node key, then node right is equals to insert node right comma key. Else we will return node because equal keys are not allowed. Now we will update the height of the ancestor node. So node height equals to 1 plus max height of node left comma height of node right. Now we will get the balance factor of this ancestor node to check whether this node becomes unbalanced. So if int balance equals to get balance of this node. Now if this node becomes unbalanced, then there are 4 cases that could be possible. First up, LL case. So if balance is greater than 1 and key is less than node left key. Return right rotate node. Now let's write right case. So if balance is less than -1 and key is greater than node right key, then we will return left rotate node. Now let's write left right case. So if balance is greater than 1 and key is greater than node left key, then node left will be equals to left rotate and we will return right, rotate, node. Now let's write the case for right left case. If balance is less than -1 and key is less than node right, so node right is equals to right rotate node right. Now we will return left rotate node. Now let's return the unchanged node pointer. So return node. Now let's write a function to find minimum value node. So node star min value node. Node star node. So node star current equals to node. So while current left is not equals to null, current is equals to current at left. Now we will return current. Now we will write a recursive function to delete a node with the given key from subtree with the given root. So node star delete node. Its arguments are node pointer root, comma, int key. For starters, we will perform standard BST delete. So if root is equals to null, then we will return root. Now, if the key to be deleted is smaller than the root key, then it lies in the left subtree. So, if key is less than root key, then root left will be equals to delete node root to the left, comma, key. Now, if key to be deleted is greater than the root key, then it lies in the right subtree. So else if key is greater than root key, then root right equals to delete node root right comma key. Now if the key is same as the root key, then this is the node to be deleted. So else if root left equals to null or root to the right is equals to null, then node star temp is equals to root left now if temp is equals to null, then temp will be equals to root and root will equals to null. Else root will be equals to star temp and free temp. Else node star temp is equals to min value node root right Now we will copy the in order successors data to this node. So root e is equals to temp key. Now we will delete this in order successor. So root right is equals to delete node root comma temp key. Now if root is equals to null, then we will return root. Now we will update the height of the current node. So root height is equals to 1 plus max of height of roots left comma height of comma height of root right. Now we will get the balance factor of this node. So int balance is equals to get balance root. If this node becomes unbalanced, then there are 4 cases. First up, LL case. So if balance is greater than 1 and get balance of roots left is greater than equals to 0, then we will return right rotate. Now if balance is greater than 1 and get balance of root left less than 0, then root left will equals to left rotate root left. Now we will return right rotate root. Now let's write right case. So if balance less than -1 and get balance is less than equals to 0, then we will return left rotate now we will write right left case. So if balance is less than -1 and get balance of root right is greater than 0, then root right is equals to right rotate of root right. Now we will return left rotate and we will return this root. Now let's write a function to print pre-order traversal of this tree. So void pre-order node star root so if root not equals to null, then cout root e a pre-order root left and pre-order root right. Now let's write a code for the main block. We will start with an empty tree. So node root is equals to null. Now root is equals to insert root comma 2 root is equals to insert root comma 10 root is equals to insert root comma 9 root is equals to insert root comma 7 root is equals to insert root comma 5 root is equals to insert root comma 3. Now let's try and print this AVL tree. So cout created AVL pre-order pre-order Now we will delete a node. So root is equals to delete node root comma done. Now let's again try and print this. So cout modified behavior tree pre-order after deletion of 10. Layout handle pre-order root read. Now let's execute this. As you can see, our deletion function is working perfectly.
History of C#. C# is a Microsoft-provided object-oriented programming language that runs on a framework for Internet, and Anders Eilsberg was the first person to create it. After learning how the C# programming language was created, we will look at the introduction of C# programming language, where it is used and why we should use it. So, C# is a Microsoft-provided object-oriented language that runs on the .NET framework. C# has its roots in the C family and is related to other popular programming languages like Java and C++. In the year 2002, the first version was released. C# version 8 is the most recent version, which was released in September of the year 2019. C# programming language is used in various fields including mobile applications, desktop applications, web services, websites, games, database applications, and virtual reality. Now, we will look at why we should use C# programming language. C# is one of the most widely used programming languages in the world. It is simple to learn and use, and it has a lot of community support. C# is an object-oriented programming language that gives programs a clean structure and reuses code, lowering development costs. Because C# is like C, C++, and Java, it is simple for the programmers to switch to C# or vice versa. Moving ahead with the fundamentals of C#, we will now look into the data types in C#. Data types can be classified based on their memory location. The first data type in C# programming language is value types. Followed by that, we have the reference data types, and finally, we have the pointer data types. We will go through all these three types in detail. First, we will look at the value data types in C#. A data type is a value type if it can be stored as values in its own memory space. That means this type of data types directly store their data or value in a variable. For example, you can see on my screen we have integer variable I is storing the value 200. So these type of data types are called as value data types. So a few examples of value data types are boolean, byte, character, decimal, double, enum, float, integer, long, short, and structure. Next, we will see the reference data types in C#. So a reference data type, unlike a value type, does not store its value directly. Instead, it saves the address where the value is kept. In other words, a reference type contains a pointer to another memory location where the data is stored. An example of reference data type is string anime is equal to Simplilearn, where the string is reference data type. The following data types are a few examples for reference types, that is, strings, arrays, class, and delegate. Last, we have the pointer data type in C# programming language. A simplest data type is the pointer data type. Its functionality is identical to that of a pointer in C programming language, and it is intended to store the address of another pointer. An example of pointer which is shown on my screen is int pointer p. We will look at the variables in C# after we understood the data types in C#. Variables are storage containers of data values. In C#, there are various types of variables defined with different keywords, such as first, the integer data type, or integers that store values such as 1, 2, 3 or -1, 2, 3. Next data type is the double, which stores floating point numbers with decimal places such as 19.99 or -19.99. Followed by that, we have the character data type, which stores single characters such as A or B. To surround character values, single quotes are used. The next data type is the string data type. The string data type stores string values such as hello world. Double quotes are used to surround the string values. Finally, there is Boolean type data type, which stores values such as true or false. Now, we will look at how to declare variables in C# programming language. To make variable, you must first specify its type and assign its value. The syntax for declaring variables is as follows. We have the data type, which is data types. Here, in this case, we are using integer. Then we have a variable name. In my case, we are having a variable with name, that is name1, and the value we are storing inside is x, y, z. So this is how exactly you try to declare variables in C# programming language. So followed by the variables in C# programming language, we will learn about the operators in C# programming language. Operators are used to manipulate variables and values. There are 4 types of operators in C# programming language. The first one is the arithmetic operators. Next, we have the assignment operators. Followed by that, we have the comparison operators. And lastly, we have the logical operators. We will go through each one of these in detail, beginning with the arithmetic operators. First, we have the additional arithmetic operator, which adds values together. Then there is subtraction operator, takes one value and subtracts it from another. Following that, we have the multiplication operator, which multiplies 2 values. Following that, we have the division operator, which divides one value with another. Next, we have the modulus operator, which returns a reminder of the division. Following that, we have the increment and decrement operators, where increment increases the value by 1 and decrement decreases a value by 1. Next, we have the assignment operators in the list. Variables are assigned with values using the assignment operators. Following are some of the assignment operators to use in C#. First, we have equal to operator, then we have not equal to operator, later we have greater than, next we have less than, following to the assignment operators, we have greater than or equal to, finally we have less than or equal to operators. Last but not the least, we have logical operators, which is used to explain operators in C# programming language. To determine logic between variables or values, logical operators are being used. The first logical operator in C# programming language is AND operator. AND operator provides a result as true if only both the values are true. If one of them is false, then it returns false. Next, after AND operator, we have OR operator. It returns a true value if either of the values is true. If both the values are false, then the result will be false. Finally, we have NOT logical operator. NOT basically is the negation of whatever the number you provide to it. If you provide a true value, it gives you a false value. And if you provide a false value, it returns a true value. Now that we know the fundamentals in C# programming language, that is the data types, variables and operators, we will now look into the basic structure of a C# programming language. So the basic structure of a C# programming language looks something like this. So basic structure of a C# programming language includes a class. So in here we have a class named by Simplilearn. You can also have a class name based on your decision. Next we have the main function followed by the class. Later we have the void and static data types and a line string argument and finally a print message. Now that we have understood the basic structure of a C# programming language, let us see the first C# programming language. So on my screen you can see a basic C# programming language that is used to print a message hello. First we'll use the system namespace in C# and we'll do so because we have namespaces that we use to organize classes and the system in a namespace. Using the system imports the namespace and you can now access the classes in the system namespace. Next, as the first program, we have the class keyword and class name, and then we will enter the main function and print the message hello. Now we will see how to write comments in C# programming language. Comments can be used to explain and improve the readability of C# code. It can also be used to prevent the execution when experimenting with the different codes. In C#, there are two types of comments. The first one is the single line comment, and single line comments are preceded by 2 forward slashes. C# ignores any text between 2 forward slashes and the end of the line does not execute it. You can see this is a comment as the comment, and this comment is being preceded by 2 forward slashes. This particular statement will be ignored by C#. Followed by single line comment, we have double line or multi-line comments in C#. So the comments that span multiple lines begin with / star and end with * can be considered as multi-line comments. C# will ignore any text between these type of comments. In this example, you can see this is a multi-line comment, and this statement will print hello Simplilearn is a comment hidden between / star and */. So this is a multi-line comment. With that, we have finished the multi-line commands in C# programming language. Moving ahead, we will try to install the best IDE for C# programming language, and the tutorial for that is linked in the description box below. Please feel free to check it out. And without further ado, let's get started with the next topic, that is conditional statements in C# programming language. The programmer must specify one or more conditions to be evaluated or tested by the program. A statement or statements to be executed in the form of a condition is determined to be true, or optionally, or other statements to be executed if the condition is determined to be false. The types of conditional statements in C# programming language are as follows. In C#, we start with if statement, then we have if-else statement. Following that, we have an if-else-if ladder and a nested if conditional statement, and finally a switch statement. We will go through all of these conditional statements in C# one after the other. We will begin with if condition statement. In C# programming language, an if statement is defined as a programming conditional statement that is, if true, performs an operation or displays information within the statement block, and the statement for if statement is as follows. If the condition is true, only then a block of code will be executed. The flow diagram of if statement in the conditional statements is as shown below. First, we will begin at the start, and there is a condition. If the condition is true, the following statement will be executed. Next, we have if-else condition statement. In C#, the if-else statement is used to perform the operations based on a specific condition. If the condition is true, the operation specified in the block is executed. Otherwise, the else block is executed. The syntax of if-else statement is as follows. If the condition is true, the block of code is to be executed is true. Otherwise, if the condition is false, the block of code to be executed is false. The flow diagram of if-else statement illustrates as follows. Next, after the if-else statement, we have the if-else-if ladder. In C#, if-else statement is used to perform operations based on specific condition. If the condition is true, the operation specified in the if block are executed, or else the else block will be executed. The following is the syntax for if-else-if statement or if-else-if ladder. If the condition 1 is true, the if block of code will be executed. Otherwise, if condition 1 is false and condition 2 is true, the else-if block will be executed. And if both the conditions are false, then the else block will be executed. The flow diagram for if-else-if statements is as follows. The next type of condition statement we will look is the nested if statement. In C# programming language, a nested if statement is defined as a conditional programming statement that includes another if statement inside the previous if statement. The following is the syntax of nested if statement. If condition 1 is true, the first block of code will be executed. If condition 2 is true, the second if of the block will be executed. And if both the conditions are false, then the else block of statements will be executed. The flow diagram for the nested if statement is as follows. Finally, there is switch condition statement. In C# programming language, the switch is defined as programming selection statement that checks for a possible match to provided condition against the available cases. If none of the cases match, the control will run the default statement of the block. The syntax of switch statement is as follows. First, we have an expression after the switch keyword. Then we have the following cases. If a case matches expression, the code will be executed. If case B matches the expression, case B's code will be executed, and so on. If none of the cases match the expression, then the default block code will be executed. Here is a flow diagram of switch conditional statement that shows how it works in detail. So followed by the conditional statements in C#, we have the loops in C#. In C#, the loop control statement performs a looping operation until the given condition is met. When the condition is false, the controls are removed from the loop statements. There are 3 different types of loops in C# programming language as listed below. The first loop is for loop. Next we have while loop, and lastly we have do while loop. The syntax for for loop is as follows. 3 statements in parentheses after the keyword for. Statement 1 is executed once before the code block is executed. Statement 2 specifies the condition under which the code block will be executed. After code block has been executed, statement 3 is executed every time. The flow diagram for the for loop is as shown below. First, we will begin, then we will initialize, and then there is a condition. If the condition is true, we will increment or decrement accordingly. And if the condition is false, we will end the process. Following that, we will learn about the while loop. While loop is a repeat statement or group of statements if a given condition is true. Before executing the loop body, it checks the condition. The syntax for while loop is simple because there is only one condition, which will be run until the condition becomes false. The flow diagram for while loop is shown as below. First, we will start the loop. Then if the condition is true, the statement will be executed until the condition is false. Now we have do while loop at the end. Do while loop is an alternative to while loop. This loop will execute the code block once before checking the condition is true, and then it will loop along with the condition is true. If the condition is false, then the loop will stop. The flow diagram for do while loop is as follows. Following that, we will learn about arrays in C# programming language. A fixed size sequential collection of elements of the same data type are stored in an array. An array stores a collection of data, but it is often more useful to think of an array as a collection of variables of the same type stored in continuous memory locations. Instead of declaring individual variables like array, array1, array2, 3, 4, and 99, you declare one array variable like array and use memory locations array of 0, array of 1 until array of 99 to represent individual variables. An index is used to access a specific element in an array. Here we have an array. Array 0 is the first element and array 99 is the last element of the array. Following that, we will look into how to declare an array in C#. In C#, you can declare an array using the following syntax. We start with data type, then we have square brackets where we specify the size of the array, and finally we have the array name. An array example is shown in the screen where data type is integer and the array name is array. Next, we will look into how to initialize array. Declaring an array does not cause the array to be initialized in memory. After the array variable has been initialized, you can assign values to it. The syntax is as follows. Because the array is a reference data type, you must see the new keyword to create an array instance. In the following example, we have an array called numbers with the data type int, which we initialize with the keyword new. We will understand strings in C# after seeing arrays in C#. So the string in C# is a string object with the value text. The text is internally stored as a sequential read-only collection of character objects. Because there is no null terminating character in the end of C# string, it can contain any number of embedded null characters. The syntax of string is given below, where first we have a character string followed by a string's name as A, B, C. An example of string, that is Simplilearn, there are string functions listed below. First we have the clone function, which returns a string reference. Next we have a compare function that compares two specific strings. After that we have a concat function that joins two strings and stores the results in the first string. Following that we have that contains return the value of the specified string. After that we have a copy to which the character from the specified position. The following equals function that determines the two string objects we have the same value. Lastly, we have a trim function that trims the string. Following these C# basics, we will learn about C# methods or functions in this tutorial. A method is a collection of statements that work together to complete a task. Every C#, the program contains at least one class with the main method. To use methods in C#, we must perform first to define the method and secondly to call the method. First, we will define the methods. When you define a method, you are essentially declaring the elements that make up its structure. The syntax for defining a method is as follows. First, we have an access specifier, then we have a return type, then we have a method name, lastly we have a parameter list, and finally we have the block of code. In the following example, we have a specific public access specifier and returns types of int. We have a method with name findMinimum, which finds out minimum number between the variables a and b. Following that, we will learn how to call a method. You can call a method using the name of the method. The following examples exemplifies it. We have used the same example in defining the method. So in the main function, we have called the findMin function, which is assigned to the result variable and prints minimum value. Following that, we will understand the collections in C#. Collection classes are specialized data storage and retrieval classes. Stacks, queues, lists, and hash tables are all supported by these classes. The interfaces of most collection classes are the same. Collection classes serve various functions such as dynamically allocating memory to elements and accessing a list of items via an index, among others. These classes construct collections of objects which serve as foundation for all the data types in C#. The following are some C# collection classes. The system.collection namespaces. Most used classes are listed below. To learn more about them, the link is in the description box below. First, we have ArrayList classes. It represents an ordered collection of objects that can be individually indexed. The next class is HashTable. It makes use of key to gain access to the elements in the collection. Following that, we have SortedList. To access the items in a list, it employs both a key and an index. After that, we have a Stack class. It represents a collection of objects arranged in a last in first out order. Next, we have Queue classes. It represents a collection of objects arranged in a first in first out order. Last but not the least, Bit Array. It represents a binary representation array with values 1 and 0. After we understand collections in C#, we will see enums in C#. An enum is a type of class representing a collection of constraints, variables that cannot be changed or read. Use the enum keyword rather than class or interface to create an enum, and separate the enum items with a comma. In the following example, the name of enum is direction, and all 4 directions, which are east, west, north, and south, are separated by comma. We will now look into the object-oriented programming in C#. OOP is an abbreviation for object-oriented programming. Writing procedures or methods that perform operations on data is what procedural programming is all about. In contrast, an object-oriented programming is all about creating objects that contain both data and methods. Object-oriented programming has several advantages over procedural programming, including the following. Object-oriented programming is faster and easier to implement. Object-oriented programming gives the programs a clear structure. Object-oriented programming aids in keeping C# code dry, do not repeat yourself, and makes it easier to maintain, modify, and debug. Object-oriented programming allows for the creation of fully reusable applications with less code and shorter development time. After learning about OOPs, we will learn about the object-oriented programming paradigms in C# programming language. First, we must comprehend classes and objects. In C#, everything is associated with classes and objects and their attributes and methods. A car, for example, is an object in real life. The car has attributes like size, color, as well as methods like start and stop. The class functions similarly to an object function is a blueprint for creating objects. The following is an example. An object is a car and its attributes are its size and color, and starting and stopping are its methods. Following that, we will go through the 4 fundamental object-oriented programming concepts in OOPs in C#. The first concept of OOPs is abstraction, followed by that we have encapsulation, inheritance, and finally we have polymorphism. We will learn all these 4 concepts in depth. First, C# abstraction. Abstraction processes hiding of internal details and displaying only the main functionality. Next, we have encapsulation. Encapsulation in C# is the process of combining data members and member functions into a single unit. After that, we have C# inheritance. It is a process by which one object automatically inherits all the properties and behaviors of its parent object. And lastly, polymorphism. It is defined as one name, many forms. Polymorphism allows a class to have multiple implementations with same name. Next, we have access modifiers or access specifiers in C#. In C#, access modifiers specify the scope of accessibility of a class member or a type of class itself. The first access specifier is public, indicating that the code is accessible to all classes. The following access specifier is private, meaning the code can be only accessed within the same class. Following that, the protected access specifier. The code is accessible within the same class or a class inherited from that class. Finally, there is an internal access specifier, which means that the code is only accessible within its assembly and cannot be accessed from another assembly. Following that, we will learn about the file operations in C#. The file mode enumerator defines various file opening methods. The following members of file mode enumerations are described. First, there is append function. Text is appended to an end of an already existing file. The following functions is the copy function which duplicates the file. The third function is the creation function, which is used to create or replace a file. Following that, we have the delete function, which deletes a file. The fifth function is the exists function, which determines whether or not a file exists. Following that, we have read all text function. This function reads a file contents. After that, we have replace function. It replaces one file's contents with contents of another. Finally, write all text creates a file and writes its contents into it. So following the file handling in C#, we have the exception handling in C#. Exception handling is a phrase that deals with handling errors and exceptions that occur during runtime due to coding errors or invalid user input. In C# programming language, we use 4 keywords in exception handling. We'll start with try exception handling. The try statement lets you define a section of code that will be checked for errors as it runs. The catch statement is used for exception handling if an error occurs in the try block. It allows you to define a block of code that will be executed. Following that, we have finally exception handling. The final statement allows you to run code after the try statement regardless of the outcome of catch. Finally, there is throw exception handling. You can define your error using the throw statement. Finally, in this video, we will learn about the new features of C# programming language. So some of the important new features of C# programming language includes the following: interface methods by default, types of nullable, references, enhancements to pattern matching, asynchronous streams, making use of declarations, interpolated verbatim string enhancement, assignment of null coalescing, local static functions, indices and their ranges, types of unmanaged construction. In nested expressions, use the read-only member stackable.
Hello guys, this is Vikesh and let's get started with enums or enumerations or enumerated types in Java. So before we go into enums, let's understand why we need it. When you will be building the Java applications, you will face scenarios where you will have to define some variables which will remain constant forever. For example, months of the year. They are not going to change. They are always going to be 12 months in an year. Similarly, let's say name of flowers. They are not going to change. A lotus will be a lotus forever. Similarly, the name of the seasons will always remain same. The season of summer or winter will always be called summer or winter. They will not be changed. The meaning of those variables will never be overwritten or will never be changed. So you can think of them as constants, but they are not the constants which your programs may mutate or your programs may interpret differently. They will be interpreted by multiple applications, multiple components, multiple consumers in exactly the same way. Similarly, if you take the example of time zones, they are fixed. They work with the GMT with respect to the GMT time zone, and they will always remain like that. So whenever you have a situation where you have to define such constructs or such constants, always think of enum types or enumerated types. Enum is basically a language construct, and you can use this language construct to define type safe variables. When we say type safe variables, what we mean is that these variables are not integer or string. They are of enum types. That's the reason Java created a completely new data type, which is called the enum type. They are by default constant, so you cannot change them. That's their property. And the way you define enums is like this. You say public enum. So instead of the keyword class, you use the keyword enum, and then you define the name of the enum, the name of the enum type, and then you define the possible values, just simply separating them by a comma. So for example, days of the week is again a constant thing. There will always be 7 days of the week, irrespective of what you do on this planet. So that's why you can declare an enum for the day, and you can define those as the values. You also notice that the values are caps by default, and yes, that is how you define the enums. Let's have a look at a more interesting example of the enums in the IDE now. So if I switch to the IDE, I have created a class called color, not a class, but an enum type called color. And this enum type color is basically holding all the different color types, their values basically, like all the WebGear colors, for example. So I've defined 3 colors here, which are red, green, and blue. So you see, I've defined them as caps. They automatically become bold. You don't have to bold them. But you see an interesting thing, a difference here, that there is another value in the brackets here. This was not there when we looked at this example of day. There is no value inside each of the enum types, but I have defined the value of the enum types, and that is optional. There will be use cases where you want to define some enum constants, where the name of the enum type is a constant, which is a placeholder, but it will have an internal value, which may be more practical for your application. So this is what your consumers see, and this is what is used whenever you call red inside your application. Is just for simplicity. There might be use cases where you use some abbreviations and their full forms. For example, if you want to use here an abbreviation of, let's say, WHO, and inside this you can define the value as World Health Organization. So this is just a toy example I'm giving you, where you will have use cases where you want to define a constant, but you want to define an internal value of it, which is to be read by your application elsewhere. But everybody who wants to consume this enum can just use this particular keyword. And if they want to get the value, they can get the value as well. So this is the use case where you might need to define values of your enum types as well. But whenever you have to do that, if you want to fetch the value of an enum type, you have to write some extra code which is written here. If you are not defining the value of your enum types, your enum can be as simple as this. You don't need to define anything else apart from just defining the constant of the enum types. I'm giving a more complex use case so that it covers both of the things of using just the constants and also using the values. So if you just want to read the constant, you can just say color.red or color.green or color.blue in different classes, and you will be able to refer to the enum types or use the enum types. But if you want to refer to the value of the enum type, then probably you need to call this method called getValue. So whenever you define a value, what you would do is you will define a private member variable inside the enum, which is defined here. You can name it anything if you want. You define a constructor where you set this particular value, and then you define a getter. So whenever some consumer application wants to refer to the value of your enum type, they can call this getValue method to get that. So this is the enum. Now let's see how we can use this enum. For using this enum, I have this main class where I have a public static void main method, and you can simply fetch the enum types by writing the code like this. Just write the enum type holder and then type the enum type. So let me show you how this is done. If you just put a dot here, you will get all the enum type options. So I've defined 3 enum types, red, green, and blue, and I get all the options. So whatever option I want to choose, I can just select here, and I can store this inside an enum variable. So if you want to just refer to the name of the enum, so this C1 is holding color.red or red. So if you want to refer to this, just this red, then you can call the dot name method on the C1 variable. So if you say C1.name, it is going to put or print the red in caps. And if you want to fetch the value inside the red, remember the value is red in small caps. So if you want to refer to the, or if you want to fetch the value of the red, then you call the getValue method, which we have defined here. So that's what we are doing here in this first 2 sysouts, where we are printing the red enum name and then printing the red enum value. Now you can also iterate over all the enum types. And for that, you need to call the .values method on the enum. So you can just say color.values, which is going to iterate over all the enum types. And you are just storing each of the enum type in this color placeholder. Then you can either call getValue to get the actual value of that enum type, or you can call the name to just print the name of the enum as well. Both of the options are available. So let's just put it back to getValue and let's run this code. So if I run this application, I get some output here, which looks like this. First sysout says red enum name is red in caps because we are calling the name method. Second says red enum value, which prints red in small because we are calling the getValue method. and then we are iterating over all the enums. So I had 3 enum variables here, red, green, and blue, and I'm going to iterate over all of them one by one here, printing their value and not the enum constants. So that's why you see the red, green, and blue here in small. But if you just want to print the enum constants themselves and not their values, then you change this to .name, and then all the enum constants will be printed here. So this is how you can create enums and use enums for the constants which are never going to change in your application. Let's get started with annotations in Java. Now, annotations is a bit advanced concept, so let's understand why we need it. There would be some cases in your application where you need to provide some metadata information to the Java compiler. Now, this sounds a bit complicated, but it's much simpler than that, because you might not want to code everything with a lot of lines of code. Rather, you want to give some smart instructions to the Java compiler so that they understand what to do. We have already seen some of the annotations, but the basic idea of annotations is to provide some shorthand metadata information about the program to the Java compiler. Generally, annotations will not have any direct effect on the operation of the code they annotate, but they provide additional logic to the code. That's the idea with annotation. Remember, they are shorthand metadata. The main use is providing information to the compiler, or providing some compile time or deployment time processing, or also providing some instructions for runtime processing. We have already seen some of the annotations. If you remember, when we were dealing with inheritance, we had this override over the methods, right? This override is an annotation. This annotation, if I show you what I'm talking about, if I take you back to one of the inheritance example or the method overriding examples, and if I open the mountain bike class here, mountain bike extends bicycle, you will see this override annotation. This is an annotation. An annotation always starts with @ in Java, and the annotation name is override. Now, this override is just a shorthand to tell the compiler that, hey, I am overriding this method from the base class. That's what this annotation does. If you remove the annotation, in some cases, the Java compiler might not understand what to do, and the Java compiler has to do some extra processing to figure out that this method is actually being overridden. But if you put this @override here, then the Java compiler pre-hand will know that this is coming from the base class. So you save some of the compiler processing time as well by using the annotation. It's a shorthand providing instructions to the compiler. You see exactly what I'm talking about. So this is one of the annotations which we have used, but we will look at some of the other more generic annotations, and we will also see how we can build our own custom annotation in Java. You might have also seen some other annotations, like, for example, you can put @suppress warning annotation, which is a very popular annotation to suppress any kind of yellow warnings in your code. Generally, we do not recommend doing that, but if you have a use case, then you can use @suppress annotation as well. There are some other annotations as well, like @author. If you want to put your name as the author of a particular piece of code, then you can add this metadata so that whenever somebody looks at even the documentation of your code, your name will be shown there as the author. So that's the idea with annotations. So let's see how you can build your own custom annotation. Whenever you have to do that, there are multiple ways to doing that. And the first type of annotation we are going to have a look at is called marker annotation. A marker annotation is just an empty annotation without having any metadata logic at all. You can see I have defined an annotation here. I will talk about what all this means, but inside the block, there is no code here. And this is how you define a marker annotation. Marker annotation is just to provide very high level instructions to the compiler. And the way you will write your custom annotation is you will put an access modifier keyword like public. Then you will write @interface. This is the keyword which you have to use whenever you're trying to create your custom annotation. Marker or no marker doesn't matter. Whenever you define your annotation, you have to use @interface. Once you do that, then you provide a name for your annotation, which can be anything, but still not complete. You need to also provide more instructions to the compiler or the runtime processor to tell them when to execute this annotation and what the annotation type is going to be applied upon. So at first you specify when this annotation is going to be active or executed or evaluated. So here you can say @retention, which is another annotation. So you say @retention, and then you say retention policy dot whatever you want to write as. You can write it as runtime or you can write it as source. If you write it as source, then it is going to be applied at compile time. And if you select it as runtime, then the annotation is going to be processed at runtime. So this is the first thing which you need to provide. The second thing which you need to provide is where this annotation is going to be applied, whether you want this annotation to be applied to a class or to a method or to a member variable or to any other type. And that's what you define in the @target annotation. You specify the target audience for this particular annotation. And here inside the element type, you will get multiple options. You can apply this annotation to a constructor, to a field, local variable, method, module, package, record component, type, etc. So here I'm going to use type, which means it can be applied to a class or a generic element type, which generally means class type. And that's all. You can define your marker annotation like this. But generally these marker annotations does not have any logic, so you will not get much value out of it until you have very special cases. But if you have a case where you want to also run some business logic or provide some metadata logic to the compiler while defining the annotation, then you can define your annotation like this. So I've created one more annotation here, which is called my custom annotation. Again, the target audience for this is method. So this annotation can only and only be applied to methods. If you try to apply this annotation to a class, you will get an error. The retention policy is runtime. It means it is going to be processed at runtime. And I've declared a method here, which is called int value. So this is how you will declare your annotation. Now let's see how do you use this annotation. So I have a class called as my class here. And if you look at this structure of the my class, we create the class and then I create a method, which is named as say hello. And I am applying this annotation on this particular method. Remember, the target audience of this particular annotation was method, so it only be applied on method. If I try to put this on the class type here, then I get an error here. It says the annotation, my custom annotation, is disallowed at this location because the type specified is of type method. So the compiler will not allow you to use this at an illegal place. So you write any method and you apply your annotation, but you provide a value to the method. The int value method is going to consume this value. And inside the method, you can write any other logic. So let's see how this pans out. I create a public static void main method and I create an object of my class. So my class h equal to new my class. And after that, I'm saying h.getClass.get method. I'm basically calling the method by using reflection API. You can also call the method directly if you want, but this is how you need to call it if you want to use the annotation property value, if you want to fetch the value of the annotation. So this is just an example of me showing you how you fetch the annotation. So we created an object and then we say get class, which is going to return my class type, and then get method is going to return the method type, which has the name say hello. So this is a way to fetch a method name or a method type from a class using Java's reflection API, which is an advanced API. You might not need to use it, but for the sake of demo, I'm using this. So we fetch the class and we fetch the method. It is going to search the class for a method named say hello. If it finds the method, it is going to return the method in this variable. And then you can call method val, which was this variable, dot get annotation. Give me any annotation which is applied on this particular method. And you supply the annotation class type as well. Once you do that, you get a my custom annotation reference type. And then if you call the value method on this, you will get this value as 10. So this is a way where you can apply an annotation and you can actually see the effect of the annotation. You might not always want to do this because, like I said, these are metadata instructions to the compiler. But if you have a need to actually see what your annotation is doing, you can use the getClass.get method to first fetch the method, store it into a method type, and then call get annotation, supplying the exact annotation class type. And then you can call the exact method which is defined in your annotation. Here I've defined it as value, so I'm just calling the value method. So if I run this particular example, I get the value as 10. So I'm able to see or fetch the exact value which my annotation metadata is holding at the runtime. And this is the power of annotation. They're a very powerful concept and they're a very advanced concept. There would be very rare scenarios in your application where you need to create your custom annotations. Generally, you will be better off with your predefined annotations which are provided in Java, like @override, @author, suppress warning, etc. Let's get started with serialization in Java. Now, before we go further, let's understand why we need the concept of serialization. When you will be building the enterprise grade applications in different organizations, you will often have a use case or a need to send an object from one application to other application which is deployed on some other machine. So if you have a network of computers, or if you have a lot of different complex setup where you have a producer application and you have a consumer application. Producer application produces the object, and then this object gets traveled over the network lines, over the network wires, and reaches at the consumer application. And how does the consumer application receive the object, and how does the producer application sends the object? Because when the data travels over the network lines, it will be all bytes. So how do you convert a Java object into bytes, send it over network, and then the consumer application has to again convert that bytes back to an object representation and then store that or use that inside its application. So you need to do this whole conversion, right? So the process of converting an object to a byte so that it can be sent over a network is called serialization. And the process of converting back the byte from the network to a Java object is called deserialization. So generally, you may have a use case where you serialize an object, create a binary representation of it, send it over the network. And that's where the Java serialization concept kicks in. Whenever you have to do this in Java, you will be using the serializable interface. So you need to extend your objects from this serializable interface so that those objects themselves becomes serializable. You need to tell Java that this object is able to serialize itself and deserialize itself. And the way you will tell Java is by letting that object implementing the serializable interface. Let's have a look at an example of this serialization and deserialization to understand this concept better. So here again, I've used the same student class where it has the name, age, and address. So you can see I have created a student class, but the student class implements serializable. This is something which you have to add to your class. Second thing, the moment you do that, all the modern day IDEs like Eclipse or IntelliJ will ask you to add a serial version universal ID to this particular class. This is added so that Java can uniquely identify your object once it is serialized and deserialized. And it will also keep a versioning track of it, right? Because when you serialize the object, what happens if somebody hops over the network line and change the representation of your object? And the consumer application will get a completely different object copy now. So this is Java's way to make sure that the same version which the producer application is producing is received by the consumer application. So it's also sort of a security feature. It basically, whenever you do an update onto the object, it is going to increment this serial version UID by 1. So when you create the object first time and you serialize it for the very first time, the value is going to be set as default 1. And as you mutate the object again and again, before deserializing it, the count will just keep on increasing. So that's how you keep a track of the state of the object which is being serialized by adding this long serial version UID. You can also specify your own value if you want to. By default, Java initializes a value of 1, and this is a long type variable. So that is the only new thing which is happening the moment you do implement serializable. After that, I have the same fields here. I have the constructor and the setters and the getters. And I also have a toString method just to print the object nicely, where I print the name, the age, and the address. So let's look at a main class and where we use the student object. We serialize this object and then we deserialize this object. So what is happening here is I create a class, I create the main method, and I create a student object. This is something which we have already seen. Then I want to store the state of this object. When you serialize this object has to be either sent to a network. But since I'm running this demo on the same machine, what I will do that I will serialize this object onto my local file system. It's the same thing, right? You can put it somewhere and then fetch it from there. So either you can send it over the network or you can put it on a file system. So I create the object and then I need to store this into a file. So far, I have not covered the file handling operations. So we will not go deeper into the file handling classes here, but I will just explain you the reasoning for it. And when we'll do the file handling session, there I will go in detail about the file handling classes. So I specify a file name where the serialized representation of my student object is going to be stored. And this is the location where I'm supposed to store this. Then I create two different classes, which is for writing to the file and then creating an object for it. So that's what I'm doing here. We can ignore this particular part where I'm just supplying the file name, and we can focus on this part, this line, where I'm saying write the object, the student object, to this particular file. That's what I'm doing here in this 3 lines of code, that I'm writing the student object to the file. So when Java has to write this object to the file, it is automatically going to serialize it. That's the only way Java can write an object to the file. So you serialize the object, and then you print that message that the object has been serialized. Again, you can ignore this part as well. Like I said, we will not focus on this. But what we technically did is we just wrote the object to a file by serializing it. Then I try to deserialize it. So I load this same file into the Java JVM, and then I read the object. And the way I read the object is by using this object input stream class. I supply the file that read this particular file, and then I call the read object method, which is going to return an object, a general object. When you call the read object method does not know that it is a student type object. So you need to explicitly cast this to the student type so that you can store this as a student object. If you do not cast this, you will get an error, because like I said, read object does not know anything about the student class. So what does this mean is that when you serialize an object, the class type information is lost. You cannot store the class type information when you serialize an object, because the moment you call this write object method from the object output stream class, so you created this object output stream class, you supply the file output location, and you call the write object. The moment you call the write object, it's just any Java object for this Java program. The signature of the student class is lost. It does not know that it's a student class anymore once it is being serialized. Similarly, when you deserialize it, the serialization API has no idea about what student class is and what student object is. So you need to tell the read object method explicitly that, hey, you are reading an object of the student type. And that's how this line works. Once you explicitly provide the casting operation. Once you have casted it, we try to print the same deserialized object to see if all the state which we stored in the object is still persisted there or not when we deserialize it. So our major focus in this particular class is this object output stream classes and the write object method. These are the two most important statements which you need to take care of. The file output stream is basically a file location. What is an output stream? We will talk about that later, but whenever you need to serialize, you need to use this particular class called object output stream. So that's all I'm doing here. I'm serializing the object with these values, and then I will deserialize and I will again print the object to see if these values are still there or not. So let's run this application. So when I run this application, let's start from here. First, this sysout gets called, which says object has been serialized. So you see object has been serialized. And what I serialized was this student object, which had the value of name as John, age as 25, and the address as 23 East California. And that's what gets printed here. Then this whole block gets completed. This whole try block gets completed. It's a standard try catch block. You see, I have also added the IO exception. You need to do that because these file operations will force you to catch or throw the IO exception, which is a checked exception. That's why it will force you to do that. Then we move to the deserialization block, where we create an object of the object input stream class, and then we call the read object. We cast it to the student type, and then we print the object. So when I print this object, this line gets printed, object has been deserialized, and then I can see that the exact same state is still there. The name which I set in the object is still there after being deserialized. The age and the address is exactly intact. So this is how you can serialize an object, send it anywhere you want, and then the consumer application need to read the object and cast it back to the student type, and they will be able to see the exact same state which you saved in the object just before serializing it. What if you have a use case where you have a property in a student class or in your object, but you do not want that to be serialized? That's also a use case where you may have 50 different properties inside the student class, and one of the properties is something which you do not want to serialize because you do not want the consumer application to see that value. If you ever had that scenario, use the transient variable. So transient is again a keyword, and the moment you put this keyword in front of a member variable, that variable becomes transient. The use case of transient variable is that if you do not want this X to be serialized and deserialized, then you put the transient keyword in front of it. The normal member variables will automatically get serialized and deserialized when the object is serialized and deserialized. But if you have a use case where you do not want a particular member variable to be serialized or deserialized, put transient in front of it, and then have the getters and setters for this X variable. And let's use this and see if this actually gets serialized or not. So I created the student object, and let me call student.setX, and let's put a value to X. Let's say 10. So I have set the value of X is 10, and X is a transient variable, and then I am serializing the whole object here, and then I'm deserializing the object. And let's see if I'm able to fetch the value of X after deserializing the student object. So I'm calling the system.out.println, and the deserialized value of X is object.getX. Let's see if I'm able to see the value of X or not. So let's run this application again. So this is exactly the same as before. This is also exactly the same as before, but I see the value of X is 0. Remember, I set the value as 10 before serializing it, but I don't see the value 10 anymore when I deserialize the object because it was transient. If you remove transient from it, then you will be able to transfer or travel this value of 10 between serialization and deserialization. So if I just remove this here, don't change anything at all, and I just rerun the application, this time when I deserialize the object, the value of X as 10 is still present there even after deserialization. So this is how you can use the transient variables if you want to not have that object serialized or deserialized when you're doing the serialization. Let's get started with concurrency and threads. The reason I want to talk about concurrency because once we understand about the concurrency, it will become much more simpler to talk about threads. And the idea behind concurrency is very simple and plain. And that idea is that as a developer, when you write a program, you would expect the machine or the computer to run multiple tasks in parallel. For example, right now, I'm recording this video on a particular laptop, which is recording my voice, which is also recording the screen, which is also running the Eclipse IDE and also running our Chrome browser. It also have opened multiple background applications. So there are a lot of tasks running in parallel at the same time. And that's the idea about concurrency. Now, how do we work with concurrency in Java is with the help of processes and threads. So these are the two basic units of execution when we talk about concurrent programming in Java. And when we talk about processes, you can think of a process as basically an execution environment, or I should call it as a standalone execution environment. Think of a logical box which is completely cut out from everything and it has its own environment. For example, again, the recording software is running in its own execution environment. And when we talk about process generally has an everything or a private set of all the runtime resources it needs and the memory space it needs. Now, there's another concept or another construct which is very important is threads. So threads are also sometimes called lightweight processes. And basically, when we talk about threads, a thread also has an execution environment, but creating a new thread requires a lot less resources than creating a new process. And you can also think of threads as a mini version of a process because a process can have multiple threads. Remember that statement that a process can have multiple threads. Threads always exist within a process. And whenever you start a process, there will be at least one thread attached to it. And each thread is basically a task. For example, the voice recording can be a process, and inside that, the mic recording expression or the mic recording task can be run by a particular thread. Let's take another example that when you play games, let's say you're playing a racing game. So when you play the racing game, there are multiple things happening at once. You see the current speed of your car or bike on the screen. You also see your leaderboard position, what ranking you have in the race currently. You also see some other kind of features like player's health or the car's health or the fuel consumption available, and lots of other stuff. The graphics, the motorcycle, the other competitors' bikes and their speeds and their distance to you as well. So if you see, all of these are running on different threads. There's a different thread to show your current speed. There's a different thread to show the current leaderboard position. There's a different thread to show the fuel indicator, etc. Everything is running in a different thread. So all of these threads need to run at the same time in your program for a complete immersive user experience. And that's what we mean when we say multi-threading, that we want multiple threads to run at the same time to create a better experience in the application. So that's basically the theoretical part of it. Please do read more about how threads work and how processes work. And there's a lot more documentation available in the Java docs as well when we talk about threads. But I will keep the theoretical part to this particular point. And now we will move to an Eclipse example to see how we can create threads. So with that, let's move to the Eclipse IDE. And here I have a demo prepared basically. So what I have here is a threading demo class, which has a public static void main method, and it has a simple for loop. And inside the for loop, I see this strange code here where I am initializing two threads and starting them. So that's all I'm doing here. But let's see how this thread1 and thread2 class have been written and why do I see two different ways of initializing them. Let's go deeper into this now. So let's see how thread1 can be created. So first of all, you can create a thread by just creating a simple class, but make sure that you extend it with the pre-built thread class. This thread class is coming from Java. So from the JDK basically. So the moment you extend your normal class from the thread class, then you will have to override the run method. So if I show you the thread class here, this is the thread class implementation available inside the JDK. And this is the class which is getting called when you are extending it from the thread class. And this thread class will ask you to override a run method. Here the override annotation is missing. So let me just add this for better understanding. So you need to override the run method. And this is something which you need to do so that you can specify what happens when you run the thread. So this run method will be called whenever the thread is running. At this particular point, I would also like to tell you that there are different states in the thread. So there is a thread which says thread is ready. Then there is a state which says thread is running. There is also a state where the thread is waiting for an IO input from the user from the console or the command line. There can also be a state which says dead, where the thread has completed its task and it's not working. There can also be a state which is called sleep state, where the thread is paused. So there are different states of the thread. And in this example, we are going to focus primarily on three states, which is the ready state and the running state and the completed state. So when you call the run method, the thread state is going to change to running. And whatever code you write inside this particular run method will be the logic which this particular thread is supposed to execute. Here I'm just putting a dummy logic where I'm just printing a sysout, but definitely if you try to create your threads, this will contain your actual business logic. For example, that fuel indicator code or for the leaderboard position code will go inside this run method. And then I'm catching an exception if there's an exception, but obviously there will not be an exception coming in because I have nothing here literally. So that's what we are doing when we are creating this thread1 class. And let's come back to the threading demo now. So to initialize a thread, or initialize might not be the right word, to run a thread, the first thing which you need to do is to initialize the class containing the run method. So I would avoid calling this class as thread because technically this is just a class. So you basically create an object of the thread just like you create the object of any other class. There's nothing new here, right? So we just say new thread1 and then we call t1.start. Now, if you observe carefully, there is no start method here. We just had a run method, but this code is still compiling fine. And I'm calling the start method here because the start method is the internal method of the thread class, which in turn is going to call the run method. So you are never going to invoke the run method directly. you just need to start the thread, which is going to change the state of the thread from ready to running. So this start method has the responsibility of changing the state to running, and the way the start method is going to do that is by calling the run method internally inside the JDK itself. From developer perspective, you just need to call the start method and that's it. The thread will start running and whatever is present in the run method will get executed. So that's the way to start the thread. Second thing, I have one more thread created here, which is the thread2 class. So in this case, when I create a thread2 class, I'm not extending it from the thread class. Rather, I'm implementing the runnable interface here. So this is a different interface available, which is a functional interface, which means it will have just one method, which is the run method. But the interesting thing is that here, when I created thread1, I said extends thread. But here, when I'm creating the second thread, I'm not using extends thread, but I'm using implements runnable. Let's understand why do we do that first of all. The reason Java provides two different ways of creating threads is because there might be a use case that you need to extend your thread2 class from some of your custom Java class. Remember, Java does not support multiple inheritance. So at a time, you can only extend this class from one class. So what if there was no runnable interface and you need to extend this thread2 from student class, let's say. So you need to do class thread2 extends student, for example. The student is not present here, but let's assume it is. So you do this, and then you also have to extend it from thread. Now, Java doesn't support multiple inheritance, and this will not work. So what would you do if you have to also create it as a thread, but also extend it from some of your parent class? You will not be able to do that. And that's the reason Java provides the implements runnable, because then you can extend it from any of your superclass of your interest, and at the same time, also implement it with runnable interface so that you can treat this class as a thread. So that's the reason Java provides two different ways of creating threads. Remember that it's a very important concept. And once you implement runnable, again, it will ask you to override the run method. So I will just put override annotation here. So once you override the run method, again, you can write whatever logic you want this particular thread to execute inside the run block. Coming back to the main class. So when you are extending from thread, the initialization is very simple, where you create the object and you call the start method on the object. But if you are creating a thread by implementing the runnable interface, the initialization of the thread is a bit different. And it's different in this particular part. On the left-hand side, you still say thread T2. Remember, you are saying thread and not thread2. This is the Java thread class. This is the JDK thread class, not your own thread class. So you say thread T2, then you say new thread, and inside the new thread, you provide your own class type. Thread2 was your own class type. So you specified your own custom thread class here. Inside the new thread constructor, this thread class is the JDK class. If you click on this, you will see this is from the JDK class. So that's the difference. Extending thread, simple initialization, implementing runnable interface, do the initialization like this. And after that, you call similarly the start method, which is in turn going to call the run method. So that was how you create threads differently. And now let's run this program to understand how the output looks like when we run these threads in loops. Remember, I'm initializing 10 instances of each of these threads. So in total, there would be 20 output lines. So if I go to run as Java application, I see this output here. So let's observe this output for once. So thread 1, thread 2 is running in sequence in the first time, but then you see thread 1 is running twice, and then thread 2 is running twice. Then again you see a good sequence, but again thread 2 has run twice here. Again thread 1 has run twice. If I go further down, thread 1 runs once, then again thread 2 runs twice. Thread 1 runs once, thread 2 runs once. So there is no particular order here, though based on the code which we have written, we should expect thread 1 is running from here and then thread 2 is running output from here in a sequential fashion. But we don't see the sequential fashion here. And this is the power of concurrency. This is because threads never run in sequence, they run in parallel. And which thread will execute first, you can't really predict that. So so be very careful whenever you are writing multi-threading code, because you cannot predict the sequence of execution, because threads are going to run whenever they find the idle CPU. So the key is the idle CPU. Whenever a thread finds an idle CPU, it is going to occupy that CPU and going to run its own execution. And the moment its execution finishes, the other thread will jump in and take a piece of the CPU. So whichever thread gets the idle piece of the CPU is going to execute. And that is the reason you see this randomized output. The next time you're going to run, you will see a different random order. So this time you see thread 1 ran 4 times. You did not see this in the previous execution. If you run it again, you will see again a different output. This time the thread 1 ran thrice. So every time you will run this, you will see a different sequence. There is no guarantee of order because the threads are running in parallel and they're running whenever they get the idle CPU. That's the bottom line. So this is how we are going to create threads. And remember, you cannot guarantee the sequence of the execution. So write your code accordingly and use the threads for independently running parallel threads which do not depend upon each other. Let's get started with thread synchronization in Java. So in the previous example, we saw that when we execute threads, then we can't guarantee the sequence. But it's actually technically not a problem in the example which we had a look at before, but it can become a bigger problem when two threads are trying to access the same object. Remember, object has properties and state. So what if the first thread modified the object state and the second thread is reading the state of the object? The second thread is expecting the original state, but while it was trying to read it, the other thread modified its state. So you can see this can become a big problem. For example, if you are working with a banking system and if there are two persons accessing the same account at the same time, one is depositing the money and one is withdrawing the money from the account. And if the total balance is 1,000, and if both of them deposit 500 and withdraw 500 at the same time, then who sees what? And if these are handled by two different threads, then we can't guarantee if somebody sees a 1,500 as the total sum or somebody sees a 500 as the total sum, or there can be a scenario where somebody sees 0 as the total sum. So the application can turn into really weird scenarios if two threads are trying to change the state of a particular object at the same time. And Java provides a solution of it with the concept of intrinsic locks and synchronizations. So the idea is that when a thread tries to work on a particular object, it basically takes a lock on that particular object. We also call this as an intrinsic lock or monitor lock. So it takes a lock on the object, and it means that that particular object becomes completely inaccessible to other threads in the system at that particular time. So the moment you put synchronization or you put lock on a particular object, only the thread which has taken the lock will be able to access the object, and other threads will be forbidden from accessing the object. So that's the idea behind intrinsic locks and synchronization. So that was about the brief theory of it. Now let's have a look at a practical example. So I have prepared another example for it. So here I have again created two threads, but these two threads, it's pretty much the same threads which we covered in the previous session, named as thread 1 and thread 2. One is extending thread class and other is implementing runnable. But that's same, but the interesting part is this. Both of them have a reference to a class called mathutils. If you see, thread 1 also has the reference and thread 2 also has the reference. And what the mathutils is doing here is basically you supply a number and it prints the multiples of it till 5. So for example, if you supply 2, you will get the output 2, 4, 6, 8, 10. If you supply 3, you will get the multiple of 3 up to 3 times 5. So 3, 6, 9, 12, 15. If you supply 4, you will get the outputs in the multiples of 4 till 20. So whatever number you will supply, you will get the next 5 multiples of that particular number. That's what this class is doing. And another thing, interesting thing which I've done here is this thread.sleep, which means that when you run this loop where you are printing the multiples till 5 of that number, every time you do the first multiplication, then you sleep for 400 milliseconds. And when I say sleep, it basically means the current thread is going to pause its execution for 400 milliseconds, and it is going to leave the CPU idle. And if there is another thread running currently in the system, that thread will get the share of the CPU for that 400 milliseconds. And once the 400 milliseconds is finished, the thread is going to wake up and it is again going to hunt for the idle CPU to pick up and start doing its execution. So that thread.sleep happens for 400 milliseconds at every step of this iteration in this for loop. So thread 1 is going to use this particular method of this particular class, and it is going to ask the class to print the multiples of 2, and thread 2 is also going to access the reference of the class and access the get multiples method, but this thread asks to print the multiple of 3. So thread 1 asks for printing the multiples of 2 up to 2 times 5, and thread 2 wants to print the output to multiples of 3 up to 3 times 5. So that's the basic scenario. Two threads accessing the same object, supplying different values and expecting the output. So if I run this demo as is without any change, here I'm just initializing the mathutils class, initializing two threads, and then calling the start only once. So if I run this particular program, I see this strange output that even when I said t1.start first, so t1 was holding the multiple of 2, remember, but I still get 3 first, then 2, then 4, 6. So multiples of 2 gets executed here, but then the other thread takes the CPU and it starts running its own multiples outputs, and you see 9 printing first, and then 6 gets printed, then 12, then 8, then 15, and then 10 at very last. So the output looks very random. It would have been nicer if I could have seen 2, 4, 6, 8, 10 once, and then 3, 6, 9, 12, 15 once. If I see them in different sections, in different sequences, that would have been so nice, because then I know which thread is running when and when that particular thread is working on the object. So I'm just trying to replicate the same scenario where two threads are accessing the same object at the same time, but they are executing the object randomly. They're changing the state of the object randomly here. So how do we fix this? To fix this, we can we have this get multiples method, which is the bone of contention here. This is the method which is being randomly accessed. So what I can do here, that I can put synchronized keyword in front of the method. So once you put the synchronized keyword in front of the method which is being accessed by multiple threads at the same time, this whole method gets synchronized now. What this means that one thread will be execute this method at once. There will never be a scenario where two threads are simultaneously executing this get multiples method, or even getting a hold of this get multiples method at the same time. There would be only one thread at a time executing this method. So if I put the synchronized here, and if I rerun this example, you see I get a more streamlined output. If you notice, everything is running like clockwork, where first the thread 1 gets executed. So I get 2, 4, 6, 8, 10, really well printed. And then the second thread starts, which says 3, 6, 9, 12, 15. The reason I get this output is because when I did t1.start, it immediately went to execute the get multiples method, but it saw synchronized there. So it took a lock on the method, and even when the t2.start might have got executed, maybe milliseconds after that or nanoseconds after that, it still could not get hold of the get multiples method, because thread 1 occupied this particular method. It took a lock on this particular method due to the synchronized keyword. So that's the power of synchronized keyword, that you can take a lock on a particular method if you put it in front of the method. Now there can be scenarios that you do not want to lock the whole method. You still want two different threads to access the method, but there can be very few lines of code inside the method which is thread sensitive code. Now, how do you spot thread sensitive code? There is no magic bullet, there's no silver bullet for it, and it comes with experience. So you need to have that experience to know which is the thread sensitive code which can create problems if two threads run that code at the same time. So the moment you have spotted that code, and if you don't want to lock the whole method, you can lock the exact lines of code by putting the synchronized block. So if I remove this and I enable this particular part, so what I'm doing, that I know that this is the code which is exactly causing the problem, which is creating this random output. So what I can do, that I can put the synchronized keyword right before the block of the code starts, which is thread sensitive. And the way you do that is you write synchronized and you supply this, which means whoever has the whoever has the object of the math utils, that whole object gets logged for this particular block of code. So whoever has the math utils object takes the lock on the object for this particular block of code. If there were some other code which was written in the get multiples method before the synchronized block or after the synchronized block, that block can be accessed by multiple threads at the same time. But this code will only be accessible to one thread at a time. There will never be a concurrent access to the synchronized block. That's the power of synchronized block, and it will work the exact same way. So to show you, if I run this particular program, I still get the output in the same streamlined way, where first the multiples of 2 get printed and then the multiples of 3 get printed. So that's how you can actually use synchronized methods or synchronized block to make sure that one thread is accessing a sensitive object at a time, and there will never be a scenario that two threads are mutating the same object at the same time. Again, like I said, be very, very cautious of when you use synchronized blocks and when you use threads, because threads have unpredictable execution sequence basically, and synchronized blocks also have problems if you have thousands and thousands of threads running in your application, and if you put synchronized on a particular method, your application may face severe performance issues because all of the threads will be executing that method in a sequence. Imagine you put this onto a huge application or a huge e-commerce application or a news website. It is going to create serious performance issues. So be very cautious of how and when you use synchronized method. And the key to that is to have that developer DNA to spot the code which is causing this problem, which might be thread sensitive. And maybe you might need to change the code itself. You might not need to go into the multi-threading scenario, and you might be able to fix it without using the threading or synchronized concept. It completely depends. But always have a good trade-off when to use the synchronized methods and synchronized blocks. Let's get started with autoboxing and unboxing in Java. So if you remember, in the very first sessions, I talked about the primitive data types, and then later on, we talked about the objects. For example, we had the int data type, but there later we also saw an integer data type, which can also pretty much do the exact same work which int data type was doing. And we saw the similar kind of experience for the float data type and the float class, double data type and the double class, char data type and the character class, and so on and so forth. So Java provides an easy way to convert a int data type variable into an integer data type variable, and also back from integer data type variable to an int primitive data type variable. Now you might be wondering why we need that. There would be scenarios, for example, if you had an int array as a primitive int array, and if you want to store that into a collection, now collection can only be of type of objects. It cannot be a type of primitive data type. So you might need to convert this int primitive data type array into an integer object collection. So you need to do this conversion of int data type to integer data type. And there would be cases where you might need to do vice versa. So that's the basic idea about autoboxing and unboxing. So when we talk about the definition, you can see autoboxing is the automatic conversion that the Java compiler makes between the primitive and their corresponding object wrapper classes. So whenever you are converting a primitive data type to an object class, this is called autoboxing. And when you do the reverse, it is called auto unboxing or simply unboxing. So let's understand this with the help of an example now. So I'm just going to open an example about autoboxing and unboxing so that we can have a look at it. And here it is. I've created a class which is called autoboxing demo. It has a public static void main method, and inside the method, I'm first simply declaring an int data type variable I with the value 10. Then if I need to autobox this, if I need to convert this primitive value into an integer object wrapper class or an integer class type, then I need to write the code like this, which says integer dot value of, and then you can supply the primitive data type value, and the output of it will be of type integer class. So you get an integer object, and then you can print the object to check if it is successfully doing the autoboxing or not. Similarly, doing the other way around, once I have converted this into an integer object, let's convert this back to a primitive data type. So from integer object, I'm converting this back into the primitive data type. And you see here, it's a simple assignment. I just have to assign the object to the primitive data type, and that's it. I can do the same for a character object and a char data type. So first I create a character object, char obj, and then if I have to unbox it, I can simply assign this char obj to a char primitive data type ch, and that would be it. So you can do the similar drill for any other primitive to object wrapper conversion. Let's say you want to convert a float data type to a float class, or you want to convert a double data type to a double class, then whichever primitive data type has an object wrapper class, you can do the auto boxing and auto unboxing like this. Remember, whenever you have to do auto box, It means you're going from primitive to object, and for that you need to call the value of method. For example, if you were converting a double primitive to a double object class, double object type basically, then you are going to call double dot value of, and similarly the same kind of behavior will be seen for other object wrapper classes as well. So for autoboxing, you call the value of, and for auto unboxing, you literally just assign this to a primitive, and the object wrapper class value will automatically be assigned to the primitive data type. So let's run this now and observe the output. So I had the int I equal to 10. Then I wanted to convert this primitive into the object wrapper. And the way I can do that is by calling the value of method and supplying the primitive data type's value. So that's why I'm doing it. That's what I'm doing here. And this IOBJ should get the 10 value now, which I can see if I print the sys out, and if I just print the integer object altogether, I get the value 10. So this concludes that I've successfully am able to auto box the primitive into an integer object. Now looking at auto unbox, like I said, you simply can assign the object wrapper to the primitive data type variable, and that should work as is. And that's why at line 15, we get this output which says value of I1 is 10. Similarly, when we try to auto box the character object, so I have created a character object here, and then I want to unbox this back into a simple char data type ch. So when I print ch, I get the same value, and when I print the char obj, I again get the same value. Remember, the reason I've put this as autobox is because this by default is being stored into a char data type. I can also write it like this. For example, I can say char x equal to a, and then I can refer here as character dot value of x. This will pretty much have the same impact or the same effect which I had just now. It is going to print the exact same output. If I rerun this program, I'm going to get the exact same output. So this basically concludes our understanding that you can use the auto boxing and auto unboxing pretty easily whenever you have a scenario where you want to convert the primitive data types to the object wrapper classes, or you want to convert the object wrapper classes back to the primitive data types. Let's get started with IO in Java, or IO streams in Java. So when we say IO, it basically means input output, and the basic idea is that your program takes an input and gives you an output. So whenever you have to do some IO handling, generally the IO handling involves taking input from some external source. It can be the command line, it can be from a file, it can be from another consumer application, it can be from a hard disk. But the basic idea is that whenever you have to do that input output handoff or input output operation, we call that as IO. Generally, whenever you will hear the term IO, we refer to the input output operations with respect to the file system or the hard disks or the external disks basically. Now when we talk about streams, what is an IO stream? So the basic idea is that you have an input source, you have an output destination. Now the way the input source sends the data to the destination is via streams. So basically it converts the data into 1 and 0, and that 1 and 0 travels as a stream. For example, you can see this pretty good image here where you have a data source and you have a program, and your program is trying to read the data from this data source, which is basically sitting on the file system, and this data gets converted into zeros and ones, and then this is streamed to the program bit by bit or piece by piece. Similarly, when the program wants to send the data back to the data source, it again goes in the form of stream. So when we talk about stream, we also use the terms as input stream or output stream. So a program uses an input stream to read data from a source. Remember, whenever we are reading, we will call it as input stream. And whenever we are writing something, we will call that as output stream. Remember that because I will be using these particular terms again and again in the demo. So that's the basic idea about streams, that you convert this into 1 and 0, and input stream means reading something and output stream means writing something. So now that we have built that understanding, let's have a look at what kind of classes support Java provides to do this IO streaming operations. So this is the Java IO hierarchy where you have the object superclass, and then you have different types of stream classes. So you have input stream, you have output stream, you have reader, and you have writer. So if we talk about this particular section, in the input stream, you have a file input stream. In the output stream, you have a file output stream. This is basically showing an inheritance relationship. So you have the input streams for reading something, you have the output stream for writing something, and you have Java provides the classes to read from a file or to write to a file using the file input stream and the file output stream class respectively. There are more classes under it, but only a few of them are shown for simplicity. Similarly, if I go to the right side, I also have a reader class and a writer class, which also have an input stream reader and output stream reader. And again, these have multiple other subclasses like file reader, buffer reader, and file writer. So I will also try to showcase the understanding of why we need this and why we need these. I mean, ultimately you have to write a stream, right? So why creating two different types of classes? I will come back to that in a while. With that understanding, let's go into looking at an example and let's build our understanding of how do we work with streams. And this is also the session where I will talk about the file handling operations in detail. So to understand that, I have created two different examples, one for byte stream and one for character stream. So let's take that concept first. Why do you need two different types of streams? And the reason is pretty simple. Whenever you are reading data from some data source or writing data to the data source, so the data can either be simple character strings like English characters or the Unicode characters, or it can be some tabular data sitting in a table in a database. It can be an XML file, it can be an HTML file, it can be literally anything. It can be a mathematical expression file, it can be an image, you don't know that. So that's the reason Java created two different types of classes, that if you want to work on a particular file which is holding characters, then you can use character stream. And if you don't know what kind of data the file is going to contain, then just use byte streams. Character streams also internally will be using the byte stream only, but it is much more simpler and much more faster to use character streams if you just have character files. Also, it is worth noting that when you're using character stream, the file will be read character by character. And when you are using byte stream, the file will be read byte by byte. So one byte at a time and one character at a time. So let's look at the byte stream example first. I've created a class called byte stream example. It has a public static void main method. And then I'm using the file input stream and file output stream classes. Basically, what I'm trying to do in this example is I'm trying to read a file and write to a file. And like I said, when we look at the theory, whenever we are using the input stream term, we are primarily doing a read operation. And whenever we are using the output stream term, we are writing something to the file. So for these kind of operations, Java provides, for file handling, Java provides these two classes, which are called file input and file output stream. So I create null references and then I enter a try block, and inside the try block, I basically provide a location to read the file from. So I've created a source.txt in the Java tutorials location. And if I show you what this source file is containing, so if I go to this location, Java tutorials, and if I open the source file, it just has a simple text which says this is a sample text file. Let me delete this dest.txt for now. So I just have a source.txt here, which is containing a sample text. This is a sample text file. So I am reading the source.txt using the file input stream and storing the output into this in stream, which is a byte stream. And I'm also creating another output stream where I will be writing the destination file. So I'm saying this particular location, write the file with the name test.txt. But these are still just containers. I haven't done much here. So you are going to initialize the reading stream and the writing stream, and then you are going to read one byte at a time till the time you reach the end of the file. The way to denote the end of the file, or the way Java tells you that you have reached the end of the file, is when the read operation returns -1. So you keep reading the file till the read operation returns the value as -1. Whenever it returns the value as -1, it means that you have reached the end of the file. So I'm going to read this source.txt byte by byte, one byte at a time, till I reach the end of the file. So I call instream.read. I store the output of instream.read into a variable called content. And at the same time, I also run this condition that till the time this output is not equal to -1, keep writing. Write where? Write to the outstream. So I want to write to this particular stream. So I call the write method. And remember, this is a byte stream, but here the output of instream.read was an integer output. So you need to convert this int output to a byte by doing the explicit casting here. So we do the explicit casting here so that the int content gets converted into a byte type, and then outstream.write writes that byte inside the stream onto this particular file. So that's what is happening here, that you load the in-stream, you read the file byte by byte, and you start writing the output file byte by byte. That's what you do in this while loop. Once you have reached the end of the file, you will be broken out of the while loop because the whole file has been read, and whatever was written in that file has been written to the outstream to this particular file location. And then in the finally block, you close both of the streams. Remember, it's very important to close these resources. Otherwise, these resources will be present till the time Java runs a garbage collection. So it's very important to make sure that you close all the resources which you open in terms of file handling. These are costly connections and they take up a lot of memory. So make sure that you close them in the finally block. And that's why if you see, I don't have a catch block here, but I've put the finally block so that I can seamlessly close them. So that is what I'm doing here. And now if I run this, I don't get any output because I'm not printing anything. But if I go to this particular location and see if I have a dest.txt. So yes, our dest.txt has just appeared, which was not there earlier. And if I double click on this, it has the exact same text as I had in my source.txt. So the source.txt and the dest.txt have the same content because I've just written the source.txt to the dest.txt. So this is how you can use byte stream operations to do file handling. Now let's have a look at the character stream example. It is doing exactly the same thing. It's just that you have to use different classes. So instead of file input stream and file output stream, we are going to use file reader and file writer. So I create the file reader and file writer references. Let's call it as reader for simplicity. And let's call this as writer. So I initialize file reader and file writer, again pointing to the same location. Let me delete the dest.txt again so that we can observe the output. So I create the object for file writer and file reader, and I again do the same thing. I call the read operation. The read operation is going to return an integer value output, and I'm going to continue reading the file character by character. This time the byte is not read, but the actual character of the file is being read. So I'm going to read this file character by character till I reach the end of the file, which is denoted by this condition. And as the output is int, I need to convert this into char. So I cast the int output to a char output and then write it to the writer. Then I close the reader and writer both, and that's it. So if I run this now, and if I go back here, I will see dest.txt and I see the output here exactly as same. So in terms of output, there was no difference, but since this was a purely character file, the character stream demo is a better use case, or the file reader and file writer classes are a better use case. But like I said, there would be cases where you have to read it as bytes because, for example, if you're dealing with databases or if you're dealing with another type of files, for example, image files, etc., that will be traveling as bytes. So using a byte stream might be a better example in that case. And that holds true for any other different type of data source as well. Let's get started with using JDBC in Java to connect to the databases. In this example, I'm using the open source community edition PostgreSQL, but you can use any database vendor provider if you want to. If you want to use Oracle or MySQL, feel free to do that. But in this demo, I'm going to use Postgres. So you can download the Postgres Windows installer. Since I'm using a Windows machine here, you can download the installer from the official postgresql.org website. And you can also download the JDBC driver for PostgreSQL going to this particular official website, which is jdbc.postgresql.org. Similarly, you will be able to find the JDBC driver for all other database vendor providers as well. Once you download this, this is going to download a jar for you, and you can store the jar anywhere. Like I put this jar into this particular location. You can see this latest JDBC driver jar for PostgreSQL. So for every database vendor, there would be a different JDBC jar which you need to download. So that's that. You install the PostgreSQL, you set up its database, and when you install the PostgreSQL, you also get a nice SQL client to talk to the database, because database has a server and database has a client, right? So to deal with that, you install the server, and all these database vendors like Postgres, Oracle, Microsoft SQL, etc., they also provide a nice thin client with it. Postgres also provides a client. When you install the Postgres server, it will also ask you, or it will actually automatically install the SQL client for it as well, which is called pgadmin. So this is how the pgadmin client looks like. The current edition of it is pgadmin 4. So you will get that installed automatically. And once your Postgres server has been successfully installed, if you just go to search and type pgadmin, you will get this option. Once you click on this option, a new browser window will be opened, and you will see this client here. You will not see this particular window. Let me close this one, but you will see something like this. You will see a server here. So you can go inside it. You will see a PostgreSQL edition here. And if you go inside it, you will see a database here. If you open the database, you will see the Postgres database by default created. So you can just right click on this and create a database here. You can name it as whatever you want. You can leave everything as is for now and hit save. Another thing which you need to do when you do the installation is it will ask you to set a database user and password. So choose whatever database username and password you are comfortable with, and you will be using that username and password in your program as well. So create your database here and just leave the database at this particular point. And now we will try to connect to this particular database. In the example which I prepared, I'm going to connect to this test database. So let's go to the JDBC demo and see what is happening there. So for this purpose, I've created a class called JDBC demo. It has a public static void main method, and there's a lot going on here. So let's take it step by step, and I will keep shuffling between the database SQL client and this particular class to build a nice narrative. So if you think carefully, what you need to have if you want to connect to a database, the obvious answer is the address of the database. Where is that database? You need to know the location of the database to connect to it. So that is called the connection URL. Every database vendor will provide its own connection URL, and you can find that connection URL from the official documentation. There are tons of examples available for it as well, but always refer to the official documentation for that particular database provider. The general syntax is JDBC : your database vendor's name : the host name. This can be any IP address or your local host. Generally, we also put a port here, something like this. 5432 is the port on which the PostgreSQL server runs. But again, you can put the port here on which your database server is running. Every database vendor has their own default port. The PostgreSQL server has the default port as 5432. So you provide the host name, you provide the port, and then you provide the database name. You provide the database name to connect to. So if you remember, I told you that I have written the program to connect to this particular database called test. So whatever that be, you provide that name here. And this is going to form the connection URL. I can remove this for now, but this is how the connection string is going to look like. And it is going to, it follows the same format for any database vendor, that you say JDBC : you write the database vendor name, and then you say : you provide the host port, and then you provide the database name. So that is your connection URL. After that, to connect your Java program to a database, you need to use the java.sql.connection class. This is a very critical class and very important, and probably the single most important class which you need to have in your program if you want to connect to a database. So you say connection con equal to null. I'm just creating a null reference to it. And before we go any further, let me also tell you why we need this JDBC and what is actually this JDBC. So Java is a programming language. It does not come with its own database, but there are multiple other vendors like PostgreSQL, MySQL, Microsoft SQL, Oracle, etc. So Java wanted to provide a uniform way to connect to all of these databases. Because imagine all of these databases building their own API contract. It would have been a nightmare for the developers to connect to different databases or shift from one database to other database. And that's the reason Java created this nice interface called JDBC. And it said, whoever wants to connect to Java should follow this JDBC specification and provide their implementation, similar to the interface and concrete class thing. It's not exactly that, but you can think of it in that manner, that JDBC provides an interface with the method declarations. And then Oracle, PostgreSQL, MySQL, all these database vendors are supposed to implement that interface and provide their own implementation. But JDBC APIs will always remain the same. Whoever wants to connect to Java has to create a driver, and that driver contains that implementation. And that's the reason we downloaded that JDBC driver. And I will come to how do we include that, but that's the background of JDBC. And that's why you need JDBC to build that uniform contract, and your vendor will provide their own jar, which will have the implementation of the JDBC interface. And in this program, what I'm trying to do is basically I'm trying to insert a record into a table. So what is a table and how do you create that? So let's go back here. So in this test database, you will see a schema. By default, you will see a public schema, and you can create a new schema if you want to, or you can just use the public schema. So inside the public schema, you will go under and you will see an entry for tables. So you just right click and you say create table. You can also write in complete SQL statement, but I'm just showing you how to do that in pgadmin. And you can give the table name, you can give the column information, and that's how you create the table. So I have created a table here, which is called student. And the student table has 3 columns: roll number, name, and age. If I show you the exact query or the whole create TDL for it, it looks like this. So I created the student table in the public schema, which has a roll number field or roll number column, which is of type numeric. It has a name column, which is a varchar or a character varying, and it has a age column, which is again a numeric. So roll number, name, and age. These are the 3 different columns which I created inside the student table. So I have a student table with these 3 columns. So that's that. Now let's go back to the program. So I have the student table, and now I want to insert some records in the student table. So let me just change the values here so that we can see a different entry. So I have just hard coded some values. Generally, you will be getting these values from somewhere in the program. But for simplicity, let's say you have got those values. Once you have got those values, the next thing you need to do is to build the SQL statement, the exact SQL statement which is going to be run on the PostgreSQL server. So you write that statement. In this case, I'm showing you a creation example. So it is going to be an insert query. So I say insert into table name, which is student, and then I provide all the column names. It is always a better practice to provide the column names in these brackets. Even if you're inserting the values to all the columns, still provide the column names. So I say insert into table column values, and then you provide the actual values as the roll number variable, which I created here, the name variable, and the age variable values. So I just supply the values here. Remember, when you are inserting the values, roll number and age are integer, so you don't need to put any single commas, single inverted commas for it. But name is a string variable, so I've put this single inverted commas. It's a simple string concatenation, nothing fancy here. So I'm just writing a plain SQL statement here and storing that into a string. Once I've done that, the next piece which I need to do is to get a connection to the database. And the way you are going to get a connection is by this uniform method. No matter which database provider you are using, you are always going to use the driver manager.getConnection method to get a connection to the database. And how do you get the connection? You supply the connection URL, you supply the username to connect to the database, and you supply the password. In this case, I've just set the username and password as Postgres and Postgres. So Postgres is the username and Postgres is the password. Pretty lame, I accept, but this is just for demonstration purpose, so it's fine. But generally, you will be getting these values from some application property file. So these are the 3 parameters which you need to supply to this getConnection method, and then you will get a live connection to the database. This is the line which is going to make it all happen to connect to your database server. So if this line gets executed successfully, you have a live connection. Once you have a live connection, the next thing which you're going to do is to create a statement object on the connection. Statement is, it can be anything. It can be an insert statement or a select statement or an update statement or a delete statement. Everything is a statement there, right? So that's why you need to create a statement object. So you create a statement object and then you execute the SQL. This insert SQL which you prepared, you're going to execute the SQL here saying st.execute update. Execute update is the method which is used for any insertion or deletion operations. So that's the method you're going to use and supplying the SQL query which you built with the actual values of roll number, name, and age. The execute update method returns the number of rows affected once this statement got run on the database server or the SQL query got run on the database server. It might impact one rows if it's an insertion. It might impact multiple rows if it was an update query, right? So it is going to return the number of rows affected, and that is what we are going to use to check if my insertion successfully went or my insertion failed. So if this execute update is going to return 1, which means that my row got inserted successfully in the database. So I'm just printing this out here. And if this particular M returned 0, which means none of the rows were affected by my SQL query, which means my insertion operation failed. So I'm just printing this out here. And then I'm just putting this in a catch block here to print any error and finally closing the connection. This is again very, very important. Database connection is one of the costliest connections you will be creating when you will be writing your Java applications. Always and always make sure to close these database connections. Otherwise, your application is going to face serious database bottlenecks. So we close the connection. So that's all we are doing here. We prepare the URL. We just create a placeholder for connection object. We prepare our SQL query with all the relevant values. We get a connection to the database. We get a create statement. We get a statement object from the create statement method, and then we execute the statement. And then we can validate the statement execution if there is a way to validate it. Once you've done all of that, you close the connection. So let's run this program and see if we can see this new record inside the student table. And before we do that, let's also validate what is present in the student table as of now. So if I go here and I say view all rows, this is just going to run a select star on the student table. So currently student table has one record with roll number 1, name as John, and age as 20. And now I'm trying to insert another row with roll number 2, name as Jane, and age as 22. So if I right click and run as Java application, I get this entry which says inserted successfully, which is coming from here. Inserted successfully, and it also prints the exact SQL so that you can see what SQL actually got executed on the database server. This is the same string SQL which I built. So this is the SQL which got run on the server, which said insert into student values, and the roll number was 2, and the name was Jane with single inverted commas because this was a string, and then age was 22. This was the exact SQL which got executed. So my SQL has been executed, my connection has been closed. If I go back to the pgadmin client and if I try to rerun this query, now I get 2 records. So if you remember, this record was already there, but now I get this second entry, which is the new entry which just got inserted because I ran the program, and you see the roll number 2, the name as Jane, and the age as 22. So this was a very simple example to show you how you can do the JDBC connection. But one of the things which I still haven't covered is the usage of the JDBC driver, the jar which I talked about. So the way you are going to add the jar is you go to the project, you right click on the project, you go to the build path, go to the configure build path, and there you will see different tabs: source, projects, libraries. So go to the libraries tab and select the class path here, and you can choose the add external jars option. Click on this, load your SQL JDBC jar for your particular database vendor. For my case, it was PostgreSQL. Let me just quickly remove this jar and show you right from how it's done. So this is how it will look like for you. You select the class path, you click on add external jars, you go to the location where you have downloaded your JDBC driver jar for your particular database, select that, click open, it will come here, hit apply and close. That's how the jar is going to be there. If you don't provide the jar, your program is going to fail miserably. It is not going to work. So make sure that you have the jar and then only it is going to be able to create a successful connection and be able to successfully execute the query. Remember, JDBC provides the specifications, and then the particular database vendor like PostgreSQL provides their JDBC driver, which has the implementation for that JDBC API. And that the Java has this uniform JDBC API, and every database vendor is expected to honor and implement that API only, so that Java developers can work on the JDBC contract and everything should work as is. Let's get started with generics in Java. So before we go about generics, let's understand why do we need generics and what was the requirement that led to the creation of generics. So as we know that when we work in any object-oriented programming language, we created classes, we create objects, we create variables, and everything has a type. Everything has a type, and that type is static. The type cannot be changed. That's why we call Java as a strong type checking language at compile time. It checks the types of the variables of the classes at the compile time, and if the classes are mismatching or their types are mismatching, then you basically get a compilation error. But what we see as we moved along, we saw that we were creating the similar kind of functionality again and again in different classes. For example, if there is a login functionality which should allow a person to log in and which should also allow an application to log in, then these are the two different use cases, but the functionality still remains the same. So how would the login functionality allow both of the types of entities, be it user or application, to get into the application or log in into the consumer application? How do you do that? And that's what led to the creation of generics, that you can reuse the same code with different types of inputs. Remember, the stress here is on the types, and that's what it is mentioned here, that we will like to reuse the same code with different inputs. We will just keep changing the type parameters and we'll keep using the same code again and again. It has some benefits over the non-generic code, like I mentioned earlier, that when we work with the non-generic code, we have the statically assigned types to the variables and objects. And if we use generics, then we don't have to do that. And at the same time, you don't even have to explicitly cast them. I already touched upon this concept of generics in different bits and pieces in different sessions throughout this tutorial series, where we saw that whenever I was creating a list, I was supplying this type into these brackets, right? And I told that this is the generic type. But now we'll go deeper into this concept and we'll see how we can create our own generic types if Java does not provide it. So with that, let's move to an example and see how we can implement our own generic types to create generic code where we can supply the types dynamically. So I've prepared an example for this. I've actually prepared two examples for this, and we'll go through both of them one by one. So here what I'm doing, that I'm creating any class. You can think of it as any class holding any functionality which is applicable to multiple entity types. Think of it as the same login class which I just talked about. So if your class has a functionality which should be reused by many different types, then one of the way to not repeat the code or repeat the class or repeat the functionality again and again is to make that class use a generic signature. And how you do that? You write the class name and then you put these brackets and you just type T. You can write any variable A, B, C or whatever you feel like, but T is sort of the default standard the Java developers have been using since generics was launched. So you put this T here. Now, whoever calls this class or whoever initializes this class will have to supply the type of the class on which this particular functionality is going to get executed. Now, remember the collection examples I took in the past series. What if this was a list class? Because we have used the exact same syntax, right? We use list, we put brackets, and then we wrote string, and we said, okay, now this list is a list of strings. If we said list of integer, then we just write integer in these brackets, and that list became a list of integers. So you see the same list was being reused for different data types. And the exact same concept is applied here for your custom classes and your own custom functionality. So I write T here, then I can do whatever with this T I want. So I just put a reference of it inside the class. I create a constructor. Constructor is also assigning the T type. I do a get object, and that's all. It's a very simple toy example, but just to get the point across, you can write as complex logic as you want inside the class, depending upon your use case. But this is just a straightforward example that you can use generics in the classes as well. Once you do that, then how do you initialize this class? So let's have a look at that as well. So I've just created a public static void main method inside the same class. Obviously, you can create this method outside this class as well. There's no stopping that logic. But for the sake of simplicity, I've just put the main class here. So it's a simple public static void main method. There I am initializing the single generic holder class, the same class. And here the t type is of integer. This t type can be of anything else as well. For example, your own student class can also be supplied here. And then this single generic holder will become of student type. In this case, I'm just using a pre-built Java class. So this single generic holder becomes of integer type. I give a reference, I create an object, and I provide a value to the object, because you see the constructor is this. Whatever t you supply, so if the t is the integer, this t becomes integer, and this obj is going to hold the value 10, because that's the constructor being called here. And after that, you can do whatever you want in terms of the logic. Here, I just have a get object method. So I'm just calling that method and printing the object. That's all. Similarly, you can also initialize the same class with the string type. So you see, I'm reusing the same class and the same functionality again and again for different class types. So this time I'm using the string type instead of integer, and I'm supplying a string parameter this time. And this constructor still will work because this is generic. When you created with integer, this constructor, this t, became of integer type, and when you initialized it with the string type, this constructor started accepting the string objects. So I just supply a string called simplicode, and then I call get object. So let's run this method. So when we run the main method, from the first invocation at line 16 and 17, when you call the get object, the value of the object gets printed, which is 10 for the integer, and then at line 20, the value of the string gets printed, which is simplicode. So that's how you can use generics inside a class or for a class. Now, there might be use cases where you have to create a class which can accept multiple types of generic types. Let's take an example. If you remember when we talked about hash map, we had the exact same situation. So you had the key and you had the value. Now, key can be of any type, any data type. It can be string, integer, whatever. And then value can also be of any data type. It can also be your custom data types. For example, the key becomes a roll number and the value becomes student object. So map is a situation where you have two generic types. So I'm just trying to replicate that similar kind of behavior, that if you have to create a class with 2, 3, as many generic types as you want, you can still do that by just providing a comma here. You can go on doing as many generics as you want. In this example, I'm using 2 generics. And then it again goes to the same drill that I've created references for both t and u. I have initialized both t and u in the constructor. And then I have a display method, which is going to display the obj1 and obj2's values, or they are two string methods basically, because when you try to call the object inside the system.out.println method, by default the two string method of the object will automatically get called. So that's all I have in this particular class. So it's a simple class accepting 2 different types of generics and then calling the display method. And here is the public static void main method for the same. Here I am initializing the dual generic class, and here the t is string and u is integer. So these t and u are assigned these class types. And then I create the class. I again write the same types and I provide the value. So for the string one, I provide simplicode. For the integer one, I provide 10. This constructor gets called. obj1 gets the value simplicode and obj2 gets the value 10. And then I call display method. There I am printing obj1 and obj2. So let's run this method. Okay, I'm getting simplicode and 10 because when I call the display method at line 13, obj1 gets printed. obj1 is holding simplicode value, and at line 14, obj2 gets printed, or the toString method of the obj2 gets printed, which is holding the value 10. So this was a quick tour to tell you how can you use generics. You can obviously use generics in the variable types as well. You can use generics in the method argument types as well, wherever you want. The simple idea is that one, you would like to reuse the functionality again and again. And second, you would not like to have a strong, strict type checking. And like I said, try to relate these generic concepts with the collection framework we listen, because collection framework is completely built upon the concept of generics. Whenever we initialize a list or a map or a hash set or a linked list or array list or anything, we always supply the type. And the type is coming from these. If you look at the implementation of array list class, you will see that. Let me see if I can open that for you to show you how that looks like. If I go to an example of collections, and if I try to just open the class, you will be able to see that. Yep. So if I click on this list class, you see list of E type. So here E is the type which you are going to supply. So in this particular case, when you say list of integer, this integer gets typed into E. So this whole list class, whatever operations you're doing inside the list class will be applied for the integer type. So similarly, you can look at other collection classes and you will always see these generics everywhere in the collection classes. Let's get started with string handling in Java. So we have been dealing with string types throughout different sessions in this whole series. But in this session, we are going to look at a lot of different utility methods which the string class provides. String class is very versatile in Java, and it provides a lot of handy functions which can help you manipulate strings in multiple ways. For example, if you want to trim a string, or if you want to append a string to another string, or if you want to find a particular character at a particular index, or if you have an index and you want to see what character is present at that particular index, or if you want to do any other kind of pattern matching in the string. So string is very versatile in that context. And today we will have a look at some of those methods. So I've just opened the Java Docs API for string, and you can see in the method summary, you will find a long list of methods. We will go through some of these methods. For example, if I just show you a snapshot of what I'm talking about, it has a char at method. So you provide an index, an integer index, and this particular method will tell you which character is present at that particular index in the string. Remember, string is basically a zero-based character array, zero index-based character array. Similarly, you can also call code point at, which is going to return the character in the Unicode code point at a specified index. Similarly, compare to method can be used to compare two strings with each other. Compare to ignore case is also there, which can compare two strings, ignoring whether they are in uppercase or lowercase. You can use concat method to join two strings together. You can use the contains method to find if a particular character or a particular sequence of character exists in a particular string or not. You can do a content matching. You can do copy. You can also see if a particular string ends with a particular character or a sequence of characters. So there are tons of different methods available here. And please do check out the API, because like I said, this is going to come very handy when you start writing real-time projects or the real-life projects. So with that knowledge, let's go to our IDE and let's have a look at some of these examples in action. So here also you can obviously have a look at the string class from the IDE itself. Just write string and hit control, and you will see an underline and a hyperlink. So just click on this and the string class will be opened, and you can actually read about the documentation of the whole string class. But we are not going to do that. We are going to have a look at some real life examples of how we can use different methods of the string class. So here I've created two strings, str1 and str2. str1 is holding a string which says John is studying, and str2 is holding a string which says in college. Now, the first utility function which I'm going to talk about is the length method. So if you want to find out what is the length of this particular string, then you can just call the length method on the string, and that is going to return the length of the current string. Let's see that in action. Let me comment the rest of the code, and let's see this one in action. So if I run this program, I get the value 16. So if you count this, 1, 2, 3, 4, space is also counted, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you get the exact length of the string when you call the length method. Similarly, another method is concat method, and concat method is used to concatenate two strings together. Concatenation basically means joining two strings together. So if you want to join the string 1 and string 2, then just call str1.concat with the string you want to append or you want to concat. So the concat method on the left-hand side of the string is going to get concatenated with the argument which you pass in the concat method. So let's see that in action now, and let's see the result as well, because I'm storing the result of concatenation into a new variable and printing that variable. So I get this whole text here, and you see the studying in just got merged. There was no space in between because there is no space here. If you just put it like this, and if you rerun this, you will see the proper space as well while concatenation. One of the things which I also want to call out is strings are immutable in nature. When I say immutable, it means that once you have created this str1 holding this value, then this particular object's value pointing to str1 cannot be changed. You cannot mutate the strings. If you try changing str's value, Java is going to create a new object and point str1 to that object. But the object which was created initially is not going to be overwritten. So remember that concept that whenever you're doing manipulations on the string, the previous string object still remains there. It doesn't get overwritten or it doesn't get modified. Whenever you modify a string, you get a new object. That's the property of string. So we saw the concatenation. Let's move ahead. There's also a format method. Format method is used to dynamically populate some parts of the string. For example, if you have a long list of students and if you want to print the name of students, then what you can do here is that you can assign those names to certain variables, and you can point or refer those variables in the string with the percentage syntax, %s syntax basically. So the string.format method is used to supply dynamic values inside a static string. So in this case, this part of the string is static, where I'm saying the name of the student is. Then in the next string, remember plus also can concatenate it. It is also doing the exact same thing as the concat method. It's just a shorthand. So I'm creating first string, then I'm creating second string, but here I'm writing %s. I will come to that. And then I've created one more string where I'm using %d. So what happens that Java format method supports certain special type of references. For example, if you want to dynamically place a string, you can use %s. If you want to dynamically place an integer value, you can write %d in the format method. Similarly, you can also write other %f for a float value, and there are more other similar placeholders which are available in the format method. So do check out the format method documentation if you want to know what all percentage types or variable types can be dynamically placed inside the format method. Here I'm just using %s and %d. And then once you have created the first part of the format method, which is string with dynamic placeholders till this particular point, then you put a comma and you start providing the values. Remember, the sequence of the values have to be exactly the same way in which you have used them here. So if %s is coming first, then you have to supply a string value. If %d is coming after that, after the string value, you have to provide an integer value. If there was another %s after %d in the same string, then after 21, you had to provide another string value. So that's the contract which format method needs to honor. And if I run this particular program, and if I try to see the output, let's try to see the output as well. And for the output, I need to store this whole string.formats output into a variable. So let's say I say string r, and then I can print r and see what comes out. So that's it. Let's run the program now. And now you will see this line. The name of the student is John, comma, and the age is variable is 21. I think it's coming because I've just wrote variable is here. But if you remove this and if you say the age is %d, then you'll get a nice human readable output without any extra formatting. So the name of the student is John and the age is 21. And that there was a comma, that's why you still see the comma. But this is the basic idea with using the format method. Now, another method which I want to talk about is the char at method. Let me comment the previous output so that we can follow along. So I'm just going to comment all of this, which we have covered already. And let's focus on the char at method. So char at method can be used to find the character present at a particular index in a string. So whatever index you specify in the char at method, the character present at that particular index will be returned. So when I say str1.char at 5, remember strings are 0 based indexed character arrays. So 0, 1, 2, 3, 4, 5. At 5, I is present. So this char at method should return I. So if I run this particular program, yes, I see the output as I. Now let's move ahead with the next example or the next API call. The next API call is the usage of equals method, where I can see if the two strings are equal or not. So here I'm saying str1.equals str2. If both strings are same, it is going to return true. Otherwise, it is going to return false. So if I run this, I get the output as both strings are different. It goes in the else block because str1 and str2 are different. They are holding different values. So here the exact content of the string is going to be matched. The next one is the index of method. So index of method can be used just for the reverse functionality of char at. In char at, we were supplying the index and getting the character. Here we can supply the character and get the index of it. So what is going to happen that you write the string dot index of, and then you supply the character for which you want to find the index of. So I supply y here, and if I run this particular program for this line, the output is 12. Let's see if the output is correct. So here, if you try to find what is sitting at the index number 12 in this string, so again 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yes, y is present at the 12th index, and that's the output I get. What if you provide a character which is not present in this particular string? Let's say z, which is not there, and see what the output is. In that case, you will get the output as -1. So if the character is not present in the string, you will get the output as -1. Another thing, what if the character is present more than once in the string? For example, I is present more than one time in the string. So if I write I here, whether I get the index of this I or this I, let's see. So I'm going to run this program again, and I get the value 5. So 5 is basically this I, because this I is definitely not 5. It's farther index. So the first match of the index is going to be returned in terms of the index of method. Okay, so that was about the index of. Let's look at the next one, which is the replace. In replace, it's as the name suggests, you can replace a character or a sequence of characters in a string by calling the replace method on the string on which you want to do the manipulation. And remember, you're doing the manipulation here, so the previous object is not going to get overwritten, but a new object is going to get created. So what I want to replace is with R. So in this particular string, I see an occurrence of S here. So this S should be replaced with R if the replace functionality works as I just explained. So let's run this program. And yes, I can say instead of S, I see R being replaced there. And that's the usage of the replace method. Next one is the split method, where if you want to split the string into multiple elements, so you just call the split method and you provide the separator. Here I'm separating the string whenever there is a space. I'm basically breaking up the string into multiple substrings. That's what I'm doing here, or multiple strings, I would just call it as. So whatever separator you provide, whenever the string is going to encounter that separator, it is going to split one part of it. So I'm providing the separator as space. It means in this particular case, I'm going to get 3 items. The first breakup is going to happen here. So the John part of it will go out, and is will go out in a separate string. Then again, between is and studying, I have another space. So there will be another break here. So I should get 3 elements if I call the split method. One element will be holding the value John. The second element will be holding the value is, and the third element will be holding the value as studying. And then I'm printing all the elements of the array. Remember that split method returns a string array. So that's what I'm using here to store the output of the split method. And then I'm just using the streams API to iterate over this string array, outputting or printing each element of the array. So let's run this program. Okay, so I can see 3 different outputs through this system.out.println. First John, then is, then studying. Like I said, split method is going to create a 3 element size array of strings because I'm separating it based on the space. The last utility function which I want to talk about. So this is the last one, but I'm skipping some more due to the interest of the time. But like I said, do check out the documentation to read or understand more about other string utility methods, which I'm not covering here in this session. So the last one I'm going to talk about is the substring method. And substring is basically going to take a mini string out of the long string. So what if you want to trim the string? What if you have a long string and you only want to get a part of the string? So you can specify the starting point, you can specify the end point, and whatever string characters are present between the starting index and the end index will be taken out from the string, and you can store that output into a new string and print that. So here I'm calling the substring method, providing the starting index as 1 and the ending index as 5. Let's run this program and interpret the output. So I'm getting the output as OHN. So what is happening here? Let's go back to the str1. So I said start with 1. Remember, string is a 0-based index. So it starts with 0, 1. It starts with O because O is present at the first index. And then I'm going up till 5. So 1 gets printed, whatever character is present at 1 index get printed, second index get printed, third index gets printed, fourth index gets printed, which is just a space, and then the fifth index is I, which is not printed here. So it means that when you call the string substring method, then the end index position will not be printed. It starts from the beginning index and it will go till end index minus 1 position in terms of printing, because if you select this, you'll see an extra bar here because the space is also getting printed. So it is printing everything before the fifth index. It will not include the fifth index character. Remember that when you use the substring functionality, that the end index is not included in the substring. If you want to include that, you need to increase the index by 1. So for example, if you want to print I as well, then you have to write it as end index as 6. And if you run this, then you will also see I now. Yep. So that is how this substring functionality works. Let's get started with java.lang package. So java.lang package is one of the most core and fundamental packages in Java, which is provided out of the box to the developer. You never explicitly import this package in your Java program because you don't need to. Java provides this automatically the moment you create a file with .java extension, and you are running that particular program inside or on a JDK. You get the java.lang package automatically. For example, when we were running the string handling demo, I was using the string class, but I never imported this string class. You can see there is no import for string because string class is also part of the java.lang package. It's automatically imported for you. You never need to explicitly import the package or any classes of that package. So this is going to be more of a theoretical lecture where we will just have a look at or a quick overview of all the java.lang package classes and other utilities. You don't need to remember all the classes and utilities, but this is just to give you a sense of what all it contains. So in terms of the interfaces, it has the appendable interface, auto-closable, char sequence, clonable, comparable. If you remember, we also used comparable when we were writing the comparable implementation to compare different objects in a collection. So this also comes automatically as part of the java.lang package. Iterable, runnable, again, we use this in the threading example. So this also comes automatically to you. You never need to import the runnable class from the java.lang package. When we move to the classes, all the data type classes which you can think of in terms of Boolean, byte, character, class loader, compiler, enums even, float, integer, long, math. So all the classes which we were using, the data type classes which we were using in different examples are also part of the java.lang package. Okay, so this is a long list. It also has the thread class. So whenever you are creating thread, you again never imported thread class, but it still just worked fine because this was also coming as part of the java.lang package. There are also a bunch of enumerations which it provides in terms of Unicode, thread state, etc. It also provides exception classes like arithmetic exception or the different runtime exceptions which we dealt with, like array index out of bound, array store, class cast, class not supported, the root exception class. So a lot of exception classes also come as part of the java.lang package. It also provides some error classes. If you remember when we talked about the exception framework, you have the error types and you have the exception types. So it also provides some error classes. If you want to use that, you never need to import any of these classes and you will automatically get them from the java.lang package. Similarly, it also provides some annotations as well, like functional interfaces, or you remember we use this annotation a lot, the @override annotation, but we never imported the override class or the override annotation because it's part of the java.lang package. So this basically tells us that there are a lot of different classes, utilities, enums, errors, exceptions, data types, which are provided out of the box from the java.lang package, which makes our life so much easier whenever we want to work with Java, because we don't need to import the very basic classes which we use very frequently. And another very important package is the java.util package. We have been using the java.util package in all of the collections, examples, and tutorials we walked through in this whole tutorial series. So let me just open the java.util package for you. So if I go here to java.util, and I will be able to see the java.util packages, different classes, etc. Yes. So here it is, the java.util package. And remember, java.util package is not imported automatically. You have to explicitly import the java.util package to use the classes of it. So that's the difference between java.lang package and java.util package, that you cannot you can use the classes coming from the java.lang package without explicitly importing those classes or importing the java.lang package. But java.util package is something which you have to explicitly import in your Java program to make it work or even make it compile. So what java.util provides? First of all, the collections framework. The whole collections framework comes from the java.util package. So for example, all the interfaces which we use while we work with the collections framework classes, interfaces like collection, list, set, map, you can see the map interface, you can see the list interface with the generics. So all the interfaces which we use from in the collections framework are present in the java.util package. Similarly, when we talk about the classes, all the concrete classes implementation of the collections framework in terms of array list, linked list, hash map, hash set, tree set, tree map, you will see all of those classes here. Here we are covering all the, this is showing all the classes summary. So you see some abstract classes, and you will also see some concrete classes as you move further down in this particular list. So you see hash map, you see hash set, hash table, linked hash map, linked hash set, linked list. We used all of these classes while we were going through the collections framework tutorials. So it provides all of these and a lot of other classes like the scanner class, which we covered in the Java project for taking the inputs from the command line from the user, stack class again from the collection, some time classes. And it also provides a bunch of enumerations like the locale, basically setting the language categories for a particular program. It also provides some exceptions which we used while we were working with the collections framework. So most of these exceptions are, or some of these exceptions are related to the collection classes. For example, the concurrent modification exception gets thrown whenever the whole execution detects concurrent modification of an object when such modification is not allowed. You will see other different types of exceptions like illegal format, etc. in this particular exception section of this particular package. Then it also provides just one error class as well. So this is what the java.util package contains. And just to refresh your memory, whenever we ran any collection demo, we always imported the java.util classes. You can see this is all coming from java.util. So this is something which you have to import, without which your program will not even compile. So that's also one of the difference between the java.lang package and the java.util package. And that's pretty much all I want to cover in this particular session. So we basically did a quick tour of the java.lang package and the java.util package. And like I said, it's impossible to cover all of that, or all of the classes and enums and interfaces and errors and exceptions with all the examples. So I would suggest you to just keep this in mind about the java.lang package and java.util package. I told you the basic concept that java.lang contains all the types, the class and the variable types or the data types we dealt with, and java.util majorly contains all the collection classes. That's the basic thing which you need to remember whenever you work with Java. And your java.lang package never needs to be imported, but java.util package needs to be imported always whenever you use the util classes. Let's get started with networking in Java. So when we talk about the networking in Java, Java has a whole dedicated package called java.net package, which has all the different classes which you need to have to write a networking program in Java. So you will see a bunch of classes, with two classes, most important ones, which are inet4 address and inet6 address. So as you can understand that inet4 address is the class which can be used to represent the IPv4 addresses, and INET6 address class can be used to represent IPv6 addresses. And then you can learn about sockets. It also has socket classes. It has a lot of interfaces, with the prominent one being the networking interface. There are some high-level APIs. For example, the URI class is there, which can be used to represent a universal resource identifier as specified in the RFC. And this is just an identifier. This doesn't provide the means to access the resource. If you want to access the resource, then you need to use URL, which is the class representing the universal resource locator, which is a slightly older concept than URI, but with URL, you can hold the address as well as access the address. URL connection is also one of the class which is created from the URL class to set up a communication link with the URL. And similarly, HTTP URL is for an HTTP connection, and you have protocol handlers. There are a lot of interesting classes which you can explore if you want to learn more about what all networking support Java provides. But when we talk about the basic ones like IPv4 address, the URL, URI classes, these are the ones which generally most developers interact with. If you want to write a socket programming socket program, then you can still do that with the classes and interfaces support provided by Java. So you can see a bunch of interfaces here, cookie policy, socket option. Then in terms of classes, you can see again content handler, cookie manager, HTTP cookie, INET4 and INET6 address with the classes which I talk about. It also has a generic class, but I would always recommend to use one of these if you know what address you're dealing with. The URL connection, the jar URL connection class, proxy class, some bunch of socket classes, URI URL classes, and some enums and exceptions as well, which are related to networking connections. For example, malformed URL, if the URL itself is not correct, then you get a malformed URL exception. Socket exception, if there's a socket timeout exception, then also you have a dedicated exception for that. So there are a bunch of different exceptions, classes, enums, and interfaces available, which you can have a look at if you want to dig deeper into it. So I've also prepared a demo where we will be using some of these functionalities of this particular package. So let's jump to the IDE and see what I've built. So here I have created a class called networking demo. And what we are trying to do that we will provide the Simplilearn URL, and we will try to get bunch of information about how this website is hosted. So you just create a simple string variable and you can type any string. You can write any favorite website of your choice here. And then we create the INET address class. And like I said, you always use the concrete implementation of the INET address class, which is in this case, INET4 address. So I use the get by name and we supply the URL to get an INET address object. And what does INET address contains? It contains all the information in terms of the internet address on which that particular website is hosted. So you will see a lot of different functionality in this class. Let's explore some of the functionality and methods which are provided by the INET address class. So once you do this, you will get an INET address object if the URL is correct. If the URL is incorrect, you will get a malformed URL exception anyways. If you want to just see the address of the IP address where this particular website is hosted, you can call the get address method. And if you want to see the host address method, then you can call the get host address. Now you might be wondering what is the difference between get address and get host address. So let's get first that out. Let me comment the rest of the code and let's first focus on this particular part. So let me comment the local address part as well. We will come to that in a while and I can just remove this comment. So we are printing the get address and the get host address, and let's see what values do we get and how do we see if it's a different value. So this explains, right? When we call inet address.get address, we just get all the values. As we know that when we deal with IPv4 address, the address has 4 values, something dot something dot something dot something. If you want to verify it, just go to your own laptop and you will be able to see some address like 192.168.something dot something. So that IPv4 address has 4 sections, and all the 4 sections will have some values. So if you use the get address method and you try to convert this into a string, it basically will return an array. The get address method will return an array which will look like this. But if you want to see it exactly in the format in which the real world networking protocols understand it, then use the get host address, which is going to show it exactly in the way in which we write the IP address, where we write some integer, dot some integer, dot some integer, dot some integer. So that's the difference between get address method and get host address method. Same value, different representation. The next function which I'm going to talk about is about local address, and the local address or the method name is any local address. So this method is going to tell me if there is a wildcard address which is associated with this particular host. You can also see what this method is doing from the documentation. So if you go to the documentation and if you search for this particular method in the inet4 address class, you will see it says utility routine to check if the inet address is a wildcard address. The result will be a Boolean, which will indicate if it has a wildcard address or not. So let's run this program and understand if it has a wildcard address. No, there is no wildcard address associated for this particular website. Similarly, there's another method which we can explore, which is link local address. So let's search for the documentation of it first. So this is the class. If you search it, it will just show you the exact class which is present with the method. And this method provides basically a check to see if the inet address is a link to a local address within the domain of the website. So the result again will be a Boolean. If it says true, it means there is a link to the local address. And if it returns false, it means the address is not a link local unicast address. So let's see the output of this with respect to the Simplilearn website. So if I run this program now, I again get false. So there is no wildcard address attached or associated with the website, and it does not point to a local unicast address either. Is there a loopback mechanism? Now these all are networking concepts, and since this is not a networking session, so I will not go deeper into what a loopback address means in detail, but to give you an understanding of where it present and how you can use this in Java is what we are going to focus on. So if you want, you can always read about what is a loopback address. But if you want to know if the URL which you are pointing to is the address which is returned by that website has a loopback address or not, then you can use the isLoopbackAddress method. And this again returns true or false based on whether it has a loopback address or it does not have a loopback address. So if I run this particular program, I get the output false again. So no, the Simplilearn website does not even also have a loopback address. The last one, or the second last one, which I want to explore is the site local address method. So let's see what does this method do. Let me just remove this extra commented lines. So let's look at the documentation of this method. So this says a utility routine to check if the init address is a site local address. The result is a Boolean indicating if the init address is a site local address, or false if the address is not a site local unicast address. Again, this concept is again a networking special concept, similar to the loopback address. So this is just basically showing if the site also has basically a local unicast address associated with it or not. So if you want to see the site local address output, I have enabled that code, and if you run this particular program, we get false for that as well. Yes, that means that the Simplilearn website is built with pretty good practices. There is no loopback address, there is no site local address, which we don't need for this particular website in this case. The last one is just a simple thing, just to see the hash code. It's not much of a relevance, mostly the programs, but just to tell you that this is also available. So you can also see the hash code, which is contained by the inet address object. So we covered a bunch of functionality in this particular example. We had a look at the java.net package. It has an inet4 address class and inet6 address class, a lot of networking exceptions and interfaces support as well. And the simple way to use it is to you point it to a website, call the get by name, call the get host address, and you will get the IP address in the exact format in which the networking world deals with it. Similarly, you can call the get address to just get an array of it, just as we saw here. And then there are a lot of utility functions available in the inet address class, like is any local, is link local, is loopback, is site local, and there are actually more. If you look at this class, you will find more methods here in terms of what, like for example, it also has a is multicast address. This is basically to check if the init address is an IP multicast address. So there are a lot of different methods here. There are some MC methods as well, which will check, which are specially created for the multicast address scenarios. So a utility routine to check if the multicast address has a global scope, if it has a local scope, or sorry, it has a node scope basically, or it has a link scope, or it has a site scope. So there are a lot of different methods available for the multicast as well, which you can have a look at. And we already covered the get address, the get host address, and the hash code address classes. There are some URL classes as well. Like I mentioned, URL and URI classes are also very important classes, which you might need to use whenever you are building a connection with a particular application based on their URL. If you're doing socket programming, there are socket classes available, which you can also use while using the networking concepts in Java. So you can build a pretty decent and robust application using the networking classes and the networking support provided by Java to build a networking application. Let's get started with image handling in Java. So we deal with images on a daily basis, and you will often be required to deal with image handling in Java programs as well, where you might need to read an image or write an image or load an image into memory and do other kind of manipulations on the images. So Java does provide support for image handling as well, and you can pretty much load any type of image, be it a GIF image or be it a PNG or be it a JPEG image. Basically, it converts into a Java 2D image to render it, and it basically creates a byte representation of the image to serve and save the contents. So in this section, we are going to talk about the image handling aspects of Java. And to do that, there are broadly two classes which Java provides. As you can see in this official documentation, the first one is java.awt.image class. And the second one is java.awt.image.bufferedImage class, which extends the image class. So this is basically the super class, as you can see here, which you can use to represent any kind of graphical image as a 2D array of pixels. And buffered image is a concrete implementation of the image class, which you can use to construct instances of the class. And buffered image is sort of the, I would say, the de facto standard or the go-to class whenever you are dealing with any kind of image rendering tasks in a Java program. And we will also have a look at how we can use the buffered image class to basically read a sample image and also write a sample image to a file system. So you can read more about this in the documentation, and there are also a bunch of documentations available in terms of how you can read it, how you can load it into the program, how you can draw an image, how you can create and save the image, etc. And like I mentioned, we will be covering some aspects of it in today's demo as well. So this was a very brief theoretical introduction about image handling. And like I always mention, if you want to know more about this, do check out the official documentation of Java, where you can learn more about the image handling classes and utilities. So with that, let's move to the demonstration part. So I have prepared a demo here, which talks about image handling. So I've created a class called image handling demo, which has a public static void main method. And I'm just giving some sample dimensions for the image in terms of width and height here. And then, as I mentioned, that we will be using the buffered image class. So I'm creating a reference for the buffered image. It's currently assigned to null. So basically there's nothing. And then I am calling the method read from file. So like I mentioned, you mostly will be dealing with reading from an image or writing to an image. So here we will look at both of the aspects as to how you can load an image from your file system into a Java program and then write it back to the file system from your Java program. So let's first look at the read from file method, which will tell us how we can read a Java file. So I provide some sample dimensions. These dimensions will vary based on your use case, and I supply the buffered image object. Inside that, I have created a try block, and in the try block, the first thing you need to do for image handling is to basically create a file object, because image is also technically just a file, right? So you provide the file image path here at this particular location. So let's go to the sample image path. This is the destination path, and let me open the sample image path as well, which is somewhere in the C drive. So this is the image which we are loading. This is the path which I have mentioned, which is c/sample.jpg. So let's first have a look at the image as well as to what this image contains. So this image is basically from a clinical trial and showing some blood sample or some vaccine bottles, which is probably the very popular image nowadays because we are living in this pandemic world. So this is the sample image which I've chosen to read, and then I will load this into the Java program, and then we'll try to write it back to the file system to a destination location. So this is where my image is present in the C drive named with sample.jpg. and this is what I've supplied here. So you just need to supply it in double quotes. Remember, when you're dealing with Windows file system, you always have to use double forward slashes, which is different if you're working with on a Mac machine or you're working on a Linux system where only this will work fine. So that's a bit awkward thing which Windows has, and you have to respect the operating system's restrictions or way of doing things. So once you have loaded the file or created the sample.jpg file object, then the next thing we are going to do is we are going to create an object of the buffered image. Remember, we just created a reference. We did not create an object yet of the buffered image class. And now is the time to do that. So we supply the width, we supply the height, and then we supply the type of the image. Let's go to the constructor of this image to see what this image type means. So this image type can be basically the type of the created image, which comes from the color space. So whether it's an RGB image or ARGB image or BGR image or byte gray image, there are multiple different types of images in the media space. And whatever type of image you have, you need to basically supply that image type in this particular argument. So in my case, it was an ARGB image, so I supplied that particular. If you click on this, you will see that currently it's inside Java. An 8-bit RGBA image basically has a static constant, which is denoted by 2. You can read more about this inside the buffered image class documentation as well. So once I've supplied that, my buffered image object is ready, which has all the details, dimensions, and the types of the image. Now the next thing is that you need to fill this image object with the file. So you basically need to read the file and store the output of this read operation into the buffered image object. Then what will happen, that along with this information, whatever is present here will also be added to the same buffered image object. So to read a image or simple a file, Java provides an IO utility which is called image IO, and there is a read method available, which is a static method on this particular class. As you can see, I'm calling the class dot method name here, and then you supply the sample file name. Once you have done that, then it will basically be reading the whole image into a 2D byte array and copying that over into this buffered image object. Once that is done, if this particular line is successfully executed, then you will get this message which will say reading complete, and it will try to print some hash code of the image object. And after that, if there's any exception in this block, for example, this particular line may raise an exception, or this particular line may raise an exception if the file does not exist, then you need to have the IO exception caught. Remember, IO is a checked exception. So if you are using these operations, file, new file, and image IO.read, you need to catch the IO exception because it's a checked exception. So either you need to catch it or you need to rethrow it. These are the only two options you have with a checked exception. So once we have done all of that, if everything goes fine, if everything is happy till line 35, then we just return the image object and our read from file operation will be done. Going back to the main method, once the read operation is done, the next thing I'm going to do is writing this image object to a new destination file. So let's see what is happening in this write to file method, because this is the method which is responsible for writing this image to a new destination location. So I've created a public static void method inside the same class where the public static void main method is present. As you know that static methods can only call other static methods. That's why this had to be static. And I'm supplying the same image object which was returned from the read operation. That goes in as the argument of this particular method. And again, I'm using a file object. And this time I'm providing a destination location where I would like to write this image. So this is the destination location I've chosen, which is F drive Java tutorials folder, and the image should be stored with the name out.jpg. So this is the location. There's already an out.jpg here. So let me just remove it so that we can observe the output. So we create the file object. After that, we again use the image IO utility. We call our static utility method called write. We supply the whole image object. We supply the image type extension, and we supply the output location. Again, if I take you to the signature of this, you take the rendered image, you take the format name, which is JPG, and the output location. So these are the three things which you need to supply once you call the write method on the image IO utility class. Image IO is a very handy class, and do remember this class whenever you are dealing with the image handling operations. It will provide a lot of static convenience methods. So we write this write this image object to a file, to a destination location, and if everything goes fine in these two lines, we will get this message which will say writing complete. If anything goes wrong, we again catch the IO exception, and the exception will be printed here. That's all is happening in this particular program, where we are reading from file and we are writing to the file, reading it from here and writing it on this particular location. So let's run this program and see if we are able to read from file successfully and also write it to the specified location. So run as Java application. It's a slightly memory heavy operation, so it takes a bit of time because the whole image needs to be loaded into memory. Be very careful about that. It might eat up a large portion of your RAM if the image is too heavy. So here it says reading complete, and then it prints the hash code details of this particular object. And then it also executed the write to file method, and it said writing complete. So just to show you the reference back again, this is what we read, sample.jpg in C drive. And if I go to the F drive, Java tutorials, where I provided the output location, I do see an out.jpg here, which was not there earlier. And if I double click on this, it's exactly the same image. So Java was able to read the image and render the exact same image by converting the 2D byte array representation back to an image exactly the same form. There's no change in this image. So this was a very short and lightning tutorial for you to show you how you can use image handling classes, for example, the image IO class and the buffered image class, to do basic image handling operations. Obviously, you can do more complex operations with it as well, but for the demonstration purpose, I've just kept it simple. Let's get started with concurrency utilities in Java. Now, concurrency is a huge topic, and it's not possible to cover this into a 10 or 15 minutes tutorials. So treat this particular session as an introductory session where I will talk about some of the most relevant classes which you need to know when you talk about concurrency. We have been talking about this whole concept of concurrency programming throughout the thread tutorials as well. And the basic idea is that you would like to do multiple things at the same time. That's the basic idea. Now, in that context, Java does provide a lot of utilities and packages, especially the java.util.concurrent package is one of the most popular package which you need to use whenever you are dealing with concurrency programming paradigms in Java. So with that, let's have a look at what does this java.util.concurrent package contains. So broadly, it contains a lot of utility classes which can be very useful for you when you are writing the concurrent programming code. Apart from that, it will also provide some basic ideas around the locking functionality and the atomic packages as well. When we talk about locks, again, we discussed about locks when we talked about the whole thread synchronization concept as well. And it basically marries very well with the whole concept of locks and atomic packages as well. Atomic is again a different topic which is used for thread safe types basically. But whenever you will hear about concurrency utilities, be it in your discussions or be it in your interviews, you will be seeing a discussion happening around executors. You will hear these terms like executors, executor service, future, completable future, callable, all of these. You will hear the name of all of these classes quite frequently. So these classes were first introduced in Java 8 and have been there since then to support the concurrency programming paradigm. So I will talk about these three classes broadly in today's session, and we'll have a look at a demonstration of these three classes as well. Let's first talk about executor. Technically, it's an interface. It's not a class, though I said that it's a class, but it's basically an interface. An executor is basically a very simple interface which will help you define the subsystems which you would like to create with the help of threads, maybe including thread pools, or if you want to do a disk reading and writing operation in an asynchronous way, or you want to create some sequence of task frameworks as well. So executor will provide you a very lightweight framework to do all of that, especially around thread pooling and asynchronous IO is where it shines most, because in your computer you have limited resources and you would like to dedicate a certain pool of threads for a particular task or for a particular executor object. So with that, the second class which we would like to know about is executor service. An executor service will provide a more asynchronous task execution framework, and this is probably the class which you will be using whenever you're dealing with asynchronous programming in Java. Asynchronous programming basically means that you submitted a particular task, but you did not wait for it to be completed. You did not hang your process or your thread for that particular task to be completed. It's very simple. It's very easy to relate this to a real life. For example, if you are, there are times when you do two things at the same time. For example, let's take a very, very simple example. If you're just boiling milk on your gas stove, so you put the milk on the gas stove and then you move out for a couple of minutes to do something else. For example, maybe checking your mobile for new emails or doing some other work, maybe just doing some laundry. So you are doing you submitted the milk boiling task. Then you moved away from that task because you know that this particular task is going to take some time, and you utilize your time somewhere else. That's what we mean by asynchronous programming, and executor service will provide you with constructs to create a similar behavior in your Java program as well. So remember about executor and executor service. We will look at the implementations later where we can talk about that. Another interesting class which I would like to talk about is future, if we have it here. Yeah, so future is another class which we will be looking at, and future is basically to fetch the result of the submitted task. Again, taking the same naive example of the milk boiling example. So it would be great, right, if there is some mechanism or some alarm which just sets off the moment the milk is boiling and it's about to be spilled out. It would be great to know that in advance via some alarm or something. So future provides that kind of a carrier or that kind of a holder where you submitted a particular task, you moved your threads to something else, you did something else, and then you can check with the future object, and future object will tell the status of that submitted task, whether it is completed or whether it's still in progress. Once it is complete, then you can fetch the result of that submitted task based on with the future object. So that's the concept of future. So remember, executor service and future, they will work quite hand in hand, because executor service will be used to submit the task and future will be able to fetch the result of that particular task asynchronously. So that was about a quick theory. You can read more about it in the documentation. You can see in executor service, future class, what does this basically in these class do. But to have a look at or get a greater sense of this, let's have a look at our demonstration of it to understand these classes better. So let's move to the Eclipse IDE to look at an example. Let me close all the classes and just open a relevant one. So yeah, so let's first deal with the executor interface itself. So if I just minimize this one, here I've created a main class and I've created a public static void main method, and you see two static methods here, executor invoke and executor service invoke. I'm basically showing you how you can use executor and executor service. So if you're just using executor, then how you would do that is basically you are going to create a reference of the executor, and then the executor needs basically an executor object, because it's an executor reference, so you need to supply an executor object. So either you can supply an inner class right here, or you can create a executor type of class, which I've created here, which is called caller class. So I've created a class called caller which implements the executor type, and the moment you write implements executor, it will force you to override the execute method, and inside the execute method you are going to run your own thread. So this is how the current thread or the executor's own thread will be running. So once you have done the initialization, then you can call the execute method on the executor class. Remember, you got this object, so you can call the execute method on the executor object here, and inside this you can provide this particular lambda function implementation, which is going to ask you what exactly you want to do when I run this particular thread. So when I run this thread, when Java runs this particular thread, what do you want Java to do? That's something which you will provide here. So this is how you can use, it's a very simple example. Like I said, if I build a more complex example, it will take a lot of time and a lot of other concepts to cover. So treat this as an introductory session, and you can basically try to run a very simple example of this, writing whatever complex logic you want to write while the thread is running, and put that into this execute. Similarly, if you want to use executor service for doing the asynchronous operations, then it will follow the same way, but there are some differences along the way as well. So this is the method which is showing the executor service implementation, or the way of using executor service. So again, I create a reference of executor service, and then here you see I'm saying executors dot new fixed thread pool with a size of 10. So that's the power of executor service. It is going to create a pool of threads dedicated to itself to do the tasks whichever are written inside here. So whatever you write here, these thread pool will be utilized to execute that particular task. You can assign the size of the thread pool based on how many threads you need. There are multiple static utility methods, like there is one new fixed thread pool which I've used. But if you just do Control Enter, you will see cached thread pool, single thread execution, a new work stealing pool. So like I mentioned, there are a lot of classes, interesting classes here, which you can use. For simplicity, I've just used a fixed thread pool here. Once you get the executor service object, then here you called execute, but here you will be calling the submit method. And then the drill goes exactly the same way, that you write the Lambda function implementation inside here, basically the functional interface implementation, and you provide your own implementation code, which you would like to run whenever you call the run method, whenever this executor service calls the run method on that particular thread. You can actually go to the submit method and you will see it accepts a runnable. It basically accepts a thread object. So whatever you write inside this particular code will be the public void run implementation of that particular thread class. If you don't remember how runnable works, please go back to my threading tutorial and watch that, where I explained the runnable interface and the run method in detail. So that's what we are doing here. So this is for executor and this is for executor service. So let's run this program. And yes, I mean, nothing, because I'm not doing anything much apart from just doing sysouts here. And that's what you see here, the executor example and the executor service example. So this was about executor and executor service. Now let's deal with another interesting class of called future, which I said that I will also talk about. So for that, I've created a separate demo because it deserves a separate demo. It's a very interesting class. So let me just make it full screen. Yeah, so I've created a class called future demo, which has a public static void main method. And again, I'm doing this executor service initialization, but this time I'm using a new single thread executor. Now, what does this do? This will basically create an executor which will use a single worker thread operating from an unbounded queue. Remember, even if this single thread terminates due to, let's say, a failure during the execution, before the graceful shutdown, a new one will automatically be spawned and will take its place if the execution is still pending. So that's the power of single worker thread from an unbounded queue. That's what I've used here. Based on your use case, you can use other ones as well, like I mentioned earlier. Then I have the executor service object with me, and similar to the previous example, I'm going to call the submit method. And inside the submit method, I need to provide the runnable class runnable interfaces implementation. And that implementation will basically be of the public void run method. And this is what I want to do in my run method, where I'm sleeping the thread for 10 seconds. Thread.sleep method takes millisecond values as the parameter. So this is 10,000, which means 10 seconds. So I'm sleeping this thread or pausing this thread for 10 seconds and then returning a string called completed. This is what I am doing in the executor service.submit implementation. The result of it is going to be a future object. Remember, the result of the submit task is going to be a future object. So I store that future reference here, and then at line 20, I'm using the same future object to ask Java to check if this task is done. And the way you do that is just by calling is done. So till the time, there's a negation condition, till the time the task is still in progress, because this means future is not done because I've put a negation, then just print this out where you say the task is still in progress, it's still not complete, and you pause this particular thread. Remember, this was a different thread. If you pause this particular thread for 500 millisecond, or basically half a second, and you again check this condition. If it's still not done, you print this, again pause for half a second, again check this, till the time future.isDone becomes true. When future.isDone becomes true, that means that this particular task is completed. Now you see, I mean, generally when we execute the programs, the execution happens sequentially, that after line 17, the control will automatically flow to line 20. And before the control can reach line 20, everything above line 17 has to be completed. That's basically synchronous programming for you. But when you talk about asynchronous programming, using the power of executor service and future objects, you can do something here which will go into a separate thread. And then you can continue your execution here. So this can be in a different method altogether, where you submit something, and this is basically checking the status of this task. Understand this very well. This is very important concept, that it's not though it's a sequential execution, after line 17, line 20 is getting executed, but line 20 is not waiting for everything above line 17 to be finished. It will continue. That's the power of asynchronous programming. So here we are checking this, and once the future.isDone says true, then we say task completed. and then you probably would like to fetch the result of this particular task, right? And for that, future provides a method called future.get. This is going to pick the future object state, and whatever you are returning from here will be returned here, and then I'm printing the result. So if everything went fine, this result should say completed, because that's what I'm returning from this future object. And always remember to shut down your executor service to release the thread pool which you created here. I've also put a catch block here because I'm using the thread.sleep method, which will ask you to handle an interrupted exception. And then there is an executor service exception, which is execution, and a timeout exception as well. There are other interesting methods as well on the future class, future object, sorry, which is like future.cancel, where you can cancel explicitly a future task which is currently in progress. You can check the status of it by calling isDone, which I've used here. You can also call isCancel to check if the user or some other process explicitly canceled the execution of the submission of the executor service task. So hope this is you are able to understand the flow of it, that these block and these block program will execute them, but they will run in different threads. So let's see what happens. Now I'm going to run this particular program. And if I bring this here, you see the task still in progress keeps getting called. So we submitted the task here, and now this block is getting executed. This block kept getting executed. So this task did not finish, right? The thread.sleep was this whole thread was sleeping for 10 seconds, but line 20 did not wait for 10 seconds. It continued execution, and it kept checking the future object 10 times at least, or till the whole 10-second sleep was taken away. And once this thread woke up, it returned completed. Future.isDone became true, and it came out and it said task completed. So that's what we get here. And at the end, in the result, you get completed, which is what you returned from here. So this is the power of asynchronous programming. Please, like I mentioned, please do read more about these classes and how they work and what is the paradigm of asynchronous programming. It does make debugging a bit hard at times, but it's a very interesting concept to be used in concurrent applications. Let's get started with regular expressions, or regex, in Java. You may hear people calling it as regex or regex. Doesn't matter. You can call it anything as you want till the time you have the concept understood in the right way. I'll just call it as regex. So when we talk about regex, let's understand why do we need them and how Java actually provides support for that. So the basic idea behind regular expressions is to find a pattern in a text corpus. If you have a lot of strings available, if you have any kind of text, any kind of string, and if you would like to find a particular pattern saying, okay, does this whole text paragraph contains any character, or contains any number, or contains any special characters, or contains characters after numbers or numbers after characters. So if you would like to find those kind of patterns in your text corpus, then that concept is called regular expression finding. And Java provides the support for that particular regular expression finding through a package called java.util.regex package. So this is the package which you would need to use when you want to do any kind of regular expression finding in the text. Now, you may be thinking that why do I need to use this? I already have the string handling methods, right? You can do substring, you can find a particular character in the string, etc. But that is limited because it only provides string methods, ways to manipulate and find and replace strings. But regex is generic. You can literally find any kind of character in your string. It can be a special character. It can be a square bracket. It can be a multiply sign. It can be a divide sign. It can be, like I said, integer, capital letters, small case letters. So any kind of pattern you would like to find, java.util.regex can be used to find that kind of pattern. Now, this package is very interesting and it provides lots of classes. And again, this is a very big topic and very complex topic. So we will just scratch the surface of it. And like I always say, whenever you would like to read more about it, go back and read the documentation. Currently, the documentation I've opened is for Java version 8, but when you are reading it, you can go for the latest Java edition documentation. So with that, let's talk about some of the interesting classes which we will be dealing with and we must know when we talk about regex in Java. So I already explained what are regular expressions. Let's go to the interesting classes. The first class which we need to know about is the pattern class. So pattern class, or an object of the pattern class, will basically be representing a compiled regular expression. So you write your regular expression in a certain way. Regular expression has its own language, I would say, to write the pattern. For example, if you would like to write a pattern saying that check if this particular text paragraph has the characters first, then the integers, then the characters, then this particular special character. So that is your pattern. You write that pattern, then you need to compile that pattern. To compile that pattern, you can use the pattern class. This class generally does not provide any kind of public constructors to you, so you cannot initialize the pattern object explicitly. But to create a pattern, you need to basically call the static method named as compile. So compile is the method which you need to use to compile your regular expression, which will then return the pattern object. Once you have compiled written your pattern and you compiled your pattern, the next class which you need to know about is the matcher class. Matcher class will provide that particular engine framework which will understand and interpret the pattern, and then will try to find that pattern on the text paragraph which you are supplying, and it will result in true or false. If it finds that pattern, it will say true. If it's not finding the pattern, it will say false. So that's the basic idea. So you need to know about the pattern class, and you need to know about the matcher class. So the matcher class also does not provide any kind of public constructors, and you obtain a matcher object by calling the matcher method on the pattern object. So once you created a pattern object, just call the matcher on that particular object, and that will get you a matcher object, and then you can use that object to find the patterns in that particular text corpus. There is also a dedicated exception which is called pattern syntax exception, which will be thrown whenever you have written the regular expression syntax incorrectly. Like I said, it has its own language, so you need to write the expression in a way regular expressions are supposed to be written and supposed to be understood. I will touch upon that in a while, but that's the basic idea about the three classes. Now, when you would like to find a pattern, it can be a string pattern, it can be some characters, it can be some predefined characters, some quantifiers. You can also create subgroups within the regular expression. So like I said, there's a tons of functionality which is available in this particular concept, and we will just cover some of the relevant ones, or just run through some of these concepts, and then I will switch to a demonstration. For example, if we talk about the string literals, then you can do the string matching. For example, if you want to find this particular word or this pattern, this is just a text pattern, right? So if you would like to find this particular text pattern in the text string, then you can write this particular text pattern as a string pattern inside the pattern object. So that's about the string literals. Now let's move to some interesting ones like meta characters. And the meta characters are very interesting because they have a special meaning. For example, if you write your regular expression like this, where you say cat and then you say dot, then when you are applying this particular regular expression to find the match into a string, it is only going to find the match for CAT. It is not going to find the match for CAT dot, because dot is a meta character in regular expression. It has a special meaning. It does not mean dot, but it has a special meaning. And that special meaning basically means that even though the dot is not present, it will basically mean that after cat, it can be any character. So the meta character dot means any character, which is why you see this match succeeds, because it will search for this pattern, which it matches. And after that, it can be any character, it doesn't care. So even if it's S or D or whatever, it will say true because CAT was found a match. So dot means any character after the pattern you have specified. Similarly, there are a lot of other characters, special characters or meta characters like the ones which have been listed here: question mark, star, plus, dot, and all of these have their own dedicated special meaning. They are not your normal arithmetic operators or other operators. They have their special meaning when you are dealing with meta characters. So do read about them in detail, and I will be using a bit of meta characters in the example as well. Then the character classes are also very interesting. Similar to the example which I told you before, if you want to find a particular string or a particular integer into a text corpus, then you can use the character class patterns. For example, you just put a square brackets and you write ABC. This means that it will try to find exactly ABC in the string. If you put a cap in front of ABC, then it will try to match any character or find any character except A, B, or C. So it's a negation. Similarly, if you specify small a to z and capital A to z, it means any character can be there between small case a to z and capital case a to z inclusive. Similarly, you can provide specific ranges like A through D or M through P. So only the characters which will match the union of this condition will be returning true, and rest of the if this particular pattern is violated, then you will get false. So similarly, you can build a lot of complex combinations and permutations with these special meta characters and character classes. Do read about these in detail if you are curious to know about it, and there is tons of materials available on this on internet which you can read about to learn more about. Similarly, there are predefined character classes as well. Dot is something which I already explained, which means any character. Then you can use /d to find a digit in a particular string or in a particular text corpus. /D is for non-digit, or you can use the classic negation condition as well. /s is for a white space character. /S is for a non-white space character. Word, non-word. So there are a lot of different examples. So I think by now you would have built a decent understanding of what I'm trying to tell you is that you can specify these patterns, compile them, and then use the matcher. So let's move to a very simple demonstration. It's not a complex example, but very simple example just to get the point across. So I'm creating a regex string here, and this is the pattern I've specified. I'm saying any character, star means any number of characters, so it can be anything here. Then the string, the pattern expects an alphabetical string or alphabetical section. After that, the alphabetical section should be followed by a numerical section. And after the numerical section, again, it can be any character. So this is my pattern. I create a simple string with this regex pattern. And like I mentioned in the documentation, you call pattern.compile to compile the regular expression. So I compile the regular expression, I get the pattern object. And after, again, as per the documentation, it said that you can call the matcher method on the pattern object to get a matcher object. So I say pattern.matcher, and I provide my string on which I want to test it. So I've just put a random string where there are some integers, then there is some alphabets, and then again there are some integers. Once you have got the matcher object, just call matcher.find. This will return a boolean where you can test whether the matcher found a hit in the text corpus or not. If it found a match, the match found will be true, and if it didn't find the match, you will get a false value in this result. So with that understanding, let's run this program. So I get the output match found. Why did I get that? Because I said that start with anything. So it started with anything. I don't care what it is. It's an integer or any special character. I don't care. After that, there should be some alphabets. So there are some alphabets. And right after alphabets, there should be some numbers. So again, there are some numbers. And after that, there can be any character, 0 or more characters. So there is nothing here. That's why you see a match found. Let's do an interesting test here. Let me do this. I put A to Z again here. So now I'm saying start with anything, have alphabets, have numbers, and again after numbers, you should have some alphabet, which is not the case here because you start with something, you have alphabets, you have numbers, and after numbers, the string ends. There is nothing after that. So let's see what happens now. You get a match not found because this particular pattern, when got compiled and got applied on this particular string, did not find the string following the regex pattern which you have specified. So this is a very simple example to show you how you can build patterns. You can use groups concepts as well to group the patterns. It can get very, very complex and very, very nasty. So use them very wisely, very carefully. And do read about the documentation and other examples which I talked about to get more understanding and more comfortable with regex. Let's get started with NIO packages in Java. Now, let's first understand why do we need this package and where will we be using this package. Let's talk about the where first. You can use the NIO package to read from a file or write to a file. Now, let's talk about the why. Because the obvious question will be that we already have the IO package in Java, right? Where you can use the classes from that particular package to read from a file or write to a file. Then why do we need another package doing exactly the same thing as NIO? So the basic reason for launching the java.nio package was providing the multi-threading capabilities to the IO library. And we could not do this in the existing IO library because we had to probably rewrite and change the functionality of it. That's why Java created a new package called java.nio package. And this package is basically, if you understand what NIO means here, generally, as per the popular perception, it means non-blocking IO, that you don't want to block your threads while you're reading to a file or writing to a file. Classically, NIO meant networking IO, but as per the popular perception, people know it as non-blocking IO. So the basic idea is, because whenever you are reading a file or writing to a file, the thread gets blocked until the whole file is written or until the whole file is read. So the NIO package provides an improvement over that. It provides an improvement in a way that you can read the file into a different thread, but at the same time move on to another thread and write to a file. So you get this multi-threading capabilities and non-blocking capabilities out of the box from the classes provided by java.nio package. So that's the brief about this package. Now, some of the popular classes which you will be dealing with and some of the concepts which you need to know about NIO package are buffers and channels. This is probably the core concept of the whole NIO package of how channels and buffers work. So let's say you are trying to read something, then the read operation will be happening from the channel into the buffer. And similarly, the write operation will be happening in the reverse way, which means to the channel from the buffer. So that's how the buffer and channel work together, that whenever you are trying to write something, you have to first open a channel, create a buffer, and then you can read from the channel into the buffer. And similarly, when you're writing to the buffer, you again have to go via the channel route. So channel is that route basically. Buffer is basically just a plain container for the data, and channel is basically representing the connection to the entities which are capable of performing the IO operation. So think of channels as a pipe, a channel literally basically. If you understand the English meaning of channel, that's exactly what we mean by here, that it provides just a means to an end. It provides sort of a wire to the buffer. And then you also have selectors and selection keys classes, which together with selection channels work to provide the non-blocking IO functionality. There are some other APIs, interesting APIs as well, like charset and some more, but I will not go into the detail of that, because if you know about buffers and channels and selectors, then we will be able to figure out what exactly we would like to do with this. I would also like to talk a bit more about the buffer class. So if you go to the buffer classes operations, the popular operations, you will see there will be the read operation, which is for reading the files basically, or reading the content of the file. This works on the byte stream concept first of all. So to read the bytes from the file, you will call the read method. There's also a very interesting method called flip, which I will be using, which makes a buffer ready for the new sequence of operations. So once you have done something and you want to, let's say you read a particular file and you have come to the end of the file. Now you would like to reset the buffer and go back to the beginning of the file. Then you can use the flip method for that particular piece to bring the current position back to the position to the zero index or to the starting of the file. So that's about read and flip, and we will have a look at some of the other methods. And there are a lot of interesting classes in this NIO package. Do read about the documentation and check out the other methods as well to learn more about this package. But the basics are, like I said, channels, buffers, some methods of the buffers, and there's also a path class which is used to basically provide a particular path to a directory, which I will not be covering in this example, but something good to know. So with that understanding, let's move to an example and understand how we can work around with this NIO package. So for that, I have prepared an example where I will be reading from a file and then writing to a file. So I have a main method here. The first section here basically is about reading from a file, and the second section is about writing to a file. So let's go through both of these sections one by one to understand what is happening. So in the read section, I use the file input stream class from the IO package. I'm still not using the paths class here, just to show you that both of them still can work together if you want to use the old constructs. So I use the same file input construct to read a file called source.txt, which is present at this particular location in my directory. And this source.txt has just a one line of text, nothing more. So I basically create the file input stream object, and then I create a channel. Because we are dealing with files, so you create a file channel. If you're dealing with network socket, then you might have a socket channel. So that's also something which you need to know about, that this NIO package is generic. It can be used for any kind of communication of reading and writing, not specifically to file handling. So we create a file channel object here by calling file input stream dot get channel. It's that simple. Once you call that, you will get a reference or the object basically of the file channel. Then the next thing is to create the buffer. Like I mentioned, that channels and the buffer are the two main tools through which you work with an NIO library. So we create a byte buffer, and we allocate some starting size to it, just some threshold size. So you can put it any number which you think is practical for your file and for the use case. Here I've put just 1024 bytes or 1 megabyte because my file is pretty small. So I just put that and initialize the read buffer, and then I call read channel dot read operation. So the file channel object you created, you just call the read method on this particular channel and supply the buffer. And then it is going to read the file via the channel into the buffer, and this read method is going to return a result to denote if the file was written successfully or not. I'm just printing a sys out here, just a bare bones sys out, nothing new here. So this section will be used to read a file. So let's see if I can read the file successfully, and then we'll move to the write section. So I go to run as Java application. Yeah, it says file read successfully, and it read 27 bytes. It means that there were a total of 27 bytes in my file, which had a single line of text. So it read all of that, and it completed the execution. Now let's move to the write section, and I can comment the read section because we have covered that. So here I'm again creating a file output stream object because I need to write something. So again, using the same construct of the IO package I have covered previously in the previous sessions. Once we have the file output stream object created, the next thing is to create a channel. So I again create a file channel, but this time it's the write channel. I again create a buffer, which is the write buffer, allocate some size to it. Then this is the string which I want to write to this particular file. So my destination file will be called dest.txt, will be present in this particular location, and this file should have this string written if this whole operation goes successfully. That's my end goal. So to do that, I say write buffer.put, and whatever string you have created, just call get bytes on it, and you get a bytes representation of the whole string. So that's what I've done here, because this put method expects byte, because if you go inside this, it expects a byte array. So that's what I'm supplying here. I'm providing the bytes array on the string by calling message.getByte, or any string object.getBytes will get you a byte array. Once you've done that, then I'm calling the flip method. Remember I talked about this flip method to basically reset the index. That's something which you need to do in this particular case, so that the index goes back to the initial position and the buffer can be written successfully to a file, to a channel basically. So once the buffer has completed its operation, then I can write the buffer to the channel. And once that is done, then if these operations went successfully, then I will see a file called dest.txt in this particular directory. Currently, there is no dest.txt in this directory. You can see there are just 3 files, but there is no dest.txt. So let's run this program. So it says file written successfully, which was the last sysout at line 28. But let's also see what is happening in the directory. So now I see a dest.txt popping up here. It's a 1 KB file. And if I double click on this, I see the same string which says this is a test string, which is the same string which I supplied here. So you can see you can use the NIO packages to do the file read and write, and much more than just read and write using the NIO package. But this is just to get the point across that this can be done using the NIO or the non-blocking IO package as well, so that you get maximum performance on your machine while you deal with file IO operations. Let's get started with Java Beans. So we have been creating Java classes and creating objects of those Java classes to work and manipulate, transfer data, call methods, create properties, etc. And Java Beans just use that as the groundwork to create a specification. First of all, let's understand that Java Beans is just a standard. It is just a specification which has been provided by Java to be followed while you are implementing production grade or enterprise grade applications. So it's just a pure specification, set of standards. If you want to read more about this, please go to this particular link which is written here. I mean, if you just Google Java Beans spec Oracle, then you will be able to find this particular link. You will see a download option here. If you go here, you will get these 2 specification documents option. So you can just accept the license agreement and click on this particular Beans 101 PDF, and you can read about the whole Java Beans specification. I've already downloaded this particular PDF, which is opened in this tab. And if you go to the TOC here, it's an official Sun Microsystem white paper basically. And if you read about this is going to explain the whole Java Beans API specifications. It's going to specify the core components of the Java Beans component architecture. So it's a specification. Let's understand that very well. if you go to the table of contents, let's go to the interesting one, which says what is exactly a bean or a Java bean. So a Java bean is basically a reusable software component that can be manipulated in any visual IDE like Eclipse or IntelliJ or NetBeans, etc. So technically, a Java bean is just a Java class. But that Java class should follow three main properties. The first property is that Java class should have getters and setters to access the properties. Second property is that Java class should have a public no argument constructor so that anybody can create an object of it. And third is that the Java class should implement serializable. The reason Java Bean specified these three conditions, which I said, let's talk about the third one where we are saying that it should be implementing serializable interface. Why is that? It's because a Java Bean would be required to be exported between applications, may be required to be written to a database or to a file system, or to be converted into an XML or a JSON document, sent over the network, again being deserialized. So this will be moving across a lot because that's what we mean by reusable. Multiple different software components and applications might be reusing that bean again and again, and that bean needs to travel across. And to enable that bean has to be serializable, because if you can't serialize it, you just cannot transport that object to another application. It's just not possible. This is how Java has been. So that's why you need to implement serializable. You need to have a public no argument constructor, and you need to have getters and setters to access your properties. You can actually read more about this if you scroll down. It will also talk about the difference between beans and class libraries. Remember, not class, but class libraries. And here it explains what I just said, that a Java bean can have properties, it can have events, and it can have methods. So properties are nothing but the normal attributes which you create inside a Java class. Nothing fancy. The same attributes are named as properties. For example, you may have a foreground property, and then you can have a method which is just a normal Java method which can be called from other applications or from an environment. And by default, all of the beans public methods will be exported. By exported, I meant when you export this, when you serialize and export this object, all the beans public methods will be exported by default. But then a bean can choose to export only a subset of its methods if it wants to. A bean can also have events. And events basically provide a way for one object to notify other objects that something has happened. So something similar to the producer consumer example or the producer consumer pattern, where you can notify other objects. Threads also have this particular pattern where a thread can notify other threads that it has completed its task, and other threads can start. So that's the property behind event, where something has occurred, and then the object can tell other objects that something has occurred so that they can react to that particular event. So these are the three main traits, which are properties, events, and methods. You can read more about this particular white paper. I will not go into the details because it's a long white paper, but it's a very well written white paper which will give you a very good understanding of how Java Bean specification was written, what was the thought process behind it. So coming back to the code, if you want to just write it, it can be very simple to write. Just write any class and say implements serializable. So it will ask you to provide a serial version UUID. So you can write this here. Then you can create your attributes as normal private attributes. You can create public methods to access and manipulate these attributes in the forms of getters and setters. So these are the public methods to access and manipulate these attributes. Here we have a parameterized constructor which will not be required, or which should not be there when you're creating a Java Bean. It should just be like this, because when we talk about the public no args constructor, as we discussed in the very first lectures, that you do not need to provide the default constructor. Java will automatically provide a default constructor for every class. So you don't need to write something like this. It's just not needed, because you can write it, but it has no value attached. It has no meaning, because this is something exact. This kind of code is already generated by Java compiler when it compiles this particular class. So a public default no argument constructor implementing serializable, private properties, and public methods. And you can have additional event methods as well, which I talked about just when we were going through the white paper. And that's all pretty much what a Java Bean is. So you can see it's just a Java class, but some additional specifications which a Java class has to follow to be called as a Java bean. Let's get started with Spring Framework. So Spring Framework is the most popular web application framework available out there today. And all of the big companies from Netflix to whatnot use Spring Framework to build the modern day Java applications. So before we go any further, let's understand why do we need a framework. So let's understand this with the help of a diagram. So let me just open a blank paint page and let me show you what I mean by a framework and why do we need this. So we built simple applications so far, but if you have to build an enterprise grade web application, you will have a front end probably where you will have what you see in the browser. So you will have the HTML, the JavaScript, or any other Java Enterprise Edition classes like JSP Servlet, etc. Then you will have a backend where your Java classes are present, which contains the business logic. So the business logic. And then you have a database where you store the basically the whole data. So you have these three different layers. We also call this a 3-tier architecture. So you cannot build all of this by just using the core Java classes which we talked about. You need to do more integrations. You need to use more different programming languages and concepts to build a complete enterprise grade application. And if you try to build all of this by yourself, then it's going to take a lot of time and a lot of effort. That's why we have frameworks which basically provide the structure to create these three layers. So that's why we have these frameworks. And in the frameworks, Spring is the most popular framework. It provides the structure to write all these three layers. One of the reasons I did not talk about the Java Enterprise Edition technologies like servlets and GSPs because nobody works on them today. Even if you learn about servlet, it's good to know the conceptual overview of servlets, but nobody today builds applications on JSPs and servlets. That's the reason I did not talk about it, because today we have sophisticated front-end frameworks like AngularJS or React.js or Ember.js and whatnot, and it is iterating at a very faster speed. So there is literally practically no need for a Java developer today to learn about GSP, because I can bet you on that. You can take it in written from me. Nobody is going to build the GSP based applications in 2021. Everybody is going to use some sort of front-end framework to build that. And then you have a backend. In the backend, you have the exact core Java classes like I just explained. So you will be using the Java beans, and you will be basically using the pure Java concepts of collections and etc. to write the backend logic using the Java classes. And then you will need a JDBC connection to write to a database as well. So you would need a database as well. And Spring provides connectors and specifications to support all of these three layers. That's the reason. So generally, when you talk about a web application, let's talk about web application because Java primarily is used in web applications. So in a web application, you basically see a browser window where you load a particular page. But what happens behind the scene? This browser has some HTML and some JS maybe, and this code is basically calling some endpoint. This endpoint is present in the backend layer. So this endpoint is present in the backend layer. That endpoint transfers the control to the business layer where you have your core business logic written. And then the business layer transfers the control to the data layer, or some people also call it DAO layer. This DAO layer then talks to the database. That's how a web application works. And that's the architecture you will mostly be following whenever you are building any enterprise grade application in any organization. So Spring provides support for all of these parts. This obviously is written by Angular and React and other frameworks, but this whole section is basically presented or supported by Spring. So with that, let's understand a bit more about Spring Framework. So if you go to the Spring official website, it talks about some of the value propositions. Spring is used heavily. Like I said, it's used everywhere. It's very flexible framework. There are a couple of concepts which Spring provides, which is around inversion of control and dependency injection. And I will talk about these concepts in a while when we'll talk more about the Spring's components. It makes it's quite productive and quite fast as well. So it's very fast to build application on Spring. It has a whole dedicated security module as well. So it's quite secure by design. And the Spring community is huge. So you can find a lot of support on internet. Let's learn a bit more about the Spring's core components or core technologies. So if we talk about the Spring's core components, these are the Spring's core components. So you have a testing module, you have a core module. First of all, inside the in the core components, you have a core module which has IOC containers, resources, events. I'll talk a bit about that. It has its own testing component, so it provides very good support for testing applications. It has a data access component. The data access component is used to provide connections, utilities to the database, because like I mentioned, your application will be talking to the database, and Spring provides a complete dedicated component to be used whenever you are talking to the database. It also provides a web servlet component to provide support for Spring MVC, which I will be covering in the next session, WebSockets and Stomp and messaging frameworks, etc. It also supports reactive or asynchronous programming if you want to do that. It provides a lot of integration capabilities in the integration modules if you want to do JMS or JMX or email or task scheduling, etc. And it also provides language support to support internationalization of the applications. So it has a lot of different components, but we will focus on this core component, which is of the interest here. So let's talk about that. The first thing which you need to know about Spring is its support for inversion of control, and it provides that support by creating an inversion of control container. What do we mean by inversion of control? The basic idea is, let me take any random example and I will be able to communicate the idea behind this. So let's go to any simple example which I have already covered. Let's go to method calling, for example. So we had a student class. We created a student class, simple student class, 3 properties, constructor and public getters and setters. And then I created a main class and I initialized the student object. So the responsibility of creating the student object lies with the student class itself. Student class have to be explicitly initialized to be having an object of the student. So this creates a problem, because when you're dealing with enterprise grade frameworks, you might need to create a lot of objects on the fly whenever the endpoint is talking to the business layer. If I take the reference of this architecture, if the endpoint is talking to the business layer classes are talking to the data access layer classes. So when the business layer classes needs to talk to the data access layer classes, the data access layer classes needs to have an object, because the communication happens between objects only. So who creates those objects? If every time the data access object has been called, and if we pass that responsibility to the DAO class to create the object, or every time the endpoint talks to the business class, we ask the business layer to create the objects, it becomes a lot of painful process, because every time you will be doing this new student everywhere, you need a student object, which is very painful process. So what Spring says, it says, okay, invert the control of creating the object. So let's not give the responsibility of creating the object to the class. Let's give that responsibility to the framework. So the framework will be responsible for creating the objects of a class, and it's not the class who will be responsible for creating its own objects. So generally, outside the framework, a class is responsible for creating its object, but with Spring inverts this responsibility. That's why we call it inversion of control. The control is inverted, it's reversed, and now it's the framework's responsibility to create the objects. You will also hear about a concept called dependency injection a lot in context of IOC, and dependency injection is an implementation of the IOC concept. So using Spring's dependency injection mechanism, you can inject the object of any class into any class. Once you do that, Spring dependency is going to use the inversion of control concept and create the object. That's about IOC and DI, or dependency injection. Then the other modules like resources will provide a way to refer different files in properties if you want to. Then you have a validation module as well, which will provide different validation constructs, because once you receive the data, you might need to run a lot of validation, right? And writing the validation by yourself can be very painful. So it provides a validation framework as well by providing the validator interface. You can use this particular framework to write the validation rules, checking the name not empty, etc. Similarly, it also supports an expression language if you want to use that. So the expression language support is wide, very wide in fact. You can create an expression parser and you can do the expression language evaluation using the Spring expression language. Similarly, it also provides support for aspect-oriented programming. Now, again, all these concepts of validation and Spring expression language and resource support, you probably would need hours of reading to learn about these concepts, and I'm just running through them just to tell you about these concepts. And do read about why do you need resources, why do you want to do validation, why do you need an expression language, what is aspect oriented programming. Read about all of those concepts because they are not related to Java. They are generic concepts which will be applicable to any programming language. So any enterprise application you build in any programming language, you would need to do the validation, you would need to do the resource reference management, you would need to have an expression language, you would need to have aspect oriented programming support. So this is just to tell you that Java does provide an AOP or aspect oriented programming support as well, and it has a lot of APIs available for that. Along with that, it also provides very good logging capabilities because you definitely need to log all the actions which the framework or your objects are taking. So this was a very quick lightning overview about Spring. I understand it's not possible to cover all the concept of a framework as sophisticated and as smart as Spring in a 10 to 15 minutes lecture. So treat this as an introduction session. And like I said, read more about all of these components. I just explained the core because this is sort of the main building block of Spring framework. And then you have other supporting components as well. So do check out the documentation. There are tons of examples available. In fact, in the Spring's official website itself, if you go to the Spring Guide section, if you go to the Learn and you go to the Guide section, there are awesome getting started and topical guides and tutorials available. So for example, how to build a RESTful web service, how to schedule tasks, how to consume a RESTful web service, how to build a simple Java project with Maven, how to upload files with Spring, how to do messaging with Redis, which is basically a caching framework, how to do messaging using Spring to RabbitMQ. RabbitMQ is a messaging framework. So there are tons of examples available here. Very good documentation and very robust documentation. Do check out the examples to learn more about this.
Let's get started with MVC and the implementation of MVC using Spring. So before we go any further, let's first understand what do we mean by an MVC application. So in the previous lectures, I discussed about the three-tier application where you had a presentation layer, you had a business layer, and then you had a database layer, which is talking to the database. And that's how we built a three-tier application, which can also evolve into an N-tier application. But when the web development started, the most popular concept which came out was MVC. M stands for model, V stands for view, and C stands for controller. So the idea was that these three components together can render a web application. And how they render the web application is basically that the controller is going to receive the request which is coming from the web browser. Then the controller will have the knowledge of where the business logic for that particular request will be residing. So the controller is going to invoke the model, the corresponding model which is required to execute the business logic of the request. And the controller will also have the knowledge of what response page to be sent back to the user. So we are talking about the response page here, not response. Remember that, because it's a web application. So the model view controller architecture basically was designed to keep in mind that you have a web application where a request is coming from, and you need to process some business logic, and then you need to return back with a page response, which is going to be displayed on the web browser of the client machine. So that's why we had these three components as model, view, and controller. Controller taking up the request, then finding the right model for it, which can execute the business logic, and then also finding the right view for it, which can render the business logic processed by the model. So that's a quick overview about model view controller or MVC architecture. Do read about it in detail to understand how this works. But like I mentioned, that MVC, the most popular MVC implementation is provided by Spring. Spring is the most popular MVC framework, and the way Spring implements it is something which I have drawn already here. So let's understand how this works. So first, the request comes from the web browser, and Spring has a very first welcome servlet, which is called dispatcher servlet. Any request which is coming to the Spring enabled web application will first hit dispatcher servlet. And once the request comes to the dispatcher servlet has all the knowledge of all the controllers, of all the view resolvers, which I will talk about in a while, and of all the views as well. It also has knowledge about handler mappings, which again I will just discuss now. So the basic premise is that dispatcher servlet is the component which has knowledge about literally everything happening in your application, and that's why dispatcher servlet is the first servlet or the first component which receives your web request. So once the request comes here, first of all it looks at the path and finds out the right handler for it, the right controller for it. And the way it does that by using the handler mapping component or handler mapping logic, which is provided out of the box by Spring Framework. So the handler mapping logic will tell the dispatcher servlet which particular controller is going to process the request which is coming, because every request will have a different controller return. So whatever the type of request is, whatever the path of the request is, based on that, the dispatcher servlet is going to find a particular controller. Once the controller is found, like I mentioned earlier, the controller will have knowledge about the right model to invoke for that particular request. Model is nothing but basically a Java class holding the business logic for this particular request. So it will invoke that Java class and get all the business logic processed, and then it is going to return a model and view object. View is here simply pointing to the UI response which you are going to send back to the user. It can be a JSP page, it can be an HTML page, it can be any other view technology. So anything which is used to render a web application on a web page is view, and controller is going to send both the model and view information back to the dispatcher servlet. The dispatcher servlet will take the view part of it and go to another component which is again provided by Spring, which is called view resolver. The view resolver will have the knowledge to see which particular actual JSP or template to invoke for the view value coming from the controller. So based on the value which is returned by the controller, a view resolver is going to return the right page mapping. And once the dispatcher servlet knows the page mapping, it is just going to invoke that page by calling the view component. So dispatcher servlet, handler mapping, controller, view resolver, and view, these 5 components together help render a web MVC application in the Spring framework. So that was about the theory of how Spring works. Now let's move on to an example to understand how this works in action. So here I have already built a Spring MVC application, and if you're wondering how to build that, there's an easy way to do that using Spring Initializer. And that's also the recommended way. Actually, if you go to the documentation of Spring, you will see that it recommends creating a new project from scratch using the Spring Initializer utility, which is provided by Spring out of the box. So just go to a web browser and type start.spring.io. You will get this page where you can specify what type of project you want to create. So it is going to create the basic skeleton for any Spring application automatically for you. It's probably, like I said, it's probably the fastest way to get started with Spring. So we will choose a Maven project. Maven is again a dependency management tool which is used to download any kind of jars for your application. So we are going to use a Maven project and we want to create a skeleton for a Java application. We are going to use the latest released version of Spring or Spring Boot, which is 2.4.2. It says Spring Boot here, but don't get confused with it. We are going to use just the MVC classes and not the Spring Boot specific logic yet. Then you provide your group artifact ID and the name for your jar. You provide a description. You can provide a welcome package name, whatever suits you. And then how you would like to run your application. Whether you would like to package your application as a jar file, which is a Java archive, or you would like to run it as a web archive, which is a var file. So you can choose either packaging mode, and it is going to add appropriate dependencies inside the project to support the packaging of jar or the packaging of var. Then you can also choose a Java version. So you can see there are 3 Java versions listed here, which are 8, 11 and 15. So whichever Java version you are working on, you can choose that particular version. And once you have set everything, just hit generate. Once you do that, it is going to create a project here, and then you can import this project just as a normal project inside the Eclipse IDE. And that's exactly what I've done for this initial project, which is showing a very basic hello world sort of example for how Spring MVC will work. So this whole structure will automatically be created for you. And like I said, it was a Maven project, and in every Maven project, you will have a pom.xml. If I double click on this, it is going to open this XML and it will list down all the dependencies which my project needs to have. Let's understand the dependencies as well. So This project is currently using the properties of 1.8, but that's fine. You can obviously definitely change this value. I just kept it as 1.8 for now because I'm not using any new functionality yet. In the dependencies section, you will see all the dependencies or all the jars which are required by the Spring application to run successfully. The first dependency we see here is about DieMyLeaf, and DieMyLeaf basically is a view technology similar to JSP or similar to servlets technically, where you can use this DieMyLeaf templates, which are basically just HTMLs with some dynamic values, and you can use these DieMyLeaf templates to render web pages for your Spring MVC application. If you want to use some other view technology, you need to include the dependency of that view technology here instead of DieMyLeaf. So that's about that. Then you need to include the Spring Boot Starter Web. The Spring Boot Starter Web is going to enable your application to become a web application. Then this is basically a good to have dependency which you can have in your project, which will help you deploy the project at runtime automatically without restarting the server, because the web application will be running on a server, on a web server basically, or an application server technically, because it needs to run somewhere so that so that clients can access it. That's how a web client architecture works, or the server client architecture works. So this dependency will allow you to deploy changes dynamically at runtime without restarting the server. Then this dependency is for tests, if you're writing any unit tests. And then you have a plugin which will allow to run this particular project with a single command, which we will see in a while. So that's about the dependency tour. Now let's look at what is in the SRC main Java. In the SRC main Java, I just have two classes. One is the main class, which will have a public static void main method, and this is the entry point of the Spring application. And then I have a controller class. I already talked about what controller is, but I will come back to that in a while. Let's understand the rest of the files as well. The next one is SRC main resources, where you will have your view technology data available. Like I mentioned, it is using DieMyLeaf templates currently, and basically, like I said, they are technically HTMLs with some dynamic data. So I've created a templates folder under SRC main resources, which will automatically be generated by Spring Initializer. And then under templates, I've placed an HTML file. It's a pure HTML file with the only difference is this value. So this is what the dynamic value means, which is supported by DieMyLeaf templates. Otherwise, this is pure HTML. It's just a paragraph with a header, and this is the dynamic value which I'm populating. It also has application.properties, which has nothing, but you can use this particular file to supply environment specific properties for the development environment or the testing environment or the real production environment. If you have any unit tests, those will go here under SRC test Java, and this is the system library already provided, supported by Eclipse itself. And I already talked about the pom.xml. You also see a couple of more files created by Spring Boot. If you want to use that, you can use that to run the program from the command line as a utility. Otherwise, you can just use mvn spring boot command, which I will show you in a while. There's also a Gradle folder which you can ignore. Probably we don't need this because we are just using Maven and we are not using Gradle. Gradle is another dependency management tool very similar to Maven. So you can ignore this folder right now. So that's the structure. And now let's come back to the controllers. Remember, I told you that controllers are the ones which receive the request. So from the dispatcher servlet, which I talked about here, after the dispatcher servlet, the request comes to the controller. So once you hit a particular URL, then you need to create a controller for that URL mapping. Remember that you need to create a controller for almost every URL mapping you are having in your application. There should be some mapping to some controller somewhere. So I've created a greeting controller, and the way you specify or you make a simple class as a controller is by putting the @controller annotation. This is the annotation which is supported by Spring, and you can put this annotation on top of any class, and that class will be treated as controller by Spring. And the moment you put this class will also be registered with the dispatcher servlet. And like I mentioned, the controller's main purpose is to receive the requests, the web requests which are coming from the client. And the way you can receive the requests to a controller by providing the exact URL mapping. So if somebody runs this web application and says /greeting, then this particular method should get invoked. And how you define that is with the get mapping annotation. Use the get mapping annotation to provide the URL path whenever somebody invokes this URL path, this method would be getting called. And when this method is getting called, at that same time, this URL can also accept some query parameters. We call that as request parameters in the Spring language. So you can use the request parameters as an annotation to provide a placeholder for the variable for which the value will be supplied in the URL. So /greeting, if you call this URL something like this, then it will work because you have a variable called name which is being parsed as a query string because you have used the request param annotation. So we'll see an example of that when once we run this application and how we can supply the query string. But you use the request param annotation to supply the query string parameters to the URL. You can mention if the parameter is mandatory or non-mandatory. If the required equal to true was there, then this parameter would be mandatory. You can also supply a default value if the client is not providing this query parameter at all. Would you like to set any default value? If yes, you can supply that default value here. And then you just give a placeholder name like I said. Then the second argument which your methods which are intercepting the request should have is the model argument. And remember I told you that the controller will have or should have the knowledge about the model, and from here that knowledge comes. This particular method will expect you to provide a model argument as well. So if somebody calls this application and provides the URLs with /greeting, this particular method will get invoked, and then the code inside this method will be getting executed. So it's a very simple code right now, but this is where your whole logic will go. Remember that. But here I'm just saying model.add attribute name with the value which is coming from the query string parameter. That's all I'm doing here. And remember I told you that the model will hold the business logic. So here this is the business logic where whatever query string parameter which is coming from the request param, I'm capturing that and I'm adding that value with the variable name in the attributes of the model. So my model is set, and after that I need to return the view so that this particular file name will be intercepted by the view resolver here. If you remember, we talked about the view resolver. So when we return greetings as a string, that string goes here, and then dispatcher servlet asks the view resolver to find a particular HTML matching with this particular text. So view resolver is going to look at under src main resources /templates to see if there is a file with the name greeting available or not. Since we have that file available, the Spring is going to render this particular file supplying the model attribute value name. Now remember, the greeting.html had the exact same variable name. So this variable name should exactly match with this variable name here. If you make a mistake here, this is not going to work because the model is holding the business logic, and I'm printing that business logic inside the view using the thy_myleaf template syntax, which is $curly braces. So whenever you have to print any variable or a model attribute or any runtime value inside a thy_myleaf template, then you need to use the $curly braces syntax to do that. So that was about a quick overview of how this application is written right now, and that's all the code is here. Now it's time to run this application. So one of the simplest way to run this application would be to provide a Spring run configuration here for the Spring application, or you can choose another way, which is to first have a look at the Spring Web Content application, which is the entry point. So once your application boots up, this is the first line of code which is going to get executed. And to make sure that this code works, make sure that you have the @Spring Boot application annotation on top of the entry point class. So this is sort of the mandate which Spring will force you to put in front of the or on top of the entry point class to treat this class as the first entry point when you run the project. So to run the project, what we will do, that we will just go to the command line and we will say mvn spring boot run. So let's do that, and let me open the terminal for that. So I have opened a git bash prompt here. You can also open the classic Windows terminal, but this is something which Git installs by default if you install Git on your system. It's pretty much exactly the same. It's just more Unix-like, but it's also just a simple terminal shell utility to access your file system. So I have gone to the project which we were working with in the Eclipse IDE, and this is the path of the project. So once you reach to the path, what you would like to run is just say mvn spring-boot:run. That's it, and you hit enter. Once you write mvn spring-boot:run, you will see a lot of code, lot of logs here where it is going to compile all the Java classes, run any tests if there are any, and then it is going to start the web content application, you can see. And once the application is started, you will get this message that everything is run. One of the interesting thing which you can see here is that it is also spinning up an application server automatically for you, and that application server here which is being used by Spring is Apache Tomcat. Technically, Apache Tomcat is a servlet container and it's not a full-fledged application server, but just to get the point across, you can use Apache Tomcat as an application server which is being used here out of the box by Spring. If you don't want to use Apache Tomcat and you want to use something else, you can do that as well. So now everything is ready and we can now execute the application to observe the output. So for that, let me open a fresh browser window so that we don't get any cached response. And now I can just type localhost 8080. And if I hit enter, I get a white label error page because there is no home page for Tomcat defined, but there is a home page for my application defined. In fact, let's try to access the URL which we wrote in the greeting controller. The URL was /greeting. So let's copy this and let's put this here. So localhost 8080/greeting. And if I hit enter, I get the message hello world. Let me just zoom this in a bit so that you can see. So you will see this hello world message here by putting this URL. Why do we see hello world? Let's go back to the controller. So when you call this URL, this greeting controller got invoked. Since we did not provide any query string parameter, the default value, which was world, was picked up, and this world value was stored in the name variable, and the name variable was added as an attribute to the model. And then we were using the greeting.html and we were printing the name variable. Since the name variable was holding the value world, so the message came as hello world with an exclamation, and that's the output which we see here. Now let's try to supply the query string parameter. The way you do that is provide a question mark, provide the key of the query string parameter and the value you want to put here. So let's put simply code as a value and hit enter. So now the message got changed and now it says hello simply code. So what happened here is that whatever query string parameter we supplied, that got passed here as part of the request param, and the value of simply code got stored in this name key and in turn in this name variable, and then I added the same value into another name attribute and added that attribute to the model. So now this name here is storing the value simply code, and then all the things work exactly as the same as I just described. It goes to greeting.html and it prints whatever is stored in the name attribute coming from the model. Let's get started with Spring Boot and how we can build a simple application using Spring Boot. Before we go further, let's understand why we need Spring Boot. And the basic idea of Spring Boot is to build RESTful web services. If you want to know more about what are RESTful services, please, you can read about the RESTful concept as a concept. What does REST stand for? But the basic idea is that if you are accessing anything over HTTP, then that particular component can be built as a RESTful component. And Spring Boot is the most popular choice for building RESTful web services today. And even in fact microservices, which you might have heard about. So you can build microservices which also run on HTTPs using Spring Boot. So what I'm showing you right now is the official guide of Spring, which you can use to build an application with Spring Boot. It will list down all the requisites which you need in terms of the JDK installations, Maven, and how to complete this guide, etc., etc. You can again use the same Spring initializer which I talked about in the previous session. You can use this to generate a Spring Boot project for you specifically. So all those options are available here. So I've already done that and I'm not going to repeat what I just did in the previous session, and will directly jump to an IDE where I have created a sample Spring Boot application. And the structure here, you can see the structure would look very similar with one change, that in the previous example, when we were dealing with MVC, we had an src main resources folder, and that src main resources folder was having all the web components or the HTMLs. But since in RESTful web services, you do not render the HTML, but you just send back the response. The response body can be pure XML or it can be pure JSON, but you do not send back an view, and that's the main difference between Spring MVC and Spring Boot. That in Spring MVC, you are required to return a view technology. Like in the previous session, we sent a thy_myLift template, which is basically an HTML. You can also return a JSP, but with Spring Boot, you do not deal with the view technology. And that's the world we are living in today. When you write Spring Boot, you do not have to worry about how this is going to be rendered on the web page, whether it is going to be rendered using HTML or whatnot. What you need to take care of using Spring Boot is to return the right response body, the exact text of the response, and that's it. So with that in mind, the Spring Boot was born, and the structure, apart from that, the structure would look very similar. There's a pom.xml here, which will provide all the list of jars and dependencies which are required for this particular project. So you can see all the dependencies here, pretty much the similar ones. We have a starter web, we have a starter test, and we have a Spring Boot Maven plugin. And we have an application file, which is the entry point, again having a public static void main method. So you need to put the @Spring Boot application at the top of the class to make it an entry point. If you don't do this, Spring Boot will not run this class, and Spring Boot will even not run your application. So what we are doing as part of this example, that we are just printing all the beans which are provided by Spring. That's all we are doing. Like I said, it's a very lightweight and an introductory session, so we will keep the logics to minimum. And I'm just getting all the bean definitions, sorting the bean definitions, and just printing them one by one. How do you get the bean definition? You get that with this application context class, which is returned when you run the application. And how you run the application is basically using this line where you say Spring application dot run, and you supply application dot class with any command line arguments which you might want to use. Once you do this, it is going to return an application context object to you, and the application context object can be used to get all the bean definitions by calling this method which says get bean definition names. So that's the basic logic which is being run in the main class. Now we also have a controller, but this time it's not a web controller, but it's a REST controller. So you see in the previous example, we just had written something like this. It was just a pure controller. But here we have become more specific. We are saying that, hey, this is not a simple MVC controller, but this is a Spring Boot controller, or technically a REST controller. So Spring provides a separate annotation for that, which is @REST controller. So you write that particular annotation or on the top of the controller class which you are creating, and then you provide a request mapping similar to what we did in Spring MVC. But while you return it, you do not return a view technology. You just return the raw response. Here I'm just returning a string, but you can return a JSON object, you can return an XML object or whatever you want to, but not a view technology. That's what I'm doing. Like you can see, there's literally nothing I'm doing in this. It's just a simple string return statement which I've printed here. And that's all the code I have right now here. I just have these two classes. Okay, so that was all about what I have written in the project, and now it's time to run the project. So I have just reached to the location inside my terminal where the project's pom.xml was present, and if I just do an ls, you will see that there is a pom.xml available here, and all the code directories are also available here. So now I will just run this application, and to run this application I'm just going to type mvn spring-boot:run and hit enter. Once I do that, the Spring Boot application is going to get started. And let's go back to the controller and actually the main endpoint and see what we were doing there. I did a sysout here which said let's inspect the beans provided by Spring Boot, and then I was printing all the bean names. And if I go back to the output, I will see the same line being written here, which was around let's inspect the beans. So you can see that message which says let's inspect the beans provided by Spring Boot, and then all the beans which are available in the application context are printed here. So that's the basic idea which I want to give you, that you can actually build a Spring Boot application and you can write your REST controllers, return a string body from it, and once this is run, then you can also run your application from the web browser as well. So let's try to hit that particular URL which I wrote here. So the URL of hello country. So for that, let me just open a new Cognito window, and our application is already running. So if I just say http localhost 8080/ I get this message here which says greetings from Spring Boot, and this is the message which we were sending from the REST controller. So this validates our understanding that we can invoke a REST controller, which is a Spring Boot REST controller, via the same method, but this time we are not getting an HTML, but we are just returning this particular string. Now you can use this string in any ways you want, so it depends upon the consumer. So that's all I want to cover as part of the Spring Boot. Now Spring Boot is a huge topic, and we can spend hours and hours talking about Spring Boot, but since this is more of an introductory session, so I just wanted the concept to get introduced, and remember the value proposition of why you would need Spring Boot. The basic idea is to build RESTful web services or build RESTful microservices. That's the basic idea behind using Spring Boot in your applications. And also remember the difference between Spring MVC application and Spring Boot application. Spring MVC is for building web application. Spring Boot is for building RESTful applications which might not have a web interface integrated with them at that moment. So that's all I want to cover for this particular session. And in the next session, we are going to have a look at an advanced Java project using some of the concepts which we might have learned during this whole journey. And that would be the last session of this particular tutorial series.
Let's get started with a demo of a project which is using Spring Boot to build a RESTful web service. So a RESTful web service is nothing but any endpoint which you can access or you can consume the data from via an HTTP layer or via a simply web layer, because most of the web traffic which we deal with is built on HTTP. So to take an example, if you go to any website where you sometimes see on the top right corner, you see today's weather. So how is that today's weather coming in? It's coming in via a REST web service. The website which you are accessing is basically hitting an HTTP endpoint, which is where the weather application is sitting, and it asks for the weather data, and that REST web application just returns the data, and that's how the website is able to show you the current weather. So RESTful web services are everywhere, and they are the most popular way to build applications today, where you just build your RESTful web service and you expose an HTTP URL. And then the consumers need to just access that HTTP URL to consume the data from your application. And you see, this makes it very easy because there is no data type restrictions. There is no tight coupling here. It's just an HTTP endpoint. So that's the basic idea. And we will look at a project where we will be using Spring Boot to build a RESTful web service. And then we will try to run that web service to save some data and also to return some data. So here on the package explorer, you see I have created a project called REST service. And let's just walk through the structure of it, and then we'll go into the details of it. So we have an src main Java where I have a package, and I have a bunch of classes here. And before we go to the classes, let's first also access the dependency file, because every project needs some dependencies, some jars to execute it. For example, Spring itself is basically a jar. So you need to include the Spring jar in your project so that your project can become a Spring project. And there are generally two dependency tools. One is Maven and one is Gradle. In this particular project, I am using Maven dependency tool for downloading and managing the dependencies which are needed to run this project successfully. And the way you will find if it's a Maven project or if it's a Gradle project, for a Maven project, you will see a file called pom.xml. And if it's a Gradle project, you will see a .gradle file. That's how you can spot whether the project is using Maven for dependency management or it is using Gradle for dependency management. So let's open the pom.xml. Since it's an XML file, it will be a bit verbose, but if you just read it piece by piece, it will become easier to understand. First of all, since this is a Spring project, I need to include the parent dependency, which brings a lot of good defaults, sensible defaults from Spring Boot automatically. And this is the jar name. This is the artifact ID, which is Spring Boot starter parent. So any Spring Boot project you are starting, do include this parent. This parent is basically bringing all the dependencies from some other jar, and you can make your project as a child of this particular parent. So all the Spring Boot projects have this as a parent as a standard practice. After that, you provide your own details in terms of what is the package name, how do you want to see the jar name, and what is the jar actual name, what is the jar version, etc., etc. You also set the minimum required Java version to run this application. And then you, in the dependency sections, you provide all the jars which you need to run your project successfully, both compile and run your project successfully. So we added the Spring Boot starter web dependency, which basically brings all the dependencies around making a controller or making a repository, context component scan, all the interesting features which Spring provides get wrapped up inside the Spring Boot starter jar. And you can actually go to the MVN repository and have a look at what all classes it provides. It's a lot of classes. So I'm just telling you in a brief that it provides all the RESTful functionality. Then you have the next dependency as Spring Boot starter data JPA, which is going to enable this project to also have a database. And if it has a database, then you need Java to talk to the database. And the way Spring suggests to talk to the database is via using the Spring Boot Data JPA library. We will see this how this library can be used, but basically this provides ways to represent your Java object in the database. And then you need to also add the actual dependency of the database. And in this case, we are using an in-memory H2 database. So I'm not using an external database like MySQL or Oracle or PostgreSQL, because that will just make more configurations more complicated. I just wanted to keep it simple. And generally, you in this H2 database, you can easily access by adding this dependency, and it will be an in-memory database created for you. Then I've also added Spring Boot starter test here, which will be used whenever you are writing unit tests, and you must write unit test for your project. And then we need to add the plugin so that Spring Boot can run this project. That's all I have in the pom.xml. Now let's move to the interesting part, the Java section part. Let's start from the main class. So this is how the main class looks like, where you just create any name with the class, and then you add a public static void main method. Inside the public static void main method, you call Spring application dot run. And this run method is basically going to run your application, and you just provide the same class name which you just wrote here. So you just say dot class. And if you're supplying any command line arguments, it can interpret that command line arguments as well if you want. So you'd always need an entry point in an application, and this is the entry point which Spring Boot supports. And this is, if you see this code, this is just normal code. To make Spring be aware about this class being treated as an entry point, you need to add @Spring Boot application annotation on top of the class. This is one of the annotation which is coming directly from the Spring Boot library. You can see this import. So once you add this, then only Spring will be able to treat this class as an entry point. Otherwise, Spring doesn't know where to start from. So when you run Spring, it will try to find a class with an annotation Spring Boot application, and then inside the class, it will try to find a public static void main method. And once it has found both of them, then it will just run the application. So it's very simple, nothing fancy here. And what we are dealing with here is a student object. So we will try to insert a student object, and we will try to retrieve the student object. So if you ignore these annotations which I've added, it's just a pure POJO. It's just a plain old Java object. You create a student class. Let's ignore this field as well for now. I'll just come back to this annotation in this field. But this is just a student class. It has 3 fields as name, age, and address, an empty constructor and a parameterized constructor, and some getters. Intentionally, I have removed the setters because generally, whenever you are building any enterprise grade application, you would like to keep your objects immutable. Means once they have been created, you would not like somebody to allow to change the values of the object. This just makes programming much more easy if you treat all the objects in your application as immutable. That's why I have not added setters here. It's just considered a good practice. So apart from the standard things which we have already seen, there are 2 things here which I want to talk about. Let's first talk about this one. So @entity is the annotation which is coming from JavaX persistence entity. And this makes Spring Boot save this particular object into the database. This is the annotation which you need to put on your class so that Spring Boot knows that this class represents a table in the database. So you need to add this to make sure that this represents a table. Second thing, a table will have a ID. It will have sort of a primary key. So I've created a new column called ID, which is basically representing the student's roll number or something, or maybe a registration number. And here I'm using a couple of more annotations. If you see, these annotations are also coming from Java X persistence library. And these annotations will basically allow a new ID to be created every time you create a student object. So you don't have to specify the value of this ID variable. Spring Boot will automatically generate a new ID value every time you create a new student object. And how does it generate? You can provide the generation type as well. So currently I've just set it as automatic, but you can set it as identity, sequence, or controlled by table. You can also see the explanation of each of these here. But I've just kept it as auto, which basically let the persistence provider pick any appropriate strategy for the particular database. In our case, the database is H2. So that's about the entity class. Let's call this as entity class. Now let's move to the repository. So you need a repository class. Like I explained in that 3-tier architecture, you always need a DAO layer or a repository layer to store your student object into the database. So we have enabled the student object to be saved, but we need a handler which can save this particular file, this particular object into the database. And the repository classes are the classes which will allow you to do that. So you create a very simple interface. You name whatever you want to name your interface as, and then you say extends JPA repository, the type of the object, and the unique identifier of the object. So the type of the object is student here, and the unique identifier of the student object is the ID, which is of type long. So you need to just supply the types: type of the object, type of the primary key, or the type of the unique identifier. And this annotation is coming from Spring Boot. You can see specifically Spring Boot data library, which we added. So you just need to create an interface, extend it from JPA repository, and make sure that you add this annotation as well. Spring heavily uses the concept of annotations, and this will help Spring understand that this is a repository layer class, and it will apply some more metadata to this class while this class is running in the JVM. So what happens here? You just created an interface. You did not provide any method to create or any method to delete or any method to get a student object, because all of that is automatically provided by Spring Boot via the JPA repository class. If we go inside this class, and if you scroll down, you'll see the find all method, find all by ID, save all, flush, save and flush, delete, etc. And if you go further up, this also extends the paging and sorting repository, which provides pagination and sorting facilities. But the interesting one is that paging and sorting repository again extends a CRUD repository. And if you go to the CRUD repository, you will find all the basic methods to save an entity, save multiple entities, find an entity by the ID. That's why it needed that long type to make sure that it can execute this method. You can check the existence of an object, find all the entries, find all by ID, count them, delete them. So all the basic CRUD functionality. So we call them as CRUD because the reason it is called CRUD, because create, read, update, delete. That's basically the generic acronym. So because this CRUD repository provides all the methods and their implementations automatically, we do not need to write any code at all. So that's why Spring Boot is so awesome, and that's why Spring Boot is very popular, because it's zero code in the repository and you still get all the CRUD functionality. So that's about repository. Now we have covered the entity class, we have covered the repository class, we have covered the entry point class. Now the only thing which is remaining is the endpoint, the HTTP endpoint, which I talked about. And that you can create by creating any class. Generally try to suffix it with the controller so that your core developers can easily find this class. And make sure that you put @REST controller annotation on top of it. This annotation will allow Spring to treat this particular class as an endpoint class. Then you can auto-wire the student repository. So if you remember, I talked about the whole dependency injection and inversion of control. So here dependency injection is in action. So here you're just telling student controller to auto-wire the student repository. And now what will happen that at runtime, student controller, or actually Spring, will automatically create an object of the student repository and supply that object of student repository to student controller. So you as developer do not have to create an object of student repository explicitly. That's the benefit, and that's how the dependency injection is working, because you inverted the dependencies now. The dependency is just injected into the class, and as a developer, you don't have to take control of creating the objects. It's the Spring which will automatically read the auto word annotation and will automatically supply an object whenever it is required. Then I have two methods here. Since we are talking about HTTP endpoints, so I have represented a post method here and a get method here. The way you will write a post method is via @post mapping annotation, and then you can provide the URL path on which somebody should call your endpoint to save something. So for example, somebody can call it HTTP localhost 8080/student/create. Whenever they hit that URL, the control or that request will directly hit this particular method. Why? Because you have provided the URL mapping here in the post mapping annotation. So since it's a post method, there would be request body. What is the actual request body which the client is sending? And you can represent that request body with the @request body annotation, and you can provide the type of the request body. And here I'm saying that, hey, if you want to access this particular URL, yes, all good, but you need to supply me with a text representation of the student object or a JSON representation of the student object. And then inside the method, I'm calling student repository dot save, which is going to save the student object which is coming in. So you see there's a lot going on here. I will show you how the student is represented in the request body as well, and then I will come back to how it got converted from JSON to Java. But this is how you can store this particular student object. You can hit this API as many times as you want and keep inserting a new student object every time. Then if you want to fetch a particular student, then you can do that by supplying the /student. And then in the curly braces, there's an ID written here. So basically you can supply the value of the ID of the student. So generally there would be another method here, which would be find all, to see all the students and with their ID, and then you can pick a particular student's ID, supply that student ID value here dynamically. That's why at the curly braces supports dynamic value. So here it can insert 1, 2, 3, or whatever the student ID you want to fetch the value for. You provide that value in the student/ID, and all good. Then if somebody is hitting the URL with saying localhost 8080/student/1, then student with the ID 1 will be returned from the request. And you need to put @get mapping to make sure that this method is treated as an HTTP get method. And you can provide the type, you can say get student, and here this dynamic value is captured with the @path variable, because you need to know the ID, right? Whatever ID somebody has supplied it in the URL, you need to capture that IDE and then use that IDE for calling the repository. So you can do that by using the @path variable. So here I'm just saying whatever ID is coming in, I will store that value inside this IDE. Once I've done that, then I can again call student repository dot find by ID, which is again a built-in method provided to me by the CRUD repository. I can supply the ID, and this actually is going to return an optional object, which is an object which may or may not contain a value. So it's just a defensive programming style. So this will return an optional, and you can call a get method to return the actual student object. This will return an optional of student. So optional of student means that this optional object may have a student or may not have a student. Why did Spring do that? Because the ID somebody is supplying, that ID can be invalid also, right? So optional object takes care of that if there is no student found, then you will not get a null pointer exception. And if there's a student found, you can return that. So it's just a defensive programming style which Spring has adopted by returning an optional of the student object rather than directly the student object. But if you're confident that this particular optional of student object does contain a student object, then just call optional.get, which I've called here, which will return the actual student object sitting inside the optional object. You can read more about the optional object and its usage from the official Java docs, and there are tons of examples available on it on internet. So this is about the controller. We have covered all the classes. Now it's time to run the application. So you go to the command prompt, you go to the particular file folder location, and there you just say mvn spring-boot:run. So I just hit enter, and this is going to run the application. It's going to spit some logs here, and if everything is fine, you will not get an error, and you will just be getting a message saying that application got started. And it's running on Tomcat localhost 8080. with no context URL. So this is not a web application. This is a RESTful web service, right? This is a RESTful service. This is not a web application. So there is no web interface. So how do you access this? You just have an HTTP URL. So you can use any of the REST client available on the internet. There are probably hundreds of different REST clients available on the internet. You can choose any one of them. I am using advanced REST client, which you can also install as an extension from the Chrome browser itself. So if I just open the Chrome browser and I just say REST client, if you just write this and hit enter, you will get many different options. And the first option you get is from Google Play Store's App Store. So you can go to the App Store, basically the Chrome Web Store, not the Play Store, but the Chrome Web Store, and you can just install this. Since this is already installed, you can click on Launch App, and it will open this interface for you. So this is this is not a tutorial for advanced REST client, so I'll just be quick here. You can choose the method type which you want to hit. So let's say I want to do a post, and then you can provide the URL here. So remember the URL which we put here in the controller method, this has to exactly match. So HTTP localhost/student/create should be the URL. So let me just copy paste this one here. Okay, so the URL is good here. It's a post type of method which I want to do, and I want to hit this particular URL. Now I need to supply the content type and the body. So in the content type, you can choose application JSON because I'm going to supply a JSON object. And in the body, this is how the JSON object looks like. Advanced REST client also provides a nice visual interface to basically create this JSON. If you are thinking that JSON creation is very tough, it's not actually tough. It's just curly braces. And then you put key and value, comma, let me just put an enter here so that it's more readable. So you just put curly braces starting and end, and then you just put key value. You put a key, which is the variable name and the variable's value, variable name, variable value. And these keys have to exactly match the student's properties. So the student.java had this name, age, and address, right? So it has to exactly match. Otherwise, this request will fail. So this is all good. Now I can send this particular request. When you click send, it is going to hit my Spring Boot application, which is running on localhost 8080. It is going to call the student/create method. It is also going to convert this JSON into a Java object because here I'm supplying a Java object. So it will convert the JSON, which I'm sending from here, to Java object automatically, and it is going to automatically save it here because I've called the repository.save method. So let's hit send here. Once I hit send, I get a 200 OK. It means everything went fine. And in the response header, I get the object back because I have returned the object here. You see, this save method is going to return the same student object which you created. So everything is good here. My object has been stored here. And now it's time to fetch the object. So it has already been saved into the H2 in-memory database, and you can obviously go and connect to the in-memory H2 database and have a look at it. But for simplicity, I'm just going to do this here. And let's say the first object is generally added as the ID1 by default by the H2 database. So let's hit this particular URL. When I hit this URL, it is going to hit the student controller here. And in the student controller, it is going to hit the getStudent method, which is having a student/ID URL, and it is going to find the database with that ID. And if it finds a student object with that ID, it is going to return that. So let's confirm that now. So let's hit this particular send button, and it is going to hit a get request with this particular URL. Spring Boot is going to find if a student with the ID 1 exists in its database. So once I hit send, I get a 200 OK. And you see in the response headers, I get the same student object back, which I added. Let's try with 2 now. Let's see what happens. I see 2 and I get 500 internal server error because there is no object stored in the H2 database of the Spring application with the ID 2 yet, because we only inserted one object. That's why only one student object is there, and the first ID which H2 database created for it automatically was 1. So when you hit for get request with a student ID 1, you get the object. When you put any invalid value and you hit this, you get a 500 internal server error. You can also make it look nice by not sending the 500 internal server error and sending a nice exception from the backend. So from here, you can also send a nice exception that if this object is not found, you can say something like that or else throw, which is again an optional object. And here you can supply a particular type of exception which you want to supply instead of just throwing 500 internal server error. But that's just additional thing, additional defensive programming you can do. You can add more and more validations and constraints into this project as you build this project in a more complex paradigm. So this is basically what I wanted to show you, that that we have created a Spring Boot application. We have connected it to a database. We have created also an HTTP endpoint with student controller. We ran that application. We used any random REST client. In my case, I used advanced REST client. And we first did a post request. We provided the exact URL. The URL has to exactly match with the controller URL. And then the body, the request body also has to exactly match with the student objects property, especially the case of the names have to exactly match. So if all this matches, then you will get a response back that the object has been created. If you want to fetch the value of the object, you're going to use the HTTP GET method, and you again provide a URL which has to exactly match to some method in some controller in the Spring Boot application, which is running on localhost. And if you provide the right ID, you are going to get a valid result. If you provide an invalid ID, you're going to get a 500 internal server error. And from here on, you can make this controller as robust and as mature as you want. You can add find all method. You can add a update student method. You can add a delete student method. You can have all different kinds of filters. Like, for example, return to me all the students starting with the name A, or return all the first students with the roll number 1 and 100, or between 1 and 100. So you can write as many endpoints as you want and build this application in with as much maturity and as much complexity as you want. And that's all I want to cover in this particular lecture. Thank you, and we'll meet again in another session.
Python. Okay, so we'll start with the basics and we will start what is Python. Okay, so we will get a gist of it. What is Python? Why Python is gaining so much importance? What are the tools we can use with Python? How we can build applications, right? Okay, so these are the things which we are trying to learn. So let's begin with Python. What is Python? Okay, so Python is an interpreted, object-oriented, high-level programming, right? So in this particular statement, there are three things. First is interpreted. What do you mean by interpreted? Second, object-oriented, and third is high-level programming. So I'll start with the high-level programming. So anyone can guess what is a high-level programming language? So there are two types of programming language. One is the high-level programming languages. Another is your low-level. Okay, understand this thing in a simple basic concept. Okay, so let us say we are trying to communicate. How we are trying to communicate? By some language. What is that language? English is the medium of that language. You can also understand English language. I can also understand, right? So that way you are trying to listen to that language, okay, and you are trying to interpret what I'm trying to give you, right? What I'm trying to teach you, right? Similarly, let's say we are trying to write something, right, and instructions to your computer so that he can understand, right? Okay, so there are two methods in which we can write the instructions to the computer. First is via low level language. Another is via high level programming, right? So low level means you are trying to write the instructions in that manner, in that format in which the program can understand. So that is very difficult to write and interpret also. So that is the difference between a high level programming language and low level programming. Low level programming language is very difficult to write, understand, right? And it only works with your hardware, right? So there is short commands to write that language. But the high level programming language is the easily human readable. You can read it, you can understand it, and in your language, in your term, with some basic syntax, you can just make the system or your computer understand. So that is the difference between a high level language and a programming language. So let me give you an example. The hardware, right? So in a computer, if you see, there are two things, hardware and software. In the hardware part, we have RAM, we have CPU, we have registers, right? So many things. So that programming, if you try to understand, so that is your low level programming. And if you try to write in an English simple language, that could be automatically converted. That is your high level. So I'll repeat the low level again.
So low level is basically when you are trying to deal with the registers, your hardware, right? So you have flip-flops, right? So these are the programming language which are taken at the core. At the core means at the hardware level, you are trying to write some language. Okay, so you have your CPU, you have the GPU, you wanted to move the data from one register to another registers, right? So actually, the if you try to talk about the hardware, so it is a I'm not trying to explain you deeply, but it is on the broader level that considered in this manner, you have a hardware. In the hardware, there are many registers, and you try to take the data into the registers from one storage location to another. So there you try to write the command. Okay. So that command you try to write, and you are trying to work with that registers, with that hardware. So that is very difficult to write also and understand also, right? So that is your low level language basically. And high level language you can simply write in your words, in your English language words, right? As we speak, right? So that is the difference between a high level and low level. I think you got it, Mr. So now there are another term, object oriented. So what is your object oriented? We have been hearing all the languages as object oriented, right? So as some of the guys told me that the security part, right? So it is easily interpretable, more secure, right? Okay. So object oriented means you are trying to have it as a real life situations or real life use cases, right? So there are four pillars of object-oriented languages, which is your encapsulation, inheritance, polymorphism, that we will try to deal with in the coming session, right? So we will try to get in depth of that. So what is your object-oriented? So basically, object-oriented deals with you are trying to work with the real life situations in which you need to have a data security, you need to have your data abstraction, right? Right? Polymorphism. One function, right? It could be governed as multiple faces or multiple functionality, right? So that is why it is object oriented, okay? Right? So interpreted. So what do you mean by interpreted? So interpreted means, let's say we have a code written, and we wanted to write this code, and the machine can interpret that code. Okay. For that, we have the interpreter, which will try to convert your code into level language. Machine level in the terms of your bits and bytes. Machine don't understand your normal language as like English language. It will only try to understand zero and ones. Whatever you write, it has to be converted into a binary form. Binary means 0 and 1. Once it gets converted into binary, it will, your machine, your computer will try to understand it and try to work according to what you have written. That is your program, and that is your interpreted. Interpreted means conversion of your programming language from the human readable format to machine readable format. This is what your interpreter is. Right? Understood? Got it? What is interpreted, object oriented, and high level programming language? Yes, no? So we will talk about these terms in future also. In future, in the sense, when we try to work with the code in the future slides also, I will try to explain you this thing in detail also. Like it is an over high level programming language, and low we will try to explain the difference between what is low level and what is high level. Okay, so let me begin with the next slide, and then we can get it going, and then I will explain it again. What is the high level and what is the low level? So now what is Python is an interpreted language. Interpreted means we are trying to write some code in a human readable format. Then that code is being converted into your byte code, which is your zeros and ones that computer can understand. And then it will try to give you some results or uh, what are you trying to take it, or what program have you written, right? Object oriented, we are trying to write our Python programming in such a manner that it follows best practices. Best practices means it should be secure. It should not leak some data, right? It should be written in such a manner that it could be reusable, right? So these are some of the things in which we can write our program in an object-oriented manner. High-level programming language means that we are trying to write some high level in which we are close to human readable format. Okay, that we can write and just pass it to the computer. Low level means it could be easily understandable by the machines only, right? So that is the difference between low level and high level. Human readable, right? So the low level is not a human readable. So we are some short commands or some programming, so which can only the hardware can understand. Second thing is that it was developed by Gaudio van Rosen in the late 90s, right? And Python is one of the most popular and fastest growing programming language. So as you can see that now is the era of 21st century, right? Okay, right? And this Python programming has evolved, right? And everything, if you talk about your web application, your data science, right? All these has a greatest importance, right? So now the engineers like try to go for the Python program, and it is very easy to learn and understand, right? Okay. So now we talk about what are the benefits of Python. So it is open source. Open source. It is freely available to anyone. Freely available means you don't need to have a paid software. Okay, so you don't need to pay any money for it. So you can just install it, download it, and use it. Right? First thing. High level language. It is under the code is able to we are able to understand the code because it is simpler, shorter syntax. Right? Okay. So it is human readable basically. Then we have a lot of scope of Python libraries and modules. So what are these Python modules and libraries? Right? So I will try to give you a practical example. Okay. So let's say you are trying to build a house. Okay. So when you try to build a house, so there are list of certain guides which you need for a house to build. So what guides are those? Your carpenter, right? Your plumber, right? So maybe your architect, right? So you cannot alone build up your house. Okay. So you need some external people so that they can come to your house and try to work with you and try to do some amendments into your house or do some modifications so that you can make your house a better place. Right? So similarly, they are called as in Python language libraries or packages. So you need some external packages or support of those guys which can make your code work according to your requirements. Let's say you are working for your data science application and you need some kind of a package or your module which can work on the data, right? Yes, let's say CSV data or your Excel data, or you need to read some files, right? So that package you can call by using your Python library, and that package would easily read your data, parse your data, and try to uh, come up with your requirements, right? What you want, basically. So that is basically your Python library. So we will see in our coming lectures that how we can use our Python libraries and we can make use of that. Okay. So these Python libraries and their modules are written by some people, right? Let's say I tell you that this is your code for extraction of your CSV data, right? You can use that code. So you can call it as a Python module or a package, and you can use it in your program for your, right? Okay. Then it also supports powerful data structures. Okay. So what is a data structure basically? So you have a lot of data, right? In whole of the industry, you are working with data. And the most important thing is that how you can leverage your data effectively. Okay. Right. So in which format, in which data type you need to convert or you need to make your data so that it could be easily interpreted. Right. I give you a practical example. Let's say you go to a grocery store, right? In there, you try to purchase some items. Then at the cash counter, they ask your phone number, your, let's say, name, let's say your age, right, and your home location address. So this is your data. So this is your data, and the data is your name field, your age field, your address field, and the purchase items, and how many how much amount, and how many items have you purchased. So these 5 to 6 items are basically your data points. Now, your task is to how do you structure these data points for effective interpretation and also your storage, right? So there are various uh, like data structures provided itself in Python in which you can store that data, right? I give you an example. That could be a list, could be a dictionary, could be a tuple, right? Right? Or a class format, right? So this we will try to understand and learn in the sessions, in the coming sessions, right? So how you can use your data and make use of the Python data structure. Understood? Right? So now the benefits are your open source means free of cost. Nothing you need to pay. Right? If even if you ask you that Python is a paid, no. Python is free of cost. You need not to have to pay anything. High level language, it is human readable, it is understandable, it is simpler, right? Python library, external tools or libraries in support in which we can use with Python. So that is the very much advantage of a Python, that we can use it with the data science, machine learning, your AI, right? So this is how it works. And fourth thing, it has powerful data structure. Okay, so benefits, object-oriented programming, as I already told you. So it helps to structure in which the Python programming has been structured dynamically typed. Okay, so what do you mean by dynamically typed? So when you are trying to declare a data type, right? So when you're trying to say that, okay, this data type is a string data type. String means character. This data type is an integer or float, right? Automatically Python will recognize whether it is a string, whether it is a float, whether it is an integer. This we will see practically, guys. Right? I'm trying to build up an story in that when we try to do the things practically, you will try to understand it better. But first, you need to uh, like know the story. That what story we are trying to learn. Okay. Then interpreted language, right? Interpreted means like we are trying to write the code, right? That has been compiled, right? And it gives us the output, right? The compiled code, and it is being read by the machines to give us the output. Okay. So that interpretation, right? That interpreter is your line by line, right? Okay. So this is what the interpreted language, right? So interpreter is basically it reads one line and try to convert it and then give you the answer. But in the compiled form, as your C or C++, it will try to read whole the code, all of the code in one go, and then it will try to give you the machine readable format. Okay, so this is between your interpreter and your compiled code. So this also we will try to see when we try to do the practice. Flexibility, it enables you the users to create any type of an application. So, okay, so is my pace slow, fast? I'll just initiate a poll. Okay, just let me know. So now the application domains of Python. So as I was already discussing with you guys, so we can use it with the data science and statistics. We can use it with machine learning, deep learning, and artificial intelligence, right? So first I will try to cover the broader areas, then I will try to give you a practical example. So where it has been used, right? Then application development, your web scraping, your natural language processing, and your data analysis and visualization, right? So let's try to understand your data science and statistics. Okay. So let me give you an example of the same grocery store owner. So let's say you have your items purchased in a grocery, right? So in that grocery store owner, I am the grocery store owner, and I hire a data scientist, and I will say that to the data scientist, okay, now every day like around 10,000 users come to my grocery store, online grocery store, maybe or offline grocery store. Now I want a broader picture of my customers, that what are the purchasing habits of my customers, what they like the most, what they don't like, right? How many items are there in my inventory in my store that has been used that hasn't been used for a longer time. Okay, can we do something about that? Okay, then can we just make up some kind of a solution, kind of a promotion in which we can increase our sales? The whole purpose of any of the business owner is to increase their sales, increase their productivity. So I hire a data scientist. I will try to give that data to that data scientist, and on the basis of that, he will try to do some data science and analysis. What he will do, he will try to calculate the statistics. Statistics by you mean that it will try to come up with that how many customers are there, which will try to that they purchase, what are the maximum trend of purchasing habits are in winters, in summers, in per month, per week, right? So these kind of statistics they will try to give it to the store owner, and from there he can make some informed decision. Got it? So this was the practical application of your data science and statistics using Python. Another is your application development. Application development, there are some tools or frameworks which we can use with Python. Right? So let's say in the grocery store owner, okay, so they need to make an inventory management system, right? So you can see you go to the store, okay, so they scan the barcode, okay. So that barcode scanner is being linked with your system. So that is your application. So that application is being made by using Python, right? It could be made by other languages, right? So I'm not trying to tell you that only Python makes this application, but other languages also. It is a you can make it by an application also. You can make the application development, right? So that application in which it will try to calculate how many items have been purchased, what is the inventory count, how many like daily purchase of that particular store is there, right? Right. So these are the applications. Then web scraping. Web scraping means you need to scrape your websites for the data, right? Let's say Flipkart, Amazon, okay, right? Your online stores, you need to scrape that data. Your Twitter, right? Web scraping, you can do it, and then you can scrape lot of data, and you can use it uh, for your analysis, for marketing, right? So these are the web scraping. Business applications, right? So business applications mean like you need to build a product, right, which will solve some kind of a business use case. So that use case could be anything. Yeah, as I told you, inventory management system, right? It could be your food management system, or maybe a complete end-to-end web application or a desktop application, right? So that will solve some business application. Then natural language processing. So natural language processing. So now, like your chat GPTs and your Grok, so these have gained popularity. On the top of that, you can also build a tool in which you can use or leverage those tools to with Python, right? And then you can build your own product also, right? Data visualization and analysis. Okay. So now the same store, grocery store example. So how would you present your data to the store owner? You cannot simply go and say that, okay, these are the Excel sheets. This is the analysis I have made. So you wanted to come up with the some kind of a diagram, charts, pie charts, graphs, right? Right? In which you can just tell him a story that, okay, look, these are the trends, year-wise trend of the customer. These are the daily purchasing habits of the customers in the x-axis, in the y-axis. These are the percentage of males to females of the children products, right? Similarly, you can just try and make some bars and the charts and the graph and present him in that way, right? So this is what Python can do, right? Then your machine learning, deep learning, and artificial intelligence. In research areas, if you wanted to go for the research, right? So there also Python is widely used in machine learning applications, training your data, right? After you train your data, you can use it with some other inference and some other application, right? So this is a broader application in which Python could be used nowadays in any of the topic. So demand for Python. So in the recent years, the demand of Python has rapidly increased. So why? Because the uh, versatility and wide range of applications, as we discussed, ease of learning, okay, and we have the strong community support. So what do you mean by community support? That if you try to come or stuck with some kind of an problem in the Python code, so people have given a community support in which they could answer your queries, okay, answer your doubts, okay, and adaptation in data centric fields and your growing career opportunities. So in your current scenario, so widely like now is the era of Python. In the 90s, I could say there was an era of Java and your front end, right? And before to that, it was a PHP, right? So now, if you go to any of the industry, so the most a prerequisite is of Python. If you're going to a backend engineer, right, and front end engineer or a full stack, right? So all these things would be requiring your Python, and there is a tremendous growth opportunities in the coming years as well as now. Okay, so now we'll come to the learning part. So this was the course introduction. Then we will try to come up with the programming basics. As I already told you, I will try to teach you the basics concepts. Okay, so that is very important. Then we will try to go for the Python programming, right? Before that, we will try to install and try to write our first Hello World program in Python practically, right? So today we will try to complete the first Hello World program, installing our Python and running our configuring our systems to Python and running our first Python Hello World program. Then we have Python data types and operators, conditional loops and statements, and we will also talk about our Python functions. Okay, so these all are a part of Python programming. Okay, so consider in this manner, guys, if we are trying to learn some new language, so there are some basic concepts or syntax we need to learn and understand. Okay, so let's say I will tomorrow I'll say that I will learn, let's say, Japanese. So in Japanese, let's say, so there are could be certain syntax, certain frameworks that I need to first understand, or phonomics, right? So in that part, I need to be well versed with that. So that is how, like in this course also, we will try to learn first the basics and then we will try to do it practically. Okay. So today's session would be a slow, and then by coming next sessions, it would be a practical implementation in which we both have to do simultaneously, right? Okay. So programming. So we will provide the overview of software and list the programming models and explain the structure of programming. So these things we will try to learn, the structure of programming and the different programming modules. Okay. Okay. So as I already told you that this is our agenda. So like we have uh, discussed the definition of Python, history of Python, and advantages of Python. Now we will talk about installing Python, Python ID, and writing our first Hello World program in Python. Okay. And the data types, data assignments. So this we will try to cover in this next session. What is data types, Python operators, strings, your file handling, right? So these are some of the topics that we will cover. After that, decision controls and structures, loops, control statement such as break, continue. So these all things we will cover. Okay, right? Then it also include your functions, arguments, return statement, scope of a variable, generator function, and function types, right? Okay. So these all things we will try to cover when we are trying to cover the practical implementations, right? So all things I will try to first give you a theory part to it. What are data types? Okay. Then we will try to cover the practical. Python operators. What are operators? Practical implementation. What are strings? How do you use Python string? Practical implementation. Similarly, decision controls. So why decision controls are important in Python? Let's say you are trying to write some code, right? Uh, a simple program, right? Let's say I wanted to write, let's say, a number which is even or odd. If the number is even, you can say that this number is even. If the number is odd, let's say I wanted to print, let's say it's odd, right? So what I will do, what is the basic thought process? If the number is divisible by 2, number is even, right? Else the number is odd. So this is your decision control. Let's say if else statement, in which you are trying to say that if this statement occurs, if it is true, do this, else do that. So these are your control structures or decision control structures in Python. Okay. So this we will see practically, but I'm trying to give you a broader picture. Okay. Loop controls means you are trying to run a Python program in a loop. Let's say print the numbers, let's say from 1 to 10. First 1 will get printed, 2, 3, 4, 5 up to 10. Now you are trying to print these 10 numbers, okay, but how do the program know that you need to stop? So there has to be a stopping criteria. You will try to check or try to say that you take some numbers, and if the number is let's say up to 10, if the number reaches to 10, stop from there, right? In a layman terms, I'm trying to write it. First, we'll try to understand in the layman term that how we can write. Then I will try to correct the syntaxes and we will try to write the same thing in Python. Okay. So the thought process you need to develop. So basic, if you're trying to learn any language, the basic concept is that you need to first build the thought process. So the thought process is very important. Until and unless you don't develop the thought process, you will not learn the Python or any of the programming. Similarly, okay, what are functions? Okay, so any idea about what are functions, guys? Yes, no? You can write your answers in the chat. What are functions in Python? Let's say in a program, you are trying to calculate uh, the, the text of a particular person. Okay, so let's say a person X receives the salary and you wanted to calculate the tax percentage. Okay. So now every time you need to write some code that, like, if the brackets falls into 10%, this much tax has to be deducted. If the bracket falls under 20%, this much tax has to be deducted, right? So and so. So let's say you are trying to calculate the tax percentage of 100 persons. So at 100 times, you need to write that code, right? That if the percentage, the salaries falls in this bracket, you need to deduct some tax to it. Instead of writing that code or a 3-liner code or a 4-liner code at 100 places, you write it at one place and you call that function. Okay, right? So you call that function and you write it at one place, and after every person or employee comes, you just call that, calculate that text, and return them. That's it. So functions are used in Python to avoid repetitive tasks. It is very much convenient and easy to use. And in case you need to do some debugging and some error occurs, so you can go to that function. Or let's say the government of India at next, or the any government asks that, like, the tax rates have been revised, so you don't need to change at 100 places. You need to change at only one place where you have written that function. So this we will try to understand how we can call a function, how we can write a function, what are the arguments we need to pass to a function, what is the scope, and your return statements. So this we will try to see all practically. Right? So I'm trying to just build up a story, right? A theory, the theory part to it, so that when you are trying to learn about functions, so you have some little understanding about it, what is a function, what that function does. Are we clear with it? Yes, functions. What that does? It is used to avoid our repetitive task, and we don't need to write it again and again. We need to call that function. The function return is in some file which could be hidden also, which could be hidden from the external world, in which no one can see the functionality. Let's say later stage your code got hacked, right? So you can go only get the access of those files in which your code has been written, but those files where you don't know that what is the implementation. So in this part, so we will try to learn like what is the software. Okay, so what are the different types of software that we use, and we will try to learn that what is their distribution methods. Okay, how the softwares are being distributed, and we will also learn about your procedural, object oriented and functional programming, and also we will try to understand like what which is the best one to use for your use case. Okay, then we will try to see that how your code snippets we can write it, right? And also the IDEs and programming tools where we can write our code and debug our code. So guys, like in my experience, so I have seen one thing. Writing a code is very easy. You can get it from the internet. You can get it from somewhere. Now the chat GPTs already give you. But debugging your code is very difficult. If you get to know that how you need to debug your code and understand your code, so it will make you a good program. Okay. So the most important thing is that you need to understand what is happening at the backend, what what exactly the program works and how it works. So this I will try to understand and explain you that how these things are working. Right? If you try to write a variable a equal to b, what is or a equal to 10, like what is happening in the backend. Right? So these things we will try to focus. So this is what is called as concept building. So ABC is a supply chain management company, and the company is trying to create a software to manage their clients for their supply chain. Okay, so this software could be your web or a desktop based installed in the warehouse. Okay, so the company needs to decide which type of software will best meet its needs and how to use your programming techniques to implement it. Okay, so now I give you 2 minutes. Okay, let's say like I am the owner of the company. Okay, so now my requirement is that like it's my supply chain department and there are lot many products which I'm trying to use it, but I need a software. And I approach you guys. So you are a Python expert guys, right? And I will try to tell you, okay, so now look, I wanted to make a software. So how you can help me better? What kind of a software you will try to make? And what type of programming languages you will try to like what type of programming language you will need to build that software. Okay, so these are the questions I will try to ask you. Okay, then you will try to come up with some kind of an blueprint. Okay, that these softwares will try to uh, be installed in your system, and it could be a web based also, it could be a desktop based also. How do you want it? If it is a desktop based, then that has to be installed in your system. If it is a web based, then you need an internet connection, right? Okay, so we will try to see what is a software. First of all, software is for the computer to understand, interpret, and execute. So basically, software is nothing such. It is a simple code or an instruction which we try to give it to the computer. But that instruction has to be understandable by the system or the computers. So let's say I'm trying to speak with you in an English language, and all of you know English language. But if it suddenly I try to speak Chinese or let's say Japanese, so you will not understand. So this is the same case. So software is a set of instructions for the computer to understand and interpret and execute. So if I have not written the software in the correct language of the computers to understand, how would the computers interpret and everything? Okay, so that is the first thing. Then the software programs are structured, they are organized and written in a computer language, right? So software is a kind of instructions that has to be given to a computer. Now I'm talking this computer always. So what is this computer? So computer consists of your hardware. If you try to see your computer, so it is made up of basically your hard disk, your RAM, right, your CPU, right? So the software sits on the top of your hardware, in which that software set of instructions has to give some commands to the hardware to perform some execution and then give back the results to the software. There you can see, right? Without this software support, hardware cannot increase its capability. Okay, so there is some manager of your hardware, which is your software, which will try to give instructions and then feed some instructions in which hardware will perform, and it will give back the execution back to your software, in which it will go to the end users. Understood? So this you need to understand what is happening at the background. Now, examples of software. Your operating system is also a software. So let's see, say guys, let's say you have purchased your system, okay, newly built your desktop or uh, your laptop, in which you got like 500 GB of RAM for your hard disk, right? 8 GB of or 16 GB of RAM. Then you are trying to install the operating system that also takes your 10 to 20 GB. So you may wonder that what this 10 to 20 GBs have gone. So basically, your operating system, when you're trying to put your power button, the Windows signal comes and loads. So that is being the instructions which are fed to the hardware to tell the hardware, okay guys, wake up. Now somebody have restarted your system and they are trying to use your resources. Now your RAM gets pumped up, your hardware or GPU gets active, and they are trying to load the system a general interface. A general interface in which you see the taskbar, you see the recycle button, you see your Windows button, your C, right? All these things get loaded, they get active. Okay, right? So this is basically a software. Operating system is also a software in which a set of instructions has been written. Then your internet browser, that is also a software. Your Adobe Reader, right? That is also a software. Spreadsheet. So we've been working with spreadsheet, work, MS Office. So these all are our softwares. Some set of instructions that has been written. So what happens at the background? Let's say you are trying to, let's say today, like we are trying to deliver this session, right? So you are working Zoom. Zoom is also a software. Okay. So what happens when you are trying to run a software in your system? That software consumes some memory, RAM, or your hard disk. Maybe you are trying to VLC player. You are trying to watch a movie, right? So there, your software gets opened up, and RAM also gets utilized, right? And your GPU, CPU is also doing some processing. So these three guys also gets activated. Okay, and let's say you are trying to open multiple software at the same time. What happens? Your system gets choked, right? Okay, it gets not responding. Maybe your RAM is low, maybe your hard disk is full, maybe your what we call your CPU is not that much capacity in which they can process multiple things at the same time. So this is your general instruction about your software and the hardwares, how they will work, right? So you are trying to open, let's say, 10 internet browsers or let's say 10 Microsoft Offices in which it will try to choke your RAM, and then RAM gets unresponding. You need to close it. Your RAM is only 16 GB or 8 GB, right? And your internet browser is taking much of the space, right? So this is how your system softwares or your hardwares interact, right? Are you guys with me? Yes, no? Okay. So let's try to understand your hardware. So hardware is your mouse is your hardware, keyboard is your hardware, Ethernet or a hard drive, right? So this is your hardware basically, right? Then why do we need software? So this is self-explanatory. If there are no softwares, then right in banks also, right? So like in the early 90s, so all the manual work has been replaced by your software. So Infosys was the first company which launched their Finacle software to the banking operation. Till now, till up to date, the whole of the banking application is using Finacle. So that was the major breakthrough in which Infosys company has utilized all the banking applications and got contracts of all the bankings in India, right? So up till date, we are using their Finacle softwares, right? So first they you need to manually make an entry, they need to look up that entry, then you need to see that which accounts get transferred. So now you have multiple software that can be used, right? And according to their customizations and according to the market, they are trying to leverage that. Right? So calculator, a simple example, right? We can use that simple fast, we can make that use, right? Okay. So as I already told you that softwares can create enterprise application for various industries such as transportation, medicine, defense, telecommunications. Okay. So into a legal tech company. So our company builds softwares in which the legal practitioners, your advocates, your legal, I would say, readers, writers, right? So they get leverage of that content. Okay, they can use that content and they can clearly utilize their product, right? So these are the softwares. In terms of medicine, right? You go to any store, right? So there's an ERP system built on the top of that software they are using, right? They can quickly uh, see what medicine is in the inventory or not, right? Right? Maybe if you go to a hospital, right? There also they are trying to use some softwares to operate the hardware, to operate the machines. You get the systematic report of the analysis of the patient, heart analysis, kidney analysis, or liver analysis, right? So these all are used in our day-to-day activities. Then we have the categories of software. Okay, so that categories could be broadly classified into two categories. Understood? So one is your application software, then it is your system software, right? So app hardware. So here interacts your hardware. So hardware means your CPU, RAM, your input output devices and others. And your system software consists of your operating system, right? Operating system could be your Windows, could be your Mac OS, could be your Linux, right? It could be your like others operating systems could be also there, right? Like which use less storage or less memory. Okay, Arduino, that is also another operating system. So can anyone tell what are these utilities? Anyone? You can think in the terms of using your computers, that you can just give a thought that, okay, in my system, I have the hardwares, I have the operating system. What else I do have in which could be categorized as system software? Anyone else? Yes, antivirus. Yes, this is a example of your utilities. One of the best examples of utilities. Okay, so you are trying to have your system softwares. Apart from that, when you are trying to work with your system, so operating system comes by default. When you are trying to buy a fresh system, so the one thing you will ask to that store owner that, okay, I want a CPU, dual core, like i5 processor, RAM, I want 16 GB, 32 GB. Okay, and in the laptop it comes, your devices, your keyboard already comes, right? So these are the things you ask for, right? Then that guy will ask you what operating system do you want? Linux, you want Windows, or your Mac is another story, right? Then it asks for utilities also. Do you want your antivirus, right? So that is one kind of a utility. Another utility can you think about is of your uh, this thing your VPN. right? So VPN is basically you are trying to connect to a remote server, right? So these are some kind of a utilities like your system software needs. Understood? Yes. Then comes the application software, which you have your games, your Microsoft Office, your Photoshop, calculator, and a number of things. So that software could be downloaded or freely available or paid version or subscription model, anything it could be there. Right? Let's say the best example is your Photoshop. It comes in under various categories. Either you can download in your system, it could be a system, like it could be a freely available, right? At some part, and then it asks for a subscription model. Okay, your Microsoft Word, Office also. Right? So these are your types of software which resides in your system, right? Okay. Then system software, it acts as an interface between a hardware and an application software. This I've already told you. So first of all, when you are trying to open your Microsoft Word, what it will happen? Your operating system knows that you are trying to request for a Microsoft Word. Automatically, it will get refreshed and it will try to get active. Okay, this guy is asking what Microsoft Word. Okay, RAM, just pick up. So it will try to get that Microsoft Word and put it into the RAM. Okay, it will also CPU will also get active. Okay, because you are trying to do some computations, you are trying to do some typing or running, right. Okay, so that is what it tries to. And when you close it, right, your this your what we call operating system then tries to give back the commands to your hardware, that saying that okay, now it is being closed, so you can just get rid of it. So now the basic thing is that the machine understands only the binary level. Binary means 0 and 1s. So system software helps to convert human readable to your machine level or machine understandable instructions. Okay. So let's say we are talking in English, right? But the another guy or a Japanese or a Chinese guy sits over me and say that like what you guys are doing, I am not able to understand. So then a translator would be there, which will try to translate your English and will give back to Chinese or your operating systems such as Windows, Mac OS, Linux, Unix, Android, and OS. So these are the various examples of your operating system that we use. Utilities, as already said by Pooja, antivirus, software, backup software, and your file management tools. Right. So these are your some of the utilities that we use. Then application software, your Excel. You already have been working with Excel, PowerPoint to make the presentations, a browser for surfing the internet, right? And your library management system provides functionality related to the library. So it could be your library management, could be your inventory management, right? It could be your store management, right? So that is being residing on your system as an application software, similar to your Excel or PowerPoint. And this library management system will be built in Python. Now you're connecting the dots. A software as a whole, we have Excel, PowerPoint, but we can make our custom made applications also, right? How we can make? We need to write some code that will do some process, right? And the next excellent example is that for Tally. So Tally is an excellent example in which it is used for accounting. Okay, right? Okay. So now we'll talk about the distribution of software. So distribution of software means whether that software is freely available or it is under license. So in most of the cases, you can find most of the softwares in a free mode, in a freeware, that which doesn't you need to pay. But some cases, some specific softwares like Adobe Photoshop, right? So they come up with a license, right? So after a certain period of time, you need to renew that license. Okay. So that is your software. So maybe it could be a web-based or a desktop-based software. Right. So we are talking about your now we are talking about your desktop-based software. So we are not worked upon the web-based software. Right. Okay. So open source, it is an open source that enables unrestricted usage, modification, and distribution. And that code is being accessible to public, right? So you can use that source code, and you can just, because when you are trying to install some softwares, okay, we can go to that particular location, right? C drive, particular particular file, you can see a bunch of files. So that bunch of files are basically your instructions written as a piece of code. So you can see that code, you can understand that code, and you can modify also, right? So that is the power of your open source, right? If you try to have your Microsoft Word, you can go and inside your Microsoft Word or any of the applications. But I recommend don't try to do that. If you try to do that, maybe the things will not work fine. Okay, so that is why we don't do any modifications. And even if you try to delete one of the files of that Microsoft Word location, maybe it is not functionable, right? You get problems with it because you are trying to click on Microsoft Word at the background, that files are being loaded into RAM. And if you are trying to work on it, and maybe at some point you get an error, you could see that that file is missing, or that file is broken, or that code is not written, it is not compiled, right? So that way you can just see and look, but don't modify it, and just try to understand. Okay. And licensed, like it is a copyright. Copyright means that you cannot have that source code. It is like it is being restricted. That if you try to use it, it could be face legal issues. Okay. And you cannot modify that. Okay. So now programming. So now we have understood about that how we can make your softwares. Okay, softwares, two types: desktop softwares, or your open source softwares, or your freeways, or your, then we can also have your web enabled softwares, web enabled applications, right? Your Netflix web based application, right? So in some cases, though, they have given you a downloadable version also, right? If you can download that application on your system, and then you can work on, and you can see the movies and your content also, right? Okay. Now we'll come to the programming part, that in that particular instructions, what sort of programming methodologies they have, right? Okay, fine. So procedural programming. So procedural programming means that programs are a sequence of instructions. One instruction is written, then go another, do another, do another, do another, right? A step-by-step execution of instruction in a sequential manner, right? The program, a set of instructions, what you write, is being divided into multiple sections: A section, B section, C section, D section. Okay, right? And this helps to improve the clarity, your quality, and development time, right? Okay. So basically, what we are trying to do is, it's a sequence of instructions, and in that sequence, we are trying to separate out as a module wise. Okay. For this, let's say word. Word are not many things: reading, writing, drawing, right? So you can just make a module of drawing. Drawing, you can just collaborate with some parts, some modules, right? What the functionality is, what they do. And if you are trying to write a sequence of instructions, you can just go with it, right? Okay. So it uses some blocks or control statements and loops in which we could write the like instructions to it. And the best use case example is that Pascal or your C language. Okay, right? So C is also a high level language, right? And it is very lightweight language, right? And like we can do lot many things with the C also. Yeah, it directly interacts with the hardware, right? Okay. Then object oriented. So object oriented, as I already told you, that it aims to implement real world entities such as inheritance, information, ID, polymorphism, right? Right. In the programs, example, your C++, Java, and Python. These all are your object-oriented languages, right? So what are the advantages of object-oriented language? So it deals with the real world entity, person. Person has a name, has a age, has an address, has a salary, right? What does that person do? Walks, eats, like work, right? So we can just relate to the entities in the real world. Okay, so that is what, like, this is the power of the object oriented. Now, in that person thing, what is the information hiding part we can do it? Can you guess, guys? For that person, right? So there could be fields your name, your age, your salary, your work location, your work, your department work, right? And your address, right? So, and you tell me, guys, so what is the part we can hide it, right? If you want that all these information are being hidden from some other word, so you can just hide it. You can only tell the name of that person, right? Maybe that company, in that company, that person is working. So that is your name, age, sex, and your salary and your location. These things can be hidden. But if you want to be publicly available, you can only give that information, name and your age, not the salary. Okay, and if in that case your location could be also be hidden. So that depends upon your requirement, what you are trying to build, for whom you are trying to build. Okay, right? So this is like the object-oriented programming language, which will try to give us the information hiding capabilities. It will try to give us the inheritance. What do you mean by inheritance? Okay, so let's say now this person have some fields, right? Now from that person, right, we have a child. A child could be a family member, right, which shares the same details. That could be have your name, age, your salary, right? But there could be some change in parameter. Maybe you're male or female, maybe your age could be different, right? But it will try to inherit some of the basic properties. Let's say name, your age, right? But it couldn't be working, it could be working, right? So these some kind of an information could be inherited from your parent object or your parent, what we call structure, data structure, right? So this is your inheritance. So that we will try to understand later, right? But on the broader level, I'm trying to tell you that these are the things in which we could structure our code in such a manner that we could write our code in a faster and in a simplified manner. Okay, information hiding, as I already told you, we can hide those information. Inheritance, instead of writing again and again, we can inherit some of the basic properties of that property. Okay, and we can use reusability. Reusable applications can be used with less code and shorter development time. And Python, I tell you guys, it is very easy to learn and understand, and it is fastest to build also, unlike your Java. Okay, and the errors and your debugging is very easy with Python, as it was difficult with Java, in which you could show a long stack trace of your errors. Okay, right. So now we will focus on your OOPS concept, which is inheritance. We are inheriting some of the properties of your base object or your base class. Right? Let's say you are a person. Let's say you are an animal. You have animal. You have basic properties. He can talk. He can walk. Right? Or basically he have four legs. We can inherit those properties. Like a person could be an animal also. Right? So we can have the basic properties. We can talk. We can walk. Right? Okay, but animal could not work, but person could work. So some properties we have inherited from the animal class to the person class, but additional functionality could also be inherited. Like we need to implement that. Encapsulation. We are trying to make a control structure, a class or a structure in which all these things could be written. A person, right? A company. A person holds an information of a person only. Name, age, sex, salary, address. Right? A company. So company owners, company GST, company information, company location, company turnover, company child companies. So that information and your personal information is separate. If we wanted to add something in company structure, we can add and modify easily. But if we try to write the company and the person structure as a whole, it will get very complicated, guys. And let's say I'm giving you an example of a person and a company. Let's say future, you will get lot many structures like this. Entities, we call it as entities. One entity, second entity, and third entity. And if you try to get 10 entities at a time, and if you club it into same structure, it will be very difficult for you. So you need to make small structures in which later at later stages you can modify that. So that is your encapsulation. Encapsulation, you make a class in which you define some properties of it. Let's say name, age, sex, right? Salary, address. Then you will try to write some functions. What it does. Person walks, eats, do job, right? 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 So these are the things you can just encapsulate. Encapsulate in a capsule. Find it. Okay. Then we have abstraction. Abstraction means your data hiding. We can hide some of the features in that we don't want to show it to the external world. That is your data abstraction. And polymorphism, a same function could be used as a like one function could be used in different forms. One function serves as two forms. Right? So this is your polymorph. Right? So these are the four pillars of your OOPS. Encapsulation, inheritance, abstraction, and your polymorph. So basically, what is polymorphism? Okay, and encapsulation. Okay. Okay, anything else? So are you guys okay? Inheritance, you already understood, right? So what is encapsulation? So encapsulation, as I already told you, so you make an entity. So what is your entity? Your person is an entity, right? So person, this entity has some certain features, certain points. Let's say person has an ID, person has an name, person has an address, person has an job, person has an company, right? So these are the entities. Now, let's say there are some functions written to it. What does that function, like what does that person do? Right? Person walks, person do job, right? Person goes to office, right? So these are the functions of that person, right? So and then we are trying to bind it in a class and object mode. So binding these person, what that person does, so this is what is called as encapsulation. There could be multiple entities. The person is one entity. Let's say another entity, like in a real life situation. So this is was a toy example. In a real life situation, when I talk about, okay, so let's say a Flipkart. Flipkart is a company in which you have a lot of products. Okay, when you try to go to a Flipkart or Amazon, you have the product listing. So what they have done is, so they have made a product ID, right? Product name, product description, product image. These are some things in which you get the entities of the product. So product could be your in which categories they fall, right? So these are some what we call this product is an entity in which they have some terms defined to that entity, which could be a name, description, right, and your which category they fall, right. These are some these are some points which are linked to that entity. Then there could be some functions which could be that product do. Okay, so Ruchi, when we are trying to do the hands-on, okay, then this could be more easy to use. I could understand that you guys like couldn't understand the oops concept, right? Because this is a very like complex concept, right? You cannot understand, but I giving you a framework to understand it. Even if I try to approach to a, let's say, in the Python via Python programming. So first you need to understand the Python program, right? So in the next or incoming classes, when we are trying to work with functions, and then in that lecture, I will try to give you a gist that what is your roots concept, right? So understand in this manner that these are some entities which are linked to each other, right? You try to link that products with your some certain functions. Okay, that is your basically encapsulation. And polymorphism is means that, let's say, in one part you are trying to write a function which will serve a something else, and in another part the same function will do some other operations. So name of the function is same, but it will serve different objectives. So that is what is polymorphism. I will try to write a same function, right? But that function will serve a different purpose. Okay, let's say build a pizza. Okay, or give me a pizza, or order a pizza, right? So order a pizza is a function. This will or try to order a pizza, but another function will be there in which it will not try to order a pizza from Domino's. It will try to order a pizza from Pizza Hut. The same function which we have written, we will try to order a pizza from Domino's. So the functionalities are different. So this is your layman terms in which we are trying to explain you what is polymorphism. Same function, but different formats or different functionalities, right? So when we try to run the code or learn the code, in that manner, you will be more clear with that, right? So now the oops concept is basically inheritance in which we are written a base class and you try to inherit some of the properties of the base class. Encapsulation, binding your entities into your member functions and your variables. Your variables are your name, age, right? Your address, ID, and your functions, walk, crawl. So these are some functions. Encapsulation. Abstraction, data hiding. You're trying to hide some of the features from the external world. And your polymorphism, one function which will serve multiple purposes, right? So same function is there. It will try to order a pizza from Pizza Hut, but the same function, if you call it in another manner, it will try to order a pizza from Domino's. Are you getting my point now? Yes, no, 30-40%. So now we'll talk about the function programming. Okay. So in 10 minutes, we'll try to have a break, guys. Okay. So just I'll try to complete this one. So functional programming is a paradigm where the programs are constructed by applying and composing functions. Okay. So as I already told you, so like when we try to write our code, so functions are really important. But in this functional programming, we only write some functions and we call that functions. So there in the previous programming, so we have the procedure or the oops concept. So we are trying to write some instructions. There we can use the control structures or the modules or the sub modules, or maybe we can write the oops concept also. But here it is purely function based, right? So example, your scale, right? Okay. So a program structure consists of multiple components which interact with each other and have a interrelationships, right? So program we try to interact it, and like we can have multiple files also. Okay, we don't want to write our program in one file, so we can interact with one file to another file. This is what it means, right? And right, so the program written should be explicit and it should be simple and it should be readable. The the best programmer is that one which will try to write our code in such a manner that others could also understand. So in a company, I've seen a lot of many programmers. So they write the code in such a manner which we cannot also are hard to understand and interpret, right? So there you need to understand it when you are trying to run or write our program, write in such a manner that the variables and the functions are defined in such a manner that it is beautifully written and it could be easily understandable. So what that function does, right? So that we will try to see what are the best practices in which we could write our effective Python code. Okay. So, so just trying to make your mindset that if you are a programmer, if you are trying to learn the coding, so learn in such a manner that everybody could look at your code and see and understand that what it is written. Because if you are trying to, if I try to give you a code of some other person, which is very hard to understand, and then also you will try to see that okay, what that person has written. Okay, so also you have to use and employ appropriate data structures. When you are trying to run a program or write a program, don't directly jump to a program statement, right? Let's say I give you a program that, okay, find the prime numbers up till 100. Don't directly try to solve it by using into editor or Python program. First, try to think. I have a number. What is the logic I will try to build? So all the logic is pure maths. That math has to be integrated and try to convert into a Python program. So that is what you need to understand. Okay. So don't try to run a program which has a single entry point and a single exit point. And poorly structured program like will try to end lot of errors. Okay. And you need to just maintain your data structure in such a manner that this is very effective for your memory management also. Understood? So these things you need to keep in mind because the execution time, if you try to see and write the program in such a manner, then the execution time will also increase. And if the execution time will increase, then your site or your application would be slow enough, and it will if it will be slow enough, and then it will cost your owners hard money, right? So basically, the all the programs share a similar pattern in which we write some statements to start the program. Then we have the variables, and then we have the block of code in which some piece of code is written. So entry point in one file, another file we try to declare all the variables, and the third is your block statements or where the code is written, actual logic is written, right? This is the normal practice which every program has to follow. Yes. So C++, Pascal, Oracle, right? So basically in C, right, we need to include stdih.file. So what it is basically does, like it is the input output file, we need to include it. And then we try to write a function, and inside a function we will try to say that print hey, right? Okay. So basically everything we will write, we will try to write a function, and inside a function we are trying to write. Okay. So in your C++, it is basically the same, but here instead of printf, we are trying to write cout. Okay, so syntax have to be. So basically, you can spot the differences. It is basically the same, but there are few modifications. Okay, yes. And your Pascal, so Pascal is if we try to write like this program hello world, then we try to begin and end. So inside your begin and end, we are trying to write this, write ln, which is kind of a print. So what it does, it will try to print on the console. Console means your terminal. So I will be trying to tell you what is the terminal also when we try to do the practical. Okay. And here, Oracle, PSQL, SQL, which is your database query, right? And if we talk about Java, Java also we try to have an oops concept, which is your class. Class is your hello world, and we will try to state that this is your public static void main. Public, this is your public function, right? Basically, you are trying to say that this is public, private, or protected. So these are your abstractions, access modifiers we call it, in which we are trying to restrict some of the functions to the external world, right? So then we have the Perl, right? So this has a different syntax. Every language guys have a different syntax, right? But you can relate to it. Okay, so in Java and C, right? So here also void, right? And this could be termed as, right? This is basically a function only. In your Java, so these are also functions, but additional functionality is being given, right? So this you can see that if you are trying to write a simple hello world program, you need to write 3 to 4 statements in your C, C++, Pascal, Oracle, or your Java, Perl. But in Python, it is simple and straightforward. As you speak, as you write. It is you want to write print hello world. That's it. End of story. You don't need to write a complex structure, right, in which you are trying to say that I just wanted to write a simple hello world program. And in this hello world program, so there the chances of error are very high, right? And even with the newbie which is trying to learn some programming, so like it will try to get rid of it. So it will say that like I'm facing so many issues in writing a first hello world program. How could I proceed further? Right? Because it is a syntax and that syntax I need to understand and I need to implement. So here in the basic Python programming, so you just need to write a print hello world. Right? Understand? That we will see, right? I will try to give you a practical like today, right? How to write a print hello world program in Python. So just few minutes with me, guys, here with me, right? Then we will try to see. Programming language could be compiled or interpreted. So Python is your interpreted language, and your compiler-based language, right? Your C or C++, Java as your compiler-based language. So what is the difference between your interpreter-based language and your compiler-based? Interpreter takes a single line of a code at a one time. Actually, I changed the orientation actually, so that is why it is causing issue. Okay, no problem. Now I think it is voice is clear. Okay, so interpreter-based languages and the compiler-based languages. So what does it mean? So interpreter takes single line of a code. So single line, it will try to interpret and it will try to send that code or your machine language code to the system, and it will try to execute. But the compiler based, it will try to scan all the instructions at one go, right? Like the programming in which your C or C++, it will try to generate a bytecode first, right? Entire program, or let's say 10 lines or 100 lines or 1000 lines of code, it will try to scan each and every line, and then it will try to return the bytecode information. But in interpreter, it will try to take a single line of code, right? So that I will try to see you practically when it will try to see. Then we have our 5 basic concepts that is being used in the programming. A variable, control structures, data structures, syntax, and tools. So these tools could be your external libraries, your carpenter, right? Your plumber, your architect, right? Which you want to use as per your requirement. Understood? So that it could be that tools also, and it could be tools which you will write your programming language, your Python code. Okay. So let's assume that you wanted to write some English letter, some instructions in a piece of paper. So what are the tools that you will use to write that instruction? Tell me, guys. I could give you a simple example that you wanted to write some instructions on a piece of paper. What are the tools that you will require? If I want to write a simple instruction on a piece of paper, what are the tools that I will require? Yes, exactly. Pen and paper. Yes. Okay. Right. So these are the tools which you require. So similarly, for Python, you need some tools to write it. So that tools are your IDEs. IDEs your mean that integrated development environment. So it is an environment in which you can write your code. So let's say you are trying to build a software. For that software, you are writing some code, and at some point you find that this code is not working. So you need to debug it. You need to identify the errors, and then you need to solve and correct it. So that tool, your integrated development environment, will give you all these features. It will not only try to tell you that at this point of time or this place, this code is giving you error, this line number is giving you error, this highlighted code needs to be written correctly, some sort of suggestions. And you can also debug it on your own. What are the variables at that point of time which are holding some value that you need to debug and correct it. So these are the tools which are your IDs that we will try to understand. Understood? So now let's talk about the variable. You are trying to understand, like as the name suggests, variable, right? So it is trying to change. So don't think in such a manner that variable is something it is reflected to change. It may or may not change. That is for sure. But think of the variable in that term that it is an identifier. It is a name in which or a let's say that holds some kind of an information, right? It is a storage location. If I try to write that a equal to 10, what does that indicate? A is the name of the variable, equal to 10. 10 is the information that variable A is holding. That variable A is holding some sort of memory space in your storage location where you are trying to reside a store value of 10. Yes, exactly. Sorry. Right. So A is the name of the variable, right, which has some address. So let's say, so every one of you are living in a house, right? This house is your storage location in which they can accompany like 5 members, 2 members, 3 members, or 1 member, or 10 members. That building has some name, right? And your location or a storage location could be an ID also or a geo lat long also. And that your house could be a name also. That name or house with your geolocation, you can take any name, right? But that geolocation is fixed, right? So you can have any name. First of all, that geolocation is fixed, and the amount of members that they can change or they cannot change. Maybe let's say you are now at this point of time, you are living 10 members, and in future it could be 5, it could be 2, right? So in that case, it could be changing at that particular time. I could ask you that this particular house, how many members are there? You can give that information 5. Let's say I come tomorrow. How many members? It could be 2 also. At that particular time, how many values or how many members or what value does it have? It has to be understood. Like it has to be known. Now you understand what is a variable? So variable is an identifier, a storage location which holds some kind of an information. Right? Understood? Yes, no? Are you clear? Because these are the concepts, guys. So what is a variable? What is a data type? So these are the concepts you need to understand. Right? So variable is an identifier that holds some information. And at consider that is a practical example, your house, which holds some information. Right? That information, like I'm not talking about that information, like how many male are there, how many females are there, how many children are there. That could be your data types. Let's say integer. It is holding only males, integer. It is only females. Let's say floating point. It is holding as a mixed. Okay, so then we have a different data types or different structures that hold that information. Okay, A is a variable which is holding only males, integer. A is a variable which is holding only females, floating point values. A is a variable which is holding a Boolean data type, which is your true and false. A is a variable which is holding a string, right? So these are some data types. So this data types we'll also see, right? I'm just giving you an information. Practically, it will be very clear to you guys, right? Okay. So control structures. Control structures depends upon the decision. If the age of a person is greater than 18, a person can vote, else the person cannot vote, right? As I already given you an example of a tax calculation. If the salaries of the person is greater than, let's say, 12 lakhs, right, or less than 12 lakhs, no tax. If it is greater than, then accordingly the tax is computed. Okay, so these are control structures. Then we are having different data structures, which is your list, dictionary, string, tuple, sets, right? So these are different kinds of structures as per your requirement, which is having in Python. As I already told you, if you have a mixed type of data, male, female, children, you can store it in a list also. You can store it in a dictionary also. That we will see. If you have only integers, integer is fine. One value integer, right? So that we will see that how you can take that data, right? The different data in a different data structures according to your convenience, according to your requirement. So guys, syntax is very important. Some of the programming languages follows a specific syntax. Let's say at every line you need to put a semicolon, right? So in Python, it doesn't require a semicolon. Have a course equal to, right? So these are some kind of structures we need to follow. I will also try to tell you that how your syntax has to be clearly written, what errors you follow, right? As I already told you, once you try to solve your errors, you are a good programmer, right? You need to solve it. So don't try to look at the internet that for the error that this is what is happening. Try to use your intelligence and try to solve it. So that will make you a better programmer, right? Because there are some tools your somebody has also gone through the same issue or problem. But the thing is that when you go into a company or a bigger organization, so there you will find that if you are trying to solve a solution or a problem, error comes, then you are getting stuck because that solution would not you will not able to get anywhere in your website or in your chat GPT, right? Because that error is specific to your problem statement or the code which your company has written. So it is better if you get an error, try to solve it, look at the error, and then you try to interpret it, right? You don't try to look at the internet. That will try to work your intelligence and try to solve it, right? So now we are going to learn the tools in which we could write it like Eclipse, Atom, Jupyter, or Microsoft Visual Studio. So these are integrated development environments that could be used to write your program effectively, easy to understand, and it will give you suggestions, error handling, right? So these kind of like environments are easily available in which you can use it. Okay, so now the knowledge check. The language understood by a computer without translation is option A, command language, B, high level language, C, assembly level, assembly language, and D, your machine language. The computer understands machine language without translation. The thing is that the machine is a machine, we call it as a machine language, right? So high level language you already know. So it needs some translation, right? Assembly level is also needs some kind of a translation. But the machine level language does not need a translation because it is directly understandable by your system or your computer, right? So the correct answer is your D. Now, second question. Which of the following software defines an operating system and a utility program? This, I guess, all can answer. So now the objective, we have now reached to a point in which we are trying to work with the Python, and we will try to write in the next 1 hour our first hello world program. Okay. So now, guys, up till now I have taught you about the theory, about all about Python, right? So why Python is important, what are the things we can do about Python, some data structures, some variables. So little information I just wanted to build up a theory in which you just relate to things. If I directly try to give you and bombard with you the topics, you might not understand, right? So now the thing is that some initial move has to be done in order to understand these things better. So let's say the same business scenario in which the company is trying to explore the artificial intelligence projects and is struggling with the right programming language for its projects, prioritizing the functionality, scalability, efficiency, developer experience, right? So these all things, like, Python has emerged a ideal choice. Why ideal choice? Because it is secure, it is simple, it is faster, right? And it has got built-in libraries, right? So Python can, anyone can code and write and build like softwares on the top of it. This is the leverage of Python, which has gained popularity in the recent years, right? So now, like this already we have tried, like Python is widely used in the data entries, right? Okay, so it is a it's just a refresher, right? So what we have taught, right? It's a high-level language, interpreter based, and it is simple, general purpose programming languages which it could be used for various purposes, right? I think this we already covered, right? Advantages we already know. It is flexible, readability, maintenance, robust, and easy to learn, right? Strengths we all know. Object oriented, free and open source, portable, powerful, and compatible, right? So anything you don't understand, let me know, guys, right? Because this is only a theory part, and we are already trying to cover much of it that we do already know that what are the advantages and the technical strengths of Python, right? Now let's try to understand like the use cases in which the Python is being used. YouTube, all we in our day-to-day activities use or follow YouTube, right? In the backend, it uses your Python for data analysis, for handling your metadata information, right? In your Google search also, your Python is being extensively used. And Dropbox, we all know, is a software utility, right? In which it is primarily coded in Python. Then your BitTorrent, right? In which we try to do peer-to-peer file sharing, download movies or the contents or your books, right? It started with the Python programming only. It is a small project which started as a peer-to-peer file sharing part, and then it got, like, let's say, recognized, and it is widely used, and it got extended, right? And Netflix, excellent example in which full content lifecycle is being used, right? So basically, these are some of the popular like software companies which extensively use Python in our day-to-day activity. Even in our company, right? So we have data engineers, we have data scientists, right, which extensively used your Python, right? Right. Now we come to the practical implementation, like how we are trying to install our Python. So let's begin. Okay. So what we now will do, we'll try to go to the internet. Okay. Okay. So this is my browser, right? I will say download, right? Okay. So guys, I will go slow. Okay. You just open up your browser. You will search on the browser, the search bar, download Python. Okay. And this link, www python.org, right? It will come. Okay. So when it will come, this is the official website of Python. So this is the official website. So guys, this is the official website. So don't try to download Python from any other source. Try to download Python from this only, this one, this official website, right? Okay. So now if I try to look at this website, so you can see docs. So in this docs, so how I click this docs, there's a link at the docs button, Python docs, right? I talk first, we'll try to look through the documentation. And meanwhile, what you can do is you can click on this download Python 3.13.3. So what it says, it is a Python 3 version 3.13.3, right? So this is your latest version of Python. If someone asks you, and generally it has been asked like which Python version are you on? So you just need to know, because if you are Python programmer and if you are working with some tool, so you just have to have got information up to date. What are you working with? Python. Which version? Python 3.13. Yes, so this is the answer which everyone expects from you. Got it? So meanwhile, what you can do is click on this download. Okay, so download will begin and it will be completed in seconds. It will automatically try to detect like it is for Windows, Linux, Mac, or OS. So mine operating system is Mac OS. It will try to download that package, right? So once you have downloaded this, I think I just need to, this installer is not opening up this screen. Just one second, I'm sharing my screen again. Just let me know once it is visible. Is it visible now, guys? Okay. So, Pushkar, what I did is I go to python.org.downloads. I click on the download Python button, and in my system, like Python got they like file got downloaded into mine. Then I double click on it. Then I install Python option comes to it. So are you guys with me up till this point? Yes, no? Yes, install now. You, Shivanjali, you can click on the install now button. Okay, what it is trying to say in the C drive, users, local program Python 3.13. This in this location, your Python will get installed. Okay, just click on this, right? Okay. Yes, yes, exactly, right? Okay, so now here you are. No need to click on this button. Use admin privileges while installing or add Python to the exe to the path. So you can click on the python.exe to the path. You can click on this button, but the upper one you don't want, because your system, it could be your let's say if it is your personal system, then it is okay. If it is your company based, then it would be difficult. Okay, Pushkar, are you facing any issue? Just click on the python.org. I'm repeating again. Just click on the download Python button, and this kind of a screen is coming, and then it will try to click it. Okay, no problem, no problem. It's downloading. It will take some time. Yes. So your C is been out of this memory, right? Okay. So guys, if this is a normal practice, okay, don't try to make your C drive bundled with so much space. Actually, the thing is that try to keep your all the things in D drive or make a compartment, right? Because these are some softwares. It has to be in one place. As I already told you, that when your operating system will work, it will try to work from your C drive only. It will try to install application from C drive. So this is the reason, like we try to keep all our softwares in the C drive. Automatically, it will try to take that space. Automatically, in the earlier screen, which Shivangi has written, like shown, automatically it will take the path. Automatically in users, drive, local, path, it will automatically install. Okay, so then it would be very difficult for you to try to install it. Are you getting my point? Yes. Pooja, yes, it is successful. Setup is successful. Let's others also complete the same thing, right? So I'm going slow up till everyone will confirm and say yes. Okay, I will not proceed further. Okay, if anyone is facing issues, try to put it in the chat, and the other fellow members also can help them, because there could be many n number of reasons in which their program could not be working or their Python could not be working. Yes, Christy, yes. You can go and click on this install now. Yes, you can just click on it. Yes, just click on it, and then after once the installation has been done, you can get the setup was successful. It will give you setup was successful. Everybody done with this? Yes, no, just keep on. Yes, install now. Yes, this install now. You need to click on. Okay, Pushkar, we'll wait. Setup is going on. Apart from Pushkar, anyone else is struggling or haven't installed Python? Yes, page issue. Yes. Shweta, you can just clean up some of the resources in C drive, or meanwhile you can just watch me, right? And then we can come up with what we have done, right? Because you like Shweta, like let me tell you, you just need to clean up your resources, because we will be trying another applications also, that also will need. Yes, after setup was complete, you can just close it. Yes. Okay. So meanwhile, what I was trying to say, that those who have done, so let me work with this. Yes. Setup was successful. Now you can close it. Okay. Now let me try to install Python on my system. Okay. So it is saying that it will take 181 MB space on your computer, and I will clicking on the install, and here I will need my password. Yes. Okay. So Pushkar, are you done? Okay. Right. So now my Python has been installed. Okay. Now this, congratulations. So this is being installed. Okay. So I don't want this installer. I will move it to the bin. All right. Okay. So now what I will do is, so you guys can open up the command prompt, CMD. So on the search bar, you just type CMD. Okay. And in my case, it is terminal. So this kind of a screen will come. Yes, command prompt, CMD. Yes. So in the command prompt, okay, so basically, so you just need to type Python. Okay. So after typing Python, so it will show you the version number, right? And this kind of an option will come. Yes. Yes, Pooja. Yes. So this is your command prompt. In this command prompt, so type here Python. Type Python and let me know. After typing, so you can see a triple arrow will come, and you will say Python version. So just paste your screenshot in the chat, what guys you are trying to see. Yes, enter. Are you able to see the Python version number? Yes. So Srishti has given Python 3.13 version, and here it is your 3 arrow. This means you have successfully installed your Python on your system, right? So it is showing your the version number, guys, Python 3.13, right? Pushkar, congratulations. Your Python version is your 3.110, right? It is showing you Python, right? Everyone on the same page? Everyone got this screen? Open your command prompt and type there Python. P with a small. Okay, Saloni, what's the issue? Okay, got it. Saurabh got it. Yes, Pooja, show. Okay, so for those who have done it, yes, everyone is right. Yes. So basically what you are trying to get it, you will try to get this screen in which you will get the Python version and you will try to get 3 arrows, right? In this thing, you need to write print capital and you will write hello space word and bracket close. So I am typing this as it is in the chat. Okay, if you have written it incorrectly, let's say there is some this quotes or bracket or is missing or P is capital, it will not work. So guys, P in small, right? Don't try to write P in capital. I am trying to write print hello world in the chat. Just try to copy this and try to paste as it is and then hit enter. You can see your hello world gets executed. So I want every one of you to, in the 3 arrow, after the 3 arrow, type print, P-R-I-N-T with the small p, bracket, quote, hello world, quote closing, then bracket again, closing bracket again. And are you guys see this hello word in the terminal? So this is your terminal, guys. Yes, great, great guys, congratulations. Arpita, so this is good. Hello world, yes, yes, everyone. Now I guess, guys, you are trying to do a practical of the first hello world program in Python. So congratulations, guys. So those who have done it, so this is how you install Python, first of all, and then you have executed your first hello world program in Python. And this is your terminal, guys. Anyone having some issues? Yes, absolutely correct. Srishti, you are also fine, right? If anyone is facing issues, okay. Now what I will try to do is, so I will try to write it again, print. Let's say I write it hello world and I explicitly, deliberately, I try to not put any bracket. Let's see what will happen, right? So it is not working because it is expecting that bracket, guys, right? Fine. So in this case, what happens is in this particular terminal, you cannot write your program, whole program. If I wanted you guys that I want to write some program, so it would be very difficult for you to write here because there is the 3 dots will not give you any information that what is wrong in that program. And there is one line, there could be 100 lines of code, and it is very difficult to debug and to troubleshoot. Okay, so for that we need some tool, editor. As I already asked you, for writing on a piece of paper, what we will write? A pen and a paper. So English is a language, Python is also a language. We need some kind of an editor, some kind of a tool to write our program and tell us that what is the issue here, what we are lacking. That will simplify our software development process. Okay, so this is what I'm trying to understand is this is your Python. We have installed successfully Python in your systems. Now the next step is that we need some kind of a tool to write our effective Python program, right? So that tool we will try to look upon. Okay, so I'm sharing my screen again and we will try to see some theory part to it and then we'll try to work on that part, right? Is that fine? Everyone, just give me a heads up that everyone is fine with Python and have executed their first hello world program before we move forward. Any questions, any doubts? Let me know. Yes. Yes. Any doubts, any questions up till here? Everybody is good? Yes? Okay. So we have installed our Python code. Okay, we have downloaded it, right? Another part where we can download our Python is from Anaconda. So this was the first installation which we have learned that how we can download and run our first Python code, right? So meanwhile, what you can guys do it, you go to anaconda.com. Okay. So in this anaconda.com, okay, so you can go to free download. In this interface that they have changed actually. Yes. Okay. So are you guys with me? Yes, no? Go to this anaconda.com. Okay. So what I was trying to say is those guys now listen it carefully. What we have done is up till now we have downloaded our Python. We have executed our first hello world program in Python, right? So now there's another software or a package or a software tool. You cannot see my screen. Yes. Now you can see. Yes. Okay. So basically, what you can do is you can go to anaconda.com, right? Okay. So now you can click on this free link, free download. Go to anaconda.com, anaconda.com. You will end up in this screen. Are you guys with me? Then you need to click on free download. For those who haven't listened, please, I am repeating again. Please pay attention. Anaconda.com. Click on this free download button. Okay. After clicking on this free download button, you can skip the registration. Right. Now, everyone, if you are seeing this screen, just let me know. Yes. Okay. In your system, I want you need to reach it here. Download now. Are you able to reach up till here? Anyone? Pushkar? Yes. Okay. So you can see distribution installers and Minaconda installation. Yes. After this, Arpita, you can skip this registration. If this is your skip registration, click on this button, skip registration. After skip, you can go into this download now. I repeat, if you guys seeing this screen, go to this skip registration. You can get here distribution installers. Are you with me, guys? Can someone share the screenshot that what guys you are seeing? Can share the screenshot to me in the chat. Yes, exactly. Yes, Saurabh, you are right. So here in this particular screen, it is showing download for Mac and automatically it has detected your download. Okay. So you can click on this download. Yes, history download and download distributions. Yes. So after this, you can click on this download button. Right. So it is asking for me, it is Apple or Intel, so it will not ask for you. Okay. So it will ask for Windows. So Windows, you can get it, like click it, right? So sir, can someone click it and then let me know what is the screen you are trying to get it? And guys, it will take some time. Okay. So it depends upon your internet speed because it is a software package, guys. Okay, it has been installed. Thank you for downloading. Yes. After it has been downloaded, you can go to the downloads folder and double click. Right. If after downloading, you can go to the downloads folder and double click and just type the what you guys are getting. Yes. It is fine, Srishti, Pooja. Yes. Now go to the downloads folder and just double click on it and then share your screen or set a screenshot what you guys are seeing. We will get a installer kind of a thing in which it will try to download, because in my system already I have installed it. Yes. So you will get a screen in which it will say welcome to your Anaconda setup, and you need to click on the next. No, Srishti, you can go to the no. You go to the downloads folder and double click on it. I think you're yes, you agree. Yes. So it is basically a software in which you don't need to change anything. Just go and click on the next. It will try to run and install. It will take some time, and that it will try to go. Yes. Go to the next, Puja. Just me. For all users, just me, you can do that. Srishti, I guess your space, you have a space issue, right? So yes, you can do it. Register Anaconda as my default Python. You can click it, right? So add 3 to my path environment is not recommended, and then you can click on the install. Right, install. Yes, 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 Sonal. Yes, you are correct. Yes, Pushkar, you are also fine. Srishti, I'm not able to your this file. Actually, this is being not being downloaded correctly. Actually, the issue is with some your file. You can try again and try to double click on it. Maybe it is simple process. You have downloaded something from the internet. You go to the downloads folder and you double click on it. And after that, you can see in your chat there are multiple windows they have tried to click. First, it is your uh, uh, it will come that welcome to Anaconda setup. Click on the next. Another screen will come. It will say advanced installation options. Okay. Then after then you need to click on the install. Now, after clicking on the install button, there will be a taskbar which will try to install all the applications, right? Okay, so it is going on. So meanwhile, don't panic. It will take this time based on your internet speed and it will complete. Okay, so guys, so first screen, if I try to tell you, is your welcome to your this Anaconda setup. Second is your Anaconda advanced installation, right? And it will click on the install, right? Yes, yes. Next, click on the next button, Srishti. Yes, it is correct. I hope everyone is trying to install it. Yes, no. It will take some time, guys. So don't try to be in a rush because okay. So before trying to install this software, this Anaconda, does anyone has asked me that what this Anaconda is? And yes, yes, it is installing. Yes, yes. Anaconda setup is being installing, and you can click on the show details. Show details, you will try to see that there are different kinds of packages that is being trying to install. Okay, so let's try to complete this activity first. It will take time, and then I will try to tell you what is this purpose of installing Anaconda. We have already installed Python, so what is the purpose, guys? Okay, anyone? Has anyone completed or still going on? Yes, Saurabh, you have tried to do the Visual Studio. Yes, it is fine. Yes, yes, yes. Hello, what? Yes, exactly. Yes, Deepak. Yes, yes. Good, good, Saurabh. Okay, so we'll try to work. Okay, so you are ahead of these. Like, okay, Okay. Meanwhile, you tell me, Saurabh, why we have uh, installed Anaconda. Okay. So, Shweta, yes. So pre-installed libraries. So this is a platform. Okay. Okay. So Shweta, okay. So you can do one thing. You can just first click on CMD. After CMD, your terminal will open, right? Black screen will open. In that black screen, you just type Python, small p, Python, and try to see what is coming. And share your screen, the snapshot. Okay. So are you guys with me? Yes, no? So, or you need some time? Any issues, any doubts? Okay. So now here in this, click on downloads. Click on downloads. No, no, not here. You need to search CMD. Click on downloads. So, Shweta, have you installed Python because you have a space issue? Okay, click on downloads and then after it is being downloaded, then double click on. So actually the thing is that you are having a space issue, right? So that is why it got stuck. So basically the thing is that you need to repair it or you need to either uninstall it and do a further installation. Yes, yes, Shweta. The thing is that, like, actually, the thing is that if you have a space issue, I would try recommended that increase your space. Okay. Yes. Why Anaconda? Yes. Yes. I think everyone has downloaded. Yes, Sisti, you can click on the next button and then its setup will come and then it will try to do the by default. Yes. Uh, Sonal, it is downloaded or not? Yes, yes, it will take some time. Actually, the thing is that Sonal, that it is downloading is going on. It is not yet completed. It depends upon your internet speed. So once it is being downloaded, and you will get a this screen that download has been completed. Yes, Saurabh. If you like know the tools, right? Because the thing is that if you are trying to work with one tool, it may not be necessary in the company or in any uh, uh, like organization. So you are strict to any particular tool. So you need to be well versed with all of the tools, right? So in your company, it demands your Visual Studio. It asks for your Anaconda or your Jupyter notebooks. So there you can't say that I am not able to understand and use it. Okay, so it is better if you have got with experience with motorcycle, bike, or car or truck, so it would be fine, right? So that is the case. So if you can download it, it is fine. Otherwise, if you are fine with Visual Studio, so that is also not an issue. Yes, it will be get downloaded. Okay, so not an issue. Okay, yes, so still it is fine. Great, great, great. So I guess the downloading of your Anaconda will take some time. So that is for sure for those who have done it. Okay, so congratulations, guys. Right? So so the thing is that so I want everyone to today complete this downloadation part of your Anaconda. Okay. The thing is that in the next session, we have already seen that how we are trying to write our first Hello World program using Python. And another thing, what we will do tomorrow is that we will start with your Jupyter notebooks, which is very interactive, which is very yes. So Sonal, I'm coming to that only. Okay, just give me some time. So the thing is that because all the guys are busy with their installation and downloading, so I was trying to give you a theory. So that is why theory is important. Why we are trying to download anything? What is the need? If someone asks you, you have your Python, so why you are trying to go and install this heavy software or your packages, right? Right? Okay, right. So this is important to understand. If we are trying to do some activity, you need to ask why we are trying to activity and what will happen. So this is the questions you need to come up with, right? So in the next session, what will I will try to do is I will try to give an overview of how we will try to run our first Python program in your Python for some guys which have still pending, right? In your, I will try to show them again, and then we will try to work with your Anaconda, and I hope everyone gets their Anaconda installed. So let us talk about what is Anaconda. Okay, so first of all, we need to understand so why this Anaconda we have installed. Okay, so let's say I give you an example. So earlier example which I gave you is of like you are trying to construct your house, right? And in the construction of your house you need some guys so that you make your house successfully built, right? So in that case you need a carpenter, you need a plumber, you need an architect, and so and so, right? So there are so many workers are being used in the construction of your house. Okay, so similarly think in this manner. Your Python is a language, right? And it supports some of the libraries, right? That comes by default with Python. So let's say, like if you are trying to build a house, right? So automatically I will say that, okay, if you are trying to build a house, I will automatically give you a person which could help you in some in maintaining your house or constructing your house. Similarly, Python. So there are some libraries which are already being provided to you by Python. But there are some external libraries or external persons, they help you in doing your task. Let's say your packages. These are your external people or external persons which are known as packages. So these packages you need to ask for it. Ask for it, you need to hire those packages, right? So for the construction of a house, you need to hire a carpenter, you need to hire a plumber, right? So in that case, in your Python, when you are trying to work with Python, at any point of time, if you are working with your data science applications, right, you need to get that packages installed. Okay, you will request that package. Okay, let's say you are working with your AI like TensorFlow or your uh, training your models and machine learning models. You need specific libraries. So then also you need to request that. Okay. In that sense, what Anaconda says, I give you a distribution, a toolkit comprising of all the packages which are widely used in the market. Okay, so let's relate to that example of building a house. So I am trying to build a house. Okay, so when I try to build a house, so when I'm trying to work in one room, right? So I need a plumber. So then at any point of time, I need another carpenter. So I would request and I go to the market and hire them. Similarly, in Python also, when you're trying to work with data science, you need a specific library or a package. So you request from the internet. What if I tell you when you are trying to construct a house, so I hire or I tell you that these plumber, carpenter are already being provided to my agency. So you directly hire agency in which all these plumber and your carpenter are already provided. Similarly, this Anaconda consists of your not only Python, but also it consists of your libraries, inbuilt libraries, which are already widely used. So you don't need to again and again request from the internet, right? So let's say you go to the market and they said that you need to buy a chips. So from these chips, so there are two additional chocolates are free, right? So this is kind of a package or a toolkit which Anaconda provides. Anaconda provides you, right? So we will try to look like what these packages they have provided us, and what are the different Python versions also this, right? Let's say in future you are working with one project and your company says no, you don't need to work with Python 3.13. You need to work with Python 3.10. In that sense, you need to install the previous version. So it becomes a headache for you. So this Anaconda says, okay, I got 3.13. Okay, you need Python 3.10. I also have Python 3.10. You don't need to absolutely go and install Python 3.10, right? So this is basically an distribution or an toolkit which provides you not only the installed packages, but lot many things more, right? So we will try to see. So this is your Anaconda distribution. So yesterday, what we have done, we have tried to install the Anaconda installers on your Windows system, right? And these are the Python IDEs. IDEs means interactive development environment. We will see. So we will be working with Jupyter notebooks. So Jupyter notebooks is a such kind of an IDE. So there are various IDEs which are present and available in the market. So this is Microsoft Visual Studio Code, PyCharm, Spider, right? Sony, Atom, Bing, right? So Jupyter Notebook, PyCharm, and Visual Studio Code, they are widely used. Okay, so it is basically like you are trying to buy a internet SIM or a SIM or a mobile SIM, right? So you have different providers. You have your Reliance, you have your Geo, then you have your Airtel, right? Vodafone. So similarly, these IDs are similar to that only. So now the question rises like which ID to use, right? It depends upon your requirement and ease of useness. Like, let's say if I try to tell you that okay, you need to buy a line SIM or an Airtel SIM, so you do a comparison. First of all, you try to see which all packages or which all uh, uh, this service plans they have, right? According to them, you decide. But if you are comfortable with one of these IDs, so you can easily switch to another. Let's say you are comfortable with Jupyter Notebook, so you got us this that what this Jupyter Notebook does, and then after that you can easily switch to PyCharm or Visual Studio Code. So I must say Jupyter Notebook is well suited for learning purpose and for data science applications, right? And for full-fledged projects, if you are trying to work with, so then PyCharm and Microsoft Visual Studio Code is best suited in the industry. So what is the difference between PyCharm and Visual Studio? So PyCharm only supports Python, right? And Visual Studio you can is supported across all the languages, most of the languages like Java, front end, right? Node.js, HTML, right? So these also can support. If you are working or want to be a full stack developer, full stack means you also handle backend development, or like backend development means your Python, Java, C, C++. So then we just then PyCharm only supports Python. Then Visual Studio can be best suited, right? And if you are working with front end also, right? So as Microsoft Visual Studio Code supports both backend and front end, Microsoft Visual Studio Code is widely used. If you are working only with Python, then PyCharm, right? So these are some of the IDs. So that we will see in a little bit of time that how we can work with Jupyter notebooks, right? Okay. Okay. So now the Python interpreter. So Python code can be written and saved using the .py extension, right? So if you are trying to work with Python and write some code, you need to save it by .py. If you will not save by .py, so the interpreter will not recognize it and it will not try to run, right? So this is this. So what it does, like Python, like this could be saved by using the .py extension, okay? And basically what it does, interpreter, how it works, it will first read the command, execute the command, output the results, right? So first the reading of the command happens, then execution, and then that execution, what you have written in the command, that got executed and it will show you the results. Similarly, let's say like yesterday we saw how to print do print hello world. So print we written print hello world. It will read that line. It will execute print, and from that print it will try to give back the result. So this is what it was happening. That was on the shell, Python shell we call it, right? Or the terminal we call it. If you are working with file and you wanted to run a file, you save that file and run it. So that also we will see. Okay, right? Now, up till now, any doubt, any questions you are having? Okay, so now the hello world got printed. Okay, so now we are trying to work with Python. Okay, so how to open it? So go to the like in the search at the bottom of your this start button. So there's a search bar. So just type CMD. So when you try to type CMD, so terminal will get open. So in my Mac, so this is a kind of search bar. So in that search bar, you need to write CMD. Okay, CMD. Okay, in the Windows, it will get open. Right? Fine. Right, Shweta? Okay. So this is basically a terminal. And now you are into your Python, and my Python version is 3.1.2 and your would be 3.1.3. After that, you can execute the statements and write, and it will get printed on your this console. Okay. If you wanted to exit it, so this is the command to exit it, and you will get out of that particular Python interpreter or a Python console, or what we call this, right? So this is your exit. So in exit, it will try to get out of your this thing. And now you are back to this thing. If you can again go into this Python, right? And then you can just write print. Okay. So clear, guys. This is how you do it. If you wanted to clear the screen, so this is your exit. After exit, you can CLS, you can clear your screen. Or you can put a clear. Yes. CLS, okay, or CLER, clear. So this activity we have done yesterday. I hope you are clear with this activity. Yes, no? Okay. So quickly, guys, just give me a confirmation so we can quickly move to your Anaconda. I hope everyone has done this activity. Okay, fine. Okay, so now you have installed your Anaconda. So I want you guys to just open on the search bar, like type Anaconda, right? So when you try to type the Anaconda, so you will try to see this kind of a logo, right? So just hit it, right? Or so I'm trying to open it. So Anaconda Navigator. So you need to go to the Anaconda Navigator, and this kind of a screen will open up on your system. So just let me know, is this screen visible, Anaconda Navigator? All of you guys. Yes. Okay. Balagration. Yes. Ruchi. Okay. Fine. Everyone. So just give your confirmation, guys, so that like if anyone is facing any issue, or because I need to tell you a lot of many things, right? But if you don't confirm me, then I cannot proceed it. And if someone is lagging behind, so then like just let me know, because I'm there to help you and guide you, right? Okay. So it is not the link, Hina. So basically, you need to install the Anaconda, and then after installing, you need to go to the search bar and type Anaconda Navigator. It's an application. Basically, it's an application what we have discussed yesterday. Now you need to open that application. Once you open the application, you could see that in this application, in this Anaconda Navigator, which is a toolkit. I already told you this is a toolkit, and this toolkit consists of a lot of tools. So consider this as a toolkit what you have in your home, right? So there's a small toolkit in which there are screws, multiple screws are there, right? Similarly, this is a toolkit in which multiple applications are there. There's a PyCharm also, Anaconda AI Navigator, Anaconda Toolbox, right? You have the PyCharm community, Notebook, Jupyter Lab, right? Single store, right? Okay. So these are the things which you have, right? Okay. Then you have the Spider. Okay. Then there you have a launch and the install button. In some cases it is installed, and in some cases it is launched. So basically the thing is that what application you need at the first time you need to install it. After you install it, so there's a launch button will come up, right? Or it automatically, in some cases it is already launched, right? So this is the case. So now, so this is basically your Anaconda Navigator, in which you get lot of applications or a tools available, right? So you have these tools, PyScript, Python Anywhere, and these keep on updating. Okay, these keeps on updating, right? So now in this Anaconda Navigator, so you could see all application on base root, okay, and here in the environments, so you can see. So what I was trying to tell you, so these applications or these libraries are pre-installed for you. Okay, so now you can see that. So these are all the installed applications or the libraries which are installed with their version numbers. Got it? Right? So these are widely used. So you don't need to again and again request the internet for these particular libraries. However, there are some applications which are not installed. Okay, so these are some applications which are not installed, and you can just request them or click them. Let's say this Boto3 library. So Boto3 library is the library when you are trying to work with your Amazon Web Services, right? So you can just click here and you can just say that okay, apply, and these particular Boto3 library will be installed for you. So this is one of the method in which you can install your library, an external library, if you are working with your Amazon AWS or some Azure service. So you can just request it, right? That in my Anaconda, I want this Boto3 library, right? So these libraries are pre-installed for you. And in some cases, so some of the libraries are updatable, right? Updatable in the sense, like let's say this is your Tornado library, a Python web framework and asynchronous networking library, right? And this is your version. So you need to update its version, and you need to do that. That I wanted to update to the latest version, right? So this actually is not required generally, but if, like, let's say you are working with some library and you feel that like this library got outdated and since some library is required, then you can update it. But it no longer like it is required. You again and again updating your systems, right? When you are working with it, so you get used to it, and when you get used to it, so you need know that okay, so I need to update this library only, right? Not all libraries or not specific ones, right? So this is basically installed, not installed, right? You can select it, right? Okay. So this is basically your Anaconda Navigator or a toolkit in which all the particular packages have been installed. Okay. So now what I will do is I will start click on this notebook. So what is this notebook? So if this is a notebook in which it is web based, right? So it will work with your browser. So it will open in your browser, and where you can just run your Python code in the form of cells. So there are cells. So let me show you. So I'll start launching it. Okay. So when you try to launch it, automatically my browser has opened. So this is my localhost. Localhost means your system, right? Your system, right? And in this port number, it has opened, and right, so it is your local system, right? It is trying to connect to you. And these are all the basically your drives will come, in which you can select any of the specific folder. Let's say I'm working with documents. In the documents, I'm working with trainings, Simplilearn, Python, right? In this, I will try to create a new folder or a new this. Yes. Okay. So any doubt up till now, right? For any part of you didn't get clarity, I want all of you to just click on this Anaconda, right? Navigator, and click on this Jupyter notebook. After clicking on this notebook, you can go and go to this localhost. Automatically it will open. So Virender, what you have not got? No doubt. Okay, fine. Thank you. Okay. Any doubts? Anyone having any doubt? Not clear? Just let me know. Everyone has gone through some specific, like let's say you need to go to some document, right? Okay, repeat the last part. Okay. So I'm repeating again for those who have missed, right? Okay, so you just need to click on this Jupyter notebook. Okay. Let's say I try to click it again. Okay, what will happen? So my localhost will get opened. In this, you can get the directory structure, all the directory structure you can get, right? All the directory structure. In this, you can click on any of the folders or you can create your own folder. So let's try to create our new folder. So you can click on the new. Okay, I'm repeating again. When you try to reach here, click on the new and create a new folder. Okay, I can go into a specific folder, let's say documents. In the documents, I can go to training, Simplilearn, May Python, and here I practice, right? Okay, so I named a folder called Python_practice. I go into that Python_practice and click on the new and I open up Python 3 IP by kernel. Click on this thing, right? So now you can see that this is a Jupyter notebook has opened up. So every one of you, I'm repeating again, you go to this directory structure and in any folder, in any directory, in any drive, you can create your own folder by the name of Python practice, right? When you go into this Python practice, click on the new and click on Python 3 and in the browser, another Jupyter notebook will get open. Up till here, any doubt, any questions you are having, just let me know. This is your, okay, I got it, what you are trying to tell me. So this is your Python, right? Python notebook. When you try to click on the Python notebook, automatically will open. Browser, this browser. This is your browser, Chrome browser. Okay. So the Chrome browser will open. Yes. So Arpita got it, right? Python 3 is not showing. So Python 3, it will, what it is showing? Yes. Python. Okay. If it is showing Python, then it is also fine. Yes. It is, if it will show Python, so then it is also fine. You click on the Python also. If you are guys seeing Python, then also it is fine. Because I installed my Anaconda when there was Python, the 3 was not there, 2.7 is also there. So that is why it is showing, right? So now it has been switched to 3. So that is why it is showing. Yes. Anyone having any? Yes. Pushkar, you are correct. Yes. So I will proceed further. Okay. So because there are not many things to do it, do let me know if you are facing any issue, right? Okay. Okay. So just pause me if I'm fast. Okay, just let me know. Okay. Pushkar, you are having this page. Okay, so go to the Jupyter in the documents, right? Click it, like create a folder. So this is your home. Okay, you got here documents. So these are your documents. So you are here, Pushkar, basically. In these documents, you can create a new folder. In this new folder, right? You can close in this training, and after that you can go Python practice. In that particular thing, you can create a Python. You can click on this Python and this file will get open in your browser. Yes. So Shweta, Python is a language. Anaconda is a toolkit. And Jupyter is your ID. Okay. So Python is a language, Anaconda is a toolkit, and Jupyter is a ID. In your Anaconda, your Python and Jupyter both exist. So this way you can just take it in a short with a crisp example. Okay, fine. Okay, so now let's try to understand what is the Jupyter. So Jupyter, you can see that there are file. You click on the file, new file, right? And you can save also. You can download also, right? You can save and export as a notebook also. In this multiple formats, this Jupyter notebook, you can just save in the HTML format, in the PDF format, in the Markdown, in the LaTeX, right? So this you can try it after we are trying to work with the Jupyter, right? Right. So then this is your run. Run selected means so you can run all the cells and you can run a specific cell. So basically these block. So this block is called as cell. Okay. This is your Python cell. What you can do is here you can simply write print bracket hello world. Okay. After writing your hello world, you can click on this run button, run this cell, or you can do it via shift enter. Shift enter also will work, or you can go it here, and here you can see that shift plus enter. In your screen, it would be written as shift enter or some other specific key. So that key you can press it, that is your shortcut key. Okay, when you try to run it, so what happens is your interpreter, remember your interpreter, it will read this line, it will execute it, and here you get the output here itself only. So you have successfully run your first Hello World program in your Jupyter notebook. I want all you guys to quickly try it out and let me know if any issue is there. Okay, just type it done. After you have written your print hello world, I'm repeating again. When you are trying to run, yes, exactly, Shweta, you are right. So print, right, and this is your run button in which you can click on this run cell and then you can write it. Done. Yes. Now don't share your screen, just type it done and just let me know if you got the output. Yes, exactly. Okay, so Pushkar, what you are not following, just let me and Saurabh. Okay, so Pushkar, where are you basically now? Have you landed up on this screen? So basically, you need to click. You have created a terminal 3. Yes, Savan, it is fine. Yes, Srishti. So Pushkar, what you need to do is you have created a particular this Python notebook, right? When you click on this notebook, so this screen will open up in your browser. Okay. So the issue is with you is Saurav is that, okay, why it is not showing print hello world? I tell you. Okay. So all of you guys just look at my screen. So I'm trying to teach you. So this is your print hello world. So you have successfully executed. Okay. So now let's try to see these buttons. So this is what is this save, right? If you wanted to save this file. So you don't need to again and again save this file. Automatically it will save, right? So the last checkpoint is 9 minutes ago, right? When you try to write something, either you can click on the save button and try to save this, right? Now it is say that checkpoint 2 seconds ago, right? This is your insert or run. This is your cut, right? This is your copy. If I try to copy this, right? This is your paste, right? This is your run. This is your stop. Fine, right? And this is your restart. If you wanted to restart, let's say some issue happened, right? You are stuck, your program got stuck, so you can restart it, or you can stop it or restart it. Okay. Now the issue with Saurav is that, so here it is raw. If you try to make this raw and try to it, nothing will happen, right? Only at code it will try to run it. Saurav, if you can check this drop down and then you can make it at code, then only it will work. Are you getting my point? Okay, so just try to click on this drop down, that is code, and then run it. So make sure if your program, you are trying to run this program and it is on the raw, it will not work, guys, right? So this is your editor, guys. So just first, if you try to work with something, some tools, first you need to get to know that tool better. Then only you need to work it, right? So this is what I'm trying to teach you, that this you can just make this happen. Okay, so let's try to do something as do markdown. So let's say I'm trying to click on this markdown and I will try to write first hello world program, right? And try to run it. So what will happen, right? So it is a markdown. Markdown in the sense I wanted to show you something, right? So this is my first hello world program. So at the later stages, so I can just click a heading in the heading, and here I could write it again, print hello world, and just click on the run button. So this is print. So this is only for the description, guys, right? So this is how these cells are interactive to learn. If you are trying to learn some topic, you can just write it here, or some documentation you can give it, right? and then you can save it, and then you can create a PDF and then show it to others. So this is only for the documentation purpose. So what you are trying to write below these cells. Got it? So this is code markdown. So how this will happen? It will the only for the code your code will run. But for the markdown, you can just put a double hash or triple hash and try to run it, and it will try to work it. Just let me know if anyone is facing any issue, because these are some prerequisite, guys, right? So if you haven't got run your first hello world program, because now from now onwards, so we will be working on this editor only, right? So I would be explaining you practically. So this is what is practical, is that all the things I would be teaching here itself only. Yes, Python is case sensitive. Yes, yes, yes. If you try to write here P with the P capital, it will not work, guys. Right, right. So now let's try to see the error also, guys. Right? Let's say if in some cases you got an error, so you need to see the error and learn that what this error is. So it is trying to say that it is a name error, right? Just by looking at the error only, you will try to say that in this cell number 11, line number 1, I am trying to get this line. In this line, there is something wrong, right? And after that, it is saying that name print is not defined. Yes, exactly. Print is not defined because Python does not recognize what is print. We have made a P capital, so that is why Python is not recognized. So these are some inbuilt modules or inbuilt functions, what we call is, that Python has provided us. You can see this inbuilt. Your color has changed. So color is green. Here your color is black. This means this Python does not know what this print is. But here green, it is inbuilt function of Python. So that is what it knows. Right? I hope everyone is clear with this first hello world program and a little introduction about Jupyter. So here we can just run it, the cells, stop it. There is code, markdown. Okay. After that, we have your file in which we can create a new file. Right? We can go to the console, we can go to the terminal. So these, all the things you can try it off your own, right? So in this, I will try to tell you, right? Okay. So raw is basically, it will also not run. If I try to run it raw, let's say I'll try to go it raw. So now you can see that. So it is basically a raw, right? So nothing will happen. Okay. So raw code, raw instance. Markdown is for like, let's say these commands will run. Raw is basically your raw text. This is what it is saying. So okay, right? Okay. So any doubt up till now, because we need to move to your variables, data types, and other things, right? So I guess everyone is clear with this first hello world program in Jupyter Notebook. Okay, Srishti, thank you. Anyone else facing any issue? So okay, Soumya, everyone just gives okay, thumbs up so that I could work with it. Anyone facing issue? Pushkar. So Deepak, raw is just basically a raw text. Okay, so like the thing is that like basically they have given us the code markdown and raw. If you don't want your cells to get executed, okay, so there is a raw. Basically that is the purpose. Navigator only is not working. Okay, so your navigator is not working. Basically, I think there's some issue with your navigator, I guess. Maybe you can share your screen, or you can just do a snapshot. Okay. So from the navigator only, you need to launch the Jupyter, basically. Okay. This we already done. Okay. So now Jupyter Lab, Jupyter Notebooks. Also, the Jupyter can be accessed through 3 environments. Could be accessed through Jupyter Lab, Jupyter Notebook, and Boiler. Okay. So we be working on only Jupyter Notebooks. Okay. So Lab is also a similar kind of experience in which you could extend multiple notebooks or make a bigger project, right? So for the time being, so we will not focus on Jupyter Lab. We will focus on Jupyter Notebook because we are trying to learn the concepts in Python. Okay, right? So we have successfully done our first hello world program in Python, right? Okay, so in print, so what we have learned in print is a function. How we'll try to recognize the function by the how will we recognize whether print is a function? Because it has got parentheses, brackets, right? Print bracket, and we have something written inside your print statement. Okay, so these inside has to be a string, is to be a double quotes. So starting also and ending also, right? So that is how your print will work. Inside your print is a function which will take your input inside your quotes, double quotes, right? Fine. So what we have done, we have tried to open a new notebook in Jupyter and tried to execute the first hello world program. Okay, so let's try to understand and work with variables. So what I will do is I will try to take here variables and data types. And I will try to put here markdown and then I will try to run it. Right? Okay. So let's try to see a variable. So what is A here? A is the name of variable. Equal to, we have tried to assign the value 10 to the variable A. Make sense? A is a variable, name of the variable is A. We are trying to assign a value 10 to the variable, right? Okay. I try to execute it and I will try to say that print A, it is showing the value as 10, right? Okay. So let's say I try to change the value of A to, let's say, 120. And then again, I will try to print it. What is happening? The value doesn't change. Why? Can anyone tell me why the value of A hasn't changed? Yes, you got it right, Deepak. Anyone else? Yes. Until and unless you are trying to run, the value will not change. First, you need to run and execute and tell Python, I am trying to change the value of A to 120. Right? Until and unless you will not run, the value will not get reflected. After that, it will get reflected, and then you can see that the value of A is 120. Right? So this is what you are trying to say, that even if you try to write A equal to 120 and did not run it means the how does interpreter know? How does your system know or computer know that you have changed the value to 120? Then what it is an identifier. Variable is an identifier which will hold some information, and we are trying to hold some information in this A. Okay. Another thing, guys, if you are trying to read, so like most of the cases I've seen that students read in this manner, A is equal to 120, it means that A is holding a value of 120, right? So you will also try to interpret or understand that A is equal to 120. No, always try to interpret your coding from right to left. Right to left means that from 120, you will start with it and you will try to say that, okay, 120 is placed in a variable called A. So from right to left, always try to understand in this manner. Let's say at this point, I will try to change the value A to B, right? And then I will try to say that B equal to C. What will happen? A is having value B. So now you will try to see that B, the value which is having in B is being copied from B to A, right? The value which is having in C is being copied to B, right? So this is how you try to interpret it. Always try to interpret from right to left. That A 120 value, this variable A is holding, and it contains 120 in the variable called A. Understood? Got it? Okay. Right? So this is your variable A. Variable is an identifier which can hold some information. Okay, so let's move to this. Python identifier is a name used to identify a variable, function, class, module, or another object, right? So this variable, what we are trying to learn here, it could be used in your function also, in your class also. It's a name basically, right? Every one of you has having some particular name. Similarly, when you define your variable, it has got some name, even in function, even in class, right? Now it follows some rules in the sense, let's say you are trying to have your name, right? So you have your first name and your last name, or could be a middle name, right? Okay, so you cannot have your name as prime minister, because your prime minister, like no one, like prime minister is one, right? So you cannot have your president as a name, right? So these names are reserved names, basically we call it. Similarly, in Python also there could be some reserved names which you cannot take it. Okay, so let's say print is equal to 1. So print is a name which has already been taken, you can see, and you are trying to assign the value 1 to the print. Print is a variable and you are trying to assign the value. Print is already taken, you cannot have this variable, right? Even if you try to do this, then your print will not work. This is what you are trying to change. You are trying to change the functionality of the print statement, which is already been inbuilt in your Python. So whenever you are trying to write some variable, if the color is not black, you try to say that this is been inbuilt variable or inbuilt name, which has already been taken. Let's say I cannot take my name as prime minister, because prime minister is only one, right? So in that sense, like it will change the color to green. If the color says that print underscore a, let's say print a, yes, this is a valid name. Or print a, printa, right? So this is also a valid name. Print ina, right? So this is also valid name. Fine. So make sure that you doesn't clash with your inbuilt methods, functions, names, and the color you try to analyze or understand. Fine. So also there are some nomenclature to be followed in case of naming a variable. So letters in lowercase or uppercase are only allowed, and digits are only allowed, and underscore is only allowed. No special characters. Special characters, we can say that, like, these are some of the special characters which are not allowed in naming of the variable, right? Only underscore is allowed. Only A to Z or capital A to Z is allowed. Understood? Right? So if I say, if I wanted to have a variable called name equal to, let's say 123, or name equal to, let's say Vipul, right? So this is allowed. Name equal underscore 1, this is also allowed. Name 123, this is also allowed. Right? Fine. 123, this is not allowed. Right? First condition is that the naming of the variables, these special characters are not allowed. Only underscore and alphabets are allowed. It cannot start with, right? So these are the three conditions in which we need to follow while naming a variable. Fine? Right? An identifier cannot start with a digit. It can be of having of any length. Special symbols like hash, dollar, percentage cannot be used as a identifier. Keywords like global and class cannot be used as identifiers. And Python is case sensitive, right? Case sensitive in the sense, as someone has also asked, that it is whether it is a case sensitive. Yes, it is a case sensitive, because if I try to say that a equal to 10, right, and equal, I say that a equal to 15, right? So these two are separate identifiers, separate names, right? Fine. So if I try to say print a, it will give me 10. And if I try to say print A with a capital, it will try to give me 12. So now 3 things you need to keep in mind, that if you are trying to name a variable, it will start only with an alphabet. It cannot start with a number, right? Underscore is allowed, alphabet is allowed, but the special characters are not allowed. Fine. These 3 rules, did you follow in naming of the variable? Yes, no? Variable and data types part, which can I return to make that bold? I didn't get you. This variable. So variables. Okay, so please pay attention, guys. So A is a variable which is holding some information. Okay, so there are some certain constants in naming a variable. It cannot start with your special characters. Only underscore is allowed, and your alphabets are allowed, whether it is a lowercase or a uppercase. It is case sensitive. Case sensitive means that A equal to 10 and capital A equal to 12. So these are different variables, right? If I try to start with a number, it will give me the error, right? So this is what I have told you, that what is a variable, right? So valid identifiers are my class, var equal to 1, count, right? So these are some valid identifiers which you can have it, or naming of the variable. Invalid, one variable, you start with the 1. Class underscore new, right? Under at the rate is not allowed. Global is a keyword. Okay, so let us try to do this in practice. So let us try to see that if I try to say name 1 equal to, let's say, ABC, right? So this is valid because it got executed and it doesn't give me error. If I try to say that one name equal to ABC, right? So invalid decimal literal. It is trying to say that in the name, 1 is coming, right? We are violating the, it cannot start with a number. 1, 2, 3 equal to sign to expression here. Maybe you meant is instead of this. It means that at the rate is not allowed, right? Because it is a special. So these are some of the constants in which we try to name a variable. Fine, understood? Then if I try to say global equal to, now you can see that the color changes, green. You cannot name a variable with the inbuilt keywords. So these are some of the inbuilt keywords. Now the question arises, like, how do I know it is an inbuilt keyword? Right? So when you are trying to learn Python, automatically you will try to get it that these are some of the words which are already taken in. Right? So let's say when someone like when a child is born, okay, so we need to have that name of that child. So we know that like prime minister, president. So these are the names which already like are globally taken. So we cannot have that name. So similarly, when you are working with Python, automatically you will try to learn. Okay, so these are lists, these are string. So these are some names which I don't need to keep it as a valid name for my variable nomenclature, right? And another thing is that the color will change. So now the color is your green, right? So it means that it is already been taken, right? And if you try to run it, and your program might not work. It will behave in a vague manner, right? Because you are trying to change the functionality. Understood? So this is your naming of the variables. So Sweta, I tried to put a shift plus enter, right? So there's a shortcut key. Yes, you can run it here. You can see what are your shortcut keys, and then you can run it, right? So instead of going again and again to your run button, you can quickly type shift enter and then you can run. Right? Okay. Any other questions? Any other doubts? This indentation I will try to tell you in a few minutes later. Okay. So first we'll talk about what are comments. Okay. So let's say I try to run some few statements. Shortcuts, you can go into here, run cell, and you can explore here, right? Okay, A equal to 10, B equal to 15, and C equal to 20, right? So these are some of the statements I have run it, right? Okay, so then I will try to say that print A equal to, so now you can see that A equal to 10, B equal to 10, B equal to 14, and C equal to 10. So let's say in your question, in while doing your programming, so you don't want that this be will get executed. So you can just directly put a hash, and in this hash, this statement will not get executed. Okay, if this statement will not get executed here, the Python will not know what was present in B. Okay, it will give you error. Okay, so similarly, I need to comment this also. So now you can see that the Python, when it will execute instructions one by one, let's say it will try to go with this instruction, right? It will say, okay, assign 10 to the variable A. Then it will go to this instruction. But here it is hash it encountered. So it will skip this instruction. It will not get executed, right? Then it will go, it is a blank space. It will blank space. Again, it will go. So 30 will get stored in a variable called C. Then blank space. Then it will say, oh, okay, it is a function. Okay, it will go to that function and it will say, okay, A equal to and A. So what this function will do, it will try to print on the screen. Now A will get printed. Again, it will go to this statement. It is a hash. It will skip this. Again, it will go to C, print this thing, and it will get printed. So this step-by-step execution will happen when you are trying to run your program. Fine. So there are comments. So this is your comment. So by hash, you are trying to comment it. Yes, yes, Saurabh. Right. And in some cases, if you try to comment multiple lines, let's say I wanted to comment line from here to here. So Deepak, it is just for the showing part that A equal to 10. So whatever it is present here, it will be, let's say we are trying to write here something, right? So it got executed and displayed on the screen. And here A is the value of 10, right? So this is for your own reference that we are trying to show in a better format that what A is. I have got A, B, and C and showed you the values also. But it looks nice that A equal to 10, B equal to 20, and C equal to 30, right? So this way I'm trying to show you that you can write your own statements here also, right? Okay. So what I was trying to tell you, there is single line comment. If you're trying to skip one line, this is via hash. And if multiple statement, and there is three single quotes. Up till here, you wanted to do here. Let's say up till here, right? And after that also here and here. First, you need to open up and then you need to close it up. And then you try to run it by a shift enter. And here you can see that A equal to 10, right? Then print A equal to B. So now what I've done is, so these are the statements which I try to comment it. So this is for the multiple comments. So why multiple comments, like multi-line comments? Because every time you need to comment this line, you need to put a hash in front of each and every line. So instead of doing this, you can just, these 4 lines you need to comment it. So just put a triple quotes here in the starting and in the ending. After that, you can write your step. So this is what your single line and multi-line comments work. Are you guys clear with it? Single line and multi-line comments? Yes, no? Okay, so comments are annotations in the source code of the computer program. So comments make it easy for the human to understand the source code, right? So this is a comment. So you can write your own instruction also. This is a comment and then you can execute. But if you don't want that this statement is executed, so you can put a comment also, right? So if the comment starts with hash, the rest of the line is not executed, guys. Fine. Okay. So Python is an interpreted language and it is very powerful language, right? And we have used editors, right? Okay. Now the knowledge check. So Python was invented by A. Gaudio Van Rosa, Dennis, Mac Alistair Ritchie, James Gosling, or none of the above. Okay, so everyone is fine that it was invented by Gaudio Van Rosa. Another question. The advantages of Python are flexible, easy to use, readability, all of the above. Very good. So the answer is D, all of the above. Python code can be written in any text editor and saved using dash extension in the system. .py text, .python, .py, all of the above. Yes, your guys correct. It is .py, right? Okay, fine. So now we move to our next session. Okay, so I hope everyone is clear with this, guys, right? Because now the complexity will increase. So now what I'm trying to teach you is variables. So we have worked with the variables and we are trying to understand what is the variable and how this variable work, right? Similarly, now we are working with data types. Okay, up till here, any questions, any doubts you are trying to have, just let me know before we proceed further. Or you are having no doubts? Yes, no. Should I proceed further? Yes. Just type yes. Fine. Okay. Fine. Okay. So now here, what we have done is we have tried to understand the variables. So variable, what is a variable? Is an identifier. No, it will not work, Deepak. So if you try to say that, like let's say this statement in the start and this statement in the end, it will not work. So this is a single line comment. Single line means that whatever you are trying to write here, only that line will be commented. Only that line, right? So that is specifically I've told you for the multi-line that you need to put a three dots, three colons, three single quotes, and here also three single quotes. That from this line to this line, all the code will be commented and it will not be executed. Yes, got it? Okay. So before moving on, so let us try to understand what are data types. Okay, so data types. So what are the typical data types that is used in Python? So data types that we are using in Python is your integer, right? Numeric alphabet, yes, exactly. Integer is your numbers, right? 0, 1, 2, right? Right. So these are your numbers, real numbers, we call it. Then we have your floating point numbers, which is your decimal point. That 1.00, take a 2 point, right? Or 0.00, right? So these are your floating point numbers. Then we have your Boolean, right? We call it as a bool. Short form is bool, right? And this is your basically true or either false. Guys, remember, true with a T capital, false with the F capital. Fine, right? Then we have a string. String, what we have inside your quotes, which is your single quote or double quote. So these are your primitive data types in Python, which are being widely used. Then we will talk about your list, tuple, dictionary, right? Sets, frozen sets, right? Fine. So these are other data types which are used, but the primitive data types or the primary data types are your integer, float, boolean, and string. So there is another data type called as complex also, right? So that we don't use, right? In that we don't use in the sense like these. I have, in my experience, I have never used maybe complex in terms of this real and imaginary part. So that we are trying to use it. But in my experience, to be very frank with you, I haven't used any complex data type in my entire career. Fine. So these are the widely used data types which are used in Python. That is your integer, float, boolean, and your string. So let us try to understand and try to see like what these data types are all about. Right. So let's say I wanted to give any person a name. What kind of a data type you would suggest? Yes, no. What kind of a data type you would suggest? String. Exactly. Yes. So how do you write a string? With the quote. First of all, you will try to put a single quote that you will say that name is Amit, right? You will try to run it and you will say that print name. right? So print is your Amit, name is your Amit. So this is your data type is your string. Let's say I wanted to get the age. What data type do you suggest? Integer. Yes, exactly. So age is 30. Then I would say print age. So guys, let's say in future you are trying to work with your data or the Excel or the CSV, right? So in that case, you are trying to identify that this is your name field. This is your, let's say, age field. So in the age field or the name field, so these are the data types you need to convert it. Until unless you don't convert it, so like your program will not run. Fine. So these are the data types you need to do it. Then you have a data type, another data type with your floor, which is your salary. Let's say salary. Salary is your, let's say, this is your floating point, 120.22, right? So this is your float. Is working is your variable where we call it as a true and false. So remember, guys, I have given the variable names a valid name. So try to give the variable names as valid, right? What does it indicate? It indicates that some person name is there in this variable. Some person age is there, right? Try to be a meaningful. Try to be a short and crisp, right? And follow a particular nomenclature. So here you can see that I have followed a nomenclature that is working. Is working could be a true and false only. I could write in a in some camel case nomenclature also. I could write here something like this is underscore working, right? Or I could write here is underscore working, right? So this is your nomenclature. So any nomenclature you can follow. This is up to you, but it should be readable. If someone else is looking at your code and it is saying that okay, so this code here in this particular variable name salary would be there. Don't what if I try to write here as a equal to 120, what will happen? I don't know that this 120 is a salary. It is a number. It is a height of a person. What does it mean? Right? So it doesn't mean anything. It could be anything. But if you try to write salary, this means that this person is holding salary information, right? Okay. So this is your Boolean, true and false. Understood? So make the variable names concise and meaningful and readable so that other person can also. Don't try to make it as A, B, C, X, Y, Z. So this is the wrong practice, right, guys? Okay, so this is your integer, float, Boolean, right? So these are the basic data types that we have used. Okay, so now let us try to understand. This is my variable and I put the salary as 1,20,000, right? So what is the data type of this, guys? Right? So basically, there is nothing called as text. You are working with Python. Okay, so these are the only data types I know: integer, float, bool, or string. Okay, right? So don't try to say something that which is not present. Okay. So some say it is a string, some say it is a integer. Okay. Then how do I evaluate whether this is a string or you guys are telling correctly or not? There has to be some mechanism in which Python itself tell me that whether this salary is holding information of a string data type or an integer data type. Okay. So it has to be some method. So that function is your type. Type data type. What data type this salary holds, you put that information inside your variable name inside your type. So this is a function because it has got brackets. It is called as a function. It is an inbuilt function because it is already provided by Python, right? And then you try to write it. Then you try to execute it. So it will take string str, which is a string. So if you are trying to work with any of the data type and you don't know that this data type is your integer or a boolean, you need to check it. So then you can check it by using your type command. Similarly, if I try to want to check the name, so this is your string. If I wanted to check your age, integer. If I wanted to check for salary, this is your float. And is working, we have done it, is not defined. So it is not defined means that we have not run that particular cell. Let's try to run it and try to see. Yes, it is a bool. So these all are data types. And we have identified that whether this data type is your like string or integer or boolean or so on. So right? Fine. Understood up till here? Then what data types we are working with? Yes, no? Yes, I'll give you 2 minutes to practice. Okay. So just create some variables, name, age, salary, and just try to check what are the data types of that variable by using your type command. Okay. And you can also do something like this, print. My name is, right? Comma, and you can put a name variable to it. Then you can put like this, my age is. I think salary actually, okay, got it. So because I like this was salary and later on I changed to A. So that is the case. So that A equal to 120 doesn't run, Deepak, basically. Right? So that is the confusion. I was trying to explain you that you cannot have a variable name as A, B, C or X, Y, Z. So this was right. Okay. So what? Yes. So I was trying to say that my name is this thing, my age is this, right? So you can just say it something like this, right? My salary is fine. So this is how you can write multiple statements and then make your program effective. So let's try to now see the next part, which is your decision control structures in Python. Fine. Before decision control, so let me try to give you print is assigned as a variable instead of inbuilt function. Print is assigned variable instead of inbuilt function. So I didn't get you, Deepak. What you're trying to say? Print is an inbuilt function, not a variable. So here you have your print, right, which is an inbuilt function, right, and it is being assigned. It is a name, basically a function name is print, right? No, this print salary you haven't executed. I guess something is wrong. So it has to be in this thing. Okay, so basically what you are trying to say that print, if you try to put here a raw, so you see that it is in black color. So maybe this code or markdown you have a issue with that. So that is why it is giving you in the black color. Okay, fine. Okay, so what I was trying to tell you guys. So data types. So we have your scalar, integer, float, boolean, and your complex, right? So these are the types of data types which we have. So another types of data types which we have the aggregated data, that is your string. So string is a sequence of characters that is your beginning with either double quotes or single quote. Whatever it is present in your single or double quotes, so that is your string. So that is why explicitly I made a salary equal to double quotes 1,20,000. So basically the thing is that don't confuse if your inside that part is a boolean, it is a string, it is a integer, it is a float, doesn't matter. Whatever it is present inside your quotes, that is treated as a string, right? Okay. And the data type of any object is checked by using the inbuilt function type, which is your type. So we have already seen that, right? So then the another data types, what we see is your set, list, tuple, and dictionaries. So these are basically different formats of the data, right? So this is your data types, which is your primitive data types, what we call is integer, float, boolean, and the aggregated data could be have your string, sets, list, tuple, or dictionary. Fine. So this will cover in coming lectures, right? So let's try to cover the control statements and your this thing. So after that, we will try to look upon what is string and sets list, tuple, and dictionary. Right? Fine. Scalar data. Scalar data presents a single value, that is integer 42. We are trying to print the integer. Float, we are trying to print the float. Boolean, we are trying to print the Boolean value, which is your true or false. So remember guys, Boolean equal to true, which is your T capital, right? So let's say if I try to, this is the learners make, if I try to put it as true, so it is not defined basically. So it has to be true as capital, and you see that the color is changed. It is an inbuilt, right? Inbuilt variable name which is already been taken true. So true, if you try to put it, it will not be acceptable, right? Also, if you try to put it under quotes, so this will yield a data type which is a string because it is inside your quotes. Understood? Even if you try to write something, this is all your string. It doesn't matter. If I try to print is working, now you can see that everything, because it is inside your code. So inside your codes, you can write anything. Fine, right? So this is your data type, which is your string data type. Okay, similarly, integer, float, boolean. Then we have your complex and real part. So the complex part is 3 plus 4j. The real is your complex dot real, and imaginary is your complex dot imaginary. By the dot keyword, we can get the real part, that is 3, and by using dot imag, we can get the imaginary, right? Similarly, we can put this. So guys, this imaginary and real part I haven't used in my career because this works with some mathematical functions, and if you want, you can try it out, right? Okay. Then we have the aggregated data. So this will work. This is your sets, list, and your string. Okay. So let us try to understand what is your list and what is your set. Okay. String we already known that it is a sequence of characters which is enclosed in either a single quote and a double. And what is a list? So let's try to understand what is a list, right? So list, I could name a variable called my list, and I would get put a bracket. So list is basically a basket. You go to a shopping mall, like you put a basket or a packet in which you put some items. Okay. So this is your empty basket. If I try to say that this is your empty list or empty basket, and I wanted to know what is the data type of this variable my list, I could simply type keyword and I would say my list. What will happen? The data type is your list, right? Fine. So when you try to put a empty bracket with the square bracket, this is represents your empty list. Now I wanted to put some items in my list. Okay. So what items I can put in the list? What are the data types I can put? Numbers, yes. Sudhi, yes, you are correct. Anyone else? String, yes. Pooja, you are also correct. Right. So in these data types, what we have understood is that we can put integer, we can put float, we can put boolean, right? Okay. Yes, and we can put your string also, right? So this we have understood. So let us try to put one by one all these values to your my list, right? So what I will do, I will try to put Amit, salary, I will put height, or right. Then I will put your is working or not, true, right? Right. String, boolean, and your float. This all I have put it. So this is your my list. If I try to print your my list, what you will see? You will see these are the items which are present in your list. So it is a bag, right? And in the sequence, in what sequence you will put it, in that only sequence it will try to give you that output. Let's say, Amit, you have entered at first position, at the second position you have entered this integer, at the third position there is a floating point value, at the fourth position is your this thing, your boolean value, true or false, right? So basically what you are trying to do is you are trying to put values and in a sequential manner one by one, and it gets printed as it. Fine. Okay, so this is your list in which you can put the items into it. Fine. So this is your list in which you can put items, which is an ordered collection of items or which could be of different data types. Similarly, you can have a list of numbers also, list of integers also. Let's say I could put a 1, 2, 3, 4, 5, and I could put a bracket here. So this is a list in which you are trying to put an list of items, right? Okay, so now one question, guys. What is the difference between array and a list? This is most commonly asked question. Like, what is the difference between array and a list? List has one row. Okay. An array. What do you mean by row? Like, difference between array and a list. So in array and a list, the basic difference is that in the list you can have multiple data types, as we have already seen, right? Okay, so an array could become a list in that. So list array can become list could become an array in that sense where you have the same data types. So this is your array of numbers. It is a list. Obviously, it is a list because data type is list. But we can call it an array because it is an array of numbers, right? A list of numbers is called an array. We can say that list of a similar data type we call is as an array, right? Fine. It could be a similar data type, could be a float, it could be an boolean, right? It could be a string, right? So that we call it. Fine. So this is your list. Then we have a set. So set is an unordered collection of unique items. Let's say I wanted to have a set is equal to this thing, right? Fine. And if I try to say type, right, it will become dict, right? So I will try to put here, right? So the reason I showed you that my set equal to this thing, right, is similar because I showed you that my list equal to this. You can create a list. You cannot create an empty list in such a manner because by default it will give you a dictionary. So set, you need to put a set constructor and put a bracket. Here you will try to put a set which is of empty set, right? So now set is your empty. This is your set which is empty. And you can put this collection as 1, 2, 3. And if you put duplicate items in this set, what will happen? It will try to filter out those items only and give you only the unique items. Fine. So in the list, you can have duplicate items, but in the set, you cannot have duplicate items. Lists are ordered, sets are unordered. Let's say if I here try to write some name, and I will try to print it. So here you can see that even if I try to write in a sequence that 1, 2, 3, 2, it is unordered. One comes after this thing, right? 2, 3, Ashish and Vipul, right? Fine. So you never know like what order it will become, right? It is an unordered list. But if you try to put items in the my list as Amit 1,20,000 this thing, so it will come in those sequence only, right? Amit as first position, this is at second, this is at third. But here you cannot guarantee what position it will come. And it will also offer uniqueness. Uniqueness in the sense that it will just remove the duplicate entries and only the unique items will be given or entered as a set, right? And the syntax is that you can create a set by using a constructor, right? So I hope guys everyone is doing it side by side. Okay, okay, fine. I'll share this at the end. Okay, this notebook. Fine. Okay. Another thing I forgot to mention, right? In this Jupyter notebook, you need to save your file, right? So when you are trying to save your file, Jupyter notebook, it got your extension as I, P, Y, and B. What does it mean? Interactive. I stands for interactive. PY stands for Python. NB stands for notebook. So it is an interactive Python PY notebook, right? So you can save it as a Python lecture 2 and save, right? So now Python lecture 2, it has been saved, right? So this is your ordered collection. This is your in-ordered collection. This is your set, fine? So we have studied sets, list, and your string. Then we have a tuple, right? So tuple, what does tuple does, right? Let's say I will try to create a tuple, my tuple, and the tuple similar to your this thing, with the same items what you have put it in the same, will try to copy it, but only the syntax change. Like we are trying to put a bracket here, right? And now I will try to print my tab, right? So list is also an ordered collection and tuple is an ordered collection also, right? Then what is the difference between a tuple and a list? Can anyone tell me? Coming with brackets, yes, exactly, yes, yes. And okay, so the difference between tuple and your list is that, so what do you mean by mutable and immutable? So let us try to understand this. So in your list, let's say I have my list, okay? So in this list at 0th position, there is an item consisting of 1, right? I can change this position to, let's say, 2, right? Right? So let's say in a basket, you have two different baskets. One is for tuple, one is for list, and you have put the same item to that, right? In your list, once your item has been put it down in your basket, right? There is a stack. Stack in the sense, so there is shelves. So in your basket, there are shelves. In one shelf, 2, 3, and 4, right? Something like that. Like let's say 1, 2, 3, 4, and 5, and 6, right? So there are 6 items in your basket, starting from 0. 0, 1, 2, 3, 4, and 5. So I put 0 at 0th place, 2 item, first place 2 item, third place, second place 3 item, and so on. So at the position 0, I can replace or change. I can put something else to it. I have the liberty, right? Right. So I can change it. But similarly, if you try to do the same thing with the tuple, you cannot do it. You cannot change or modify. Once the item has been put into a tuple, you cannot change or modify or cannot remove it. So this is the difference between your list and tuple. So consider it as these guys, like you are trying to go to a market by using your two different baskets. One is your list and one is your tuple. In the list, if you pick some item and put it, you can replace, modify, or change. Let's say you put a jar of, let's say, jam, right? And you can just say that, okay, so this jam I don't want, I can just replace it. But in the tuple basket, if you put a jam basket, you cannot remove it. Once it is goes to, it is being locked. Understood? So this is the only difference between your tuple and your list. Mutable. Mutable means which is subjective to change. I can change the item. I can modify it. Right? Mutability. Right? If you go to someone else, you adapt yourself. Right? These are the natures of human being, in which at every condition, at every temperature, your human beings can reside. Right? But there are some creatures, some persons which cannot change themselves. They are immutable, which is your tuple, right? So another thing to remember, that when you are trying to go to a bank, right, and say that, okay, you can change the bank account. So in at some place your bank manager is friendly with you. They can change some of the details, right? But in some place there are some government employees which they are not very friendly. They are immutable, right? So they are tuple, right? Understood the difference between tuples and list? Yes, no? Okay. So another part is that like we have dictionary. So dictionary are unordered collection of key value pairs. So here we can put a name and a value, name, value, name and a value, right? So here in the dictionary part, so we have an name and value. So let's say the same thing we wanted to put. So I will say my dict equal to this. So this creates an empty dictionary. And I will put a type and I will put my dict and it's a dictionary, right? So in this my dictionary, the same items, right? Let's say name, age, salary, and is working. I could put it by using a key value. Let's say I put a name. It could be your Amit, right? Then I put a comma. Then I could put a salary, colon. I could put. Then I could put height. Then I could put is working, right? And close it. This is basically your dictionary. And if I try to print that dictionary, I could say this is your dictionary. Fine. So this is your dictionary. Okay. So these are the data types which we are trying to study. So first we have studied there are primitive data types, integer, floating point values, then boolean, and then we have the list which is being ordered collection of items. We could have duplicate items in our list also, right? And then we talk about set. The set we cannot have duplicate items, right? It is unordered. Unordered means that the ordering it will try to give you a different order. The order which you have written in my set, it will not give you that exact ordering of the items. Tuple, on the other hand, my sets are having duplicates. Where you are trying to see the duplicates, Bhumika? This is my set, and this is. Are you able to see any duplicate item here? Okay, I think no. Okay, so in the tuple, we are trying to have the items in a tuple, right? But we cannot change that items. Fine. So lists are mutable, tuples are immutable, right? And now we have dictionary. That is another data type where we could have it as a key. So this name is a key, salary is a key, followed by a colon, which is value, followed by a colon, which is value. So this my dict is very important in which we are working with your this thing, your CSV part, where name is the name of the column, and here I could simply put a list and put different names. Let's say comma Vipul, right? Then I comma Sunil and close the bracket. Salary, right? Height, right? So now you are trying to relate the CSV file format. Is working, false, is not working, is true, is working. So what we have done is name is the name of the column which you are working with the CSV, and these contains all the entries in the column. These is the name of the column. These are all the entries in the column. This is the name of the column. These is all the entries. Fine, right? So this is how your dictionary is being a data structure which is very efficient, which is very convenient to use and work with. Okay, so Bhumika, your sets are having duplicates. It can't be actually. Okay, my set, I have tried to create a set with the set, and when I try to keep the set, just check it. It can't be. If you are facing, just let me know and share your this thing. share with me the snapshot. Okay. So Amit, Sunil here. Okay, I forgot to put a comma here. Actually, right. So when I try to print, you can see it, right? So this is how your data structure is being organized and taken into your Python with the help of, like, we are trying to get the data from. Now you can understand and relate practical relationship, that whether it is a name, whether it is an age, whether it is how many items he has purchased, right? And what sort of occupation does the person holds, right? You can take all the fields and then you can do some data analysis and cleaning and all sort of things what we have discussed yesterday, right? By using these particular fields. Once you get the data inside your Python, then you can perform multiple operations and work on your data. Are you getting my point? Yes, no? Up till now, is anyone having any doubts? Anything they want me to repeat, I can repeat. So these are the basic data types. Just let me know. Or we can proceed further. Yes, no? Guys, should I proceed further? Yes. So in dictionary, why can't we give after name instead of colon? Okay. So Deepak, so actually the thing is that this is the data structure which is framed in this manner. Okay. I got your point that why it is not colon or equal to, right? It could be. It is like the designer, which was the guy who's invented this type of structure. So they have made it structure according to like colon, right? So this is basically a syntax that we need to follow, right? So any other questions? Any other doubts? Yes, Arpita. How to access the values name under name in dict? Yes, yes, Sudhir, I will tell you. Yes. Any other questions? So this is basic introduction about all the data types I have touched on, but in depth I will try to cover slowly, because if I try to give you a lot of information so that you cannot digest it right now, right? So this is the case, like I'm trying to give you uh why does the why does it print with brackets? Because because this is your dictionary. I have told all my dictionary to get printed. So now, like, it is trying to print all the dictionary, whatever values it present. Similarly, in list also, it is trying to print with the bracket. And here it is tuple, right? So you can get all the information here, like it is there. Okay, so Python variables, as I already told you, so Python is a variable. Variable is an identifier which holds some information. So here, this is the repeat in which we got it. So let's say x equal to 34. This x contains some ID, identifier, right, which is holding the information 34, which is a integer, and that has some ID. So you can see here, this is some kind of an ID. Fine. So this ID is basically, we are trying to say that x and y are trying to refer to the same ID, same storage location, because it considers the value 34, right? X equal to 34, y equal to 34, and this ID x and y are same. So you can see the identifiers are same because they point to the same memory location. If I try to say x equal to 34, y equal to 78, these IDs are different because they are pointing to different storage location, right? So these references can be verified by using the ID function. Okay, so ID is a function in which will try to tell you that where this, at your memory location inside your hardware at this particular point of location, this variable or this variable is storing this information, right? So this is your ID function. Let us try to quickly see. Let's say if I try to say that x equal to 23, and I will try to print the ID of x. right? So this is the identifier, this is the value, this is the in story location. 23 is being contained here, right? If I try to say that x equal to y equal to x, and if I try to say print id of y, print, right? Same, right? Instead of that, if I try to say that y equal to 34, and then I will try to check it, you can say that the ID has been changed. Fine. So this is how ID works. Okay. So now we'll try to work with operators. Okay. So now what we have done till now, so we have covered your data types. Sir, have you defined X prior? Yes. I hope Deepak it's clear, right? Okay. So till now, what we have done is we have tried to do your variables, naming of the variables. Then we talked about our print statement. Then we talked about data types. There are various data types, and I give you a touch upon all the data types, right? So the questions like how we can access the data types, the name, and this part, how we can get more into it. So I will talk after this, like when we try to cover the operators and their control statements. Then we will try to in touch upon in depth with this tuple, dictionary, and your list. Now we'll work upon the operators. So operators are special symbols or keywords that perform computations, right? So let's say there are different types of operators, which is your arithmetic operator, assignment operator, comparison, logical operators, and there are miscellaneous operators which are used in Python. So let us talk about the arithmetic operators. So these operators we have been using since our class like 2 or 3, right? So we have the plus for the addition, minus for the subtraction, star for the multiplication, slash with for the division, and this operator is called as modulo, right? This I will try to explain you. This could be a new operator to you. Then this is also a new operator, which is your integer divide, right? Which is a double slash. Then exponent, which is double star. So let us try to see first the basic operators, plus, minus, division, and your multiplication in practice. So let us take two variables a and b. So a equal to 10, b equal to 12. So I will try to say that print a plus b equal to, then I will try to say a plus b, right? The value of a plus b is equal to 20. Simply I have told a plus b is equal to 22. It added those operators, is values, and gave me the result. Here, if I try to say that a minus, and here I put minus, it is minus 2, right? If I try to say that a multiplication, then it will give me a into b. Similarly, if I try to get it a divided by b, and here I put a division, now you can get a division of a divided by b. It is 0.0.83333, right? This is the division. Remember, the division will occur. The output of the division will always occur in float. Even if I change the values to, let's say, b equal to 5, if I try to say that, I will try to change it. So you can see that the answer is not 2, it is 2.0. Okay, right? Always the value of this would be 2.0. Output of a division is always float. This you need to remember. Okay. In some cases, I don't want this output to be float. I want to have the output as an integer. What I will do is I will try to put a double slash instead of single slash. it will give and result me in the integer. So now you can see that it is integer. So this what we were trying to see, this integer divide. When I try to divide 50 by 4, it will give me 12. Similarly, when I tried to divide a by b, it gave me 2, not 2.0. This is your division, which is also called integer divide or float division, we call it. Fine. Then another is your modulo. Modulo operator is very important, guys. It will give you the remainder, right? Let's say if I try to divide a modulo by b, right? If I try to divide a by b, a is 10, b is 5. 10 divided by b, 10 divided by 5 is 0. 0 means, right, the quotient is 2, the remainder is 0. If you try to divide 10 by 5, the quotient is 2 and the remainder is 0. Now the remainder is 0. So let's say if I try to change the value a to 11 and I divide it, the remainder is 1. Fine. So this is how we try to write a logic if we need to divide a number by another number and try to get the remainder. So this is known as modulo operator. Right? So then we have the exponent. Exponent is simply your power. If I wanted to, let's say, a is let's say 2 and b is let's say 5. I wanted to calculate 2 to the power 5. So what I will do is here, print, I will put a double star. Here also, a to the power b. I didn't run this, sorry, 32. Right? If 2 to the power 5 is 32. So you wanted to calculate the power. So here is what we are trying to calculate. So these are operators, arithmetic operators. So we can use it. Addition, subtraction, multiplication, division, float division, modulo operator, and exponent. I hope you are clear. Yes, no? Quickly try this and just let me know in the chat. What about others? Saurabh, Deepak. Okay. Fine. So these are your arithmetic operators. Right? So then we come to the assignment operators. Assignment operator is that equal to. So we have already talked about this. We are trying to assign value 10 to a. So this is always read from right to left. This is your assignment operator. Right? So assignment operator could be written in this manner also, right? That plus equal to. Plus equal to mean that we are trying to add a value. The last one, which one, Deepak? The operators or this exponent or this one? Assignment. Arithmetic operator. The exponent. Exponent is basically your 2 to the power 5. Let's say a to the power 5. A to the power b. Let's say 2 to the power 5. So 2 to the power 3 is 9. Oh, sorry, 8. Right? 2 into 2 into 2. Right? Similarly, if I try to say here 2 to the power 3 and here I will try to run it, so it will get 8. Got it? Yes, no? Fine. Okay. So in your assignment operator, so this I was trying to tell you, let's say I wanted to have a. So a equal to let's say 4. Right? So what I will do is a equal to a plus 1 if I try to do it. So now the new value of a, what is become 5. Right? So I just wanted to rewrite this statement for my use is that a plus equal to 1. right? If I try to say that A equal to 4, similar. So these two statements I have reframed it. So it is only in the framing part, only in the in some like this way also you can write it, this way also you can write. Why I'm trying to tell you, when you are trying to look at other person code, in that sense they have written something like this. So this makes you some confusion. So if you know that what this means, so that will clear your confusion. So basically what I'm trying to tell you, this thing and this thing are the same. If I try to do is A equal to 4 and A is equal to A plus 1. And now the new value of A is your 5. Right? So this is how you can write it. Similarly, if you wanted to subtract it, you can just write it here. If you wanted to multiply is, right, let's say I wanted to multiply it by 2 and then 8. So similarly, this will give you A is equal to A into 2, right? And if I put here divide, so it will give you A equal to A divided by 2. No, it will not take A plus as a variable. No, it will not take, right? Because it is like A plus equal to sign is there. We are trying to assign it. So this is basically, I got your point, Deepak. What you are trying to say is, like when I try to say A plus, so this A plus is a variable, right? So you are trying to say that. No. But if this operator comes together, it is treated as one only. Okay, either plus, equal to, or your multiplication or division, right? So it is treated as one only, right? Okay, so this is your similar operators. Comparison operators comes with your double equal to. So guys, this is very important. When you're trying to write A equal to 4, this means you are trying to assign 4 to A. But if you are trying to write A equal to 4, this what you are trying to do is you are trying to check whether the value of A is equal to 4 or not. Whether the identifier in which A is there, value if A holds is actually A, and it will give you value in a Boolean format, which is your true and false. Right? If I try to put 5, it will give you false. No, A does not have 4, it has 5. Right? So it is false basically. We are trying to check whether the A contains 4 or 5 or not. Right? This is your comparison. And this is an operator which is not equal to. Now instead of equal to, I will put not equal to. So this is your not equal to. Right? It is true. Yes, it is not equal to 5 because the value A holds is 4. Right? So these are your operators, which is your comparison operators, right? And these are your assignment operators. Understood? Yes, no? Yes? Proceed further. So now these are the comparison operators. So this also, I think you are well versed with. These are operators, which is your x is greater than y is greater than x, right? So these already you know. So let's quickly try to do this activity. Let's say A equal to 10 and B equal to 20. I will say A is greater than B. It is false. A is not greater than B. A is less than B. Yes, A is less than B. A is equal to B. False. It is not equal to B. A is not equal to B. Yes, A is not equal to B. Then A is less than or equal to B. Right? It is false. A is less than greater. Sorry, A is that was greater than. It was less than or equal to B. Yes, it is true. Right? So these are the operators which you already know. Fine. I think this is self-explanatory. So these things we have been using since our class second. Okay. So now comes the logical operators. The logical operators are and, or no. Okay. So for these logical operators, let us try to revise the truth table of and, or. Okay. So how do we try to write the truth table? Okay, so these are X, this is Y, and this is your result. Okay, so let us try to do it by using AND. Okay, so here what we will do, it is just true. The value is also in Y is true. What is the result? If both are true, just quickly tell me, guys. For the AND, it is true. Yes. Fine. If it is true and here it is false, what is the value? False. Right? Here it is false. Here it is true. What would be the value? False. And here we have false. Here we have false. What would be the value? False. Right? So this is the truth table for AND. AND means, let's say, if one of the condition is false, you have false. You need to have both the conditions true. Right? Right? So this X has to be true. Y is also true. Then only then this condition makes sense. Okay. Are you getting this point? So this is your AND. So AND comes with both the condition has to be true. Then only then your result will be true. Either it will be false. So let us try to quickly revise your OR truth table. Similarly, X, Y, and your result. Just quickly tell me, guys. True. Here also true. Yes. Here we have false. Here we have true. Here we will have true. Yes. Exactly. Here we have true. Here we have false. And here we have true. Similarly, we have false. We have false. And here we have false. So the truth table of OR is that if one of the condition is true, we will have true. So this is your truth table of AND and OR. Right? So let us try to see one by one in practice. Let's say A equal to 10 and your B equal to 20. Then let us try to see A greater than B and A equal to B. Okay. What would be the answer, guys? What is A greater than B? It is true or false? Okay. And what is A equal to B? False. And false and false. What it will be? False. Yes, exactly. So if I try to run single entry, let's say I will try to run A equal to B, or I'll try to show you the complete. It is false. So A equal to B is false and A equal to B is also false. Then we could say that false and false. So these are your AND operator and OR operator, right? Okay. So let us try to see. So this is OR and NOT. So NOT takes the opposite. If the condition is true, it will give you false. And if the condition is false, it will give you true. Fine. So these are the logical operators which is very useful when you are trying to run your programs. Understood? Are you clear with these logical operators, arithmetic operators, and assignment operators? Just give me yes, no, everyone. Yes, yes, guys. Okay. So now there are some miscellaneous operators, which is your is operator. So is operator is basically for to identify that whether these both of the variables are same or not. Right? Let's say in A we have entered some of the values. In B also we have entered some of the values. Whether A and B are same or not. Right? Fine. So A is having some information and B is also having some information. Fine. So whether is A is B or not, let's try to understand and run this. A is equal to 1, 2, 3, 4, and B is also having, let's say 1, 2. Okay. So let us try to understand this, what is happening at the background. Okay. Okay. So guys, memory allocation. Okay. Yes, because A is not equal to B. So you are right. You are closely to this part that why it is because of the memory allocation. Yes. So guys, let me try to understand this point, that when you are trying to learn Python, just try to understand like why this is happening, why it is not happening. Okay. And in some part, if you don't understand it, so you go to pythontutor.com. This is a very interactive thing to learn like what is happening at the background by some sort of visualization. Okay. So this is basically go to this and edit code and get this thing. Click on this. You go to this and edit code and get AI help. So click on this link. Okay, so you will get a sample program. So delete this and try to run your own. If you don't understand anything and if you are stuck somewhere, just go it, copy paste your code and try to see the visualization. Right? I'm repeating again for those guys, right, who have missed this. Go to pythontutor.com, click on this edit code. Fine. So now go to this edit code, and after going to this, like you can click and copy paste your code. I have copy paste that link into the chat. Right. Now you are trying to visualize this execution. What will happen? As it is an interpreter language, it will try to read the first instruction and execute it. So this is what happens at the background, guys. Right? So A, your cursor is here. It means this is the line which is going to execute. Okay, I will try to hit next. What it will happen? A variable A is got created, and it points to a list which is holding some information. A is the data type or the variable. Oh, sorry, A is the variable which is holding a data type called list, which contains some information, which is your integers, and it is placed at 0, 1, 2, and 3. Right? Another part, B is also another variable, right? And it is another list which is holding some information, and these two information are separately stored at separate locations. This means that A is not equal to B, guys. A is B, it is false. Fine. So A is B is false. If I try to run it and try to here write it, print, it will show me in the console. Fine. So this is a very interactive site in which if you try to understand what is happening at the background, you can just type your code here and just try to hit in the next button in which you get a visualization what is happening. Now here the output is false. Understood? Hope everyone is clear with this. Yes, no? Fine. So this is what is happening, right? So that is why I tell you that A is B is false. Similarly, A is not B, so you can see that it is true. Fine. If I try to see that here, I will try to here, right here, instead of I will say B equal to A, and then we'll try to visualize it. So what will happen? A and B are pointing to the same object, same memory location, which is your true, right? So here, if I try here that A not A is not B, so this is A is not B, which is false. Understood? Fine. So this is your miscellaneous operators we have covered. Then we have in operator also, in which we are trying to see that whether this 10 exists in this variable A, which is a list or not. Right? So in and not in. Whether 10 is not in A, right? It will give true and false. If it is present, it will give true. If it is not present, it will give false. Right? So this is your in operator. So let us try to understand in operator. Let's say A, let's say 1 in A. It is true. 1 is present in A. If I try to tell it 1, 10 in A, it will give me false. If I say that 1 not in A, it will give me false. Fine, right? So this is your in and not in operator, which will be used, which is called as miscellaneous operator. Right? I hope everyone is clear with this part. Yes, no. Up till now, any doubt, any questions are you having? Because we can start the next topic today, or we can start the next topic from tomorrow onwards, because I just wanted to start fresh with these strings in Python. So we have still 5 minutes left, guys. So what we can do is we can just revise what we have learned, and also we can take the doubts. Okay, if you have any doubts, right? So what we have covered today is that let's try to understand. We have first seen the print hello world, right? So this hello world we have seen by using your print statement, right? Then we have seen that what are variables and data types. Variable is identifier which holds some information, and variables consist of some naming conventions, right? It can only start with an underscore. It should not start with an. It could only have the underscore and alphabets, and it cannot start with a number. And special characters are not allowed in naming of the variable, right? Okay, right. So then after that, we also saw that the data types. So there are primitive data types and your mixed data types, which is your list, tuple, dictionary, sets, and frozen sets. Right, frozen sets we have not covered, so we will take in the next coming session that what these data types are. Okay, right, and after that we will try to talk about our functions also, which is very important, because up till functions, if you try to learn Python, so that would be sufficiently, you can take it forward and try to get your hands dirty into any of the programming languages or any of the applications, or maybe your programs in Python, right? Then there are different data types, which is your float, right? That we saw, and how to check whether that data type is of whether that variable is of what data type, right? Okay, by using your type key. Then we saw list. We can create an empty list, right? And we can have duplicate entries in a list also, fine. Then we have set, which is unordered collection of items. Then in these sets, we cannot have duplicate items. It automatically removes your duplication. Tuple, which is similar to list, but the thing is that lists are mutable, tuple are immutable. We can change the list, but we cannot change tuple. Elements of tuple we cannot change. Elements of list we cannot change. This is the conclusion what we are trying to see. What are why lists are mutable and tuples are immutable. Dictionaries, name, key order values. This is your key. This is your values, right? Then we saw operators: addition, subtraction, multiplication, division, flow division, modulo, assignment operators, in, not equal to, greater than, less than, equal to, right? Then logical, or, and not, right? Then in and not in, right? These are some of the things which we are trying to studied in today's session. No, Chandra, Shekhar, next class is not project, so it is only like next is also practical session, which will cover your concepts like string, tuple, loops, right? For loops, while loop, conditions, if statements, nested if statements, and then we will talk about your functions, your Python functions, right? And then a little bit advanced part also I will try to cover if the time permits, right? Okay. So at any point, if you feel that you have missed something, just let me know. I will try to share this notebook and it will be reflected on your LMS part. Okay. And any topic, any doubt, if you have, just let me know. I will try to clarify that doubts and also repeat the topic in whatever you have missed it or you didn't understand. Okay, so I've shared your this lecture in the chat. So please download it and try to work and try to see if any errors or if any doubts you have, right? So, okay, so as Deepak asked the question that what are sets? So basically you can create and set empty set by using your set, right? and if I try to see print my set, it will try to give you set. And if I wanted to check print type of my set, basically it is a set, right? So it is a set. In your my set, I could add some items, right? Let's say a right. So as you can see that some of the duplicate items I'm putting, right? And let's try to run this. So when I try to say print my set, so what you will observe? My sorry, set. Nice. So what you will observe? So A was duplicate, it got eradicated, and only one is also duplicate, right? And right, rest of the items are unique. So it will give you unique items. So set always rely on set if you want some unique items, right? And ordering is changed. So if I try to put A in front of you, right, at first position, so it ordered, it is an unordered. So the ordering will change and it will try to give you some A would be present at some other location. So this is the beauty of set. If you want your items to be sorted, right? Sorry, not sorted, uh, to be unique, right? So on unique items to be present in the set. But on the other hand, in the list, duplicate items also may exist. So this is the difference between set and your list. I hope you're clear, Deepak. Whatever I've shared you this Python notebook, try to run this itself only, right? Okay. Okay. So let's begin. So naming of the variables, right? So it will only take the alphabets and it will not start with a number. Then we also try to see data types, right? So we have like primitive data like types like integer. So it could be value from zero, right? From minus infinity to infinity. It could be 0, 1, 2, 3, but it could be a whole number. It couldn't be a decimal or a floating point value, right? Okay. For the floating or the decimal point value, we have a float data. So these all are data types. Integer is your data type, float is your data type, boolean is your data type, which consists of true and false. So true and false with a T capital and a F with a false with a F capital. So this makes sure that if you are trying to put a variable and this would be in capital, right? Okay. And string anything which comes under a single quote or either a double quote, that is treated as a string. Okay. So these are the basic data types which we have studied, and then there are another data types which could be a list, tuple, dictionary, sets, rows sets, right? Okay. So these are also our data types, and then this we will try to cover today, right? Then we'll try to see how to see the type of a data type. Let's say if the salary is equal to 1,20,000, right? So this is the data type. So I asked this question in previous lecture also. So and some of you stated it is an integer, okay, and some of you have said it is string. But how do I check like whether this data type is actually a string data type or a integer data type? Then there is a type command. So type shell, it will try to tell you that what sort of data type is this, right? Similarly, type is working, it will tell you it is of Boolean data type. Okay. Then uh, then these were some of the print statements, like you can take like my name is this, my age is this, my salary is this, and try to print these statements according to the data type, right? Okay. So then we discussed about the list also. Okay. So list is another data type used in Python, which consists of a homogeneous or a non-homogeneous type. Homogeneous means only a one single type of data type. Let's say a list of integers, a list of floating point values, a list of strings, right? So this is your list. But if you have mixed data types, so then we could have a like a non-homogeneous, right? So list is basically, I explained you the bag, right? When you go shopping, you take different items. You put the chips also, you put the cold drinks also, you put food items also, you put clothes also, you put your accessories also, right? So this is your list. It is a bag, is a container which can handle different types of data types in it, right? Okay. It could also have a list inside your list. Means that a bag consists of a small bag. This we generally do, right? When you go shopping, you put a smaller bag, and inside this bag you put a smaller bag also, right? So let's say, so if I put a bag of, let's say, Amit and Vipul. Yes, sir. We'll come to that tuple again. Okay. So we'll first cover this topic, and then we'll try to come up with the tuple also, right? So here you can see that in the list there is Amit, there is 1,20,000, there is a floating point value, there is a Boolean value. So these are your items, right? And there is another, this whole item is your list. So this means that in a bigger bag, there is a smaller bag, right? This we generally do. When you go shopping, what you do is like, let's say you make a bag of fruits and you put it in a bigger bag. So this is what you are trying to do. You make a bag of fruits and you are trying to put it in a bigger bag, right? So this is basically what it does. It is trying to store the values inside your list. At the zeroth position, it is Amit. At the first position, at the second position is your integer floating point. At the third position is your boolean, and at the next position is your another band, which could be 0 and 1. Okay, right? Okay, so this is how the complexity arises when you are trying to work with your data types, right? Understood? So this is your list. Okay, right? Then we are having tuple, right? So after that, like this is a tuple, right? So tuple is also similar to your list only, right? Okay, so we can have items inside your tuple. Okay, but the only difference in your tuple and your list is that list is mutable, tuple is immutable, right? Lists are mutable, tuple are immutable. Means that the element present at 0th position, element present at 0th position in a list can be changed. Let's say in this particular list, you have the 0th item. This is the 0th item. This is the first item. This is second. This is third. And this whole is at 4th item. Total, there are 4 items in your bag. And at the 4th item, there are another 2 items inside. So this means you are having a bigger bag. Inside it, there are 3 items and sorry, 4 items, right? So there are 1, 2, 3, and 4. And 5th item is your another bag which contains 2 items. That's this could be like interpreted in this manner. Okay, right? And it at the 0th. So always the indexing start with 0, not 1. So we will call it at 0th position. At the 0th position, we are storing Amit. Okay, in tuple also we are storing 0th position Amit. But in the tuple, we cannot change it. We cannot change like Amit to Vipul because it does not allow us. Okay, it is the nature. It is the property of a tuple that inside your bag, once it is being placed, you cannot modify it or you cannot change it. Right? So, but inside your list, if there is one item you have picked it from the shopkeeper and you have put it in your bag, you can just replace it. But once in the tuple, that item you cannot make changes to that item. So this is what the tuple is, right? So I hope Saurabh, you are clear. Okay, so just let me know if you need more explanation. I could representatively or visually explain to this topic as well, right? Okay, just let me know. Okay, so we will try to cover the more functionalities of tuple list and your strings also. Like this is just because I'm trying to go slow. Okay, so when I will try to discuss more into depth of a tuple or a list or a set, right? So that way you can explain better because so that is the reason I have scheduled another session tomorrow. Okay, because the topics are yet to cover and we are trying to go slowly so that you will try to complete your project. Okay, fine. Okay, so any questions, any doubts you are having till now, just let me know. Okay, right. So then we try to cover the dictionaries. So dictionaries also are having key value pair. So this is basically your keys. right? And this is your value, right? So we have arranged the dictionaries into a key value, right? Okay, right? So then we try to, so this is basically your data types. So these data types, if you don't understand, you have struggling with the data types. So we'll try to cover today itself only. Tuple and list data type or variable. Tuple and list data type or variable. I didn't get you. A tuple and list data type or variable. Acha, you are trying to ask that tuple and list are data type or variables, right? No, tuple and list are data types, right? So variable is just a what we store identifier in which we store information, right? So list and tuple are data structures basically, or data types we call it, in which we store some information, right? So this is the structure in which how we store and they have some property. So consider in this manner, like in a bank, like we try to have different employees, right? Okay, so we could have a manager also that holds some properties, right? Some attributes, right? So this is like how they store information. So that is your list in which they could have any kind of a data type or values which could be stored. So tuple, there is a just a constant, so it cannot change some value, right? Okay. So dictionary, on the other hand, has some key values. So these are basically how you store the data. If in future I ask you, you need to store data in this format, then it is the job of the programmer to decide what variable or what data type I should consider, okay, in trying to store my values. Okay, and like this structure or this data type is very efficient. Okay, because this can be organized in such a manner that you could all have the keys in one place and values in one place. Okay, so this we'll discuss in today's lecture, right? And next lecture also, right, in depth, like what the dictionaries offer and how it will be working. Okay, right? Then we will try to, we have covered like arithmetic and logical operators like plus, minus, division, floor division, right? Then we have exponent, right? So this was like arithmetic operation, right? We have multiplication, we have division, right? So this was like basic class 5 problem, right? Then we also covered like greater than or equal to, right? Not equal to, right? So then logical operators like and or, right? So we also tried to cover the truth table, like if this and both the conditions must be true. If the conditions are not true, then the and operator will not work. And in or operator, one of the condition is true, then it is the output is true, right? So example, like we have this condition and this condition. If both the conditions are true, then only we will try to get the output as true. If one of the condition is false, then we get the false, right? Right. So this we try to see. Okay. Then we also try to get set. So what is basically a set? Set is a collection in which is an unordered collection of items, which does not hold duplicates. So basically, set is a type of data type which does not contain duplicate values. It always have unique values. So let's say you wanted to filter out some values. So set is the best operation, right? Okay, okay. So this we have covered. Okay, so I hope like this you have understood and practiced, and if not, like try to practice it, right? And in today's session, we will try to cover the flow statement, control flow statements like for loops, while loops, right? If condition, and then we'll try to cover the strings, list, tuples, and your dictionaries more into depth, right? And we'll also touch upon your Python functions, right? So up till here, my agenda is to complete these topics, right? Okay, fine. And in case you have any doubts, any questions, just let me know, and I will try to solve the your problems, right? Okay. So before wasting any time, so let's try to create a new notebook. Okay, and I will try to make it and logical operators also we have covered, right? Right. So now we will try to cover the strings in Python. So let us try to cover what are strings. Okay. So what are strings basically? So strings are a sequence of characters that can be either letters or alphanumeric, right? But the only difference or the key points to here to take in mind is that strings are enclosed in either single quotes or double quotes, right? Okay, whatever is placed inside your single quote or double quote, so that is treated is your string, right? So here the message one, and it is being treated as a string. Okay, right? So we can also try to cover triple quotes, right? If the data is large or the string is large or you have large text, right? So then you can put a triple quotes here, right? So this we'll see in practice. Let me try to cover the slides and then we will try to cover it in practice. Okay, right? So this is also is you can do it. Okay, so let us try to see what is a string. Okay, so what I will do is I will try to give my string equal to hello world. Okay, so then I will say print my string. Okay, so I urge you guys to just try to type as I am typing. So practically, like I'm giving you time so that like you can just do it, right? Okay, so this is your string. So this we have converted, this we have printed hello world, and this is in the course. Okay, if you are trying to see the data type, let's say I try to print and I will say type and I will say my string. So it is a string, right? So the data type is string. I will take another string, my string one, and I will try to take the hello world, right? So, so either in double quotes, single quotes, or triple quotes. So these all things are treated as your strings, right? So, so the strings can be accessed by using subscript or indexes. Indexing in Python starts with 0. Okay, so this is your indexing. So indexing, you can say that like this is your hello world. So how it is being stored? It is stored at 0th position. So just try to consider this hello world uh, to be stored in a form of a stack. So let's say you have a stack, you have a rack. In the rack, you have some numbering. So this is all a rack in which it is being numbered from 0 to 11. So consider it in this manner at the 0th in a rack at the 0th position or 0 numbering, first element that is your H is being stored. At the first numbering of the rack, E is stored. At the second, it is L is stored. Third, L is stored. Fourth, 0 is being stored. And at the fifth position, okay, so don't confuse here. If there is space, space is also stored. Okay, so space is also stored. All right, if I have a double space, so like it will take a double space also. Okay, so space is also a character. Don't try to confuse that space is not a character. Space is also a character. It will also store some information and it will also be stored inside your rack. So this is your rack basically, in which there is a number associated to that particular space. Okay, right? So then it comes W, then O, R, at 8th position, 9th position L, and 10th position D, and in 11th position there is explanation mark for the course. So there you can ask me a question for the course. Is there any number? No. So course there is no number. Okay, right? So after course and before course, whatever is being written, so that is being stored sequentially as a numbering in the form of a step. So this is how you store it, right? So this is called as forward indexing, where the indexing starts from 0. Okay, so this is one of the nomenclature, right, in which the information inside the string is being stored. And there is another nomenclature in which the numbering starts from last element. The last element, the numbering starts from -1. Okay, so let's say like I am like I wanted to store this information in the form of a rack, and I number these racks 1, 2, 3, 4, 5. Right, I come from right left to right or from left to right, right? But there's another guy who tells me that okay, no, I will not go from left to right, I will go from right to left. Okay, so then he tries to say that okay, I will start from numbering -1, -2, -3, -4, -5, and so on, and I will store information like this. Okay, so both these nomenclatures are correct. Either you go from 0 to 11, or either you go from at the last -1. So whatever information is stored at the last, that is your minus. the reverse we call, right? Okay, so let's try to do this in practice. Okay, so let's say my string hello world. Okay, so if I try to say my string 0, okay, so I will try to say print my string. So h is being stored, right? So if I try to say print my string, right? Let's say uh, this is 0, 1, 2, 3, 4, 5, right? So let's say 5. So if I try to hit enter, what would be the value? You tell me what element I will get? Blank. Yes, exactly. Blank, or we could say that space, right? So now you can get a blank element or space, you can get it, right? Okay. So if I try to see my string, let's say 5, then it was 6, 7, 8, 9, 10. 10. Okay, so I said 10. What I'll get? D. Okay. So now another question to you guys. What happen if I try to give 11? What do I get? Just try it out and let me know. Yes, everyone. If I try to put or access 11th element of this particular string, hello world, what do I get? Error. Okay, fine, great. Yes. Error. Yes. Yes, exactly. So you are trying to get an error. What it says. Okay, so now the thing is that the most important. Okay, so you are trying to do Python or learn Python, and this is not the case. You will not encounter any error. You will not face any error. You at times you will face an error. But the only thing is that how you can interpret your error, how you are trying to understand your error. Okay, so now it says that index error, string index out of range means that, okay, means that, so we have stored hello world and we have made a stack. Okay, so this stack is of, let's say 11th number only. So 11 number is only stored, right? So in our case, so exclamation mark is our exclamation mark is at 11th position. Okay, here we are only storing D up till D, right? So the thing is that if I try to access 12th element, so there is no element present after 12, right? In the 12th number, there is nothing is present. So we haven't stored anything. So we have only stored up till here only. So this racks is allocated dynamically at only 11th positions. 12th position or 13th position is not does not exist. So that is why it is trying to say that index out of range means that I'm trying to access an element which is not present at my index, at my range, right? In my range, right? So this is what the error says. So basically, it is trying to say that okay, the element you are uh, trying to retrieve is not present at the 11th position. Okay, right. Okay. Similarly, if I try to access the last element, so what I will do, I will try to say print my index. I will say -1. Okay. So now the last element is D. If I try to say print my string, if I say -5, you will get W. If I say print my string -10 E, right? Or let's say if I try to say, right, here also, right? So here also it says string index out of range. Okay, so if you count, right, from here to here, right? So 12th minus 12th, right? So -12th is not present. In our case, it was hello world, right? Hello world. So -1, -2, -3, -4, -5, -6, -7, 8, 9, 10, 11. Right? Up till 11 elements are only present. 12th element is not present and it will say index out of range. Right? Okay. Yes. How can we get the index number? Okay. So index number like you want a particular for a particular element or a particular string, you want that index number, Pooja? Okay. Okay. Okay, I'll tell you, right? Okay, just be with me at some point, right? So there's some inbuilt function in which we can get the index position also of a particular element, right? If you want. Okay. So the next part is that, okay, so this you have understood that how we can access these strings in a reverse order and in the forward order, right? If the element is not present, it will give you an error that index is out of range. Okay. So now let's try to understand. There are some methods, right, of the string. Okay, right. So let us try to understand. So we have my string, right? Hello world. Now I wanted to get what is the length of this string. Okay. So you are trying to count, but if I say that I write her here, like randomly I write around 50 words, but I don't want, like, I don't know like what is the length. Okay. So what I will do is I will try to calculate the length by using your length keyword. Length, and I will say my string. Okay. So it will try to give the length of the string. So indexing always start from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Indexing always start from 0, but if you count, if you try to count something, you will always try to count from 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 characters, including your space. So space is also be counted. Okay, don't try to ignore the space. Understood? So the length of this particular string is your 11. Okay, right. Now let us try to understand this string. Okay, have some functions. Okay, so you have seen movies like Avengers, right? So Avengers. Okay, so for space it doesn't show anything because space is an empty character, right? If you try to see, and if you try to see space, right, so it will not show. Okay, right? Okay, so string, right? So these data types, so we have already studied these data types. So we have the strings, we have the list, we have tuples, right? And we have your list, so list we are seeing, and then we have your sets, right? So consider these data types as your Avengers. Okay. So what does Avengers mean? The Avengers are some superheroes, right? So everybody has watched those movies like Avengers, which we have Spider-Man, which we have like Captain America, right? And other guys like Hulk also we have, right? So these are also some superpowers. Let's try to understand it, right? So let's say my string. So this is also superpower, which have some format or data types or functions. And these Avengers have some powers. Similarly, strings also have some powers in which they can use that. How will we find which bracket to use? Which bracket I didn't like square bracket. Okay. So generally, okay. So generally, I tell you, if you're trying to index something, then it is the or the square bracket. But for functions, always there is your round bracket, right? If you are trying to access something, let's say you are trying to access your my string, right? And this is your 0, right? So this is your square bracket. You are trying to address index, and these brackets are generally used for functions, right? So when you are trying to get familiar with your these data types, so automatically you will try to understand that these are some functions. These has been used by brackets, and if not, they are trying to access it by 0, 1, 2, something like that, right? Okay, fine. Okay. So now what I was trying to say is like these strings, like my string is a variable which has some value, that is your hello world. If you put a dot and do hit a tab. I'm repeating again. You make a variable, let's say my string, and you put hello world to it. Hello world. Okay. Run this string. Run this. Run by this run button. After that, what you will do? You will try to stay my string, put a dot, and that tab. Put a tab. So you can see a list here. F means function. So these are some powers. Okay, so these are some powers of my string. Okay, so all these are powers. Okay, so this we have capitalized, we have center, we have count, encode, ends with, expendables, find, format, right? Is alpha, is num, right? So we will not try to see all of these. We will try to see few of these. Okay, and basically the thing is that the idea is that these data types could have many functions, and you don't need to memorize all these functions because it is very like in Python when you are trying to do programming, nothing you need to memorize. Okay, you all needs to understand the concept. Fine. Tab. There is a tab button, right? Okay, then press that. Okay. So let's say these capitalize. I wanted to, by the name itself, it says that I wanted to get my string capitalized. So just put a bracket to it. Okay, and just put a print statement to it. Right? And put a bracket. So what you are trying to do is this is your print. Inside your print, this you need to capitalize and you have made it, and then you hit enter. Right? Okay, so you will see that nothing happens. Why nothing happens? It will only try to capitalize the first word. If I try to say that hello and I will run it, right? Now you see the difference. Only first word H, only H is being capitalized. Fine. So this is your capitalized. Let us try to see another. So all of you guys try with me and let me know. Okay. So capitalize, I'll try to say that it will capitalize only first character. Right? Only the first character it will try to capitalize. But I want all the words should be capital. So I will try to put a dot, put a tab, and I will try to see. And there is one function called upper. So upper, right? Then I will try to put a bracket. Then again, I will put a closing bracket. So this was the opening bracket of print, and this is the closing of the bracket, right? Now you can see that my string has been capitalized. So this is your upper. Understood? Yes? No? Anyone? Are you guys doing with me? Yes. So there are two functions. So one is capitalize, which will try to capitalize only the first character. Another is your upper, which is try to give me the all the characters in the uppercase. Okay. So the here one thing, my string, you need to put dot. Okay, my string dot capitalized. After capitalized, you need to put bracket. Okay, so I'm repeating again. My underscore string. This is your variable name. First, you put a dot, right? After dot, you put a tab, capitalized, and then you put a bracket. Okay, then you put print. After print, you put another bracket, and this is your closing bracket. And then you hit enter. Understood, Pooja? So remember, guys, these are our functions. Functions mean powers. Okay, so they try to do some job for you, right? But the only thing is that you need to put, if there's a function, you put a bracket to it. And by dot, okay, so by dot, you are trying to get those powers. So this is your, let's say this is your Spider-Man, right? Spider-Man has some powers. So by dot, you can access those powers, and by putting a bracket, you can just put it. And this is your print in which the overall bracket has been put. Okay, so I'm repeating again. This is your my string. You put a dot. Dot means you're trying to access some powers. Put a tab. So these are all powers which comes, right? So let's say we'll try to see another power. So let's say index. So someone asked me, I wanted to find that at what position a particular element is present. Okay, so let's say I wanted to check what position W is present. Okay, so you can see 6. At 6th position, W is present. So let us try to verify this also. My string, and I will say 6. Yes, W is present at 6th position. This is right. Okay, so this we can check that at what position a particular word or character is present. Understood? Yes, no? Yes, guys? Okay, right? Fine. Okay. So similarly, let us try to take another. So I will quickly try to see all these functions. Let's say I will try to create another. Okay, I will say Python is awesome, right? Okay. Okay, so this is my string. Okay, so let us try to put all these things in lowercase. So I will say my string dot lower, put a bracket and put a print statement in front of. So all the characters are being replaced automatically in lowercase. Okay, fine. Right. Similarly, let's say another function. Okay, is lower. Is lower is means that is lower. By the name itself, it is trying to suggest that is lower. It will return me true and false. So I am trying to see that whether this my string. Yes. So Deepak, yes, I got your point. So this W sys character is being outputted without print. Yes, I got your point. So this is basically your Python, your Jupyter notebook is your interactive Python. Okay, right? So if you try to put print, that also will work. If you don't try to put print, that also will work. Right? So here, let me try to put string hello world, and here, let's right? Okay, right? If I don't put your my string, this also will work. Okay, so print is basically into the console, and this is also a kind of an interactive notebook in which you values which are being present. Okay, right? So both it will work. Fine. Yes, understood. So similarly, let's say my Python is awesome. So I'm trying to print the string in the lowercase. Now I wanted to check whether my string is in the lowercase or not. Okay, so whether it is in the lowercase, guys, or not? Yes, no. All the characters has to be lowercase, then only it will be considered at lowercase. If one of the characters in the uppercase, then it will not be considered in the lowercase. So what will be the output? Just write it out. Let me know. False. Yes, exactly. Right. So if I try to do a print and then give me false because it is not lower. So this lowercase or in the uppercase. Okay, so now you can relate to your real life situations, whether you are taking your input from the user, let's say your name, right? The user can put the name in the lowercase also, in the uppercase also. Okay, in that sense, you need to convert that into a lowercase. So you will try to convert it by using your capitalize, your upper, your lower, right? And then you are trying to see whether that name like is something you can make statements out of it. Fine, right? So let us try to see the input command also, where we will try to take the name from the user. Okay, so let's say I will take say the name input underscore name. There is an input command, and I will say enter the name of the student. Okay, right? Then I will say print input. So now we are trying to make a short program in which we are trying to enter the name of the student and we are trying to print the name. Okay. Now the task is that if the student enter the name in the uppercase, I want all the names should be entered in the lowercase. Okay. Right. So I will try to say that. Okay. I try to write Vipul. Right. So now the Vipul has been entered, printed. Right. So let's say the Vipul which I have entered all should be in the lowercase. So what I will do is I will put here print dot lower and I will put that name. If I try to say that Vipul Sharma, right? All these things are in the uppercase. Now you can see that Vipul Sharma is in the lowercase. Fine, right? So these will help us in which we are trying to do some string manipulation by using some functions, right? Okay. Understood? Not yes, no. Yes, guys. Arunima, Deepak. What about others? Okay. Let me know if you are following. Okay. Okay. If you're not following, then also let me know. Okay. Okay, fine. So I will try to give more examples. Okay. Okay. If you guys want, right? Okay. Fine. Right. So this is your like statement, right? So we have entered a name and then we are trying to put that. Okay. So now the next function is your, let's say, split. Okay. So split, right? Or let's say, let's try to do your my string. And if here, hello. Okay. So now you can see that there is lot of empty characters here in the starting of the string and in the ending of the string. Okay, fine. Okay. If I try to see what is the length of the string, 30, right? But only 10 to 12 characters are only needed for me. All these blank space are empty. Like I don't want these, right? Okay, if you are trying to store these empty spaces, so like you wanted to get rid of these spaces. So how you can get rid of these spaces, right? So there's another method or a function or a power that is your strip. Strip means to remove the spaces, right? You wanted to get rid of the spaces which is coming at the beginning and at the end. So remember guys, you cannot run, right, whether it is a blank, whether the space is in between. Okay, let us try to print this hello world, right? So now you can see that the spaces has been reduced because you have made a strip function. what you can do is you can copy this into another variable, right? So you can see that your string has been stripped and the stripped string is been copied to my string underscore one, right? Always try to read from right to left. So what will happen? This will try to strip this my string. Okay. Strip function will get in place to my string. It will just uh, try to apply on this my string. After applying, after reducing it, it will just try to copy it on my string one. Okay. If I try to now print my string one, so you can see that your original string has been replaced. So, oh, sorry, here I need to put underscore. Yes. Now you can see that, right? So I've copied to my string one, and then here am I trying to print it, and this you can see that this all got stripped. Okay. The thing is that Deepak, this cell, okay. So Deepak has a question where like it was trying to run this cell, okay, input one. Okay, so this I'll try to run it again. Let's try to run it again. Okay, so now when you are trying to run this cell, so see this is a star. So star means your cell is still running. Okay, so this is asking for an input. This is asking for the user to type some command. Let's say I've typed here Vipul or Suresh. After writing Suresh, I need to hit enter. It is trying to ask me that after hit enter, right? So now you can see that this star has gone. Understood? So that is why the deadlock has been like it is not trying to like complete first step, and you are trying to move it to another step. So that is why the deadlock occurs. Okay. So if you try to see a star in your cell, so there is something wrong. This is still executing. It still needs the your input from the user, and the user has not given the input. So that is the case, right? Okay. So this strip, so you have understood. So this is strip is used to strip the empty characters, spaces, right? Beginning and the ending. So you cannot strip the space in between of your sentence. Okay, right? But in beginning at the ending, you can strip it. Okay. So let's say I have another string, right, which is something like that, @ and I put a hello word, and at the end also I put a hello word. Okay, right? I just wanted to get rid of this, right? So now Deepak, input underscore name and input name, right? So there is your case sensitive, right? So you cannot have a variable name, right, with the N capital, and here you are trying to refer it with the small name. Okay, so already in the line number 2, it shows that your input name is not defined, means that your variable is not defined. Okay, so you just need to be sure of that your variable name, whatever variable name you are trying to do, that must be exact. Okay, so this is good, right? So until and unless you try to encounter errors, you will not able to learn Python, guys. Okay, so errors are good. If you are trying to learn something, so you will try to get some errors, and then you are trying to solve that errors. Okay, so Deepak, here you put n is capital, n is small. So this is the only difference. Okay, if you try to put n here capital and try to run this, these will work. Okay, so now this is your my string, right? So now here I just wanted to get rid of the alphabets. So we have a same function which is your strip, but this strip is used to give or remove the empty spaces. But here we wanted to remove the at the rate. So what you can do is case is I just wanted to remove at the rates. That's all, right? And then you are trying to print it, or you can store it some other value also. But for the time being, I'm trying to print it. So hello world. Okay, so all the characters have been replaced. If you try to put some dash also, let's say, and you try to run it, okay, only the alphabets at the rate should be removed, not the dash should be removed. Okay, right? So this is your strip method. Understood? Okay. So there are lot many methods of the functions you can explore, right? Okay. So find, is alpha, is num, is lower, join, is upper, is title, right? Okay, replace, find. So let us try to do a title also. I just wanted to go a title, right? So this is your title. Okay, so title, I think I'll do one thing, right? Okay, so title, what it will do, it will try to capitalize your H and your W both. Capitalize will only try to capitalize only the first character alphabet, but title will try to capitalize both the words. So let's say you don't know what this function does, right? Either you will try to search from the internet, right? Either you need to know that what it like count does, right? So this s dot count, so this is something kind of a dog string or a dog string, right? Right. So it will try to give you some reference that it will try to return the number of non-overlapping occurrence of a substring in your string, right? So let's say I just wanted to count how many times the word H is being present, right? So let's say I will put a H 3 times in the word, in this character, hello world. Okay. So how I am trying to, right? Then you put some, let's say for the capitalized, you wanted to check for the capitalized, right? So you put a shift and tab. After putting the bracket, you put a shift and tab. So return a capitalized version of the string. More specifically, make the first character have the uppercase and the rest lower. So you don't need to cram anything, guys. And also you don't need to look to the internet also. Even if your internet is down, okay, how do you check? This is the method. Okay. So earlier days the internet was so costly. Okay. So then the people don't have some documentation or what, right? So what they do is, so they have the Python. So they have the some commands or tools in which they could relate to the doc string and then check. Okay. So what is your like next activity, guys? Right? Like I want you guys to try it out every function of your Python, of your string. Let's say there are a lot many functions: case, fold, center, encode, and find. What does find does, right? Let's try to check it. So what it will does, it will try to return the lowest index in string where this substring is found. Let's say I wanted to find where the L is. Okay, so it will try to find that index, right? Let's say I will try to say L. It will say at the second index my find is there. Count will give you the count of occurrence. Okay, index will give you where it is find, right? So this also give you the find. Okay, double L, right? Double L is being present at second index. Okay, right? So this way you can just write it out. So right, guys, now remember for the list also there are some functions. Then you have tab. Let's say you wanted to see lower. Okay, after that put a shift and tab, shift tab, shift tab, shift tab, shift plus tab. Okay, return a copy of the string converted to lower. Fine. So this is how you can see the doc string. Are you guys following? Yes? No? So guys, so this is like I'm trying to tell you about one superpower, right? Okay. So if we talk about other superpowers also like list, tuple, so these pattern or these how to check how to run a function, this will remain the same. Only the function name will change, functionality will change. Okay. So your string one has to be defined, guys. Okay. So this Deepak, right? Your string one, like I have defined my string one somewhere in the this there string one is present like here, right? So what you can do is you can just first you need to define your string. Let's say hello world. Run it, then you can do it. Okay, if I try to do it by string 1, okay, then lower, then put a shift and tab. Shift and tab. Just try it out and let me know. Yes, guys. Any doubts, any questions here? Okay, so this is something which we will try to do in the list also, in the tuple also. Okay, strip. So strip, what it does, let's say I just wanted to this is my strip. So there are some empty or blank characters at the beginning as well as at the end. I just wanted to get rid of it. So how I would get rid of it, I will use this strip method. Strip, okay. So you don't know about the strip method. So let us try to put a shift tab. Return a copy of the string with the leading and the trailing white space removed. So what it is trying to say that it will try to return the copy with the leading and the trailing white space removed. So this is your strip method. Okay, if I try to strip it, so you will see that the leading and the trailing white space has been removed. And you need to store it in some other variable so that you can use it. Okay, so this is your strip method. Another version of this strip method is that if you want any specific character, let's say at the rate or something written, that has to be removed from the leading and the trailing. So that also you can remove. Fine. Okay. Okay. So another thing to that, let's say this is your my string. Right? Okay. I just wanted to remove only the left part to it. What I will do is R strip, and I will put a at the rate. Right. So now you can see that the at the rate at the right hand side has been removed. Right. So you can see that the left part has been stripped. Understood? So this is your L strip, R strip, title, okay, count, find. So these many functions we have seen. There are not many more also, guys. Okay. Okay. The thing is that so these functions I cannot teach you, like it will take like much more time, right, to explain you. But the to understand this point, how you can see a function. That function could be these power could be limitless, right? Okay. So next time, like your Spider-Man gets another suit, right? So his powers get upgraded. Similarly, with every version, so they get modified. Okay, these functions change. It doesn't mean that the older functions get deleted. So they also remain it, but additionally they also like gets added. Can strip more than one type of character or mark? No, we have this kind of a pattern. This pattern we can strip it. At the rate, like this is the pattern. If I try to have, let's say, in this something like this, and here something like this, right? Only that pattern will get removed, right? So right. So if I try to see it, right? So the pattern which is occurring right here and here, so that gets removed. Fine. So let's try to move it right in the next part. So this your string functions, capitalized, lower, upper, strip, right? So join and split we have not covered. Okay, so let us try to pause here. Okay, this we will try to cover when we'll try to learn about your list. Okay, so when you are trying to learn about the list, so then we will try to understand how we can convert a string into a list and list into a string, right? So first you need to understand the list functions also. So here we have covered the most basic functions of string. So I urge you to cover most of it. You try to run and try to see what are functions these strings offer. Fine? Understood? Right? Fine? Yes, no? Before we move to the next part. Okay. All of you guys, are you guys with me? Okay, fine. So the next part, there's some file operations. Yes, join part we'll try to cover. So when we will try to cover, okay, in that part, so I will try to make sure that like join and split. So these are two functions, right? How we can perform join operation, how we can perform a split function. Okay, so let me cover the file handling. So file handling is a very crucial topic. Why? Let's say we have a file, right, in which there is some data stored, and we wanted to read that file and get that data into our Python data type, right? How we can do it, right? So these operations are very crucial for data manipulation, storage, and transfer. So let's say you have a file in which you have some data and you wanted to first read that data, perform some manipulations, and then you need to write the data to a file, right? If you try to do it manually, how you will try to create one file, write some data to it, then modify that data and then close it. Okay, but I want you to do it in a programmatic manner, in a automation manner. Like you open one file, you add something, you delete something, and you store some information, and then you close that file. Automatically, it will try to handle this task. So that task is being handled by a file handling operation in Python. Okay, so how we will do it? We will use a open function. This is a open function name followed by a bracket. So whenever you try to encounter this bracket, so you mean to say that this is a function. We will call it as a function. This is the open function. Open means open is the name of the function, and this is like the print function. Okay. You are trying to open a file. Which file? Example.txt. You can have it any name. It been stored in your local, or you can give a path. And in which mode you are trying to open? W. W means write. Fine. So we have basically three modes. One is your read mode, write mode, and append mode. We will try to see one by one all these things. Okay. So first let us try to understand. Let us try to make one file. Okay. What we will do? We will try to go in this. Okay. So this is some file I've made it. So I will name it demo.txt. Fine. Okay. And I've saved it. I've closed it. So what I wanted to do is I have written some text to this file. I wanted to read this file and I wanted to get the contents of this file. Okay, so let us do this operation. So, okay, guys, you also quickly try to create a new file, text file. From the new file, new file. After that, write something, whatever you feel like, and you need to close that. Save it. You need to rename this file, demo.txt, rename it, save it. Okay. Save all and then close that file. Understood? Okay. So this file will be stored here itself only. And let us try to do a file handling. All you guys done it? Made one sample file, demo file, demo one or demo.txt. Okay. So let us try to open that file using f is equal to open, right? I will say demo.txt. I will open it in the read format, right? Then I will say print f.read. Okay, now you can see. All of you guys has to do this activity. You make one file, demo.txt, write some content. Okay, then you try to write a function which is your open demo.txt. In the read mode, you need to write a f is your function or a variable, right? And then you are trying to read this file, f.read. Okay, so this automatically gets saved. This save in your those folder in which you are trying to work on it. So let's say I'll show you. So this is automatically saved at where you are trying to work. Okay. So basically I have done it. I'll show you in the same directory in which you are trying to work. So let's say in the documents, so I have got training, this is simply learn, Python practice, right? So here I'm trying to save it, right? Yes, yes, I will share it. So basically what it's trying to do is it is trying to open that file. It is trying to read the contents of the file. Okay. Okay. Right. So this is how you can read that file. Fine. Yes, exactly. Fine. Okay. Right. So this is your basically you are trying to read the contents of this file. Okay. To read one line at a time, use the read line method. And for reading all the lines into a list, use read line. So there are two methods, which is your read line, which will only try to read only a single line. And if you are trying to read all the lines and save it in a list, then we have read lines. Let us try to do that also. If I will say print f dot read line. Okay. So my file.txt. So have you created your file? So basically, Deepak, you need to create your file and then you need to write. So where you have created your file, so you need to give the exact path. Okay. So let's say this file demo.txt, I'm trying to create in the same folder where I have created your Python session. Right. If this file exists in your desktop and you are working with the documents, right, inside your document, this is your Python session. So then it will not able to find your file, right? So just you need to give the exact path of that file and you need to copy that path. This is what it is saying. Okay. Okay. So let us try to, I will try to put, if I try to put read lines, okay. So read lines will be empty. So demo.txt, let me try to make my file again. Okay. So I have gone to these documents and here I'm trying to create a new Python session. And here I have created one demo, new file, demo1.txt. Okay, in this demo one, now you can see that in the documents, training, Simplilearn, May Python, Python practice, in these folders, I'm trying to create the demo1.txt. Now you are able to see that this file is being created in this particular folder. Okay, right? And this folder and this folder are being residing at the same place. Okay, fine. So let's say I will say I love Python. Okay, Python is awesome, right? And I try to save this, save all, and I will try to close it. Okay. Then I will try to f equal to open demo one dot txt in read mode. Okay. Then print f dot read. Right. If I say print f dot read line. Okay, it is blank. So why it is blank? Okay, let me come again. Okay, so okay, so this guys, I'll tell you. Okay, so this lead line, so there is some blank. It is coming, right? So I'll figure it out, right? So why it is coming? Okay, so you got the point, right? So basically, what is happening here is that so we are trying to uh, read the contents of the file, right? Okay, and these file contents have been read. Fine. Are you getting my point? Yes. So below folder, so you are trying to get your file, right? So you want it, I'm not able to get you, Deepak, what you're trying to say. Only run open file code and then read line. How can I move it to below folder? So you can just drag it down, yeah, copy, yeah, this folder, yeah, this is fine. Python practice, in the Python practice, you have made the two notebooks. and inside the same notebook you have given your untitled.txt. So this is fine, Deepak, I guess. So you're not able to run this file untitled. First rename this file to some demo1, demo2, something like that, and then you are trying to run it. Okay, so basically, yes. Okay, yes. So seek is also another option in which we can just try to seek it and then read line and then seek by zero offset. Yes. So this is also it will work, right? Yes. So thanks. Right. So basically, yes. Fine. So first we are trying to seek it by the zeroth element or the zeroth position, and then we are trying to read line, and then we are trying to close that line. Okay. Fine. Yes. Now the second operation is that we also trying to write something to that file. Okay, so this is what the read operation in which there was some file in which we wanted to read the content through that file. But what about that we need to write something back to the file? So that operation we can do it by using your this thing. Let's say I try to open your demo2.txt, right? So demo.2.txt doesn't exist. Okay, I'm trying to open it in the right mode. Okay, then what I will see, what I will do is I will try to write, okay, some text to it. Let's say this is my new file, right? And then I will say f dot close. Fine. So this is the code I'm trying to put it into the chat. Yes, yes, Nina. Just one more. So just try to open this file in the right mode and write it and then close it. Okay. What will happen in this? You will try to have a demo2.txt. And if I try to open it, so this is my new, right? Okay. So this we have seen how we can read a file, take the contents, and this we have seen how we can create a new file and add some contents. Have got a list that how we can read from a file, how we can write to a file. Okay, so this is your method in which you can open a file and read some contents to that file. Okay, and this is how you could write to a file. So this is a small like code snippet in which you need to understand that this is an open method or open function in which takes a parameters, your file name and your mode, in which mode you are trying to open a file, whether it is in the read mode, whether it is in the write mode. Fine. Okay. So unable to open the file. Okay. So are you facing any issue? Like there is some error, like the file which is located is not present or not visible to you. So can you share me that error? Yes, error. Because in most of the cases, you will find that error. The file demo1.txt may be present at some other location. Okay, right. In this which I have shown you, this Python session 2 and your demo 1 and demo 2 is already present here itself only in the Python practice folder. Okay. If your demo 1 is not present in the same folder as you, then it will give you error. Got it? So, yes, it is trying to say that your file is, you know, such file or directory demo1.txt. Okay. The what you can do is you can go to your folder, right? This Python practice, right? And you try to create a new file, fresh file. Okay, right? New file you can create it. After creating a new file, you can create a new Python terminal also. Then you can just see and run the code. Then let me know. Okay. Okay. So anyone here is facing any issue, doubts? Okay, up till now. Okay, before we move to the next topic. So what you can do is you can just go here and try to create a new file and write some content to it, and then you try to open a new terminal, Python 3, and here a session will come, right? And you copy paste the code which I have written in the chat, and then you try to let me know. Okay. Okay. All of you are trying to do the code. So this, what it does, it tries to seek. Okay, so this tries to get your pointer pointed to that particular location, like zeroth position. Okay, so let's say I have my file. Okay, so this is your demo. This is my new file. Okay, demo one. Let's say demo one. So demo, I love Python, right? Okay, so here I wanted to seek from 10th position. So you can see that Python will not come proper because it is trying to get the position from, like, I love Python 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? From here it will go, right? H1, right? So H1, right here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H1, right? From H1 it has, like, you are trying to put your pointer here, and then after it you are trying to read the contents. So this is what is seek is basically. Understood? Yes. You are trying to open a file, then you are trying to seek after 10th. Like after 10th, you are trying to read the lines and then you are trying to print it. So it will try to print HON only. Okay, so this is what is seek. Okay, any other doubt? Any other questions before we move to the next topic? No? Yes? Just, shall we proceed further? Yes? Just type yes. Okay, right. So now what we will do, we are trying to apply some decision control structures to solve. Okay, so braces is basically, Deepak, right? This is braces, like, is a function, right? So we are trying to call a function. This is also, we are trying to call a function. So that is why braces is being used. If we define some braces, so this is open. This is also a function. In the function open, name of the function is open. Write is also a function in which we are trying to give some argument. So these are called as arguments, and this is the name of the function. And this is also multiple arguments. In this function, we are trying to give file name and we are trying to give your mode, what the mode is, right? So this is why the braces are always included when we are trying to work with the functions. So functions will try to cover in the next lecture. Okay, so today I will try to cover, like, most of the part of the functions, data types, and your control statement, right? The next part, when we try to deal with the function, that in that part you will be more clearer. Deepak, right? Is that fine? Okay, right? Okay, so control structures. So we are trying to apply decision control structures to solve some problems in the Python. Okay, right? So let us try to say that we are trying to make some decisions. Okay, we start with some statements and then we evaluate by using your expression. So this is your expression in which we try to put some condition to it. Okay, so let's say I will give a practical example. So I have a list of students in which there are names of some students. Okay, there are some numbers or marks of the students. I want to find the names of those students which their marks is greater than 40. So I will put a condition. If the marks of the students is greater than 40, print those students only. Right? Okay. So this is what I am trying to do is. So let's say I'll try to give you a simple, let's try to do a program. Okay. If statement program. Okay. So let's try to write some steps. First step is that I will try to input by using the input, right, from the user. I will try to input the day, right? Day. Example, Sunday, Monday, Tuesday, so on, right? Next step is that if the day is Sunday, use user will go shopping, right? Third, if the day is Monday, user will go to work, right? If the day is Tuesday, user will go to gym, right? Let's say if the day is Friday, user will go to party, right? And other than these days, user will work from home. Okay, right? So this is your program in which you need to take the input from the user, and based on these conditions, you need to make a program. Okay. So now what we will do, we will try to make a live program. Okay. So this might help you in building up your. So here by using the input keyword, I'm trying to take the input from the user, enter the day. Okay. So then I will try to print the day. So this we already see, right? So let us try to enter. So I will say Monday, right? The day is Monday, right? Similarly, if I try to say Tuesday, here the day is Tuesday. So Ina, what you want the code? So the first part we have done, take the input from the user, example Sunday, Monday, Tuesday. Do we need to write the if else state? If the day is Sunday, user will go to shopping. If the day is Monday, user will go do something. If the day is Tuesday, user will do something. Right? So this we need to make it in the form of if else statement or control statement. Okay. In Python. Okay. So let us try to see first that. The syntax in the Python for the if else statement is that condition, if condition, this condition has to be true or false, right? Okay, so this we need to evaluate whether this condition is true. If then go to this statement. Step. If let's say if day is equal to let's say Sunday, I start a day equal to Sunday. Okay, then I put a colon. Okay, so now you can see day equal to Sunday. This is a variable in which I have stored the value as Sunday. And here, what I'm trying to do is I'm trying to compare that this day is equal to Sunday. It will give me true or false. Okay, if you need to check only this condition, it will either give me true or false. It is false. Why it is false? Because I haven't run this. Let me run this. Okay, so day is equal to Sunday. And now I am trying to check it whether this day is exactly a Sunday or not. If it is Sunday, yes, it is true. Okay. So here also I'm trying to check if this condition, this is the condition which is could be either a true, either a false, followed by a colon. After that you hit enter and you can see that one tab space. So this is one tab space. Okay. So this is the indentation. So most of you guys will face some issue in the indentation that this indentation is not correct. Then you can say that print today is Sunday. Right? And if I run it. So if day is equal to Sunday, print today is Sunday, right? So just try to run this into your no, Deepak, don't try to run this statement. I have not written this. This is only for the explanation, right? So this input day, enter the day. So this you need to run it. Okay. So the code which I've shared now, you try to run this and try to run this. Fine. Okay. So this is my statement. If the day is equal to Sunday, print it is Sunday. Fine. If everybody run it and then let me know what you get. Today is Sunday. Yes, no. Just try to run it and then let me know what you get. Yes. Okay. So what you are trying to run is, you are trying to see if the condition is true, then we are trying to do something. As we already seen here, if the condition statement. Okay. So let's say if statement input, we are trying to write nationality. If the input is equal to French, then print. So similarly, what we have done is we have taken an input from the user, which is a day, and we are trying to check if the day is equal to Sunday, print. It is Sunday. That's it. Simple statement we have tried to do it. Fine. Up till here, everybody is clear? Yes, no? There is if else condition. If the condition is true, do this thing. If the condition is not true, then we need to do something else. Okay. So let's say in this only, we are trying to say that if the day is Sunday, today is Sunday. Okay. Or you can say that take rest, or it's holiday. If the day is not Sunday, we can say that else. Remember, where if is there, in that sequence else is present, and you need to put a colon. Okay, here also you need to put a colon. So this is your condition. After that, you need to put a colon, and then after it is one tab space, that is your indentation. Then we need to tick it. Similarly, you put enter, and here you will put print. Then you can say that it's a working day, right? So here also one tab space. Okay. Now you need to say, if it is Sunday, take rest, it is a holiday. If it is not Sunday, let's say it's a Monday. So let us try to see this in your Python tutor, that how it is trying to evaluate and it is trying to see. So this, you will get a visualization picture that how actually it is happening at the background. Okay. So let's say day. Day is equal to Monday. What will happen? It will try to execute step by step. Monday is some string. So this is your string, which is being stored in a variable day. It is a global frame. Your day is a variable which is being stored value as Monday. Then it is trying to check if the day is equal to Sunday. It is false. It will not go inside this. It will not execute this step. It will go inside your else. Right? So this from here, from line number 2, it has directly gone your control up till 5, because this condition is false. When it is false, it will directly go here, and it will say it print it is a working. It's a working. Are you getting this, guys? Yes, no? Let me repeat it again. Day equal to Monday. So Monday is some string which is being stored into the day, right? And we are trying to check if the day is equal to Sunday. So here you can see Sunday is not equal to Monday. If the Sunday is not equal to Monday, this expression will not get evaluated up till here. 2 and 3 line will not get evaluated. It will directly go into the else part, and it will go into the print. See, so control will pass here, print. And now it will print it is a working day. If I try to change this code and say it is a Sunday, then the control will pass to this second line. Right? Take rest, it's solved. Understood? Yes, everybody? Just let me know. If else statement. Yes, Saurabh, you are correct. Okay. But the thing is that there are some few modifications which need to be done. Okay, I'll tell you. But your code is somehow correct. Okay, fine. So this is how your if else statement will work. Okay, right? So let's say we are trying to have a statement which is your input. Take a number, enter the number. If the number is greater than 0, we need to print it's a positive number. Else it's a negative. Simple. Right? So let us try to do this again. Number. Right? So we'll take the input from the user. Enter the number. Right? If number is greater than 0, print number is greater than 0, right? Else print number is not greater, right? Okay. So let us try to execute it, but there is a catch here. So now it will give me error that is not spotted between instances of string and integer. So remember guys, whenever we are trying to use the input method, it will take the user input in a string. But here, what we are trying to do is we are trying to check the number with 0 or 1 or 2. Fine. So in that case, what we need to do is we need to typecast it. Typecast means we are trying to convert the data type. So what we will do is we will try to put integer number is greater than 0. Okay, let me run it again. Number is not greater than 0. Right? So this code I also have shared it, right? Just try to execute it and let me know. So this is, hope everyone done it. Yes, no, just type in the chat. Everyone got the output? Okay, Deepak, you're trying to do it. What about others? Fine, great. Okay, so let's move forward. Okay, so this is your normal if-else statement, right? But what if you need to do multiple ifs? Okay, so here itself only, let's say I wanted to check if the number is equal to 0. Okay, so what I can do it. I can say that elif integer number is equal to 0. If the number is equal to 0, we can say that print number is equal to 0. Right? There could be three conditions. Either the number is positive, either the number is equal to 0, or either the number is greater than 0. Okay. So three conditions we have checked. Let's say I will try to put a number 0. Okay, hit enter. Number is equal to 0. Number is equal to 0. Let's say I put a 10. Number is greater than 0. If I put minus 30, number is not greater than 0, is less than 0. You can say that, right? So this is how you can check multiple if-else statements, right? If there are more than one if statement, you can put a else. And here also in this, you need to write a program in which user take the day from the user. If the day is Sunday, user will go shopping. If the day is Monday, user will go to work. If the day is Tuesday, you will go to gym. And if the day is Friday, user will go to party. And else it will be work from home. Okay. Number is already integer, so why do we need to write integer? Why we should convert to string? Okay, fine. So I'll answer this question. So you have this input. Okay. So input is a function. Okay. So if you have some doubt regarding this, just follow the docstring. Right? So here, what is it is trying to say that read a string means that it will try to read a string. Whatever you try to write it, it will by default take it as a string. Whether you write a number, whether you write a floating point, true, false, boolean, anything, it will always try to take it as a string. Right? Right? But we want number. And numbers has to be correctly identified into their correct data type. If you don't do it, you will not perform the arithmetic operations. So that is why, like you are trying to enter a number, right? It is not string. It is not integer. So you need to typecast it. You need to convert into integer and then follow the mathematical operations. If you don't do it, it will result in error. Are you getting my point? Yes? No? Saurabh? Yes. So make sure if you are trying to take the input from the user, you need to do some validations. Okay. So user is dumb. Okay. So user can enter anything. It is the task of the programmer to correctly handle the data from the user. So it can have the junk characters, right? So let's say you are trying to first take the input. Let's say in this case, Sunday, Monday. Okay. So user can enter any spaces, blank spaces also in the end. So what you need to do is, let's say I try to enter it from the enter the day. Let's say we try to put this thing, right? Okay. So let me try to. Okay. So enter the day. Okay. So let's say I put a space and I say Sunday. Okay. So here I say enter the day, I'll put Sunday. Okay. So if the day was Sunday, how come it is a working day? It has to be a rest day. It has to be a holiday. So now your program got failed because you haven't put the correct validations. Okay. So what is the method in which you could put the validations? You can just say that day is equal to day dot strip. I just wanted to remove all the junk characters. Okay, and I wanted to check, right? So now let's say I'll put another space and then I will say Sunday. Take rest, it is holiday. So this is how you need to do the validations. Int num. Okay, Hina, int num, it doesn't work like this thing. So if you are trying to do is like int num equal to, so first of all, int, like we are trying, we don't have, this is like your C or C++, right? So this we explicitly first declare what kind of a variable we are trying to hold. But in Python, this is your dynamically typed, right? Whatever you are trying to hold the information, let's say 10, automatically it will try to recognize that in the number, integer will come. Okay, right? So this you need to handle it. Okay, right? So what I was trying to tell you, so this you need to make the validation, and this you are trying to do it a file, these string operations, what we have learned today in the first half, strip, right? So then we are trying to put it in the lower case, upper case. Okay, so you cannot make all the possibilities. Let's say the user will try to make it in the upper case, and this is case sensitive. Sunday is not equal to Sunday. If I try to write here equal to Sunday and here equal to Sunday, small Sunday, this will be false, right? This is also Sunday. In that case, you need to make another validation, day equal to day dot lower. So now what we are trying to do is we are trying to learn and implement what we have learned today, right? So we need to input the day, we need to strip it, remove the junk characters, or we need to remove the spaces and then make it a lowercase. After that, we need to make it. So now you understood like how we can make this this statement or a function or a program, make it possible. Yes, guys, right? So these are small concepts in which we are trying to build a program. We are trying to build a software. So these things are really necessary. Yes. So Deepak, it is the syntax basically, right? In other programming language, this syntax could be followed by your brackets, curly braces. So here we only put a colon, right? To identify that we are trying to make this as a curly braces as a syntax, right? And this after colon, so this is your one tab space. Here after colon, this is one tab space. So just make sure. So all of you guys now can make this program if the input, take the input from the user, right? Convert it into the lowercase, right? This lowercase, strip it, and then you can check if the day is equal to Sunday, right? Then else if the day is equal to Monday, do this. Else if the day is Tuesday, do this. Else if, right? And in the end, you can put a else statement, right? So now this is your task or activity for your home to do this, right? To complete this program. So I've given you a small program in order to understand and work. Like until and unless you don't try it yourself, you will never get to know. and all of you guys in the next class. So I want this program to be done by you. Are we clear? Yes, no? So this was the if else statement in which we have a condition and we put the multiple statements to it, right? So another part, like let's say enter the marks. If the marks is greater than 90, right? So here also we are trying to typecast it to the integer part. Print grade A. Else if the marks is greater than or equal to 70, grade B. Similarly, else if these conditions does not met, then we put a F grade. So this is also a small program in which we are trying to get the marks from the students and then trying to print their grades. Right? Okay. Now another condition, that is your nested if else. Nested if else means a condition within a condition. So let's say here, if the day is Sunday, right? Okay, so I'll take you another program in this part only. Another program. Okay. Take the input from the user, right? If the day is Sunday, if this day is Sunday, user will go shopping, right? Here there is a twist. If the bank balance, his bank balance is greater than 20,000, only then only the user will go to shopping, right? Else he will watch TV. Okay, what do you do on Sunday? You will watch TV. Okay, so the condition, now there is an if condition, and inside this if condition there is a nested if condition. So we are trying to say that if it is Sunday, that is okay. User need to do something. But what if is trying to check if the balance, his bank balance is greater than 20,000. If it is 20,000, greater than 20,000, he will go to shopping. Okay, fine. If it is not there, he will watch TV or he will take rest. We can say that. Right? So this is the condition in which we can say that this is how you can structure your program. So now let us try to see the program. I will just copy it for the sake of the time. This thing, right? So we are trying to take the day. Okay, we'll strip it below it if this is Sunday. Now here, if balance is greater than 20,000, we can say else print rest. Now remember guys, this if condition is the outer if condition of this else. This if and this else, right? You can see. And this if and this else, they are inside and the same indentation. Don't try to put here something like that. It will be wrong. So this is your inner if else and this is your outer. Okay. And indentation, this is your course, colon. And here also it colon. Yes, Saurav, you're correct. Right? So this is how you do it. Now, if I try to run this, you will get an error. Okay, because we have not defined the balance. So balance, we need to define it. So we also can check, we can say balance. And here we could only say integer. Balance is also, we're taking an integer input and we are trying to say that enter the balance. Okay, now we'll try to run it. Okay, enter the day. So we'll try to enter it Sunday. Enter the balance. Let's say I will try to enter 20,000. 30,000 because it was greater than 30,000. Okay, 30,000. Now go shopping. So enter the date is Sunday. Enter the balance, it is 30,000. We'll try to go for shopping. Okay, so now I will try to run it again. Enter the date Sunday. Enter the balance. Let's say I have only 10,000 balance. Take rest. It's a holiday or watch TV, right? So this is how you can make a program with the input statement. I hope it is fine with you guys. Now try to run this and try to check it for yourself. Okay, so these are small code snippets. Okay, before moving or developing a bigger software, you need to understand the flow, right? So these if else statements, you need to get it going and try it yourself. Okay, then only you can make your bigger softwares or applications. Understood? Okay, yes, no, before we move to the next topic. Are you guys following? Yes, no, any doubts, any questions you have, just let me know. Okay, this is like it is up to you, Bhumika. Basically, the thing is that if you don't do strip and lower, so this is for the validations. As I already shown you, Sunday could be written in different formats, in many formats, right? S capital, U capital. There could be space also, right? So you need to make sure that whatever the user is writing, that has to be validated, and it would correctly meet your software requirements. That it is comparing it exact. The user has entered Sunday, but it is a capital. It will be this Sunday is not equal to Sunday, so it will give you false. That is why we have tried to make it as a lowercase and strip. That remove the junk characters and make it as a lowercase. Understood? Okay. Anyone? Okay. So this was the nested if. Okay. So let's say the number is 15 and the number is greater than 0. If the number is equal to 0, print 0. Else it will print a positive. Else it is a negative. When there is multiple condition, uses else, if else need to be used only if equal to condition using first line only. Yes. Yes. So if you are trying to say that if there are multiple if else, so if is like you try to write if at the first, and then after that you try to write if else, elif, elif. So at the first point you write only if, after that there are multiple ifs, you write elif, right? And if there is single if else will work. Okay, fine. Okay, so nested if the number is greater than 0 or equal to 0, go into that loop. If the number is equal to 0, print 0. Else it will try to print positive number. And if it is negative, then it will be printing negative. Okay. 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 So now we'll work on the loops. Okay. So loop, what it happens in the loop? So there is a repetitive execution of a statement or a group of statement. Okay. So let's say we are trying to work on a condition and that gets executed. Okay, so let's say we'll talk about two kinds of loops which are used in Python. One is your for loop and another is your while loop. Okay, so let us try to understand and write. I wanted to print numbers from 1 to 10. Okay, fine. So let us try to print numbers 1 to 10. So I will try to use a for loop first. For I in range 0 to 11 colon print I. Okay, so let me explain what is this. For I in range of 0 to 11. Okay, I is your temporary variable. Range we are trying to take the range as I need to start with 0 and I need to end up till 10. So I'm trying to print the numbers ranging from 0 to 10. Okay, so this is what we are trying to do. Okay, I is your temporary variable. Okay, Indrajit, the thing is that you check if the day is equal to Sunday, after colon, there's a tab right? If balance is greater than 20,000 colon, after that print. So print and if you haven't made a tab, right? Similarly, else, after else, you are not having a, right? So in the error itself only, they are trying to say that in the line number print, today I will go for shopping, today I will go for shopping here. So you need to put a one tab space. So here, see, if my balance is greater than 20,000, after that there is two tab space, one tab space and one tab space. One tab space for the outer and one tab space for the inner. Right? Here it is error. Are you getting my point? So after colon, you need to hit enter and you see there automatically there is one tab space. Or either you can put a tab. Tab. Fine? Okay. Right? So I was trying to tell you, this is your for loop in which there is a range from 0 to 10. I wanted to print the number. And what is this I? So I could be anything. I could be A, B, C, anything, or num, right? It's a variable. It's a variable, a valid variable name could be there, right? I could write num1, num2, num3, anything. So for simplicity, we will try to take as ABC or IJK, something like that, right? Okay. So what will happen? It will try to first go into 0. I will get stored at 0. Then it will increment. After automatically it will increment and it will go to 1, 2, 3, 4. And this way it will try to print. So let us try to see this in execution by using your Python code. What is happening? Right. So I is a global frame in a variable where 0 is stored because it will take the range from 0 to 11 and it will try to print I. So now I is having 0 value, it will try to print it. Right. Next, it will go again to the for loop again. Right. How many times it will try to execute up till whenever the I will reach to 10. Right. Because this is your stopping criteria. You have a range. Right. In this range, you need to print it and you need to keep on going. Once this I is greater than 10, it will stop. It will go out of that loop. Fine. So next, it is 1. So it will try to print 1. Again, it will try to go. It will print 2. Again, 3. Again, 4, 5, 6, 7, 8, 9, 10. Now, I value of I is 10. Right? Okay. Now it has stopped. Up till 10, it will try to see and it will try to print. Okay. Right? Because we have made a criteria. This you understood? What is this for loop? Any doubts in this for loop? Because this for loop is if statements, for loops, your data types, and the complexity will rise. At any point of time, you feel that this concept is not clear, let me know. I'll try to explain again. Everybody is clear? Yes, no? For okay. So let me try to give you another example. Yes, let's say let's say hello world, same example. Right? So now we will try to see and try to work on it. I fetch, it will try to print h, then it will try to print t, then it will try to l, then it will try to l, o, w, o, r, l, t. Right? Dot upper. Okay. Now every character is in the uppercase. Right? Understood? Okay, so let me also work on another example. If uh, mm, okay, in this particular string, I wanted to print only the words in the uppercase. So here uppercase is your H and W. Okay. So what I will do is if I dot is upper is a function, we will try to see it. We are trying to print only those characters which are is in the upper word, in the upper characters. I want a program, okay, in this print hello world or a hello world string. I wanted to print only those characters which is only upper. H and W, I want the output. So I will simply say print I. Okay, it will take first H. It is upper. Yes, it is. It will print it. It is not going. It is not going inside this loop. You can see in the if condition it is not going. Yes, H and W are being printed. Yes. So Saurabh saying that for range from 0 to 11, so it started. So here it started from 0 and stopped before yes, before 11. Yes. So range will always like the first element. It will start from the first element, and it will stop like if you specify 11, it will stop till n minus 1. It is from 0 to n. It will stop at n minus 1. If it is 12, it will stop at 11. If it is 10, it will stop at 9. If it is 5, it will stop at 4. One prior to that. Okay. So this you need to understand. The range function. This is the functionality. Okay, so there is no answer like to known that why it does it. So it will take the first element as it is, and the rest it will stop at n minus. Okay, fine. Okay, so this is a small snippet of the code in which I wanted to take this string, right, and try to print only the characters in the uppercase. Is upper is a method or a function we have already seen, right? Upper. We have seen upper, but is upper will try to give it in the upper one. It will try to give me true or false. So inside the for loop, I have made a if condition and will try to print what is the output. Are you guys trying to understand what we are trying to do here? Yes, no? Okay. So do you want more examples? Okay, small. Uh, yes. Are you guys trying or not? Okay. So this for number. Yes. So for number in range, body of the loop, right? So this is basically a for loop structure in which we are trying to this number with the temporary variable and it will work in a range, right? Okay. Okay. So now we'll try to work with the while condition, right? So the same thing I wanted to do with a while. Number is less than 10. Print number. Number is plus equal to 1. Okay. Okay. What we are trying to do is we are trying to initialize the number while 0. So it will check whether the number is less than 10. Yes, it is less than 10. It will try to print the number. Then it will try to increment the number by 1. Okay. Again, it will go here and it will try to check whether the number is less than 10. Yes, it is. And it will go keep on executing when this condition is met false. So this is your while loop. Okay, so let me try to first run it. So you will see that from 0 to 9 it has run. Okay, and here if I try to put it here, equal number is greater than or equal to 10, it will print from 0 to 10. Fine. So this is the same which we are trying to do by using a for loop, and this is the same which we are trying to do with via while loop. So let us try to see this in action and in your Python tutor how it will work. We have a global frame of number equal to 0. Now we are here at the here we have entered while number is less than or equal to 10. Number is 0. It is less than or equal to 10. Yes, it is. It will go inside. It will try to print. It will try to print what number? The number is having value 0. It will try to print 0. Then it has incremented the number by 1. So now the value of number will be equal to 1 because 0 plus 1 equal to 1. Again, it will go to the while loop. While the number is equal greater than or equal less than or equal to 10. Yes, 1 is less than or equal to 10. Yes, it will go inside. It will print the number. What is the number? 1. It will try to execute 1 by 2. Again, it will go. What is the number? 2 is less than 10. Yes, it will print 3. Okay. It will go 5, 6, 7, 8, 9. Yes. 10. Number 10 is less than or equal to 10. Yes, it is. It will go inside it. Print number. Yes. Now the value of number, what is 11? 11 is less than or equal to 10. No, it is not. It will not go inside this loop. So this means it has a condition where our loops keep on executing, and when that condition is set to false, it will not go inside your loop. This is your while loop, basically. Yes, the program has stopped. Yes, so Deepak, like I was trying to tell you in that particular thing that if you try to this upper, so in this program I want only those uh, words which are only in upper. I want only H and W. Right, write a program or solve this question. You have a my string hello world with the H and W capital. I want to retrieve only those words which are in capital. So that is why I have written is upper. If the numbers are upper, give only those characters. Right. So this is why I have entered is upper. Fine. Okay. So everybody got this while loop concept. Okay. Why we are trying to do a while loop and where we are trying to do for loop. How we are trying to execute while loop. Right. For loop is simple in practice. While loop is a little complicated because if you try to miss some condition, it can go endless. Fine. Right. So that is why while loops are dangerous at some time. So it is better to prefer for loop. But if some programs require and you know that this condition will be false, okay, at some particular point of time, there you can use while loop. But that condition you must know prior. If you don't know that condition, it might end endlessly. Your while loop will keep on running endless times. Okay, let me show you. If your number is less than the number is greater than or equal to 0, it will keep on printing your number. Right? Right? It is keep on printing. It is keep on printing. Now you can see here this code is getting executed. Okay. If this code is getting executed, this means your cell is currently in running. You just need to stop the kernel or interrupt the kernel. Then and only then your this code will be stopped. Otherwise, it will keep on running. sometimes in the class also some guy his code was getting executed. Okay, so either you need to put a stop here, and either you can check here that the star is being activated.
Now, JavaScript is a powerful client-side scripting language. It is used mainly for enhancing the interaction of a user with the web page. In other words, you can make your web page more lively and interactive with the help of this programming language. So if you love web development, then you're in the right place. This video will help you understand the basics of JavaScript in just under 4.5 hours. So here's a list of topics covered. First, we'll look at a simple hello world program in JavaScript. Then we'll move on to topics like arrays, loops, objects, functions, closure, promises, and async await. Then we'll learn about JavaScript this keyword, form validation, regular expressions, email validation, and JavaScript DOM tutorial. Lastly, we'll look at the JavaScript learning path and we'll understand how to become a full stack developer. So without further ado, let's begin. What's in it for you? Now we'll start by understanding what JavaScript actually is. Then we will get to know why it is so popular these days. And lastly, we will write our first program in JavaScript which will print Hello World in the browser window. So what is JavaScript? JavaScript is a dynamic computer programming language which is lightweight and object-oriented. Now the best part about JavaScript is the fact that it's open source and is cross-platform compatible, meaning one piece of code written in any system regardless of the operating system functions the same in other operating systems as well. Lastly, most commonly used as a part of web pages, it allows client-side script to interact with the user and make dynamic pages. Now moving on to the next important question, why JavaScript? Now being the most popular language in the world, JavaScript has a huge fan base and benefits from a large community support. JavaScript is now being used in many industry fields such as web development, mobile application development, and also game development. It is very diverse in nature. There are great career opportunities for JavaScript developers as this technology seems to be holding on its own when compared to other languages. Alright, now moving on, let's go ahead and execute a simple program to understand JavaScript better. So we'll go ahead and execute a simple Hello World program. Alright, for that, first thing you need is a text editor. In this case, we've used the VS Code editor. So now let's go to our text editor, that is VS Code, and here let's open a file. Here say new file. And now you can type in your code here. So we will have to add the JavaScript to the HTML code and then print out the words Hello World on the browser window. Right? That's our objective. So let's add the HTML boilerplate in this file. So let's type in HTML. This is our tag. And then next we have the body tag. So within the body tag, we can add the script tag to insert the JavaScript into HTML page, right? So we say script language equals JavaScript and type equals text slash JavaScript. Alright. Let's close the tag. And then in the script, we call a JavaScript function that is document.write, which writes the string to our HTML page. Right? So we say document dot write, and within braces we say hello world. Okay, and now we close the tags. We also close the body and finally the HTML. Alright. Now when we save the file, we're going to save it, say on my desktop, and I'm going to call it index.html. right? So make sure the extension is HTML and then save it. Alright, it says it already exists. I say replace it. And now once you save it as an HTML file, you can see that the colors have appeared. So any errors will be easily indicated here. So now let me save this, and now let's go ahead and execute the file that is stored. So let me go back to my desktop, and here I have index.html. There you go. When you click on the file, it opens in your browser and you can see the words hello world. In this video, we will be learning all about JavaScript arrays and the popular methods of the array object. So without further ado, let's get started. So what's in it for you? We'll start by understanding what a JavaScript array is. Then we will get to know about the operations that we are performing on the array. After that, we'll get familiar with some of the most used array methods. And lastly, we'll go through map, reduce, and filter functions. So what exactly is an array? Now an array object lets you store multiple values in a single variable. It stores a fixed size sequential collection of elements of the same type. Now an array is used to store a collection of data and it uses only integers as element indices. However, associative arrays can also use string indices. Moving on, let's understand what array operations are. Now we can perform various operations on an array in JavaScript. But let's start by creating an array. So for that, let's go ahead and create a folder first, which will consist of the file that we're creating, right? So for that, let me just go ahead and create a folder. And I'll call it demo_array. So once you're done with that, open your Visual Studio Code editor and here say open folder and click on demo array. Okay, it's creating the workbench. Alright, and now here you can see the new file icon. So go ahead and create demo.html file. Alright, here you go. Now let's start typing the code. The first thing we do is type in our HTML tag. And here I have the head tag. And let me say JavaScript tutorial. Alright, and now let's create the body tag. Now within the body tag, I create a paragraph tag and create an ID and let me call it demo and then close the tag. Now I'll explain to you why we're doing this a little later. So first let's go ahead and create the script tag. So say script, and within the script let's create our array. So let me use the keyword let and say we give the name of the array cars equals in square braces we say BMW and Volvo and then say Honda. Alright, so now we create an array. Now one more thing is that we use the keyword let so that which indicates that the array can be changed throughout the program. Alright, so now we go ahead and display it. So I say document dot get element by ID and here I say now the ID created was demo, so I say demo here and I use the dot inner HTML property which is equal to cars. Okay, let me change this to BMW first. Alright, so what exactly inner HTML does is that it is responsible for what is being displayed on the web page. Okay, now since we've taken ID as demo, any changes made is reflected in this ID and then displayed onto the web browser. Alright, so let's save this and now execute the file. So here I go back to my folder and then to the file and go ahead and click on it. So there you go. The heading is displayed and the entire array is displayed here. Alright, so let's go back to our VS Code. Okay, so I hope this was easy to understand. Now let's go ahead. So the next operation is to access an array element. So let's go back to our VS Code. And here, let's create another variable. Say let BMW. BMW is the name of a variable. Don't get confused with the array element. So BMW equals cars of the index 0. So basically, cars of 0 is nothing but BMW. Alright, so that is being saved in the variable BMW. And now let's just go ahead and display this. So let's just copy this and paste it here, and instead of cars, you use the variable name BMW. That is this one. Alright. So now let's save this, and when we execute it, you see BMW here. That's how you retrieve an element from an array. Next up, we have the array length property, which displays the length of the array. So again, let me show you how to do that. Let's go back to our code. And here, let's create a variable and let's call it length variable. So I say let len equals cars.length. Now you can use the length property, which will retrieve the length of the array for us. It's as simple as that. And now after this, again, let's just copy the same code here and then let's pass len. Okay. Now let's save this, and when you execute it again, it says 3. So we've successfully retrieved the length of the array. Alright, so the next operation is to access the last array element, right? So let's go back to our VS Code, and now let's create another variable and let's call it last, and we'll just say last equals cars, and within square braces cars.length -1, right? So basically, the length of the array is 3 and 3 minus 1 is 2. So it should retrieve cars of 2, which is Honda, right? So let's just execute this. Let me pass last here, save it, and see if it displays Honda for us. There you go. It's as simple as that. Alright, so moving on, the next array operation is loop over an array item. So for that, let's go to our code, and here, let's use the for loop. So I say cars dot for each, and within this, we'll say item, comma index, comma array, and now we use the arrow function and display the content on the console. So I say console.log of item along with its index. So let's save this. And now let's go ahead and execute it. Alright, now as you can see, nothing is printed on your web page, right? Because whatever is being printed has to be printed in your console. So now click on F12, which opens the developer options. And here you can see console, so click on that. And now you can see the name of the item in the array along with its index. So you see BMW 0, Volvo 1 and Honda 2. Alright, so moving on, now that we've learned about the array operations, let's go ahead and learn about the array methods. So the first method is toString. Now, as the name suggests, it is used to convert an array into a string. Alright, so let's go back to our VS Code. And now, let's copy the same code here. And here, instead of last, I just say cars dot toString. Now you can use this method to convert the array into a string. So let's save this and let's execute it. Alright, now here the same output is shown, which means that the type has only been changed to string type. Alright, moving on. The next method is pop. Now pop basically removes the last element from the array. So let me show you how that works. Let's go back to our VS Code, and here we have to save the popped element into a variable, right? So let's create a variable, say last. Okay, and since last is already used, let me call it last one. Last one of cars dot pop. Now we can use the pop method to pop the element. And now we can just copy the same code to display this onto our web page. And here I just say last one. Now, since we've popped the last element, the array has only two elements, right? That is BMW and Volvo. So if you want to display the last element, it should display Volvo, right? So what we can do is we can just create another variable, say last2, and just use the same logic here. Okay, and now let's just display it on your console, and let's say last2. Alright, so now let's save it. Now the popped element has been saved in last one, which is displayed on the web page, and the last element of the array after the pop function has to be displayed on our console. So let's go ahead and execute the file. Alright, so Honda has been displayed. That is the element that has been removed from the array. And now once we check our console, here you go. Here you can see Volvo, which means that is the last element in the array. Moving on, the next method is the push method. Now, as the name suggests, it is used to add a new element to the array. And remember, to the end of the array. So let's go back to our VS Code. And here, let me say cars dot push. Push is the method that we are using, inside of which we'll say Audi. Alright. And now let's just display the same thing. So let me copy this. And here let me say cars. Okay, so let me save it. And once I execute it, it says BMW, Volvo and Audi. So we've successfully added another element to the end of the array. So the next method is the shift method. Now basically shift is used to remove the first element from the array. Now this method shifts all the elements, reducing the indices of every element by 1. Alright, let me show you how this works. So let's go back to our VS Code. And here, let me just say cars dot shift. It's as simple as that. And let's just display this. Let me copy the same thing. Let's save it. And when we execute it, here you can see it just displays Volvo and Audi. So now cars has array elements Volvo and Audi with array indices 0 and 1. Alright, so moving on, the next method is unshift. Alright, so to add an element into the beginning of an array, we use the unshift method. Therefore, this method increases the array index by 1. Right? So let's go back to our VS Code and use the same function unshift. So let's say cars.unshift. And here we go, let's Save it. And here we have to specify what we're adding, right? Let me say Hyundai. Okay. Let's save this. And when we execute it, you can see Hyundai, Volvo and Audi. It's as simple as that. Alright, moving on, the next method is the concat method. Now this is basically used to merge two different arrays, right? So let's go back to our VS Code. And here, let's create another array first. And let's just call the array bikes. Okay. And let's create, say, Yamaha. And let's say Suzuki. And then we'll say Royal Enfield. Okay. And now, let's save this. And say let vehicles, this is another array, which is basically the after concatenation, the entire array is saved into this array, alright? So let's say cars.concat of bikes. We just concat bikes and cars together. Okay, and then let's just display this over the web page. So let me change this to vehicles. Alright, let me save this. So let's go ahead and execute it. There you go. Now both the arrays have been merged together into a single array. So the next array method is the sort method. Now basically sort is used to sort the entire array into ascending order. Alright, so let's go back to our editor. And here, let's just use the sort method on the array vehicles. Alright, vehicles.sort. Okay, and let's just display this on our web page. So again, let's go back and execute it, and here you can see it has been sorted. The next method is the reverse method. So the reverse method is again used to reverse the elements in an array. So it's logic, right? So sort was used to sort it in ascending order. Now when you reverse it, it just sorts it in the descending order. So let's go back here. I want to copy the same thing. Alright, and here instead of sort, let me just say reverse. So let's save this and execute it. There we go. It has displayed the entire array in the reverse order. Alright. With that, we finished the array methods. Next up, we have map, reduce and filter. First up, we have array.map. Now the map method is used for creating a new array from an existing one by applying a function to each and every one of the elements in the first array. And it does not change the original array. Alright. So to make you understand this better, let's go back to our Visual Studio Code. And now here, let's first create another array. Okay. So let me call this num1. And let's have integers, let's say 2, 3, 4, 5, 6 and 7. Okay. And now let's have another array, num2. So let's go ahead and say num1 dot map of, let me define a function, say multiply. Okay. So multiply is the function that I'm going to define here. So let's say function multiply of value. Okay. And inside this, let me say return value into 2. Okay. So what this basically does is that it multiplies each and every element of the array num1 by 2 and saves the new elements into the array num2. Okay. Now after this, let's go ahead and display the content. So let me copy this. And let's display the content in the array num2. Right? So let me save it. Let's go back here, execute it. So there we go. Every element has been multiplied by 2 and then displayed again. I hope this was clear for you. Now the next method is the filter method. So the filter method takes each element in an array and applies a conditional statement against it. And if this condition returns true, the element gets pushed onto the output array. But if it returns false, the element does not get pushed. Alright, so let me show it to you. Now, let's go ahead and create another variable, say num3. And here I say num1 dot filter of say comp. Now comp is a function. Let me define the function here. Let me say function comp of value takes a value as a parameter within which I'm going to check if the value is greater than 4. Now it only appends the element into the array num3 if the value is greater than 4. Alright. So now let me just go ahead and change this to num3. Alright. Let's save this. And when we go back and execute, here we go. Now the values, so let's go back here. Let me check. Now num1 had the values 2, 3, 4, 5, 6 and 7, right? So according to this, it has to only display 5, 6 and 7. Do not get confused with num2 here. We've passed num1 here, so it checks for this array, right? So according to the logic, it should display 5, 6 and 7 and it has done so here. Okay. Moving on. The next method is the reduce method. Now the reduce method reduces an array of values down to just one single value. Now to get the output value, it runs a reducer function to each element of that array. Okay, now this method does not reduce the original array again. So let's go back to our VS Code. Now let me create another variable, say num4, and say num1 dot reduce, and let me call it sum. So what we're basically doing is that we're adding all the digits 2, 3, 4, 5, 6 and 7 in num1 to a single value, right? That is the sum, and then we're going to be displaying that. So what we're going to do is let's define the function here. Function sum basically is total comma value, right? And then here let's say return total plus the value. Okay, and after this I'm going to display the content. So let's say num4. Okay, let's save it, go back and execute. Here we go. It displays the sum of the entire values in the array. In today's video, we're learning all about JavaScript loops. So without further ado, let's begin and look at what's in store for you. So we're going to be covering topics like for loop, while loop, which also includes the do while loop, and then we're going to learn about breaking out of a loop, and then we'll see how to skip a loop cycle. Before proceeding, make sure you subscribe to our channel and hit the bell icon to never miss an update. Now before jumping into the for loop, let's first understand what exactly a loop is, right? So a loop is basically a programming construct that executes a piece of code as long as a certain condition is met. Alright, and there are two different types of loops. We have entry control loops and exit control loops. Now, what exactly are entry control loops? Now, these are the loops where the test condition is checked before executing the piece of code. For example, you have the for loop and the while loop. So in their case, before entering the loop, the condition is checked, and only if the condition is met, it enters the loop and executes the code. Alright, when it comes to exit control loops, the test condition is checked after the loop has been executed. Alright, so in this case, the loop at least gets executed, the code in the loop gets executed at least once. So the example for this is the do while loop. Alright, with this basic knowledge, let's go ahead and learn about the different loops. So the first loop is the for loop. Alright, so what exactly is a for loop? This is the basic logic and the flowchart in front of you. So what exactly happens is that, say for example, you want to print the word looping, say 10 times, right? So what you can do is you can start and you can have a for loop which goes from 0 to 9. And then you increase the number by 1 every time you print the loop. Once it's equal to 10 or even greater than 10, it ends the loop, right? So let me help you understand this better with an example. So let's go to our editor, that is VS Code. Here I've created a folder called demo_loops, within which I've created a file called for loops. Alright. So now let's just write down our initial code for HTML, that is HTML, and then I have a head tag within which I say JavaScript loops. Alright. Now I have a body tag within which I give a heading for clearer understanding. Let me have a heading, say JavaScript for loops. Alright. Let me just call it for loop. Now let's have the script tag within which I'll have a variable, say x, and now we'll have the for loop. So we say for x equals 0, x less than 5, x plus plus, within which I say console.log of x. So basically, what happens is, now you have the first variable which is called the counter variable. Now this keeps track of how many times the code is being executed, right? And next, I less than 5 is the condition. Now the loop keeps executing as long as the condition is met. And lastly, the counter variable is incremented, and usually it's incremented by 1, right? So here we've done the same thing. And inside the loop, we print the value of x. Alright, so let me save the file and then execute it. Alright, it's printed JavaScript loops here. Let me just go back. Okay, my bad. I missed out on the title tag. So this has to be enclosed within the title tag. So let me just change it here. Now let's save this. Let's go back and just refresh the page. And that is it. So whatever is in the title tag basically appears here. Alright. So now since we're printing the value of x on our console, we'll have to inspect our element. So let's go here. And here let's check on console. And here you can see all the values have been printed from 0 to 4. Alright, now this is a simple for loop. So next up is a while loop. Now the logic is similar to that of a for loop. So first the condition is checked, and if the condition holds true, then the code is executed, and if it is false, it terminates. Alright, So moving on, let's understand the general syntax. So here first you have the variable whose value keeps changing, and then you have the ending condition, which is basically the maximum value a variable can reach. Alright, so let's go back to our VS Code. And here, for better understanding, let me just change this to JavaScript while loop. Alright, let's just delete this, and here, let's initialize the value of x to 1. And now I say while x less than or equal to 5, within braces, I say console.log of x, and then I increment the value of x. Alright, so let me save this and let's execute the file. Alright, so it says JavaScript while loop, and let's inspect. And here in our console, it displays the values of x. Alright, so according to the logic, x is initially initialized to 1, and the value gets executed once it enters the while loop. Alright, it's incremented and then checked every time until the value reaches 6, right? And then it breaks from the loop since the value does not hold true, and then it terminates. So this is the logic behind the while loop. Next up is the do while loop. Now here, as you can see, first the code is executed and then the condition is checked. If the condition is true, then the code execution continues, and if it falls, it's terminated. Alright, so this is an exit control loop. Also, in an exit control loop, the code is executed at least once. So let's go back to our VS Code, and here, let me just delete this. Now let's initialize x to say 15, alright? And now I use the do keyword within which I write the code. So first I'm going to print the value of x. Console.log of x, and then I increase my value. And here I mention my test condition, which is while x less than say 10. Alright, so according to the logic, initially the value is x, and once it enters the loop here, it should print the value of x, which is 15. Alright, and then it increments the value. But once it comes out of the loop, it checks for the condition. Here the condition says less than 10, but since x is not less than 10, it prints the value x, that is 15, and then terminates. Alright, so let's save this and execute it. So let me execute this, and here let's check the console. So there we go, it prints 15. So what it does is that it prints the value 15 first and then checks the condition. Now let's go ahead and change the value of x to say 5. Alright, so now it enters the loop and then it prints the value of x and then increments it. And when it comes out of the loop and checks the condition, as long as the value of x remains less than 10, it prints it. Okay, so let's save this, go back here, and let's refresh the page. And here you can see the values 5 to 9 are printed. So this is how the do while loop works. Moving on to the next concept, breaking out of a loop. Now, as the name suggests, break is the keyword that is used to break out of a loop. Now here is a simple code for you. So according to the logic, it prints the values between 1 to 10. And say at the value 5, you want to break out of the loop. You can simply use the keyword break. So let's go back to our VS Code. And here, let me just make it simple and say for x equals 1, x less than or equal to 10. Let's increment it. And within the loop, let's display the value x on the console, and then we're going to check for the condition if x equals 5. Alright, so if x equals 5, we break out of the loop. So let's save the file and execute it. And there you go. It's displayed the values from 1 to 5. So basically the code inside the for loop is executed, and once the value of x reaches 5, it breaks from the loop. Simple, right? Alright, so let's move on. Next up, we have skipping a loop cycle. Alright, so here, what exactly we do is we make use of a keyword continue to skip a particular loop cycle. Say in this case, we have a for loop which displays the values of I ranging from 1 to 10. However, we want to skip the cycle when it reaches the value 3. So what we do is we make use of the keyword continue here. So basically it displays 1 and 2 and skips the third cycle and then directly displays 4. Alright, so let me show you in our VS Code editor. Here, let me just remove this and save. If x equals 5, I'm going to continue. Alright, after which I'm going to say console.log of x. So let me save this and then execute it. So here, let me refresh the page, and there we go. As you can see, it displays 1, 2, 3 and 4, and the fifth cycle is skipped. Alright, and the rest of the digits are displayed. So that is how you can skip a loop. I highly suggest you also practice all of this and then play around with loops to get a better understanding. So taking a step forward, we're going to learn about JavaScript objects in this video. So without further ado, let's begin and look at what's in store for us. First, we'll start by understanding what a JavaScript object is. Then, we'll learn how to create a JavaScript object and also get to know about the properties of these objects. After that, we'll get familiar with using JavaScript methods. Lastly, we'll understand what JavaScript accessors are. So what is a JavaScript object? JavaScript is an object-oriented programming language, so everything in Java is an object. A JavaScript object is like a real-world entity having state and behavior, for example, a car. Now we can take a car as an object. It will have its state like color and model. It will also have behaviors like accelerate and brake. JavaScript is template-based and we can create objects without having the need to create a class. Generally, object is accompanied by a class that defines an object's blueprints, but JavaScript doesn't require any class to be defined for objects. Moving on to the next concept, to create a JavaScript object. Now basically there are 3 different ways of creating a JavaScript object. Alright, so we'll look at them one by one. The first one is to use a literal to create and define a JavaScript object. So let's go to our VS Code editor. Now if you have any doubts regarding the initial setup, then I suggest you go through the previous video, that is JavaScript arrays, to get you started with it. So here I've created a folder called demo objects, and now I'm going to create a file called create_objects.html. Alright, so we'll begin by writing the initial code, that is the head and the body. So I say HTML, within this I create the head tag, and then I create a title tag, and let's say JavaScript objects. Then after the head tag, I'm going to create a body tag. And let's create a heading and say creating JavaScript objects. Okay. And now we create an ID. All of this is explained in the previous video. I really suggest you go through the video beforehand so that you get a clear picture. And then I say ID equals, say demo, and then I'm going to close it. Now the first method that we're going to use to create an object is by using object literals, right? So what we can do is say script within which I declare a variable, say var student. Now within the object, we're going to create 3 different properties. Now this is basically like a dictionary. It has a property, a key, and then a value. Okay, so I say name property, and let's say Chris. And then another property, say age, and say 21. And another property, say studies, and say maybe computer science. Okay, so this is the syntax used to create an object using an object literal. Now after this, what we're going to do is we're going to display this. Right, now we want to display the message saying Chris of age 21 studies computer science. So what we can do is say document.getElement by ID, and the ID that we're going to pass is demo, and we say inner HTML equals student.name, which is Chris, after which we display the message of the age, and then the age, that is student.age, studies, student.studies. Okay, let's save this, and when we execute the file, it says Chris of the age 21 studies computer science. Alright, this is one of the ways in which you can define an object. Alright, so moving on to the next way of creating a JavaScript object, it is to use the new keyword. Now this is the most traditional way of creating an object, right? So let's go back to our VS Code. Let's create another script within which we say var student equals new object. I'm sure everybody has learned the same way, the same syntax. So this is one of the ways. After which we can say student.name equals Chris. Again, student.age equals 21, and then student.studies equals computer science. Alright, now after this we again display the message. So let me just copy this. Alright, so let's save this and run our code again. And there we go. It displays the message Chris of the age 21 studies computer science. Alright, this was the second method used to create an object. Alright, so then moving on to the third method, it is to use an object constructor to create and define a JavaScript object. So let's go back to our code editor, and here we define a function. So we say function, say stud, with 3 parameters, that is name, age, and say studies. Okay, and now within the function we use the keyword this. So we say this.name equals name. Alright, we say this.age equals age. We say this.studies equals studies. Now what we do is that we can create a variable and pass parameters to the function. So we say var student equals stud, and within braces we say Tress, comma 21, comma computer science. Alright, so we've done passing the parameters. After this, we're going to copy the same print message here. Alright, so let's save this and execute our file. So let's refresh the web page. And there we go. It still displays the message, Chris of the age 21, studies computer science. So this was the third method that can be used to create objects. Moving on to the next topic, object properties. Now a JavaScript object is basically a collection of unordered properties, right? Values associated with the JavaScript object are called its properties. And properties can usually be added, updated, or deleted, excluding read-only properties. So now let's have a look at the demo to help you understand this better. So let me go back to my VS Code. So this was where we left off, and this was how we created objects, right? So now let me create another file, and let me call it objects_properties.html. And now what I'm going to do is I'm going to copy the first piece of code here. Alright, I'm going to just copy this into my new file. And here, as you can see, student is the object that we've created, and name, age, and studies are the 3 properties. Now say we want to update the age. Alright, so what we can do is here we can just say student dot age equals, let me change it to 24. Alright, and let me save this, and when we execute the file, that was object_properties, you can see Chris of the age 24. So 21 is updated to 24. So this is one of the ways you can do it. Or there's another method. You can just assign the property to a variable and then display the variable instead. So what we can do is we can just assign student.age to a property, say x. And here, instead of displaying student.age, we can just say x. Alright, so let's save this. And when we run it, it says 21 because we haven't updated 21 to 24 anywhere. Alright, so 21 remains the same. So another method we can use is we can just say x equals age. So we're directly assigning the property to the variable. And here, when I'm displaying it, I say student of x. Alright, so let me save this. And when you look at the web page, it still displays the same thing. These are different ways of accessing the properties. You can update them, delete them, unless they're read-only. Alright, So let's move on to the next concept, object methods. Now basically, a JavaScript method is an action that can be performed on the objects. So you'll understand better with the help of the demo. So let's go back to our VS Code, and here I've created another HTML file called objects_methods. Alright, so let me just copy the initial code, paste it here, and let's have the enclosing tags as well. And HTML. Alright. Now here I declare another tag, that is the button tag. So we're going to be making use of button here. So I say button ID equals click me. So that is the action that I'm going to be performing. And the message that is going to be displayed on the button will be click me. Alright. So we're going to see the usage of it a little later. Now let's go ahead and create an object. So I say script, within which I create the user object. So we're creating using a object literal here, and I declare the property name as Chris again, and age say 24. Okay. So let's close this. Alright, so the next thing I'm going to do is I'm going to create a new function that we will use as an object method. Alright, so I say function, and let's give the name say hi. Okay. Within the function we basically display a message. So we're going to say alert and hello. Alright, so this is going to be displayed in a separate dialog box. So now once the declaration is done, what we're going to do is we're going to create another property, basically say user dot, let's say message, and assign say hi to it. So basically what we're doing is we're adding the previously created method to a new property that is user.message, the message property. Alright. So now I say document.getElementById and say demo. And the message that I want is just hi plus the username. Alright. So what we're going to do is we're going to display the message hello, alright, when the user clicks on the button. So for that, let's just copy this. And here, instead of demo, right, we're going to be passing the ID click me as per this, and the event is going to be on click event. So here I say on click, after which I'm going to simply pass user.message. Let me just delete this. Alright, so here I notice that I've given an equal to sign. I'm sorry, it's a colon. Alright, so let's save the file and let's go ahead and execute it. Alright, so here you can see hi Chris being displayed, and once we click on the button, you can see an alert which says hello. Alright. So now let's move on to the next concept, that is Java object accessors. Now getters and setters allow defining an object accessor. Alright, to get the value of a property in a JavaScript object, we use a getter, and to set the value of a property of a JavaScript object, we use a setter. So let's go back to our demo, and now let me create another file. and let's call it object accessors. And now again, let me just copy the first initial part. Alright, so now let's go ahead and create a new object. So let me say script, within which I say where, and let's call it car. Alright, so let me define the properties, say model, and the model is say BMW 320D, and another property say color, and let's say it's navy blue, and the last property say fuel type, and let's say it's diesel. Now what we can do is we can make use of the keyword get to access the properties. So I say get and say fuel, within which I return this dot fuel type. Alright, it's as simple as that. So now let's display it. Document dot get element by ID, demo dot inner HTML equals, we say car dot fuel. Alright, so now let's save it and execute our file. Here you go, it retrieves diesel for us. Now this is one of the ways of accessing the properties. Now to help you understand setter, let's go ahead and create another object. Alright, say where car again. Now let's say the model is Audi A4, color be bright red, and fuel type, let's keep it blank. Alright. Now to set the value, we use the set keyword. We say set fuel, and the parameter is fuel, within which we say this dot fuel type equals fuel, right? Now let's set the value for the fuel. Say car dot fuel equals petrol. Alright. Now let's display the same. Let me copy this. And what we want to display is the fuel type, right? So here we say fuel type. So let's save this. And let's go ahead and execute the file. And there we go. It retrieves petrol. So what it does is basically it assigns the value petrol to the property fuel type, and then we display the same on our web page. So this is how you make use of getters and setters. In today's video, we're going to learn all about JavaScript functions. In our previous videos, we've covered topics like JavaScript arrays and loops. Alright, so before jumping in, let's go ahead and look at what's in store for us. First, we're going to learn what exactly JavaScript functions are. Then we'll look at JavaScript function expressions, then the function constructor, self-invoking functions, functions as values, functions as objects, arrow functions, generator function, and the predefined functions. Also, don't forget to subscribe to our channel and hit the bell icon to never miss an update. Moving on to our first topic, what are JavaScript functions? So basically, a function is a group of reusable code which can be called from anywhere in your program, right? When you have a piece of code that you want to execute repeatedly in your entire program, it makes more sense to define it once and call it over and over, right? It makes the code more efficient and readable. This also helps programmers write modular codes. So this is the syntax. You make use of the function keyword, followed by which you mention the name of the function. The name of the function is completely your choice. Next, you mention the parameter list. And within curly braces, you can define the function. Now, the function body is basically the code that is executed every time the function is called. So let's go to our VS Code editor. And here I've created a folder called demo functions, within which I've created an HTML file called functions.html. Alright, and now I've just typed in the initial code. Now let's create a function. So let me say script, within which I use the keyword that is function keyword. And now I give the name for my function. I say my underscore function. And the function takes a parameter, say value. Now this function basically returns the square of the digit, alright? So within which I say document.getElementById. The ID is demo. And now it just displays value into value. Alright, so the function basically displays the square of the number. Now outside the function, let me call the function. It is my function, and let me pass the value 5. Alright, now let's save this and execute it. So let me go back to my file. And here we go. It displays the value 25. So this was a simple function which took a value, a digit as a parameter, and then returned the square. Moving on to the next concept, function expression. Now what we learned previously was function declaration, but a function can also be defined as an expression. Now this is what the syntax looks like. Now here the function is created and assigned to the variable explicitly like any other value. The meaning remains the same. That is, you create the function and store the value that it returns into a variable, and in our case it's x, right? So let's go to our VS Code and let me help you understand this better. So now I create another function, and here I say let x equals, let's use a simpler function. So I just mention function, and within curly braces I display an alert message, and I display a message saying hello. Alright. Now after that, to display the message, what we can do is, let me just copy this output code and paste it here. And here what we're going to be displaying is the value x, right? Now since it consists of a function, you'll have to type the curly braces. Now this is crucial for its execution. Alright, so let me save this and then execute. Let me execute this. And here you go. It says the site says hello. So we've successfully executed the piece of code. We can also assign this variable x to another variable and then call that variable instead. Right? We can say let y equals x, and instead of calling x here, we can simply call y. Let me save it and then let me refresh the page. And there we go. It still displays the message hello. Alright, so this is one of the ways of defining a function, that is as an expression. Moving on to our next concept, function constructor. Now JavaScript functions are defined using the keyword function, right? Now functions can also be defined using a JavaScript built-in function. Now this is the basic syntax. So here we've created a function called myFunction, and we've used the keyword new. After which we've used the constructor function, and inside we provide the parameter list. After that, the return value. Next, you can call the function here, right? So let me just go back to my VS Code. And now let me just make changes to the same piece of code here. I create a function, say my_function. Okay, alright, let me just change the name to my function. Alright, and then here I use the keyword new and the function constructor, that is function, within which I'm passing all the parameters. So I have a, b, and I'm going to return the sum of the digits. Alright, and now while calling the function, let me just store the value in a variable, say x, and let's call the function, that is my function, with the parameters 2 and 3. Alright, and now let me display it. So I'm just going to copy this, and I want to display the value of x, right? Alright, so let me save this and execute it. If you refresh the page, it displays the sum, that is 5. To make it more readable, let me just display another message here. Let me just say the sum is x. Alright, let me save it and then refresh the page. It says the sum is 5. Alright, now this is how you make use of the function constructor. Next up, we learn about self-invoking functions. Now, as the name suggests, these functions are invoked automatically without being called. Now, previously when we learned about function expressions, we saw that parentheses were crucial. So you have to add parentheses around the function to indicate that it is a function expression. So here is a syntax for you. So what we've done is we've made sure we've enclosed the entire function within parentheses. So let me help you with that. Let's go back to our VS Code and let me create another script. And here, let me create the function within the parentheses and say function. It's not taking any parameters. Instead, it is going to alert a message. So let me say hello, welcome. Alright. After which, we are going to call the function. So again, we have to mention the parentheses. Let's save this and execute. So when we refresh the page, it says hello, welcome. So we never called the function, rather it got invoked by itself. So these are self-invoking functions. Now let's go ahead and look at functions as values. Now in JavaScript, a function is basically a value. So we can deal with it as a value. Now here is a simple syntax. Now if you closely look at the syntax, you might think that this is same as function expressions. Well, no. In this case, what we do is we first define the function and then we assign it to a particular variable. But in the case of expressions, the function definition was defined during the initialization of the variable, right? And also we have to specify the parenthesis in order to call the function. So to help you understand this better, let me go back to our VS Code. And here, let me just erase this. And let's define a function that returns the product of two digits. So let me just call it product, which takes two parameters. Let me say a and b, within which we return the value a into b. Alright, now after this, let's create another variable, say y equals function. Oh, I'm sorry, the name of the function is product. So product of 2 and 5. Alright, so this basically returns us 10. Right, so let me just copy this to display this on our web page. And here I change the message to the product. And here let me change it to y. So let's save this and execute it. So let me refresh the page. And here you go. You can see the message, the product is 10. Now what we can do is we can make alterations to this. Now say I want to multiply the value with 5 again. Right, so basically this returns 10 and that value is multiplied by 5. So let me save this and refresh our page, and there we go. It returns, and there we go. It displays 50. So this is how you can make use of functions as values. Moving on to the next topic, functions as objects. Now JavaScript functions are a special type of objects called function objects. Now a function includes a string which holds the actual code, that is the function body of the function. The code is literally just a string. Although not recommended, you can also create a function with the help of the function constructor. I will show that to you a little later on. But for now, let's look at the syntax. Now here we have a variable called body, which basically consists of the function body. It's enclosed in double quotes, and that's a mistake. Please ignore it. Alright, so next we have variable function name. So here we create a function using the keyword new, and then we pass a parameter list, and the body basically tells us what the function returns. Alright, next we have an alert message to call the function. So let me just show how this is executed. Back in our VS Code, let me create another function, and let's say the function returns the area of a circle, right? So let me just create a body variable which returns, so the area of a circle is pi r square, so we make use of math.pi into radius, right? So it's basically pi r square. After which, let's say where circle, and here let's create a function using the new keyword function, and then here we pass the value, that is the radius, and then the body, right? So basically this is the definition of our function. So let's use alert to display the area. So we say alert of circle of 5. Alright, so let me save this and execute it. So when you refresh the page, it displays the area of the circle. So this is how you can use functions as objects. Moving on to our next concept, arrow functions. Now functions can be written more compactly and more precisely with the help of arrow functions. Alright, now arrow function expressions are ill-suited as methods and they cannot be used as constructors. Now also while using arrow functions, using const is a safer option because a function expression is always a constant value. So this is the syntax. Now you can only omit the return keyword within the curly braces if the function is a single statement. So this is the syntax. First you provide the name of the function with an equal to sign followed by the argument list, and later you make use of this arrow icon and define the expression. So this is basically nothing but this. So let's go back to our VS Code and check for ourselves. So let's create another function, and here let me say const myfunc equals. Now say we want to display the product of 3 digits. So let me just pass A, B, C as my parameters. And we make use of this icon which indicates that this is an arrow function, within which I say return A into B into C. Alright. Now let me just assign this to a variable. Okay, let me say product, because we've used X here. And then let me call my function, that is myfunc, and pass the value 2, 3 and say 4. Alright, so let's display the product. So let me just copy this code. And here let me say the product of the 3 digits is. And let me say product here, because that is what is being used here, right? Alright, so let me save this and execute it. Alright, first it displays the area of the circle. Alright, and then we say OK. And there we go. It displays the message. The product of the 3 digits is 24. So let me do one thing. Let me just comment this out. Okay. Let me save it and then execute it again. It just displays this. Alright, so this is how we can make use of arrow functions. Moving on, let's look at the generator function. Now, regular functions typically return only one value, right? Or a single value, or sometimes even nothing. But a generator function can return multiple values. And the speciality is that it can do it so on demand. Alright, now to create a generator function, we make use of an asterisk. So an asterisk indicates that the function is a generator function. So here you can see that we have a function followed by asterisk, and we've created a function called generator sequence. So here you can see we have the asterisk after the keyword function followed by the name of the function, right? But the main method of a generator function is the next method. When this method is called, it basically runs the execution until the nearest yield value, alright, or the nearest yield statement. Then the function execution pauses and the yielded value is returned to the outer code. Alright, so the result of the next method is always an object with 2 properties. It has the value property, which is basically the yielded value, and then it has the done property, which displays true if the function code is finished or false if it's otherwise. So let me show its execution for a clearer understanding. So let's go back to our VS Code, and here let's create the generator function. Let's say function asterisk generate function, alright. Now within which I make use of the keyword yield, and I say yield 1 first, followed by yield 2, and then finally I make use of return, which indicates the termination, so I say return 3. Alright, now we make use of a variable, say generator, and assign it to the generator function, that is generate func. And now I create another variable, say 1, which will basically return the value when I call the next function. So here I say generator dot next. Okay, so whatever generator dot next returns, it's stored in 1. So to display the message, I say alert. And now I'm going to make use of a method called json.stringify. Alright, so basically this method converts a JavaScript object or a value to a JSON string. Alright, so within which I'm going to say 1. That is this. Alright, so now let me save this and execute it. Let me refresh the page. And there you go. Here it returns 2 properties, that is value and done. It says value is 1 and done is false, right? It is false because we haven't reached the return statement yet. So what we can do is to display the rest, let me just copy these and display it one by one. See there, let's do this. And here let me say 2. And this is 3. Let me copy this. Okay, here I say 2 and then I say 3. Alright, so let me save this and then execute it. So when I refresh the page, it says 1 and false. After which again it says 2 and false. And finally, when it displays 3, it returns true for the done property. That means we've reached the end of the function definition. So this is how you make use of a generator function. Now let's move on to our last topic, that is predefined functions. Now JavaScript has many built-in functions, alright? Now here are a few of them. We have eval, parseInt, parseFloat, escape and unescape. Now let's go through one by one. Alright, first up is eval. Now this basically evaluates a string and returns a value. Alright, so to help you understand this better, let me go back to our VS Code. And now let me just create another file and let me call it predefined functions.html. Alright, and I've just copied the initial code. Alright, so for eval, the syntax is eval, within which I say expression. Alright, now this is the general syntax. So what this eval does is that it evaluates the expression. And if the result is not a string, the result is just returned. And if the result is a string, it is taken to be a JavaScript program and evaluated. So let me show you how it's done. So first, let's create 3 variables. Alright, let's call them x and initialize it to 5. Then y with 6. And then let z be 7. Alright. Now let's just display the result on the console. So let's say console.log eval of, let me say, x plus y. Alright. After which I again say console.log of eval of z. Here, since the expression is a string, this gets evaluated. And here, since it's not a string, it just returns the value z. And here, since it is not a string, it just returns the value of z. So let me save this and then execute it. Alright, so let me just check our console. There you go. It evaluated the expression and added the 2 values, that is x and y, and returned 11, while z is returned as it is. Alright, this is what eval does. Next up is parseInt. Now, as the name suggests, it parses a string argument and returns an integer of the specified radix or base. And the syntax basically includes the keyword parse and the string within parentheses. ParseFloat, on the other hand, parses a string argument and returns a floating point number. Again, the syntax has the keyword parseFloat along with the string within parentheses. Next up is escape. Now this returns the hexadecimal encoding of an argument. And on the other hand, unescape returns the ASCII string for the specified value. In this video, we're going to cover the topic of JavaScript closures. So without further delay, let's begin. So before understanding what exactly closures are, let me brief you about the variable scope. Now JavaScript defines 2 scopes. You have the global scope and the local scope. Now any variable declared outside a function belongs to the global scope, and as a result of which it can be accessible from anywhere in your code. These variables are nothing but the global variables. And local variables are those variables which are declared within a function, and as a result of which these variables can only be accessed within the function or maybe its nested functions. So to give you a brief example, consider this piece of code. Here, the variable a is defined outside the function, and as a result, it is a global variable. And the variable b is declared within the function, that is function name. And only this particular function can access this variable. Alright, so let's go to our editor, that is VS Code. And here, I'll help you understand this better with an example. So here, I've created a file called closures.html within a folder called demo_closures. And now in my code, I've written the initial code. And now, let me say script. Now I'll create a variable, say let x be say 10. Okay, now I'm going to create a function with the keyword function, and let me give it the name my function, within which I define another variable, say b, which is equal to 20. And now let me just display a plus b. Alright, now here the variable x, oh I'm sorry, I've said a here, so let me just change this to a. Alright, so here the variable a is a global variable, alright, and the variable b here is a local variable. However, the function my function can access the global variable a as well. So now let me just call my function, alright, and let's save it and run our code. And there you go. You can see it's displayed the value 30. So the code can access the value of this variable as well. So I hope you understood what global and local variables are. So moving on. Now let's see what a closure is. Now closures in JavaScript is basically a feature where an inner function can access the outer function's variables. Alright? So basically a closure has 3 scope chains. So every function has a set of variables that it can access. So all the references to these variables are stored in a stack, and this is called the scope chain. So a closure has 3 scope chains. So it has scope chain of its own, that is the variables defined within its own function body. It also can access the variables of the outer functions, and finally it has access to all the global variables. So to help you understand this better, let's go back to our VS Code. So here let me just comment this code, and then let's just create another script. Alright, now first let's create a global variable. So let me call it variable a and initialize it to 10. And now let's define a function, and let me call it first function. Alright, within which I'm going to define a variable b. Now this is going to be a local variable which is local to this particular function. Alright, and within this function I'm going to define another function, call it second function. And now I'm going to define a variable c, which is basically the sum of a and b. Alright, I say a plus b, and this function returns the value of c. So I say return c. Alright, and finally our function first func is going to return the second function. So it is nothing but return second function. Now let me call the function. So I say variable sum equals first func. So if you have any doubts regarding functions, I highly suggest you go through our previous video on JavaScript functions. Alright, so moving ahead, once the function is called, the value return is going to be stored in the variable sum, and then we're going to print the sum. So we say document dot write, and let me display a message. The sum is, and let me just break it. Alright, let me save this and then execute it. Let's go back to our browser and just refresh the page. It says the sum is 30. Now we can also go back and make changes here. Suppose I want to add a value. I can just say 20 plus a plus b. So let me save this, and here it says 50. So basically, the function second func can access the value of b and a. So this is what closure is. So it has access to its own variables, the variables of its outer function, and the global variables. I hope this was clear. In our previous few topics, we learned about arrays, functions, and loops. However, this time we're going to take a step forward and then learn about promises. So let's go ahead and jump right in. Now you must be wondering why JavaScript promises even came into picture and what exactly these promises are. So don't worry, I've got your back. In today's video, we're going to learn about promises, why they were introduced, and also I'll explain their functionality. So let's go ahead. First up, why JavaScript promises? Now, JavaScript is predominantly single-threaded, meaning all processes contain the execution of instructions in a single sequence. So basically, in simple terms, one command is processed at a time. Now, if a function relies on the result of another function, it basically has to wait for the other function to finish and return. And until then, the current function remains idle. Now, this can be extremely frustrating because it's time-consuming and very restrictive. I mean, you're not using the system to its full capability. So to overcome these drawbacks, asynchronous concepts or asynchronous programming came into picture. So in this case, the main thread continues its execution while JavaScript allows long network requests and other tasks to happen simultaneously. Now with the help of features like callbacks, promises, and async await, asynchronous programming can be easily achieved. I hope now you understood why promises or asynchronous programming came into picture. Moving on, what are JavaScript promises? Now in the case of synchronous actions, you could, instead of arranging for a function to be called at some point in the future, return an object that represents this future event. This is what the standard class promise is for. Now a promise is basically an asynchronous action that may complete at some point in the future. And when it's completed, it produces a value. Now it is able to notify when its value is available. The easiest way to create a promise is by calling the promise.resolve method. Now this function ensures that the value you give it is wrapped within a promise. Now a promise basically has three states. First up is the pending state. Now this indicates that the underlying operation has not yet been completed. Next up is the fulfill state. This indicates that the promise has been fulfilled with a particular value. Lastly, we have rejected. Now this indicates that an error has occurred during the operation and the promise is rejected with a particular reason. Moving on, a promise is said to be settled when it is either fulfilled or rejected. Because remember, promises are immutable. They cannot change their state. So once they're either fulfilled or rejected, they're said to be settled. So when a promise is fulfilled, it has to do a particular job. So for that, we make use of the then method. Now the then method basically runs for a result, and this is used to attach a callback when the promise has been resolved. Alright, same with the case of the scenario when the promise is rejected. It makes use of a catch method, which is used to attach a callback when the promise has been rejected. Don't worry, you'll understand the concepts better when we get to the demo. So moving on, let's look at a quick flowchart to understand promises better. First up, you have a new promise. Now the promise is in the pending state. Now this promise runs for an asynchronous action. Now we check if the action is successful. If it is a yes, then we call the then method. And if it is a no, then the catch method is called. And to end it, if it is fulfilled, then the asynchronous action is performed. And if it is not, that is if it is rejected, then error handling is performed. And lastly, the values of these methods is returned to the promise. I hope this was clear. So moving ahead, let's look at the general syntax. You can use the let keyword and provide a name for your variable, and then you create a new promise. Now this promise object takes a function which in turn takes two parameters, that is resolve and reject. So to help you understand all of this better, let's go ahead and look at a simple demo. So in VS Code, I've created a folder called demo promises, within which I've created an HTML file named promises. So I have the initial code ready here. So let's begin typing our code. So let's say script And here, as I explained, we say let, and let's give the name car to our variable. Say car, and we create a new promise. Alright, so the promise object returns a function which takes two parameters called resolve and reject. Alright, so within the function, let's define a simple use case. Now let's assume that we're checking the car for its fuel. Alright, so we'll create a variable called fuel underscore full tank. Now let's set the variable to say true. Alright, now let's set the variable to true. Now this indicates that the fuel tank is full. So now if the fuel tank is full, what I can do is I say resolve. Alright, else I reject it. Okay, I hope you understood what I'm doing here. I'm just checking for the fuel tank, and if it is full, which is true, then it gets resolved, and if it is false, then it gets rejected. So if the promise gets resolved, the then method is called, right? So let me call it here. I say car dot then. Now this runs a result, right? So it's a callback function within which I say document dot write the fuel tank is full, happy driving. Alright, and if it is rejected, I say dot catch, which also returns a function that says document dot write. Let's just display a simple message saying that the fuel tank is not empty. Alright, so let me save this and execute it. So here it displays the message, the fuel tank is full, happy driving. Now that happens because we've set the value to true here. Now in case we change it to false, let's see what it displays. Alright, it displays the message, the fuel tank is not empty. So this was a simple example showing how a promise works. Now let's go ahead and understand nested promises. So for that, let me just comment this out. And now let's create a function that returns promises. So in our case, what we're going to do is first we'll check for the fuel tank. Now in our case, we're taking a scenario where the fuel tank is empty and the engine of the car is overheating. So as a result, the car is not safe for traveling. Alright, so let's go ahead and create these functions. So I'll say let empty underscore tank, okay, which returns a promise. So within which I say return new promise, and the function takes two parameters, that is resolve and reject, within which I'm going to display a message saying resolve, which says the car doesn't have enough fuel. Alright. Now let me just copy the same piece of code to check for the engine. Alright. So let me just change the name of our variable here. Let's call it engine. And here it displays the message, the engine is overheating. Alright. And lastly, when both of these scenarios hold true, that is the car doesn't have enough fuel and the engine is overheating, we say that the car is not fit for travel. Let me just call it travel. And here I'll display a message saying the car is not safe for traveling. Alright. So right now we've created 3 functions that returns promises. So first we check for the empty tank, right? So let me just call the function here empty tank, and we make use of the then method, which is executed when the promise gets resolved, which takes a callback function. Alright, so basically when we check for the empty tank, after this is executed, we check for the engine, right? So here we simply call the engine function. So let me just say return engine. Alright. Now this is a nested promise in itself. So on top of it, I can run the then method again. So if the tank is empty and if the engine is overheating, then I'll just check if it is safe for traveling or not. So let me say function, and here let me just return the method travel. Alright. Now after this, if all of these are executed, then I say function. Finally, I'll display a message saying done. Alright. So let's save this file and execute it. So here I go ahead and click on promises. Let's go and check our console. And there we go. The message done is displayed. So here, since every time the promise is being resolved, a message is displayed, I can basically catch the message in a result. Okay? And this result can be passed to the coming methods. So here I just say result. I say result again. Alright. So now we get the message, the car doesn't have enough fuel. So we have to append it with the next message. So let me just say message here. I've used MSG. And let's just append it here. And the final message gets appended here with result. Okay, I have to add message here as well. Alright. So let's save it and execute the file. Alright, so here you can see the message done gets displayed first, and then since we're appending it after the message done, it says the car doesn't have enough fuel, the engine is overheating, the car is not safe for traveling. So this was how you can make use of nested promises. In today's video, we're going to learn all about JavaScript asynchronous concepts, that is async and await. In our previous video, we covered the topic of JavaScript promises. So without any further delay, let's go ahead and learn about async and await. Firstly, let's understand the basic concepts of synchronous and asynchronous programming. In case of synchronous programming, all the actions are performed sequentially. So you have the execution of the function 1, after which you have function 2, and then you have function 3. And after all of these are executed, the program terminates. Now, although synchronous programming is clean and has lesser errors, it has its own drawbacks. The entire system is halted when a particular process is being executed. Now, as a result of which, it is time consuming and the system is not used to its full capacity. So to overcome that, asynchronous programming was introduced. Now in this case, let's assume that a particular function or a process is being executed. Now let's consider that this particular function is waiting for a resource, let's say a network resource. Now instead of waiting for the function to acquire this resource, the main thread continues its execution with function 2 and function 3. And when the resource is acquired, it receives a callback, indicating that the function 1 has to be called. And finally, the entire chain is terminated. So this is how asynchronous programming works. It makes sure that the system does not halt when a particular process is waiting for a resource. This makes the entire system very efficient. Now that you know the concepts of synchronous and asynchronous programming, let's move ahead. Now async and await are purely asynchronous programming concepts. I again suggest you check out the video on promises before watching this. Alright, so moving on. What are JavaScript async functions, that is async and await? Now async and await are built on promises. The function is basically accompanied by the keyword async, indicating that it returns a promise. Within this function, the await keyword is applied to the promise that is being returned. And the await keyword ensures that the function waits for the promise to resolve. Now on the surface, the execution looks synchronous while it's actually asynchronous. Now at the place of usage of the await keyword, the execution of the function is practically blocked. Now async functions make the code more readable and are easier to handle when compared to promises. Now to give you the general syntax, you have the async keyword associated with the function name, within which we have the await keyword with a particular promise. Now to help you understand the entire concept better, let's look at a demo. Now I've created a file called async await in my Visual Studio Code. So what we're going to be doing is that we're going to have two functions that help you check for the result. Now you pass this code as a parameter to these functions, which in turn return promises telling if you have passed and will also give you the grade that you've scored. Alright, so let's go ahead and say let me call the variable result, and let's have a function which takes the score as a parameter. Alright, within which it returns a promise. So I say return new promise. Now as you know, a promise basically has a function which takes two parameters, that is resolve and reject. Now I just display a message saying calculating results. Alright, now if my score is say above 50, I resolve it by displaying a message saying congratulations, you have passed. Alright, and if it is less than 50, I reject it with a message saying you have failed. Alright, so this is a very simple promise that I've created. So moving on, let's create another function that returns a promise. So basically this function will tell you the grade that you've scored. So say let grade equals function. Now this takes response as a parameter. So let me just say response. Now again, let me just copy this. Alright, within which I'm going to console log a message saying calculating your grade. Now we're just going to resolve the promise with the message your grade is A. Alright, and then we append the response. Now the first promise either resolves saying that you've passed, or it rejects saying you failed. And in case it gets resolved, then the next promise is automatically resolved with the grade A. Alright, so moving on, let's call the functions. So here, let me first call the function result. So I say result, and let me pass the value 80 since it gets resolved. And now I make use of the .then method. Now here I catch the response. Alright, and then I just display a message indicating results received. Okay. Now what I'm going to do is I'm going to pass the response to my next function, that is the grade function. So what I say is I say return grade and the parameter is response. So let me just pass that. Now what exactly happens is that the grade function also returns a promise. So on top of that I can use the .then method. So I use the then method and let me just say final grade. Now within which I just display the message final grade. Alright. Now lastly we make use of the catch method. In case of errors, this catches the errors. So let me just say error and then we'll console log it. Alright. So this is the code. Let me save this and let's execute it to see its normal execution. So this is without using async and await. Alright. So let's go ahead and execute this. So here let me check the console and there we go. It says calculating results, results received, calculating your grade. Your grade is A and congratulations, you have passed. So this was basically without using async and await. So now let me show you how you can use async and await and how easier the code becomes. Alright, so what we can do is, let me just comment this out. Alright, now what I'm going to do is I'm going to call my function, right? So I'm just going to make use of the async keyword while calling it. So I say async function and let me call the function calculate results. Okay. So now inside this method, I'm going to call the functions result and grade. So when I first call result, the value that is returned by result is going to be stored in the variable response. So for that, let me just say const response. Now I make use of the await keyword here. I say await result of 20, or in our case, let me just say 80. Alright. So what the await keyword does is that the function result ceases to execute until the promise is resolved. And whatever the promise returns gets stored in the variable response. Alright. So now after this, let me just display a message that says results received. Alright. Now next, I'm going to call the other function, that is grade. So again, I'm going to say constant and I'm going to have to create another variable. Let me call it final grade. And it's the same procedure. I use the await keyword and call the function grade. And I pass response as the argument. Alright. And after this, I'm going to say console log for final grade. So it's as simple as that. So first we call the result function, which returns a promise which gets stored in the variable response. Alright. Then we're going to call the grade function and pass the response as an argument, and the result of which is being stored in final grade. Alright. And lastly, we display final grade. So now you must be wondering, if this executes, what about errors? What if the value that I pass is less than 50, right? For that, I'm going to have to catch an error. So what I can do is that I can place this entire code within the try block. Alright. So let me just say try. And now what I can do is I can catch. Now if there is an error, it gets caught and then I display it. So let me say console log error. Alright. And lastly, let's call the function calculate results. Okay. So let me save this and execute it. So alright, here we go. It displays the same messages in the same sequence that we saw before. So now to give you an example of rejection, so here let me just pass 20. Alright, let's save it. And there we go. It says calculating results, you have failed. So you can make use of async and await instead of complicating the entire piece of code by using promises.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
In today's video, we're going to be learning all about JavaScript, this keyword. So without further delay, let's jump right in. So you must have heard about the this keyword several times. So in JavaScript, the this keyword basically refers to an object which is executing the current piece of code. Well, in simple terms, this keyword basically just references the object that is executing the current function. Now, if the function that is being referenced is a regular function, then the this keyword references the global object. Alright, I'm sure it must be a little tricky at the moment, but please hold on. And if the function that is being referenced is a method in an object, then the this keyword references the object itself. So to help you understand the concept better and to clarify all your doubts, let's look at a simple demo. So here in VS Code, I've created a file called this.html. Alright, you can give it a name of your choice. Now here, let me first define a variable and let's call the variable, say, value, and let's set it to say 50. Alright, now let's go ahead and create a simple function. So let me say function, my function. Alright, and within this, let me define the value for value. Let me set the value for the variable value as 100. Okay. And now let me just alert it. Alright. So let me say alert value, okay, plus value. And then let me have another alert message, which is going to display this dot value. So let me just say this value, and instead of just saying value, I say this dot value. Alright. Now after this, let's go ahead and call the function my function. So let me just save this and execute it. So here it says value equals 100, and then when you see this dot value, it says 50. So now here you can come back to the code and see. Now when I just say value, it takes the value 100, alright, which is taken locally. But when I say this dot value, since it is a normal function, it references to the global variable, which is here, this value. I hope this makes sense to you now. Now moving on, let's look at the behavior of the this keyword within an object method. So let me create an object here. But before that, let me just comment this out. Let's say script. And now let's create an object. So let's say const. And then I give the name of my object as random. And within this, let me say name and let's call it John. And then I create a method called info. Okay. And within this, I display a console message that says, hi, my name is. And now I make use of the this keyword. I say this dot name. Alright. And now let me just go ahead and call this method. So I say random dot info. Alright, so let's save this and execute it. So let me check my console. And there you go. It says, hi, my name is John. So if you clearly observe here, when we say this dot name, since it is being used within a method that is defined inside an object, it references to this property here. Alright, unlike this case where it references to the global variable that was mentioned outside. So I hope this helped you understand the difference between the two. Now let's look at another simple example. So now let me just change the value of name here to say tutorial. And now let's define another property which is basically an array. So let me just call the property video, within which I have an array, let's say JavaScript, another value, say this, and then let's say keyword. And in my info method, I'm going to just display these video tags. So let me just say this. Okay, let me just delete this first. And let's say this dot video. Now since it's an array, we can make use of for each. And now for each in turn takes a callback function. And then I say, I'm going to call it a tag, the parameter that's being passed, within which I just console log it and say tag. Alright, so let me save it and then execute this. Now here you can see that the values in the video property are displayed. That is JavaScript, this, and keyword. Now let's suppose that you want to display the name along with every string here, right? So naturally you would go ahead and just say this dot name, right? It makes perfect sense. So let me just save and execute this. Now if you see, just the values of the property video are displayed here. Now the main reason for this is, if you closely observe, that this function here is mentioned within the callback function, right? So when it is referencing to the global object, which is unclear, which is undefined in this case. So to overcome this, what we can do is that the for each method takes in two properties. One is the function, the other one is the object. So here we just pass this. Alright, so what happens is, it's going to reference the current object, that is random. So let me save this and then execute it. And there you go. You can see that tutorial, that is the name, has been displayed. Alright, I hope you understood the concept of the this keyword. It could be a little tricky, but as you work on it, you'll get the hang of it. In today's video, we're going to learn all about JavaScript form validation. So now, without further delay, let's begin. So what exactly is form validation? Now I'm sure you must have filled several online forms, right? A simple example would be a new registration for a website. Now every time you miss out on giving a particular detail or end up giving faulty information, the website alerts you. So this process of ensuring that the information provided is legit is called form validation. Now this generally happens on the server side. However, JavaScript facilitates form validation on the client computer before sending it over to the server. Now there are two functions performed. One is the basic validation, which ensures that all the mandatory fields are filled. Now this is implemented with the help of a simple loop. And the other is a data format validation. Now this checks the data for its correctness. So to help you understand form validation better, let's look at a simple demo. Alright, so back in my Visual Studio Code, I've created a file called forms. Alright, it's an HTML file and I've typed down the initial code. Now the simple use case that I'm going to show will include the validation of the email and the password fields in a form. Alright, so for that, let's go ahead and first create a simple form. So here, HTML allows the form tag. So I say form, within which I'm going to provide our fields. So I say input, and then the name I'm going to be providing is email. Alright, and then I'll provide a placeholder and call it email. And then the type of the input is going to be text. Alright, And then let me just give a break tag here. So now let me just copy the same thing for my password as well. So here you go, I say password here. And then the placeholder again will be password. And then I'm going to keep the type as text. And finally, I'm going to have a button, a submit button, right? So let me say button, type is basically submit, all right? And let me display submit on my button, all right? Okay, so with the help of this, we've created a simple form. So let me show you how this looks. So here we go. We've successfully created an email field, a password field, and a submit button. And every time I click on the submit button, you can see that my page is getting refreshed. Now, once the user provides the correct email ID and password, we want to display a message. Alright, so for that, I've created another file called message.html, and this is a simple file where I'm displaying the message, hello there, welcome. Alright, so this is a simple message that I want to display. So for that, I have to add it in my form tag. Now, once the form gets submitted, an action has to be performed. And the action is to navigate to the message.html file, right? So let me just say action equals message.html. Now you can also provide a name to your form. So let me call it my form. Alright. So let me just save this. Alright, so moving on, we have to now validate the information that is provided. For that, I'm going to create a function here. So let me call the function validate. Alright, so here I'm going to check for my fields, right? Now, if the email field is empty, then I'm going to alert the user saying please enter the email. And if the password field is empty, I'm going to again alert the user to provide the password. So for that, we're going to make use of this simple if-else logic. So let me say if document dot my form dot email dot value is null. So I'm going to check if the value provided on my email field in my form is null. Alright. What I'm going to do is I'm going to say alert. Please provide your email ID. Okay. And then I'm going to say document.myform.email.focus. Now, what exactly focus does is that it makes sure that the cursor remains at the email field. That is, it is focused at the same field. Alright. So let me just copy the same thing for my password field. So let me say else if. Let me just copy this. Instead of email, I say password, within which I'm going to alert the user to provide the password. I'll say please provide your password. Alright. So basically it first checks for the email field and then for the password field. So let me just say finally else do nothing. Alright. Okay. So now what we're going to do is every time we click on the submit button, the form gets submitted. Correct? Now we can control when the form is getting submitted. So basically the form gets submitted when this function is executed. So for that, we can use another property here called onSubmit. And here I'm going to call my function, that is validate. So let me say validate here. Alright, so let me save this and let's check the output. So here, as you can see, let me just try submitting it without providing the email field. Alright, so here we go, it alerts us. Alright, and once I click on OK, it still displays the message, hello there, welcome. Now that is not what we want, right? So once the email field is empty, it should remain in the same page and the form shouldn't get submitted. But here in our case, it is getting submitted. So for that, we're going to have to make use of return values. So what happens is, if my email field is empty, then I'm going to return a false. So here I say return false, and here as well. And finally, when both my email and my password fields are filled, I'm going to return true. Alright. And same goes here. Let me just say return validate instead of just validate. Right. So here we go. Let me save this. And now let's check the output. So here, let's first submit the form without providing any information. Alright, so it says please provide your email ID. When I click on OK, observe that the cursor remains at the email field. So here, let me just give some random value. And then let's try submitting it again without providing the password. And then it says please provide your password. Alright. Okay, now if you observe that the cursor remains at the email field. So let me just check my code once. Here we go. I haven't mentioned password here. So let me change email to password. So let me just provide some random value at my email field and say submit. And then I get a message saying please provide your password. And now you can see that the cursor is at the password field, right? So let me just give random information there. And then I say submit. And here we go. The message hello there, welcome is displayed. So this was a simple demo on form validation. In today's video, we're going to learn all about JavaScript regular expressions. So now, without further delay, let's begin. So what exactly are regular expressions? Now, a regular expression is basically a sequence of characters. Now, these characters could be digits or the letters of the alphabet. And this expression usually searches for a particular pattern. Now, the user can basically define what has to be searched in a text, alright? And these expressions could be alphabet or digits as I explained before. Also, one of the main reasons that we use regular expressions is for text search and text replacement operations. So this is the general syntax. You have a pattern that needs to be checked and you have a flag associated with it. So further on in the video, I'll explain to you what flags and patterns are. But before that, let me give you a small example of what a regular expression is. So I've made use of this website called regexr.com. I'll link it down in the description box below. So this is the website. Now here, let me just show you a simple regular expression. Now say we have a text that says apple. Alright, and now we have to search for the letter A. So what I do here, now this is going to be my expression. So I first provide a pattern, right? So I just say capital A. So when I say capital A, you can see that the letter A has been matched in my text. Alright, so it's as simple as that. Now one thing to remember is that here it is case sensitive. Alright, so if I say a regular small a, it does not get matched. Alright, so if I want to match AP, I can just say AP and it gets highlighted here. Alright, so this is a simple regular expression that matches with the text. So moving on, let's see what exactly these flags, patterns and quantifiers are. So what exactly is a flag? So we previously saw that the syntax consists of a pattern and then a flag, right? So these flags basically specify to alter the behavior of a regular expression. Now these flags are generally appended after the regex literal and can be specified as a second argument in your expression, right? So let's see the different flags that are supported by JavaScript. Now you have these 5 flags here. You have G, which is the global flag. Now this finds all matches instead of stopping after the first. Alright. Then you have I, which is ignore case, which makes the entire expression case insensitive. And then you have M, which is multi-line. So the caret and the dollar match the beginning and the end of each line respectively. Then you have Unicode. And if this flag is not supported, you must match specific Unicode characters. And then finally you have Y, which finds all the consecutive or adjacent matches. So moving on, we have patterns. Now these patterns are basically brackets and are used to find the range of characters. Now again we have these patterns. You have A to Z, which finds all the characters from A to Z in lower cases only. Then we have 0 to 9, which finds all the digits between 0 to 9. And finally we have the letters of the alphabet and the digits separated by a pipe. Alright, so this basically finds any character, be it an alphabet or a digit. I hope this was clear to you. So moving on, we have quantifiers. Now these quantifiers define the number of occurrences of a particular string. Now consider n to be a string. So we have 3 quantifiers here. We have the plus, we have the asterisk, and we have the question mark. So plus indicates one or more occurrence of the character n. Alright, and the asterisk indicates 0 or more occurrences of the character n, while a question mark indicates 0 or 1 occurrence of the character n. So now that you know flags, patterns, and quantifiers, let me help you understand them better with the help of a demo. Alright, so here I have a simple text which says, "Welcome to this tutorial on JavaScript. This video teaches regular expressions." Now here, when I search for a particular word, say let me search for the word this, okay? So I say this. Now ideally, even this has to be highlighted, right? However, it does not. That is because, as mentioned earlier, it is extremely case sensitive, right? So what we can do is here we have flags. So here I say case insensitive. So once I click on that, both these words get highlighted. Alright. So this was how you make use of the I flag. Now moving on, let me help you understand patterns. Now as mentioned, you can have a range of characters. Now just in case here, say I just make it case sensitive again. And here I would like to select all the letters of the alphabet from A to Z. Alright. So when I do that, you can observe all the letters are highlighted except the ones that are in the uppercase. Correct? Because that is not mentioned here. So here when I make it insensitive, you can see all of them get highlighted. So this is how you can make use of a pattern. Now to understand quantifiers, let me use a separate text, alright? Let's have a couple of A's and a few B's. Now here, when I say A, you can see all the characters A are being highlighted, right? Which is correct. But when I use the asterisk symbol here, what happens is you can observe all the 4 A's are considered to be a single unit. What asterisk does is that you can see here it says matches 0 or more of the preceding token. Now the preceding token is A and matches 0 or more occurrences of the character A. Now same, if I say B next to it, you can see all the characters B are matched, right? However, you can check the characters A in this particular text are not highlighted. I'm sure you can understand why, because the expression that I'm looking for is any occurrences of A followed by the character B. In this text here, there are no characters A and B together, correct? So here you can say that A is not highlighted. But once I give an asterisk again, what happens is that the character A gets highlighted. What happens is that B can have 0 or more occurrences. So here there is a 0 occurrence of B. So A gets highlighted. So this is how the asterisk quantifier works. Now one of the most important concepts of using regular expressions are the special characters. So here we're going to indicate the special characters with the backslash. So we have \w, for example. Now what W does is that it matches any word character, right? So all the characters here get matched. Now it also has a counter character, which is the capital W, alright? So what this does is that it does not match any word. So it matches everything that is not a word, including the periods. Now let's say we want to match all the white spaces. You can make use of the character S here. Alright, and when you have the uppercase S, it matches any character that is not a white space. Now let's say you want to match a digit. You can just have \D. So let me just type in a few digits, and here you go. All of them get matched. Now let's say you want to have a range of values that get matched, right? Now let's say I want to match just 3 digits. So I can make use of curly braces, and within which I can mention 3. Now here you can see that it matches 3 of the preceding token, correct? So the preceding token is basically a digit, so it groups them in 3s. So let me just add 2 other digits, and there we go. Same goes with the matching of words. So here, let me say W. So when I say 3, all of the characters are grouped in 3s, alright? Now let's say I want to group the words that are 3 or 4 in number. So here I can just say comma 4. Alright, now it gets matched. Alright, so now it gets grouped in 4s. So this is a simple example to show you how special characters work in a regular expression. Moving on, let's see how you can use regular expressions to search for phone numbers. Now here in my phone number, I'm going to have an area code. So let's say 080 followed by an 8-digit number. Alright, so let me give a random number. Alright, so it's 8 digits. So some people write a phone number like this, while others could write it something like this. You could have a hyphen in between and then an 8-digit number. Alright, now how are you going to look for this text? So what we're going to do is we're going to make use of the special character, that is for a digit, we make use of -t. And first we're going to look for the area code, that is a 3-digit number, right? So let me just say 3 here. And next we're going to have an optional hyphen. So for that, now since we learned a pattern can be enclosed within square brackets, so let me just say hyphen here, and let me say a question mark. Now a question mark indicates 0 or 1 occurrence of the preceding character, right? So we're going to have a hyphen for a question mark, and then finally we're going to have a digit again, and here the number of digits is 8. So let me just specify that. Alright, so when this happens, you can see both my numbers are getting highlighted. Although the text remains the same, it could be specified with different formats, right? So just like this, you can create expressions that match various formats. So this was just a simple video to acquaint you with regular expressions. In today's session, we're going to be learning all about JavaScript email validation. So first of all, validation is an essential part when you're communicating with the user. Almost all the websites and applications that you use have forms that you need to fill in. And every time you fill a form, that information you provide needs to be validated. So this is an essential and a crucial part. Now, when you're providing more critical information like user credentials, say your ID, your password, your date of birth, all of that needs to be validated. So JavaScript enables this with the help of a feature called email validation. Now, email validation, first of all, ensures user authenticity. It also facilitates email validation on the client side so that all the processing that takes place on the server side is faster. And lastly, with JavaScript, one can validate a name, password, email, date, etc. Now, I'm sure everybody has used email IDs, right? So here's a dummy email ID for you. One thing that you must have noticed is that all IDs come with an @ symbol. Now, the first part before the @ character is the personal data. Now here it could include your name, you can provide digits, etc. So the length of this personal information can be up to 64 degrees. And following the @ character, you have the domain name. The domain name can be up to 253 characters. Talking about the personal data, now this data can include any sort of information. You can provide your name, your birth date, etc. So basically it can consist of all uppercase and lowercase letters of the alphabet. It can have digits from 0 to 9. It can include all special characters. And lastly, it could include the period character. One thing to remember is that the period character cannot occur twice and is not supposed to be either the first or the last character. Alright, so this was just a brief introduction to email validation. Now, to give you a better understanding, let's go ahead and look at a simple demo. So back in our Visual Studio Code, I've created a folder called JavaScript Demo, and I've also created a file called email validation. I've also typed in the initial code. Also, if you haven't watched our videos on JavaScript regular expressions and JavaScript form validation, then I highly recommend you go through them. Email validation is basically just a combination of the two. So I'd suggest you first head back and watch those videos and come back here. Alright, so the first thing that we need to do is create a form that includes the email field, right? So for that, let's go ahead and create our form. Here I'd say form, within which I'd give input. Let the ID be text, and I'll give the placeholder property and let it be email, and the type text. Alright, and then I will break the line, and finally I have a button that's basically the submit button, right? So let me just say button, type, say button, and then the message displayed is submit. Alright, so now when you're validating a form, you will have to provide certain cases, that is the if-else conditions, to validate it, correct? Now first I'm going to create a function wherein I'm going to pass the information typed in by the user as an argument, and this function consists of a regular expression against which the ID provided by the user is checked. And if the pattern matches it, then the ID is valid, and if it does not, then you'll have to alert the user. So now let's create our function. Let's say script, and now let me create a function called validate. Alright, and now I'm going to create a variable called mail, and I'm going to get the information provided by using this ID from the input. Now I'm going to get the text using this ID, correct? So let me just say document.get element by ID, within which the name of the ID is text. Let me say text.value. Alright. So the next thing is to create a regular expression. Now consider two different IDs here. Now the domain of the first ID ends with .com, while the next one is ending with .co.in. So when we're defining the regular expression, we'll consider all possible scenarios. So now let's head back to our VS Code. And here let me just say variable regex beginning with a /, and then you have a caret. Now the caret symbol indicates the beginning of the regular expression. Now since we can have the lower cases, upper cases, and all the digits, let's go ahead and mention them. So here, let me say A to Z, all lower cases. Then we have uppercase, and we have all digits, 0 to 9, followed by which we can also include a period and an underscore. So when you're including a period symbol, you will have to use the escape character, that is \, and then you mention the period. Now, one thing to remember is that a period symbol in regular expression means that it can include any of the characters. But here, since we're using the literal character, that is the period, we have to include backslash. After that, we can have an underscore as well. All right. Followed by which we have a quantifier, that is plus. Now, plus here indicates one or more occurrences of all these characters. So here we include plus, after which we have a literal, that is the @ symbol, followed by which we have the domain name. So again, the domain name can include all the letters of the alphabet and the digits. So for that, let me say A to Z, and 0 to 9. Again, to remember, we have to include the plus symbol, indicating that let me just get rid of this. So we include the plus symbol to indicate one or more occurrences of these characters. Again, followed by which we have a period symbol. So for that, let's just go and type in period. Now, you must be wondering why I didn't use the backslash. Now, a backslash or an escape sequence here can only be used within the square braces. Outside of it, it is considered as a literal. So here I just mentioned the period. Again, I highly recommend you go through the JavaScript regular expressions video to clarify all your doubts. So moving on, after this, I have to mention the extension, that is .com or .co.in. Now, generally, these extensions are in lower cases. So for that, let's just go ahead and mention A to Z, again followed by a plus, that is a quantifier, with an optional dot again, followed by the letters A to Z. Again, these can, again I mentioned plus, followed by which I'm going to add the question mark. Now, the question mark indicates 0 or 1 occurrence of the preceding expression. So in this case, this extension, that is .in, is optional. Now, the question mark here indicates either a 0 occurrence or 1 occurrence. All right. So to end the expression, you have the dollar symbol and then the front slash. I might have missed something. Okay, yeah, I haven't closed this, so let me just add the parenthesis. All right. So this is your regular expression against which we're going to be checking the email ID, right? So now we're going to use the simple if-else logic. So for that, let's say if regx dot text dot mail. Now, mail is basically what has been passed by the user. All right. Now, if this is true, that is, if the mail when checked against the regular expression comes in to be true, then I'm going to alert the user saying you have provided a valid email ID, and I'm going to return true. Else, if the expression does not match, then I'm going to alert the user with a message saying, sorry, incorrect email ID. And I'm going to return a false. So now you must be wondering, where is the return value going? So for that, I have to add the onClick event on my button. So here, let me say onClick. It's going to call the validate function. All right, so there we go. Let me save this and execute it. In my browser, when I type in xyz@gmail.com and when I click on submit, it alerts me saying you have provided a valid email ID. So to check the other condition as well, let's type in .co.in and submit. And again, it says that we've provided a valid email ID. Now, let's just add a period and an underscore as well. So if I say x, y, z dot a underscore bc at gmail.co.in, and when I submit it, it again says it's a valid email ID. For a false case, let's go ahead and remove the @ symbol and submit it. It says, sorry, incorrect email ID. Or you can also go ahead and remove the period here. And when I submit it, it still says that the ID is valid. Now, here what happens is that Gmail Co is taken as one domain name with an extension .in. So here, this is valid. So this was a simple video to explain email validation. I encourage you to play around with regular expressions and also consider all possible scenarios while you're validating your ID.
And in this session, we will be seeing what exactly is DOM, which is Document Object Model, and how can we manipulate the DOM. How do we interact with the DOM elements and nodes? And then we will wrap up the session with a very interesting and engaging demo, which is about movies. So we'll be creating a movie web page where you can see the list of movies. You can search for these movies, and we also can add a new movie and delete a movie. So these DOM manipulations we'll be seeing for a movie web page. So what is DOM? Document Object Model. It is the data representation of the objects that comprise the structure and content of a document on the web. So this DOM is a programming interface for HTML and XML documents, and it represents the page so that the programs can change the document structure, style, and content. DOM represents the document as nodes and objects. This way, programming languages can connect to the page. A web page is a document. The document can either be displayed in the browser window or as an HTML source. But it is the same document in both the cases. The Document Object Model, or DOM, represents the same document so it can be manipulated. DOM is an object-oriented representation of the web page, which can be modified with a scripting language, very powerful language like JavaScript. DOM is usually represented in a hierarchical tree-like structure. So you can see this picture onto my right, where you can see a HTML element, which will be the root or the parent element. And it has two child elements that you can see. One is the head, and then we have the body. Head consists of the metadata, like title. It also consists of script and style tags. And body comprises mostly of the content of the web page. So in this example, you can see a h1, which is a heading tag. We also have another element, which is the list element that you can see, which is an unordered list, which consists of two list items. Now these two list items are the child elements of this particular unordered list, and these two comprises of the child element of body, which in turn is the child of the root HTML parent element. So we have a parent and child relationship that you can see over here. And when we speak about events later in the module, so you can see like how the parent can handle the child event, or the child can be able to manipulate the events of the parent element via JavaScript. So we can use JavaScript to perform different tasks of DOM manipulation, like traversing the DOM. You can read the text, or the HTML text or inner text, or whatever property value which is present in the form of the element, inside the element or a node. So you can do a read operation basically, or you also can edit or update something. And we also can add new element. We can delete the existing ones. We can change the style. So we can do all these manipulation of this document object model using just JavaScript. So all of the properties and methods and whatever events that we have available for manipulating and creating pages, and these are organized into something like objects. So the document object that represents the document itself, the table object that implements the special HTML table element, DOM interface for accessing HTML tables, and so forth. So the entire DOM, if you see, it's like object reference, object by object reference. So what is the power of JavaScript in manipulating this DOM? So we'll see the perspective of JavaScript now. So using JavaScript, as I told earlier, so you can add elements or nodes, or you also can remove the HTML elements or nodes that we see in the structure. But this is just not HTML elements or the content. Even you can manipulate the style. So you know cascading style sheet or the CSS, which represents the theme of a page. So for a web page, the theme or style is very, very important. So the HTML represents the content and CSS represents the style or theme. And the JavaScript is the core functionality or the feature of a web page. So these three things are like, like a trinity of a web page or website. These three things complement each other and go hand in hand. So just with your JavaScript, so your content is definitely important. Content is king for any particular website or system. So content is mandatory. It has to be there. So without content, it's nothing. But style is also very important. So if you have to attract your first-time customers, so you can attract them only with a very nicely styled theme or design. So this UI and UX design plays a very important role to attract your customers. So after attracting your customers, so these are just not enough. It is also important to provide good features. So your customer is now trying to shop from your website. So he is so attracted by your design, minimalistic, beautiful design. So he starts shopping. And after that, at some point or the other, he is unable to put items in the cart, or he is not able to contact you via some contact form. So these are provided by your JavaScript or some JavaScript packages like jQuery or Angular or React. So this is very, very important. So the functionality and feature, if you don't provide it, of course, you're going to lose your customer. So your JavaScript is so important and powerful here that, so I was saying that using your JavaScript, you can add a whole lot of HTML content. You can, from scratch, you can add styles also or change the existing style, not just the font and color. You also can completely change the spacing, padding, alignment, everything. So the entire theme, style, and content you can change via JavaScript alone. And coming back to your events. Now, this is very important part of JavaScript. This is the place where the user interacts with that web page or website. Say, for example, in the form of a form. So you have a registration form or a contact form. So using these forms, so where we have these input elements like a button, we also have a lot of text boxes and check boxes. So using all these input elements. So we can get the input and we can interact with the user. So the user can click a button and he can select something, he can blur, or he can get into some particular input element, but by gaining some focus. Now, all these are done in the help of some triggering points, which is called as events. Now, we have these event listener, especially for older browsers. And these events are nothing but some triggering point which can trigger some actions. Now, these actions are termed as functions or your handler for that particular event. So, to put this in a very simple layman form, say, for example, someone is ringing the bell, your doorbell, and you're getting up and you're attending the door, so you're opening the door and checking who is it. So in this scenario, so someone ringing the bell is the event. And you getting up and going and seeing, so who is it, and accordingly responding. So that would be the function. So that is the action. So that particular event, doorbell ringing, has triggered you to do or take some action, which is your function. So we will see more about this event. So in this project, we'll have a lot of events, and we will also be handling those using some functions and actions. So what next? Here in our project, so in this demo that we will be seeing, what are we going to do? So what is the takeaway? So what can you expect out of this? So you can see this screenshot. So this is the web page that you will be creating. Now this web page, as I told you earlier, it is a movie website. So it's like a movie web page. It's a single page that we are going to create. And you can see a list of movies to watch, some latest movie. So you also have some red color buttons to your right. So these buttons so here it is written as delete button. And there is also a green color add button over there, which is at the end of the page, where you can input some movie name and you can dynamically add it. Now all these we are doing via JavaScript. So you can statically add it also using your HTML. But in this particular example, so we are going to use JavaScript to dynamically add a new movie. And if you want to delete those movies, we are going to delete that also. So this is what we are going to see as an example. And in this demo application, so wherein you can create these details of the movies. Now I have to say something here. So I have styled this using CSS, but we will not be going in depth into the CSS because that is not in our scope, but I will walk you through the code that I have written so that you get this beautiful, the background image and the alignment and margin and padding. Those are the properties that I have included to get this style. So I will walk you through that. Then once that is done, so we'll focus more on our JavaScript code so that we can create this particular movie website in an easier, so very, very simpler, easier manner. So how we can implement this particular concept of DOM manipulation. So that we will be seeing in our movie project. Okay, so let's get started. And before we begin with the actual coding of creating a new movie and deleting a movie, so before we do that, I would like to walk you through the actual application. So let's get started on that. So before we get on to the coding and stuff, so I would like you to take a look at the final web page or the website that you would be creating. So let's take a look at that now. So this will be the website that you will be developing. So you can see that it's a movie web page. It's kind of a single page application because we are creating just one single web page for this particular demo. So you can create any number of pages you want later. But for this, we are just going to create one index.html. Now in this, if you can see, there is a list of movies here, popular movies. Yeah, so most of my favorites that you can see. And as I move my cursor, you can see that there is a purple color, like a border. That's actually a border that I have written in CSS. It's a border property. So you can see that on the left, which is highlighting that particular row. And you also can see a corresponding button in red, which is the delete button. So when I press, it's going to delete that particular movie. And you also can see a text box at the end of this page. And there is a green color button to add a new movie for this. So you can see the entire page has been styled in CSS. So it looks quite appealing. So I have given an image which emulates like a movie screen, movie theater screen. And there is a card that you can see. So this is the card, and so which has this title and a tagline, and all these have been aesthetically arranged here, as you can see. So there's a lot of CSS here, so which goes about to create the theme and style of any web page. So CSS is very, very important. So if you have to attract any probable customer for your page or for your business, something that is very important, the entity that is very important is your style or your theme. So the CSS plays a major role over here. So I will show you the, I will have a code walkthrough of how I have styled using CSS. So let's try to add a movie over here. You also can see there is a placeholder, tip also, text also over there. Let's go on with this movie. Yeah, the popular one. So let's say add, and you can see instantly now Avengers getting added at the end of this particular row. And you also can see that there is a delete button that got added automatically. So if I have to delete a movie, so you can see that it just goes off instantly. And I have to remind you, so this is not linked to any database, so it's not persistently stored. So if I have to refresh it, you get everything back. So this is just like stored in an array. So it's just a list of movies that we are just going to store in the page. So if you have to have these changes reflected, of course, you'll have to connect it to a database. So this is what we are going to do. So using the DOM and using the JavaScript features, so how are we going to add an entity or element to your DOM, and how are we going to delete it? So this is what you can expect out of this demo. All right, so here we are in the editor. I'm using Visual Studio Code. So this is the editor that I'm using currently. I do use other editors like Sublime, Brackets, WebStorm. So this is purely up to you. Whichever is the editor that you're comfortable with and you're already working, even if it is going to be Notepad++, or if you're from a Java background and you use Eclipse more, you can go ahead with Eclipse. So whatever is your editor, your preferred choice, you can go with that. Visual Studio Code I've been working since the inception, so I'm also from the .NET background, so I've worked exhaustively with Visual Studio also. So here this editor is very comfortable in many ways. It is just not for JavaScript. You also can use VS Code for Angular or React or Python, any other type of technology that you choose, any type of web development, you can use Visual Studio. So it has a very nice, intuitive and simple user interface, and it has an integrated terminal, so where you can run your server also, and it has a very good debugging options with IntelliSense, and you can install packages on the go, and you can also use this particular space for deployment also. So it's pretty easy and comfortable. So if you prefer Visual Studio and you're from that background, or you have been using exhaustively for mean stack or MERN stack, so you can use Visual Studio. Otherwise, it's completely up to your choice. So you can see that I have a folder which is called as DOM demo, where I already have 3 files there. So 2 of which is nothing but some pictures. So this is the background so that I'll be using. So if you could recollect, so I had shown you the web page with that theater background. So I will be using these 2 images for that. So you can take a look at it. So you can see this one, right? You could recollect that. So I will be using this for background, and where I will be listing out the movies, so I will be using this image. I will not be using the entire image. I will be cropping and I will be using it. And all these style, to use these images for other style features also, for including those buttons and the rows, all these I have used CSS, cascading style sheet. And so this is the style that I will be including. So I will not be explaining each and everything. So I presume so you all have some basic knowledge of CSS and HTML. So what I have done briefly to get that style, I will explain it in a very concise manner, so that you will get an idea what feature I have included, and you can explore on your own these style features. So you can see that the background image I have added as this property, and the size, font family, and colors and spacing I have set. This is for the heading. And so you should be knowing about different types of selectors, like ID selectors, tag selector, class selector. So this hash denotes the ID selector. So I will be using this ID selector when I'm creating my HTML page. So what I have done is, for that particular, I'm creating one container. Okay, so for that container, I'm giving a name called as wrapper. So where this container is the one which is going to list out all the movies for us. So the margin, padding, border. Now these are very, very important. So if you want to have a evenly aligned, readable, legible list or text or content, so you have to play around with these different properties of CSS. And you also can see that there is a page banner. So this is the outermost container. Then I will also be showing an image within that where the movie list will be displayed. And within that, I will be giving the top movies, that list. So for that and the paragraph for the tagline. So some of these alignment features and width and margin I have given. So you also can see that I have given certain elements with these IDs, movie list, and this is for the button add movie. Margin has been given there, and the list it's an unordered list. So unordered list, I don't want to specify any particular bullets there. So ordered list will be having like 1, 2, 3 or ABCD. Unordered, usually bullets will be displayed. So I don't want any bullets, so I'm displaying that as none. And so this is the one I have used for the list items that you can see. And by default, if I don't move the cursor, the border left, if you can recollect, I had one purple color one, right, which got highlighted only on the left border. So by default, I have made it as, gray. So, but when I hover so this is the pseudo list. So when I hover over it, so the state, it gets changed. So it becomes, the color becomes purple here. And these are the style features that you can see for the delete button. So this is the delete button. So it's a class. So that's why it has this period symbol. And so what are the difference? So it has a radius, it has a rounded corners, that button. And the text is white, so all these. And again, like when I hover, so from red it changes the background color. And you also can see this is the style for the add movie button. You can see that. So this is predominantly, it is in gray color. And so this is for the input, which is your text box. And this is the add movie button. So this particular button, so I have made it as green, and you can see the other features also. And again, so however, it becomes like a dark green. So these things and all you can change, right? And for these label, so for all the elements that I will be creating now in the index.html, so this is the style that I'm going to apply. So you can go ahead with your own style. There is no restriction, so you can change the color, the alignment. You want to change the background layout, so completely up to you. So our focus is not CSS for this particular demo. So our focus is on the JavaScript's DOM manipulation. All right, so let's start creating our web page. So the first step how do we create our web page is by creating a HTML page. After we create a HTML page and set those content, the list of movies, we'll try to create the most important file, which is your JavaScript file. And we will connect all these together to your HTML file. So we already have the styles.css in place. So after we create our HTML page, we'll be creating the JavaScript page also, and we will be connecting all these three together. So here you can see there is an icon which states new file. And so let's give this name index.html, and you can see the icon gets magically changed over there. So I have a corresponding extension file which actually gives all these extension. The logos will be automatically updated. So you might not be having that by default. So if you want, you can just go ahead with your these extensions. You can see that. So you can see this. This is the one that I have already included, VS Code icons. So if you want to have those logos so that you have a clear picture of what you're creating, you will be able to do it. So here we also can create one more, which is your app.js. This is the one that you will be creating next. So you can see this JS icon also pops up nicely. So by default, you might not be seeing this icon. So, but if you have that particular extension, that file, you should be able to see it. All right. So inside my index.html, so let's start with our coding. So first thing, so you can see that very nicely, this IntelliSense is also popping up. Okay. So here I say that it is a HTML5 document. So the HTML document, earlier we had HTML4 version for many years. So recently it was upgraded, W3C, which is our World Wide Web, upgraded that to the next level, which is your HTML5. So here, this particular, the first line where it denotes the namespace, it's much more concise and precise now. Otherwise, if you have already coded in HTML4, you will know the pain of writing that, lines and lines of that namespace. So the first line indicates that it is a HTML5 document. So now we'll have to specify the root element or the parent element or the outermost one, which is our HTML. So all our tags and elements goes inside this HTML tag. So we have this head and we also have the body. So head, as I told you earlier during the discussion, so where I was saying that all the metadata and other properties like your title and so if you want to link other files like your styles or your script, everything goes inside your head. Having said that, you also can include your script src anywhere inside your body. Also, you can have more than one script source also. Not necessarily that it has to be inside your head only. But we specify some metadata and other within your head elements. So here I'm including one character set here. So this is the default one, which is your Unicode. Okay, 8. So not mandatory, but you can include this one. And as I told you, we can also include your style and we also can include your script, but we'll do that later. So right now I'll just include my title, so which will be displayed on the web page title bar on the topmost one that you can see. I would say movie time, right? So now this goes inside the head. Inside our body, as I told you while we were going through this style, so we have already created this outermost container and I have given some name for that. So we will be using this in our HTML content. So where I'm going to create a div and all the ID so will be represented as hash that you will be using in your CSS. So you can see this one. So I've used this hash. It means that we'll have to use an ID over here. So let's say wrapper. Now this is going to be my outermost div, and all other elements are going to be present inside this div. And inside my div, I'm going to have a header. So this is a HTML element header. And inside this header, I'm going to have the title. So which says movie time, and it also has a tagline. I showed you in the finished web page. So those movie title as well as the tagline, I'm going to include it here. So inside my header, I'm going to have this one more div, and I've already created the style for this. So this will be the page banner, and inside my page banner, I'm going to have this title. So the movie title, I'm going to use h1 over here, and I'm also giving the class because I've already defined. And you also can define the style outside, or you can have a style inside the head that you can refer. So in that case, it would be referred as internal style. Now this will be external style. But if you want, you can also have an inline style. Say for example, I can include a style property here. So this will become the inline style of h1, which will have the highest precedence. So in this, I say I want to have a white color. So you can either pick from the text as such, or you also can give this hex value. So both are same. Then after that, so all your CSS properties are terminated by a semicolon, and it's separated with this colon, like this property name and the value separated by colon, and the statement, it ends with a semicolon. So here you specify whatever is the heading that you wish to display. And next, we will be giving the tagline. So let's also have an inline element for the tagline. So we'll be using the same thing, which is the white text. Since we are going to have a colored background, so we are using the white text here. So I'm copying and pasting it here. Yeah. So here, so we'll have to close this. Here, let's say a curated list of most amazing movies. So you can write your text like however you want. So however you want to display those taglines and the title. So I'm closing my paragraph here, and I'm also giving a break there. And so with this particular div, which is the page banner, so this is over. So I've created this page banner just to display. This is the entire thing is your header, you can see. So this is your div, which is your banner, and this entire thing is my wrapper. So I still have my list of movies that will be coming up here in this section. So this will be the title and the tagline. So after this header, I want to include a div which is going to be my movie list. So we'll call this movie list, and inside which I'm going to have the title again, something like a subtitle. So I'm using my h2, so where I say, again I give this title class, so which will be used in styling, and within which I will say movies to watch. So this will be the title for the list. So after which we are going to include our unordered list of movies. Now inside the unordered list, I'm going to have now, see, two things here. If you could recollect the movie page that I had shown, we will be creating the name of the movie in the row-wise format, and it will also be having the delete button. So you would be able to see that the delete button would be there, and so both elements have to be there for each movie list. So I will be specifying the name of the movie here, and I will also be specifying the delete button. So inside my list item, I'm going to have a span. Now this span, so I'll say, so it will have name, and where, let's include the first one, and done, and I will be including a span element for the delete button also, and I will just say delete. Okay, so let me copy this one because we are just going to use this for all this particular style for all our movies. So I'm copying this and I'm pasting maybe 4 or 5 movies. So 3, 4 and 5. Okay, so let's write whatever movies that you want over here. So let me just change these movies quickly. Okay, so all of my favorite movies, Inception again, yeah, and Stage, and okay. All right, so the last one, maybe I have included one extra, it's okay. Say Avengers, The Avengers or Avengers, okay, whatever. So I have included this 5 movies now. So with this movie list is over. So now next what we will do is we'll have to do one more thing before we move on to JavaScript file. So in this one we have to create our, we will be having a form element here. The main reason being we have to include a submit button so that I can inform the JavaScript module or the function, so which can handle the addition of new movie when I have to click on the add button here. So I'm giving a name for the ID. So this will be the form, so which will be the parent element, and inside the form I'm going to what we are going to have is we are going to have the button and also the input box. So the input, the text box we will be including, so you can see the list of input elements of your HTML. So we'll be selecting text, and we can have a placeholder. It's nothing but the text, so where I can specify, okay, so this should not be inside. Okay, so this is text. So the placeholder property where you can give some hint of what is supposed to be entered in that text box. So I'll say add so let's close this input box. Now this button, let's add So now this is going to invoke the function which we will be adding in the JavaScript page. So with this, we have closed this form and we have also closed this div and the body. So with this, the HTML content, the code for the HTML content is ready. So if you have to see this page, so I have this option set up here. So open in default browser. So when I click this one, okay, so you can see this, and so if you're wondering why is this blank over here, you can see this here now. Yeah, it's the main reason is I've given white text because we'll have to include the style. We have not included the style yet, so just the HTML content, it looks like this. So it doesn't look so great, I know. So there is no JavaScript function also, but we can see that whatever content that we have mentioned, so it has been displayed properly. So the next step for us to do is to add the CSS and see if it matches the style that I had shown earlier. So if you have to add the CSS, so let's see. Okay, so we have now seen before adding CSS. So I keep saying about the importance of the style and theme also. So I know your content is ready, but it doesn't look so attractive. So how could you make it so engaging and so that the probable customer or your business user can start using your web page? So how can you make it much more engaging and attractive? Let's add the CSS and see if it creates a magic or not. I know this is not our prime focus, but CSS definitely helps. So the link is the tag that we will be using to specify the reference. So this is the reference where I have to add. So whatever is your CSS style. So this is an external style. So I use my href property to attach this external style here. So I'll have to include, so you can see that it gets listed. Yes. And it's not mandatory, but still you can mention that it is a style sheet. So CSS is the default style sheet, and JavaScript is the default scripting language for your HTML. So we have attached this now. Okay, so let us see again. Okay, look at that now. Look at that. So you can see this before CSS. So literally it is nothing. It doesn't look like anything at all. But you can see like after CSS. So if you are, if you have fancy taking for your fonts, if you love fonts, maybe you can change all these fonts. I've used some default fonts. So however you want, you can go ahead and change it. You can see that whatever we have given in the CSS that I've highlighted, it's now getting reflected in this new page. So you can see the difference between this and this. So that's why I opened another tab for you to see the difference. But nothing is going to work. So you can see that the hover, so you can see the red is changing into maroon, and this maybe not much of a difference, but you still can see. I would say if you're using CSS, don't change those text size and the alignment and placing, because there the effect that you will be getting where it will be like flickering a lot, and it will be the alignment will be an issue. Always change the color or some highlight, those things, not the size and alignment. So you can also see like how nicely these rows are getting highlighted. So now whatever we add, so nothing is going to be coming on because we don't have a JavaScript functionality yet. So that is what we are going to see now next. So let's start our JavaScript coding, which will be the next module. Now let's start with the app.js, which will be your JavaScript file that you will be including and coding for DOM manipulation. So this app.js file has to be integrated inside your index.html. So how we have included our style, we will have to use another element, which is your script, and we have to include src instead of href. So that we will do it later. So now let's start creating this code for the app.js. So let's start with this document element, and we will have to do the coding for one of the event. So we'll be writing those functionality, whatever we have done. So we are going to create the event and attach your functionality for that particular event. So there are ways, different ways by which you can do it. An event listener is one of the way. So I can specify, so as you can see in this IntelliSense, this purple color box indicates that it is a method. So you can see that it is a method. And this blue brick that you see, so that is a property. So we'll be using this method. So I'm adding an event over here. So what is the event that we are going to add now? So we are adding this event, which is called as the DOM. So I will explain. So what exactly is this? DOM content loaded. Now this event fires when the initial HTML document has been completely loaded and parsed. So without for other dependencies like your CSS files, style sheets, images, or any other elements to finish loading. So your original content, so if it is loaded and passed, this event will be fired. And the target for this event is your document itself, and that has to be loaded. And you can listen for this event on the window interface to handle it in the capturing, bubbling, or the tunneling phase. So JavaScript event has different type of phases also. When the event can traverse inside from your parent to your child so that it can be handled at that level also, it's called as your tunneling. And when it has to go upwards, so it will be like bubbling phase. So different ways by how your event can traverse and it can be captured. So there is another event which is called as load. Now that will be, you will not be using that for this particular purpose. So here I'm just using this event to check if the content, if that particular document, your HTML document is loaded without the other dependencies. That's what I said, without the style sheet or other features to be loaded. But another event is there which is called as just load, and it should be used to detect a fully loaded page along with style sheet and everything. So it's usually people confuse between this load and the document content loaded. So understand the difference. For load, it is like fully loaded, whereas DOM content loaded is only when the DOM features or the HTML content is loaded. So let's write the function for this. So we will be using this syntax. So first is this event name, and here we are going to include the function. So all of the function that we will be including, so it will be going inside this main function that I have. First thing that I'm going to do is create a variable. In this case, we will be creating a constant because we are not going to change anything. To capture where exactly these event and the functions will be affected. So in our case, the list, movie list is where we are concerned. We can add a movie, we can delete a movie. So we have to create entity which can refer to that particular list. So I'm creating. So you can use a var also. Here, since this is not going to be changing, so I'm using a constant. So I'm using this method which is called as your query selector, by which you can select that particular, the element, whatever element that you have created. So here I want to select my unordered list. So I'm using this movie. So it is present inside container which is called as your movie list. So inside which I'm selecting this unordered list, and that is getting stored in this list. So this is, it's like disabled or like grayed out because we have not used this list object yet. So when we use it, so it will be highlighted. I'm also going to create one more to store my form. So whatever forms, you can have like multiple forms also, and all the form elements I'm storing here. And so let's do the first one. Say if I have to delete my movies. So to delete these movies, I'm going to attach. So we have already created that list. So to that list, now I told you, right? So now if you start using it, it will be highlighted. So you can see that one. So I'm adding another event listener. So whenever I'm going to click that, I'm going to check if the user is clicking the delete button or he's clicking something else. So I'm using this click event. So I'm attaching an event handler. I'm attaching over here, and then I'm also you can also pass on another parameter. So in this case, I'm passing some E parameter, which is, you can also name it as event also, or whatever name that you want. So this event parameter is nothing but all the metadata will be stored in that particular object, E, or the event object. So it will have all the necessary properties stored there. So you can find out the source of the event, you can find out the target of the event. So everything will be stored in the event object. So here I'm checking using my if condition. So I'm checking if the target, okay, so if the target element has, I told you, the event object will have the source where it originated and which is the target. So here I'm checking if the class name is equal to delete, meaning if I'm trying to click on the delete button, I'm checking that. So if it is right, so if it is true, then I'm creating li, which is your list item, and I'm trying to remove that particular element there. So I'm saying the target. So I'm saying which is the parent. See, when I have to delete the element, it has to delete the entire li, right? Including the span, which is the movie text. Also one more span which has the delete button. So I have to delete the parent element. So here I'm mentioning that I'm creating the li, which is the parent element, and now I say the parent node of this particular li. So I want to delete this. So to delete an entity in DOM, if you have to do it, you have an method which is called as your remove child. So you can see that. So the parent node along with your, so both your span, so the entire li element I have to remove. So I'm removing it like this. I'm calling this method which is called as your remove child, which is going to remove that particular li element. So now this is with your li. So here we have added this, and we are trying to delete it. So this is one of the functionality. And the next one that we have to do is add movies. So before adding the movie, so let's see if this is going to really work. So for that, we have to include one more step. What is that? Yes, right. We have to attach it. So your index.html does not have this app.js linked yet. So let's add that. So here we'll be using Sqift src is equal to, so this is my app.js, and let's include this one. So once you have included, so in my app.js, I have given the main DOM content loaded event. So underneath I have these different features included. One is the deleting the movie, one is deleting the movie, another one that we will be writing is adding the movie. So let's see if this is going to work or not. So go back to this. I've already added the script, and so you can open it, or you can refresh the existing page also. Let us see if the delete button really works now. Yes, it works. So, okay, I just deleted everything, but as I told you earlier, this is not a permanent database that you will be like storing. So these does not get reflected in a persistent way. So when we refresh the page, we are going to get it back, but we can see that the deletion via DOM manipulation using JavaScript code has worked successfully now. So we are done with the first feature. So we will have to move on to the second one, where we can add a new movie, and when we click on this button, it has to be instantly added. Let us go back to the editor to add the next feature now. So let's get started with adding the new movie. So it's not like the straightforward delete feature. There are certain series of steps that is involved when we are adding a new movie. So first being to creating the elements, like whatever elements that we are going to add. So it's just not one text or the movie list. We also have to add the delete button along with that, right? So that would be the first one, and the second one would be to add the text content as such. So what is the text content or value? What is the new one? So the delete text and also the name of the movie. So that has to be added. And you can see that each and every, it has a distinctive style property. The left a purple border when it is highlighted, and each row it also has a delete, which is like a red color button which is curved on the edges. So these different style features have to be included. So how do we do that? So that would be another step that we have to do, which is adding the classes. And finally, we will have to attach it to the DOM. So then you attach it to your DOM element. So let's start with the first phase. So all these element now, it's present in the form. So from the form, we are trying to add the new movie, new element. So for that, we'll have to capture the form. So form is in the form of an array. So each HTML element can have n number of forms. So we have already given the ID as add movie. For that form, we just have one form. So we are retrieving that, and I'm storing it inside my add form constant. Next, so I'm using this add form to add this event listener over here. So when the button, so here you can have all these events. So here I'm saying submit is the event. So submit is the most important event, so by which you can actually submit the value. Otherwise, whatever changes that needs to be captured will not be done properly. So I'm including this function. And again, I'm passing this event object, which is your E. So now here, I'm adding all these ones. So first one that I'm doing over here is to include your prevent default. This prevent default method cancels the event if it is cancelable, meaning that the default action that belongs to the event will not occur. Say for instance, if we have to use it when the user clicks on a submit button, but it has to prevent that clicking or submitting of a form, or there is a clicking on a hyperlink or something, but it should be prevented. So these default actions now, if you want to prevent, so you can use this one. So here we are going to use it because we don't want this to be literally bubbled up, and but you also have to note that not all events are cancelable. You can use the cancelable property to find out if some event is cancelable or not. And this particular prevent default method also does not prevent further propagation of an event through the DOM. So if you want to literally stop it, so there is another method which is called a stop propagation. So we are invoking this method first, and so let me just close this one also. And I want all these other features to be included within this one. Okay. So first step after creating the capturing the form element, I want to create the other constants for these values and elements, the other elements. So first thing, I'm creating a constant called as value. Now here I am selecting using the query selector again, this method again, and I want to retrieve this input type. So where I say my text box, so I want to retrieve it. So where I say the type as text. So I want to retrieve the input type where the type is text. So be very careful with the quotes. So if you are using the double quotes as the outer one, just use it for that, and use an inner, for the inner quote use a single quote, so vice versa. So check on that and how it is closing. So otherwise it will not throw any error, but you will not be getting the value that you expect also. And the second constant that I want to create it is for the list item. So here I have the document, and here we are going to use this special method. You can see that there are so many number of create element, create event, many create methods are there as a part of JavaScript DOM feature. So we are going to use this one, create element, and I'm going to create a new li element because this is the one that we want, which needs to be added to the unordered list. And of course, we will have to create the corresponding variable or the constant for the name of the movie. So that has to be there, right? So I'll have to create that one. So that one again is, as you can see, it's a span. So I'll show you the HTML code here. So quickly, let's go. And so you can see this one. So this is what we are trying to create here in this feature. So I will have to create two elements over here. So one is for the movie, another span is for the delete button. So these two has to be created. So this is a span, and you can see that the class will have to add next. But this li element, we have to create it like this. That is what we are doing here. So I am creating a span. So one is for the movie name, and another one we have to create a delete button. So if we have to create a new record, so each record has a movie name as well as the delete button. So I'm going to create that as well. So in this one again, so what is the element that we will be creating? In both the cases, both are span, which is present inside li. So li is the parent element, and these two span will be the child element. So all these have been now created individually or separately we have created. Now we have to set the hierarchy. So we have to append these two as child of this li, and this li has to be attached to this body. So this one, so this appending we'll do it at the last. Right. So first step, we have created this elements. So first we have retrieved the movie, and we have attached event listener for the submit button. And then in the second phase of creating elements, we have created So we have checked if whatever is the value that the user is entering inside the text box. So using that, we are going to create it. So then we have created the li element, which is your list item, and then the span element for the movie name, span element for the delete button. So all these have been created. Now let's go to the next phase, which is to add the text content. So we have already receive the value that the user has entered in the text box, and we are storing it in the constant called as value. So now that we have to attach it to this particular element, which is the movie name. Okay, so that will be the next one. So here I will say movie name dot. So it has this property, as you can see, which is called as the text content. So this is the span element. So if you have to create a text for that, so I'm saying that whatever the user has entered in the text box, that is stored in the value constant, so that I am storing it here, that I'm passing to my text content property of the movie name, which is nothing but the span that we have created. Now the second one, we have also created this delete button span, right? So content we have to create, so which is nothing but the text that will be displayed. So here we are creating the button as delete button. Okay, so however you want to create it, remove or the decaps, however you want to create, you can go ahead and create it. So now this step is also over. So first we have created this form, and then we have created all these elements, the corresponding li, and then the movie name span, delete button span. And then we have also attached the corresponding content for these two span elements. Now we have to add the style. So of course you can see like how it is displayed. So this one has the red color buttons, and then you can see the different these borders, so that we have already created in the external style sheet. This has to be updated here. So we are doing this. So I say class list dot add. So this is add. So we are adding the class name for the corresponding element that we have created, so that you get the style feature that we have already defined. Okay, by default it goes on with your add event listener. Alright, so this is the class name. Okay, so we are adding it. So let's go to the style.css, and so you can see this delete and name. So all these are present over here. Right, so all these are there. So I want to attach, so you can see this one, name and delete, it already has this one. So that we are trying to attach it here. So this step is also over. So we are attaching the class for the style or the theme purpose. Now final and most important one is to attach it to the DOM, so that all your content along all your elements along with those textual content added with those class properties with the CSS features, now it is all rendered onto your DOM in a proper hierarchical way. So that is very important. So that is the final step. So I am saying li. So now li is your parent element, right? So I am attaching my li. First, your li has to be attached to the list. I think we have already created this list, which is nothing but the unordered list. So this li has to be attached to the list, and inside your li, these two spans, your movie name and delete button, both has to be attached. So your movie name and delete button are the child elements of li, and li is the child element of your list. So it has to be attached. So first let's attach your movie name. So the child of your li, which is the first span, and I'm also attaching the delete button, so which is another span child, and finally I'm attaching the li which is in turn a child of the list element. Okay, so here I say list dot append child, which is your li. Okay, but inside your li you can see the movie name and delete button. We can go to the index.html to check. So ul or the list is the parent element, inside which I have my li list item, and the li it becomes the parent for these two, which is the name of the movie and the delete button for each corresponding record. So these two child elements first we are attaching to li, and then this li we are attaching is to the ul. So that is what we are doing here, right? So this will be the final and most important step. So with this we are done with our script. So make sure you save this one, and let's go back to this and refresh it once. Okay, so this delete button, it is working as usual. We have already seen that, and let's see if new movie can be inserted. Okay, let's say wow, now you can see that instantly new movie has been added at the bottom, and you can see the two span elements, okay, which is the child of this li. It gets added to the parent, which is the list item. So this is the outermost one, which is the ul or your list, and then each one is the child, which is li. The li has two child, which is your movie name as well as the delete button. So we have first created these values, and then the classes have been added to ensure that the CSS is consistent. And then finally we use the DOM's append child. You can use your append method also to attach it so that this hierarchy is formed. So using DOM manipulation via JavaScript. So we have seen that so very powerful in a powerful way, and in a very simpler and effective way, how we can add new elements, new nodes, attach events, listen to events, and also to delete it. All these, it can be done so effectively. So you can keep adding more. You can try to validate this also, and say if I want to edit this, I want to edit the existing movies, even that it is completely possible. You can do that, or only the style if you want, you can change that style also. So everything just with JavaScript. So just with JavaScript, so how you can create the elements. So without the HTML content at all, you can just right from the heading to the footer to the content, everything you can create just with your JavaScript. So that is the power of JavaScript. So I think we have done quite enough with this DOM manipulation. So for a quick recap, we started with these three files. So style.css. So I walked you through the entire style and theme features I have incorporated. And we also had these two images already. So you can include, so this is just an overview guideline of how this DOM can be manipulated in one way. You are free to explore having this as a base, and you can just work upon how you want to carry on with your DOM manipulation. So we created first this index.html. So we created all the content, the head and body. And initially we didn't attach it with the style sheet as well as the script. Then we created those containers, the wrapper and page banner, so that we had the corresponding styles for all these. And we also created a UL, which is an unordered list with all these list items. So these list items internally, so it has, each one had two span. One is the name of the movie, another one is the delete button for the movie. And you also can see that last we have also added an input element for the text box where you can add the movie. and also a button to submit so that the new movie has been inserted. So after this, we created this JavaScript coding. So we started with the DOM content loaded, and first we saw the delete movie. We used the event listener whenever I click on the delete button. So based on the event object, I check for the target and I'm removing that particular element. So I'm using the remove child over here for deleting a movie or deleting any particular node as such, and we are using append child to add the movie. So these two are the important functions that you have to keep in mind. And in the second one, we added a movie. First, we created this form, we captured this, and then we created those individual elements, the li, span for the movie name and delete button. And we also had those values that needs to be written, which was added. And then we added the class. And finally, we used the append child to append these two span element to the li. And then li, which is the child of your list, gets added. So that is how we saw this DOM manipulation. So I hope you all enjoyed this demo, and also your the concept of your DOM manipulation via JavaScript is clear to all of you.
Hey there, let's consider a discussion between Joe and Jess. Joe wishes to learn JavaScript but is overwhelmed with the vast amount of content to cover. Jess kindly helps in creating a learning path to make things easier for Joe. If you're looking for assistance with this too, then you're in the right place. So let's begin. To make things easier, I've classified the topics into fundamentals, advanced level topics, web platform, and other tools and frameworks. But before we begin, if you haven't subscribed to our channel already, then make sure you hit the subscribe button and the bell icon to never miss an update. First, let's begin with JavaScript fundamentals. I'm sure these are topics that everybody has already learned. However, getting your fundamentals strong lays the foundation for better and faster learning. Some of these include the lexical structure of JavaScript, JavaScript variables, types, and expressions, JavaScript functions, which include the function constructor, self-invoking functions, functions as values and objects, arrow functions, generator functions, and predefined functions. Then there's JavaScript arrays. It could be array methods, map, reduce, and filter. Then there's JavaScript loops, which include the for loop, for in loop, while loop, and the do while loop. And then we have objects, which include creating objects, object properties, methods, and accessors. Moving on, there is data structures like boolean, string, number, null, undefined. There's control flow statements like if, else. There's data object. There's type conversions, that is converting from one data type to another. Then there's mathematical operators. And lastly, there's scope in JavaScript that talk about the local and global variables. Now, once you've laid your foundation strong, you can go ahead and work on more advanced topics. Now, let's have a look at them. First one being callbacks. Now, this is a pillar for something called as asynchronous programming. And then there's promises. And finally, there's async await that are built on promises to achieve asynchronous programming. There's closures that are an extension of variable scope and define how global and local variables are accessed. The next important concept to learn is timers that help in delaying the execution of certain code or functions. Then there's prototyping, followed by inheritance. Now they specify how JavaScript objects inherit properties and methods from a prototype. Next up, there's binding. There's also regular expressions where you'll have to learn about flags, patterns, quantifiers, meta characters, and basic string search and replacement techniques. Lastly, we have Unicode, event loops, which involve blocking an event, creating a simple event. And lastly, we have generators. Moving on, let's look at some of the important web platform tools required to master JavaScript. First up, we have cookies, that talk about how to create, read, change and delete cookies for any web browser. There's local storage, that is, you'll have to know how data is being stored locally on the browser. We have APIs or application programming interfaces that define how to extend functionalities to a browser. One such important API is the Fetch API, which is important to request resources, be it network resources or database resources. Finally, there's the document object model that defines how anything that is being changed on the browser is affecting the model state and vice versa. And lastly, we have service worker, which is basically a script that runs in the background of a web browser and assists in offline app development. Moving on, let's have a look at the tools supported by JavaScript. Now, JavaScript offers a wide range of these libraries and frameworks. However, you could choose to learn whichever that suits your interest and requirements. Firstly, there's React, which is an excellent JavaScript front-end library that helps create interactive web pages. Now there's Angular, which is a JavaScript framework that is used to create single-page applications. Next up, we have Vue, which is also a front-end JavaScript framework used to create single-page applications. Now, although these libraries and frameworks have the same objectives, their underlying architecture and working differ. And as a result of this, different people prefer different frameworks and libraries for app development. You can choose the one you wish to learn and go for it. Next up is TypeScript. Now, TypeScript basically defines a set of types to JavaScript and helps users write JavaScript code that is easier to understand. Typically, all the TypeScript code compiles down to JavaScript code. The next framework is Electron. Now, this framework again enables you to create desktop applications with the help of JavaScript, HTML and CSS. And lastly, there's jQuery. Now, jQuery is a lightweight, write less, do more JavaScript library. The purpose of jQuery is to make it much easier to use JavaScript on your website. It does so by simplifying AJAX calls and DOM manipulation. Now, to give you a simple overview of what we've learned, we have beginner level or fundamental topics. Then we have the advanced level topics, there's web platform, and finally there's tools. But you must be wondering, how can we help you? Now, one thing you could do is take up a Simplilearn certification course. Now, to help you understand this better, let me just open the website. Here you can type in JavaScript. And there are a few courses and master's program that we provide. You have the Node.js training course, and then there's the full stack developer mean stack master's program. You can also click on them and go through the overview. And if you think this is what you're looking for, you can go ahead and take up the course. Now, there are a lot of aspiring full stack developers out there, so I'm sure this video will help you all out. But before we begin, make sure to subscribe to our channel and hit the bell icon to never miss an update. So here are the topics that we're going to be discussing. So first we'll see what full stack development is, who is a full stack developer, then we'll move on to the responsibilities, and then we'll dive into the detailed roadmap, and then I'll also let you know about the salaries of full stack developers, and finally how you can get certifications. Alright, now, what exactly is full stack development? Now consider a web application. Let's say Instagram. So every time you refresh the page, new images are loaded. So this is what the user experiences, right? New images are loaded onto his feed. But what exactly happens behind the scenes is that the backend fetches new images from the Instagram servers, and these images are then loaded onto your Instagram feed, right? The app is so easy to use and leaves the users extremely satisfied. In case of any application, there's always the front end, the back end, and the database. So the process of building all of these aspects for an application is called full stack development. So I hope you understood what exactly full stack development is. So moving on, let's see who a full stack developer is. Now basically, a full stack developer works with both front end and the back end of an application. He has to be familiar with languages like HTML, CSS, JavaScript, and also one or more backend frameworks like Node.js and Python. Now, these developers have got all the web development skills to build websites and applications from start to finish. Now that we've understood what exactly a full stack developer does, let's look at some of his responsibilities. Now, the first responsibility is developing the front end. So as discussed, they must be able to develop the user interface for the users with the help of HTML and CSS. Next up is design the backend. Now, this is also the most crucial part of app development. They should be able to design robust backend architecture to ensure the smooth functioning of fetching and updation. Next up is to design database and servers. Now, databases and servers must be resilient to any outages and must maintain consistency. Next up is cross-platform compatibility. Now, depending on the platforms, there could be some discrepancy and alteration in the functioning of an application, right? It's crucial to make sure that the applications behave accordingly on all these platforms. Next up is developing APIs. Depending on the planned architecture, the developer must be able to develop APIs. The application must also be responsive and interactive and keep the user completely engaged. And lastly, it should meet all the technical and consumer requirements. So these were the few responsibilities of a full stack developer. Moving on, let me explain to you a simple roadmap of how to go about to become a full stack developer. So this roadmap basically shows you the prerequisites and skills one should have to become a successful full stack developer. Alright, so let's go ahead and begin with tools and software. Now the first and the most rudimentary requirement is a text editor. Now the most widely used editor is VS Code. It is free, open source and can be used to code in different platforms like Windows, macOS and Linux. Next up is a web browser. So you can either use Firefox or Chrome, but Chrome is highly preferred. Now also you could need a few editor extensions and VS Code has a few of them. Some of them could be Live SAS Compiler and Live Server. Moving on, you need to have a good hold on HTML and CSS. So HTML is a markup language that is used to define the content that appear on your web page, right? The developer can incorporate images, text and videos depending on the requirements. And moving on to CSS, it is basically a style sheet which is used to decorate your entire application. It is used to define the appearance of the content, say in terms of shape, color, size, spacing, etc. Next up is JavaScript. Now this is the most widely used front-end language and enhances the interaction with the web page. Now you might want to brush up your knowledge on simple concepts like arrays, functions, objects and loops. You can also learn ES6 features like callbacks, promises, async await, DOM manipulation and event, fetch API and JSON. All of these are required when you're making use of different JavaScript frameworks and libraries. So I'd recommend you brush up your knowledge on all of these topics. React, Angular, Vue, and jQuery are some of the JavaScript libraries and frameworks that one can use. Now, all of these topics that we discussed earlier, be it ES6 features or basic concepts, they come in very handy when you're using these frameworks. Among React, Vue, and Angular, over the last couple of years, React has gained immense popularity, followed by which Vue is also being widely used. Now, Angular has seen a downward curve over the past few years. So depending on your requirements, you can choose one of these frameworks. Next up is version control. Now, Git and GitHub are the most widely used version control systems. Now, Git basically helps you manage project files. Git basically keeps track of the entire history of things that the user is working on, right? So it makes sure that it allows the user to backtrack and see what he's worked on until then. Moving on to GitHub, it is basically a web-based service for version control using Git. Now the user can also look into other people's code, identify issues or errors, and also even propose changes. Now, this comes in extremely helpful when you're working in a team. Let's move ahead and look at some of the backend environment. Now, the most popularly used environment is Node.js. Now, this is basically an open source cross-platform runtime environment that allows developers to create server-side tools and applications in JavaScript. Now, Node is typically used to create real-time applications with two-way connections, wherein both the client and the servers can communicate and exchange data without any hassle. Now, I really recommend you have a basic knowledge on command line as well. That is, now knowledge on basic command line like npm, that is Node Package Manager, is also essential. So this was a simple overview on Node.js. Moving on to other backend languages, there's Python and the most commonly used framework, that is Django. Now, Python is the easiest programming language out there, and I'm sure everybody will agree with me with this. So it also offers many libraries and frameworks for different technologies. So when it comes to backend in full stack development, Django is a clear winner. Now, it is a high-level Python framework that enables rapid development of websites. It is also free and open source and has a huge active community of users. So I'd really suggest you get your hands on Django and work on it extensively. Moving on, let me give you a brief overview on the trends in 2020. First up is blockchain. Now, blockchain is an emerging technology and has seen tremendous growth in the last few years. Now, it has also entered into domains like healthcare and finance. Next up is AI and chatbots. AI is booming, and there is no doubt in that. So languages like Python and JavaScript frameworks like TensorFlow are widely used. Mobile app development. This is one of the top trends you should look out for in 2020. Now, there are mobile applications for practically anything these days. So frameworks like React Native and Flutter can be deployed to develop these applications. Next up is progressive web applications. Now, these are like a hybrid of mobile and web apps. They are faster to load and provide some amazing features like push notifications. Another important feature is their ability to work offline. Lastly, we have IoT. With the increasing number of devices getting connected to the internet every second, development of IoT applications is also on a rise. So these were a few trends that you should look out for in 2020. Moving ahead, let's look at the salary of full stack developers. Now, according to PayScale, the average salary of a full stack developer in India is around 5,90,000 rupees per annum. The average salary of a full stack developer in the US is around $75,000 per annum.
Foundation in Sqift, the powerful and intuitive language used to build apps for iOS, Mac OS, Watch OS, and more. You will start with the basics like variables, data type, and control flow, gradually move on to functions, object-oriented programming, and working with Sqift unique features like optionals and closures. By the end of this course, you will be confident writing clean, efficient Sqift code and ready to start building your own Apple ecosystem apps or move into more advanced iOS development. Let's start by understanding what Sqift actually is. First and foremost, Sqift is a programming language created by Apple. Think of it as a tool that developers use to give instructions to computers, especially Apple devices. It's designed to be both powerful, meaningful, it can handle complex tasks, and intuitive, making it easier for programmers to write the code. Sqift was built with safety, performance, and good design in mind. This means Apple focused on a few key things. Safety. Sqift helps prevent common programming errors like accidentally accessing the wrong part of the computer's memory. This leads to more reliable and stable apps. Performance. Sqift is designed to be fast, so apps built with it run smoothly and efficiently. Design patterns. Sqift encourages developers to write their code in structured and organized way, which makes it easier to understand, maintain, and expand. Sqift primarily used to create apps for Apple ecosystem. That includes everything from apps you see on your iPhone, which is iOS, and iPad, which is iPad OS, to the software that powers your Mac, which is Mac OS, Apple Watch, which is Watch OS, and Apple TV, TV OS. But its use is actually strictly limited to Apple products. One of the great things about Swift is its modern syntax. The way you write code in Swift is designed to be clear, conscious, and even enjoyable. It's generally considered easier to learn and use than some older programming languages. Finally, Swift is an open source language. This is important because it means that Apple has made the important language available for anyone to use, modify, and distribute. This has led to large and active community of developers who contribute to Swift development and provide support to each other. Let's move on to the process how downloading and installation takes place. So as you can see, I've opened swift.org to install. So this is the official platform where you can run the code for installation purpose. So you can download it for Mac OS, Linux systems as well as Windows. So the latest release of Swift is 6.1. So you just need to download. So as per your system requirements, you should download what version is compatible with your system and you have to run it. So here I'll be using Windows as my primary system in which I'll be able to run the Swift code. So after downloading, so according to this document, you can follow the instructions and download it in your system to run the Swift code. Now in Windows, you can run Swift three ways. One is via command prompt, one is with the icon that they have provided, and the third way is VS Code. I will be majorly using the system's old way, which is from the icon, which is basically converting any text document into .swift file. So you can write your code in any text document, convert it to .swift file and upload it to the Swift compiler, which will be already installed in your system. This is the procedure. For VS Code, there is another two packages that you have to install in VS Code, and to run it in command prompter you need to copy the path as you do it for Python or any other process and copy and paste it in the environment. So let's run a small program first to check if your Swift is running or not. So here I'll be creating a new text document which will be renamed to .swift file. So let me give this as test.swift file. So it will give you an option and you just need to give OK. And here you can write your code. So I will be writing, first I'll be importing Swift, and let me just print a welcome statement. So it's print So the output for this should be the statement of hi, welcome to the course of learning Swift by Simplilearn. So you have to just save the file and you will see a compiler here. You need to just select the file. The file is on desktop. You can see test.swift and you need to open it. First you need to compile. If the compilation is successful, you can run the program. And here is the statement printed. So this is the first program to check if your Swift is working or not. So you guys are aware of how the download and installation of Swift take place. And also please do try it with your own printing statement. Check if Swift is running. Try it with different statement and check in command prompt and as well as VS Code if you are also using those both. Here the central question here is how do we declare a variable or a constant to further code? And Swift gives you two main ways to do, which we will look at in parallel. Explicit declaration. As the name suggests, with explicit declaration, we are very clear and specific about the type of data we want to store. For example, we use var, that is var, to declare a variable. If we write var x int is equal to 5, we are saying I want to create a variable named x. It will hold an integer value and its initial value is 5. Similarly, var y, float, declares a variable named y that will hold a floating point number. Now let's look at implicit declaration. Swift is smart enough to often figure out the data type for us. This is called type interface. For example, if we write var second is equal to 5.6, Swift often knows that 5.6 is a floating number. So it automatically sets the type of the second to float. And if we write var first is equal to 8, Swift interface that 8 is an integer, so it sets the type of first to int. Let's move on to what kind of data types are there. So here initially for whole numbers we use int or uint. As we all know, int as per other programming language it's used for whole number, but here we use uint for unsigned integers. And also we have float, double, boolean, string, character, optional and tuples as well. So we know float is a point number with smaller decimal point, and double is a 64-bit floating number which is a larger point value. And boolean is either true or false as a value, and string is a collection of characters which is a name or a collection of alphabets. Character is a single character, a single alphabet. And optional represents a variable that can hold either a value or a no value. Tuples, this is used to group multiple values in single compound value. Next, let's talk about string interpolation. String interpolation allows you to embed variables or constant directly within a string literal. This means you can insert values into the middle of the string without having to break the string apart. The syntax of this is use backslash and parenthesis, which is a backslash and a name. Anything inside the parenthesis is evaluated and its result is inserted into the string. Let's move on to string concatenation. String concatenation is a process of combining strings together using the plus operator. The syntax here is straightforward. If you have two strings A and C and if you want to combine them and store the result in a new string A, you would write let A is equal to B plus C. Now let's see a small example regarding string interpolation and string concatenation. So here, firstly, I'll give you an example of interpolation. So first, let me give var variable name is equal to Alice, and then I'm going to print hello, and then I'm going to put the name. Let me add a explanation mark and this. So here eventually it won't print hello and name, the same statement, instead of which the name contains the name called Alice. So it will print hello Alice. So let's save this and run it. Okay, so first we have to select the file. Let's compile. It's successfully compiled, and if we run, we get, okay, it's printing name because I have missed the backslash. So let's give the backslash and name, save it, and then you can compile this file now. So let's check the output of this. So save it and then you can run it here. You can run it even in a command prompt. So I have missed a space. So here, so let's correct our errors. Save it and then again you can compile your file. It's completed and you can run. So here we have hello Alice instead of the name. So moving on to concatenation, I'll give you an example here only. So let's say I'm giving variable a is equal to hi, and also I'll give variable b is equal to how are you doing. Simple. Now I need to add this, so for that I'll be storing it in a variable called c, which will be a plus b. Let's print c and c. So ideally the output should be hi, how are you? So I'll give a space so that you'll understand. So let's save this and compile. Sorry, first you have to select the file, compile, successful, and then you have the output hi, how are you doing? So these are the concepts of concatenation. Let's move on to the next topic, which is type interference and type safety. So Swift has the ability to often automatically deduce or figure out the data type of a variable or a constant based on the value you initially assigned it. This means you don't always have to explicitly state the type. Now what about type safety? Swift is a type-safe language. This means that the Swift strongly enforces the rules about how different data types can be used together. It prevents you from performing operations that don't make any sense, such as typing to adding a number to a piece of text. This type safety is a powerful feature because it helps catch more errors early in development process when they are easier and cheaper to fix. By preventing these errors at compile time, Swift makes your code more reliable and prevents unexpected behavior while your app is running. Now let's talk about comments and code readability. Comments are essentially notes that you add to your code to explain what it does. They are ignored by Swift compiler, meaning the computer doesn't try to execute them. They are purely for human readers. Swift supports two types of comment: single line comment, which starts with 2 slashes, and multi-line comment, which are enclosed between symbols. I'll give you an example of both now. So as you can see, we have performed concatenation. So I'll be giving single line, which is 2 ashes. So this I'll type hi is assigned to A. So like that you can give single comment, or else if you want to do multiple line commenting, it is backslash asterisk, and then you can type this program is about concatenation and it prints hi, how are you? So these are the 2 second sentence, so you just can close it up by the same symbol inverse. So this line and also this line will be ignored by the computer. It is not considered a part of the code. So code readability is about writing code that is clear, concise, and easy for others to understand. It's a crucial skill for any programmer. There are several key principles that contribute to good code readability, which includes clear names, consistent style, small functions, and helpful comments. Now let's move on to some part of coding. So we have control flow conditional statement, which include if statement, else statement, and else if statement. So the if statement is most basic condition statement. It allows you to execute a block of code only if a specified condition is true. Now you can see I've given you an example of syntax where syntax is if, the condition, and open and close parenthesis. Coming on to else statement, the else statement is used to conjunction with an if statement. It provides an alternative block if the code to execute in the if condition or if statement is false. Here also the syntax is very similar. We have else and open and close parenthesis, and between there is the code. Coming to else if statement, when you need to check multiple conditions in sequence, you can use else if statements. They allow you to chain together several conditions and execute the corresponding code block when a condition is met. The syntax here is if else, the condition, and open and close parenthesis in between the code. Let me give you an example of this type of coding using if-else statement. So for if loop, let us execute a program where we can check the number is a negative or a positive or a 0 also. So what was the syntax? We have if the condition. So the condition if firstly the number should be greater than or equal to 0. That means it is a positive number. So we'll give the print statement, which is print the number is positive. What will be the second condition? The second condition will be else if number is less than 0, we should print the number is negative. And then we have else statement. So here there is no need of any other condition, because if it is not lesser than or greater than 0, it is 0. So I'm just directly going to print the number is 0. And you can close it. Now let me initialize a number. So let the number be -5. So we're giving now save this and let's execute it. Okay, there is a missing. So I'll save it and I'll run the program. First, let me close the previous one. So let's select this file and compile. There are no errors, and then we can run it. The number is negative. Let's move on to the next topic, which is control flow loops. So for looping, there is for loop and while loop. The for loop is used to iterate over a sequence such as the element in an array or range of numbers. It executes a block of code once each item in the sequence. The syntax involves specifying the item variable, the collection you want it to iterate over, and the code if you want to execute for each items. For example, if you could use for loop to iterate over an array of names and print each name, or iterate over a range of numbers and calculate their squares. But whereas in while loop, the while loop repeatedly executes a block of code as long as specified conditions remains true. It continues to loop until the condition becomes false. The syntax involves writing while followed by condition you want to check, and the code block you want to repeat within curly braces. For example, if you could use while loop to repeatedly ask the user for input until they enter a valid value, or to stimulate a game where the game continues as long as the player has lives remaining. So let's see an example for both kinds of loop. So firstly, we'll check if the number is even or odd in for loop. So for number in 1 till 5. So this is the operator that I'll be discussing in the further classes, where instead of range as in Python, we use a range operator here. So this will give us the values from 1 to 5. So the condition being if the remainder after dividing the number by 2 is equal to 0, then we have to print it is even, else we can print it is odd. And then you can close the program. So as I told before, the syntax is for the range, and then we have the conditions for it to run. This will run from 1 to 5 because we have already given the range. So I'm going to save this and let's run it. So let's select the file, compile it. It's compiled, and see it is odd, even. Okay, I'll specify the number as well in the program so that there is the number also mentioned. So let's give backslash the and same here also. We can give the same. Save it and then you can execute this. It's successful, and you can see here 1 is odd, 2 is even until 5. It is looping until 5. Now same condition if I use a while loop. So I'll keep this. I'm going to use, instead of a for loop, I'll use a while loop. So here the condition will be the number should be greater than 0. This loop will start and I have to initialize the number. And after this, I'll also ask the number to keep decreasing so that until a negative number comes, I can execute it. So this is the decrement operator, and you can close the loop. And I have to initialize the number also. So let's say the number as 5. So 5 times it should execute. 5, 4, 3, 2, 1. I need to get the answers for these. Number is equal to 5. So here firstly we have given number is equal to 5. It will loop. While will loop until the number is 0, and after executing after checking each number if it is even or odd, I'm decrementing it by 1. So let's see, save it and then select the file, test.swift, compile, there are no errors, and run. So here you can see it is looping in a decreasing order. So 5 is odd and all these things. Try using different codes, like you can take another question and you can start using if else loop or while loop or for loop according to the problem or your knowledge. Moving on to the next topic, it's control flow range operators. So firstly we have closed range operator. The closed range operator denoted by 3 dots defines a range that includes both the starting and the ending values. So I've already given you an example which is 1.5, which is representation of 1 to 5 numbers. And then we have half open range operators. The half open range operator denoted by ... either it is greater than or equal to, defines a range that includes the starting value but exclude the ending value. For example, the expression is 0 till less than 3, which represents 0, 1, 2. Next we have optionals and optional binding. In Swift, an optional is a type that can hold either a value or it can hold a nil. Nil essentially means no value. We use optional to handle situation where a value might be missing or undefined. This is a common scenario in programming. For example, a function that searches for a user might return an optional. It returns the user if found or nil if not found. You declare a variable or constant as an optional by adding the question mark. So moving on, we have optional binding. Because an optional might not contain a value, we need to be safe way to access its underlying value. This is where optional binding comes in. It allows us to safely unwrap the optional and access the value only if it exists. Swift provides 2 main ways to do this. One is if-let and one is guard-let. If-let construct executes a block of code only if optional contains a value inside that block. You can use the unwrapped value, whereas guard-let construct is used for early exit from the function, method or loop. If the optional is nil, the guard statement else block is executed, typically to exit the scope. If optional has a value, you can use unwrapped value after the guard statement. The next topic is nil coalescing and optional changing. This covers 2 more techniques in Swift that help us work effectively with optionals, which is nil coalescing and optional chaining. They provide concise way to handle situation where the value might be missing. A nil coalescing operator provides a default value to use when an optional is nil. Whereas in optional chaining, it provides a way to access properties and methods of optional that might itself be nil or might contain a value that leads to another optional, and so on. So moving on, we have arrays. Arrays are one of the fundamental data structures in Swift used to store collection of ordered items. Arrays in Swift are stored in ordered list of elements of the same type. You can declare an array using square brackets. Here are few examples. So you can go through the examples where we have given various number of declaration. We have var numbers is equal to int 1, 2, 3, or else you can give names also, or an empty array also. You can access elements in an array using their index, which starts from 0 in the first element. For example, number 0 is referring to the first number of the array. Arrays in Swift are mutable, meaning they can be changed if they are declared using var. Here are some common ways to modify the arrays, which is append, insert, remove, or remove last. Next, we'll move on to collection of dictionaries. Dictionaries stored elements as key value pairs each key in unique with a dictionary and is associated with a specific value. And a couple of examples include var ages, where string and integer is given, where you can store string or integer values. We can also give an empty dictionary, which is also given on the screen. We have var empty dictionary and we're giving it as string, and it is empty, it has no values. In dictionary, elements are stored as these key value pairs. You use the key to look up its associated value. A crucial point to remember is that all keys in a dictionary must be of the same type and all values must be of the same type. For example, in the ages dictionary, all keys are strings and all values are integers. You access a value in a dictionary by providing its corresponding key within square brackets. And there is an example also given, which is ages, and it's declared as Alice's. Dictionary in Swift are mutable, that is changeable, if they are declared using var. But if you want an unmutable dictionary, you can use let. Even it applies for arrays also. You can add a new key value pairs by assigning a value to a new key, like ages. Charlie is equal to 28. Moving on, it is sets. Like arrays, sets stored a collection of values, but with a crucial distinction. Sets only store unique values. Any duplicate values you try to add are automatically removed. Here's how to declare a set. There's an example. We have var empty set and we have set it to string. And we can enter the value as 1, 2, 3, 4. Var unique number set into 1, 2, 2, 3. In this example, even though if the numbers are repeated, this will consider it as 1, 2. The key characters of sets are that they store unique values and they do not maintain any specific order. The order in which the elements are stored in a set are not guaranteed. Sets are particularly useful in scenarios where you need to ensure that you don't have any duplicated values and where the order of the element doesn't matter. Here are some of common use cases. You can use it for checking for membership, removing duplicated elements, performing set operators, union, intersection, and difference. Next, we have iterating over collection. The for in loop is very common and convenient way to iterate or go through all the items within a collection. The basic structure is for item in collection and the code. When you iterate over an array, the for in loops gives you each element of the array in the order they are sorted. When you iterate over a dictionary, the for in loop provides you with each key value pair. Each pair is represented as a tuple where the first element is the key and the second element is the value. In sets, you iterate over. For in loop gives you each unique element in the set. However, remember that the sets do not have a defined order, so the element will be provided in an arbitrary sequence. So let's quickly see an example for this. Firstly, let's see an example for in loop over an array. So firstly, let's give an array. Colors is equal to sum of the colors, which is red, let's give it green. And blue. And so in for color, in colors, we can have print. We can print the color. It iterates through each string in the color array and prints it. So let's execute this, saving it. And there is no errors and it should iterate. So we have all the 3 colors which is in the array of colors. So now let me execute for a while loop in foreign format. So it's a similar way, but let's give a dictionary first. Ages is equal to, we'll give ls. Then the age will be 30, and you can give Bob as the second name, and the age be 25. This is the dictionary, and then we have for loop. We have 2 of them, which is name and age in ages. And then we can print the name. Here it won't print name, but the value stored in the name will be printed as discussed before. Then we have age also in the same way. And you can give full stop, and I think that should work. We'll check for errors, we'll compile it. So there are no errors, so I'm running it. So we see that I've given only 2 names. So we have Alice is 30 years old and Bob is 25 years old. So this is an example for a dictionary using foreign loop. Moving on to the next topic, it is function, parameters and return type. Parameters input for functions. Functions can receive data when they are called, and this data is passed in through parameters. Each parameter has a key part, a name, which is what you can call the parameter, and a type which specifies what kind of data the parameter can hold. The syntax is parameter name and parameter type in braces. For example, if a function takes a person's name as input, you might define it as name string. Return types. Output from functions. Functions can also produce a result after they have done their work. The result is called the return value. The return type specifies the type of data that functions will send back. You indicate the return type using an arrow followed by the type. We'll see the syntax for this in the coming up program. It's important to note that function can return values of any data type, whether it's simple type like an int or more complex type like an array or custom object. So let's see a classic example of functions. Let's see a basic example of using a function. So firstly, let's declare a function. So function is, and let's give it add numbers. And I want a as integer. Here, if you are declaring any kind of variables, which is the data types, it should be in capital. The first letter should be in capital. It's a case sensitive programming language, so you might miss out on that. And then we have an arrow, and then this should return me, this function if I call it should return me the value a plus b. Sorry. It's a very simple function where you enter the values and the return type should be the addition of the 2 of the values. Now let's call this. the result will be calling the function by the name, which is add numbers, and I'm going to give A as 5 and B as 3. Now after calling the function, let's print it. So we have print the sum is, I need the result, so backslash the result. So let's save it and run it. So here the answer should be 8. So let's see if we are able to achieve that. So as usual, open this, select the file, firstly compile. There is an error, I left out a space, so let's give that space, save it, and then select the file again, compile, and it's done without any errors, so we can run it. So the answer is, the sum is 8. So this is a very basic program for a function and a calling function. So the next topic is object-oriented Swift class and objects. So we'll have an idea of what classes and objects are. So in Swift, a class is like a blueprint or a template. It defines the structure and behavior of a certain type of entity. A class specifies the properties, which are like data or attributes, and methods, which are actions or functions that objects of that class will have. Think of a class as a general description. For an example of class car, define a property like color, model, or making year. The methods like start, engine, and drive. Objects, which is concrete entities, on the other hand, is a specific instance of a class. You create objects based on the class definition. Each object has its own set of values for properties defined by a class. So let's see a classic example of classes and objects here. So some of the properties and methods of object-oriented Swift are holding data. Properties are essential variables and constants that are associated with the class or its objects. They store data or attributes of an object. For example, if you have a class called dog, its properties might include a name, breed, age. Each dog object will have its own values for these properties. Whereas methods, which are like defining the behavior. Methods, on the other hand, are functions that are associated with the class. They define the actions or operation that objects of the class can perform. Using RDog as an example, it might have methods like bark, fetch, or eat. These methods define the behavior of the dog of the object. Then we have instance method. The method we have been talking about so far are instant methods. This means that they are called on a specific instance or an object of the class. For example, if we have a dog object named my dog, we would call it bark method using syntax my dog bark. Each dog object has its own copy of instances. So next we have object-oriented Swift initializers, where we have to ensure proper setup. Initializers are special methods within a class that are automatically called when new instances or object of that class is created. The main job is to make sure that the new object is properly set up and that all the properties have valid initial values. You define an initializer using a keyword called init. Self is a keyword used within the initializer to refer to the instance or an object that is being created. This helps to distinguish between the property name like name and the parameter also, which is also called as name. Then we have default initializers. If a class provides default values for all its stored properties and doesn't define any custom initializers, Swift provides a default initializer with no parameters. This means that if all the properties of your class already have a starting value, Swift will automatically create a simple initializer for you, so you don't have to write it yourself. Moving on, we have inheritance and overriding. Inheritance allows a class to inherit property and method from another class. This promotes code reuse. Instead of writing the same code multiple times, you can define common properties and methods in a superclass, then have subclasses inherit them. This also establishes and is a relationship. Overriding is a subclass that can provide its own implementation of a method or a property that it inherits from its superclass. This is called overriding. So we'll move on to the next slide, which is access control. Control the visibility of the code. Access control lets you restrict which part of the code you can access other parts. This is important for encapsulation, which is key principle of object-oriented programming that helps you hide the internal workings of a class and prevent unintended modification. So we have three types of it, which is public, private, and internal. In public, entities declared as public are most accessible. They can be accessed from anywhere within the same module, and also from the code in other modules that import your module. In contrast, private is most restrictive access level. Entities declared as private are only accessible from within the defining type. This means they can only be used code inside the class or structure when they are defined. If you don't explicitly specify an access level, Sqift uses internal by default. This means that entities declared as internal are accessible from any source file within the same module but not from the outside the module. So here's an explanation of object-oriented Sqift self and super slide. The keyword self refers to current substances of a type. You use self to access the properties and methods of the specific instances. For example, if you have a class person with the property name inside the person's class, you would use self.name to refer to the name of a particular person object you're working with. Whereas in super, the keyword super is used in a subclass to access members, which is properties and methods of this superclass. This is particularly useful when you're overriding a method in a subclass but still want to call superclass implementation of that method. You can also use super to call the superclass initializer. For example, if you have a subclass student that inherits from a person, you could use super.init. In students initializer to call person's class initializer and set up the inheritance properties. Next, we have structures. A structure is essentially a blueprint or a template that allows you to define a new type that fits your specific needs. You use them to structure data in a way that makes sense for your program. The characteristics include holds relatable data, that is, structs allows you to bundle together variables or constants known as properties that are related to each other. This helps you keep your data organized. The second being can have behavior, which is methods. In addition to holding the data, structs can also contain functions called methods that define actions or operations that can be performed on that data. Thirdly, we have no inheritance. Unlike classes, structs do not support inheritance. This means you cannot create a new struct that is based on an existing struct. Some of the use cases includes a common example representing coordinates like a point with x and y values. You might also use them for things like representing size, colors, or other small self-contained data structures. Next, we have enumeration. An enumeration essentially lets you create a custom type that represents a fixed set of possibilities. Each of those possibilities is called a case. Some of the characters include fixed list of possible values. You define all the possible values that a variable of the enum type can hold. This provides type safety and makes your code more predictable. Secondly, we have improved readability. Using enum's descriptive case names makes your code clearer and more self-documenting compared to using raw values like string or integers. Lastly, we have optionally associated value for context. In Sqift, enum cases can have associated values which allow you to attach additional information to each case. This can be very useful for providing more context. Some of the use cases include representing states like different states of a process, example loading, success, or error. We can also represent days of the week and also setting with a fixed number of possibilities. Next, we have protocols. Think of a protocol like a contract or an agreement. It declares a set of methods and properties that a type must implement if it wants to conform that the protocol. Some of the characteristics of protocol have these key characters, which is list requirements, that is what to do. A protocol specifies what functionality a conforming type must provide, but it doesn't provide the actual implementation. Enable polymorphism. Protocols allow you to treat different types in a uniform way as long as they conform to the same protocol. Usually no implementation in protocol itself. Typically, a protocol only declares the method signature and property requirements, not the actual code that makes them work. Some of the use cases include using to achieve flexibility and allow different types to work together based on shared abilities. This promotes a more modular and adaptable code base. So you have covered all the basic information required to start coding Swift and to understand Swift. So what next? Firstly, I would suggest you to keep practicing. The most important thing is to keep writing Swift code. Try to code daily even if it's just for a short period. Experiment with the playgrounds to try out code snippets and build small focused programs. Consistent practice reinforces what you have learned and helps you build muscle memory for coding, making you more fluent in Swift programmer. Secondly, I would suggest you to dive into Apple's documentation. Apple provides comprehensive and up-to-date documentation on the Swift programming language on their developer website.
And with that, we have reached the end of this session on Programming Language Full Course 2026 for Beginners. Should you need any assistance or any other resources used in these sessions like PPTs, code documentation, Git links, PDFs and others, then please let us know in the comment section below and a team of experts will be happy to help you as soon as possible. Until next time, thank you and keep learning. Stay tuned for more from Simply Learn.